By the end of this masterclass, you'll know exactly how to build and sell AI agents and automations that solve real business problems for yourself in your own business or your clients, even if you're starting from a complete beginner. I've personally built over 150 AI automations using these exact methods and tools, and I've got 500 other entrepreneurs successfully following these methods inside of my community as well. But I'll be honest, 90% of people that I see struggling with either building or selling AI automations are usually always making one critical mistake, and that's that they're focusing on the latest AI models instead of actually just focusing on solving real business problems that people will pay for. So in this comprehensive course, I'll walk you through the entire process from setting up your first automation to building advanced AI agents, as well as how to package them up and sell them for thousands of dollars. We'll cover everything in 4 practical phases designed to get you results fast. And by the end, you'll have built nearly 20 complete automations. So we'll start with phase 1, which is all about the 20% of n8n that will give you 80% of the value. And then phase 2 will take those fundamentals and we'll start building out actual robust business systems before moving on to adding agentic and AI powers through an agentic and AI deep dive in phase 3. And then finally, we'll talk about how to systematize these and package them up so that you can sell them as complete AI automations in various ways. So let's get started with phase 1, where we'll cover the essential concepts and get you set up with your n8n environment.
So getting started, we're going to be talking about workflow automation. Now, simply put, workflow automation is about getting technology to automate your repetitive tasks. So we've got a few examples before we go to n8n and understand what that does there. But say a customer is filling out a form on your website, it might automatically send them a confirmation email and then automatically add them to your database. That is a workflow that's been automated, therefore workflow automation. When you receive an invoice and it's automatically sorted, processed, and sent for approval, again, just another process that's been automated. When you have a new employee that you need to onboard, they join, their accounts and access are automatically created based on their role in the company. Again, a really clear example of something that has been automated already within your business. But we can automate so much more, and we can do it ourselves really simply using something like n8n. And the main benefits, if they're not already obvious, are it saves you time and reduces your manual workload. There are fewer human errors, and we can get consistent results every time because a computer's doing it for us. And it takes away all the mundane work that we have to do day to day. And it allows you to focus on the important tasks within your business, not the ones you don't want to be doing. So n8n is just a workflow automation platform. And there are a few commonly known platforms out there. It enables you to connect to all your favorite services that you currently use within your business. So that might be Slack, Trello, Google Sheets, Outlook, Intercom, your database. It has over 400 pre-built integrations, which mean we don't have to build anything from scratch. If, for example, you wanted to post to LinkedIn, this is inside an n8n workflow, which we'll get to, but you can see they've got a pre-built integration with LinkedIn. So it's plug and play. We don't need to code anything. We can just connect it to our LinkedIn account and tell it what data we want to send. You might have seen some alternative services or use them already, such as Zapier or make.com. All of these are viable solutions to build out your workflows. But there's some key differences or key benefits that n8n offers over the alternatives, and that's why we've chosen n8n. Firstly, pricing. We're just going to compare something like Zapier to the n8n pricing. At the basic level for Zapier, you're going to be spending $30 per month, and you have restrictions on what you can use in terms of functionality. If you're a bigger business and start to use more tasks per month, it's going to really, really add up, and you're already at $200 per month without all of the features. Make.com is cheaper than Zapier in terms of pricing. But again, we have limited functionality in Make.com versus n8n. When I see Make.com automations posted, they're often looking like this with a lot going on. And then I see comparisons of n8n flows built with a better feature set. And actually, you could build something like this in fewer steps. So it makes n8n far more flexible. And then in terms of pricing, it's the cheapest option out of the lot. Firstly, you can set it up directly on n8n for £24 a month and have 2,500 workflow executions. So that's 2,500 tasks. And secondly, n8n uses a sustainable use license, which means we can actually host it ourselves. And for unlimited workflow executions, it comes in around $15 to $17 per month. So significantly cheaper. And the feature set is far more advanced to do things in fewer steps. n8n is a no-code software, so you don't need to know any coding to start this course and build your first automation. And from day one, you can have useful things running automatically for you, for your business. So you might be wondering at this point, what could I actually build with something like n8n? The list is endless. Here on screen is a picture of a LinkedIn and Twitter post generator. So it automatically creates all the content tailored to my business needs and posts it to the relevant platforms. I get to approve that in my database exactly on my terms. Here in just 7 steps is an example of a workflow automation that monitors my inbox for customer queries, and any that need escalation, it sends a direct message to me in order to feedback what I want to say and reply to the customer. That feedback is then drafted automatically for me, so I can just push send in my inbox. We have other examples that create and write a blog automatically for us based on tailored SEO keywords, and a complete invoice management system that you're going to actually build out in this course step by step. The possibilities are endless in terms of what you can build out for your business. You just need to take the first step and get started. So let's talk now about hosting and how to set up n8n. So we're going to talk about the 2 options for hosting here. The first is hosting directly through n8n. So if you are happy to use my affiliate link, then go to n8n.partnerlinks.io/scrapes AI and come to n8n's homepage, or alternatively go to n8n.io. You're going to land on this homepage here. And what we're going to do is we're going to run through the sign up process of getting started for free, and you get a 14-day free trial directly through n8n. You're going to fill out all of your details and give it an account name like your business name. You're then going to start the 14-day trial. And once that has completed, you'll be put onto the starter plan, which is around £24 a month. This is the most straightforward way to get set up. However, self-hosting has other benefits and is really, really simple to set up. If you follow the steps provided, we can do it in under a few minutes. So think of self-hosting as your n8n service being hosted on your own computer, but on a server somewhere in the world. So it means that you don't have to keep your laptop or computer on all times, but your automations will continue to run 24/7. When we sign up through n8n directly, they're just using a server and we're hosting through their server. If you're self-hosting, you're just doing the same, setting up your own server elsewhere. Now, sometimes that comes with having to manage the infrastructure, but I found a service called ls.io, which we're going to set up now, that fully manages all the infrastructure. So you get the benefits of the low cost of self-hosting, so unlimited workflows for around $15 to $17 a month. But they also have the benefits of managing the infrastructure for you. So it automatically updates the software. You don't have to worry about any changes. It will do that all for you. And we still get the benefits of the low cost and the community features that come with it. So you're going to go to ls.io and you're going to set up an account there. Once you set up an account, you'll come into a dashboard like this and you'll have no services here. We're going to go and create a new service in the top right. And thankfully, they've already pre-set up an n8n service for us. So it takes away all of the technical details. So we're going to select n8n there. We have the options of different service cloud providers. We're just going to click Hetzner because it's the cheapest and reliable, and then choose the region that's closest to you. It will automatically pick that for you. So we'll leave it like that. We then need to select a service plan. Don't worry about the details here. This basic plan, the cheapest plan, is definitely good enough for your business when you're starting out. I run hundreds of workflows on my server and still have this medium-sized service plan. On the right-hand side, you can see the estimated monthly price of $15, and we're going to hit next on that. We then want to give it a name. So we'll give it a name that makes more sense for us, an admin email, and then we'll stick with level 1 support. Later in the course, we'll talk about backups and error handling and all that, but we don't need any extra from ls.io. So we're going to go down here and click create service. Now that's going to deploy our service. It'll take between 1 and 5 minutes, depending, and you're going to come back and we'll load it up. I'm going to come back here and you can see now 5 minutes have gone, but the service is now running and it's showing green here. So we're going to click into that. And then we're going to display admin UI. And this has all the details about your server. So if you ever need to change anything, you'd come to this dashboard. So we're going to click on the link that it provides under that. And that's going to open up the n8n page to sign up. So we're going to fill out the details here. And then we'll hit next. And that is basically it for setting up your own self-hosted server. So incredibly easy. We're just going to fill out the survey for n8n there. You get 3 additional paid features forever if you register your community edition, and they're really helpful. And we touch on them later on in the course. The first is getting workflow history, which we know version control is very important, advanced debugging, and then you're also able to search your past execution logs. So I definitely recommend getting that free license key and registering that because those features are really helpful, and we'll touch on them later. You then come into the dashboard for n8n. So this is where you start by creating your own automations. A personal preference of mine is changing the theme. So I go down here to settings, go to personal, and then in here we can change it to light theme. And I just think it's a bit more aesthetically pleasing. And that is it. You've set up your very own self-hosted instance of n8n, and it's always going to be hosted at this address. So you can come back and access it with your username and password. And this is going to continuously run your automations whilst you sleep. What we're going to move on to now is navigating the dashboard here and working through the basics step by step to create our very first automation. n8n is a workflow automation platform. And what that means and what that enables is us to automate pretty much any of our work by connecting different softwares visually on a workflow. So I'm going to run through first the different fundamental building blocks of n8n, which are workflows, credentials, and executions. You'll open up your n8n environment in a screen like this, and what you'll see is an overview on the left-hand side, and that's where we store all of our flows, as you can see down here. We've then got a link to the n8n templates, which we'll cover later as another tip. We've got variables, don't worry about that for now. And then we've got some help and support section. The first thing you're going to come across here are the workflows, credentials, and executions. You can think of workflows as the logic that connects all of our different software pieces. The credentials are just our keys. So how do we get into each of those softwares? We need our password, we need our username. So that is where your credentials are stored. And then you can think of executions as our history of all of the logs. So when we execute our logic, we need our keys to make sure it works, and then we get into the right accounts. And then the executions show us our history of all previous workflows that have run, including the errors and those successful as well. Understanding those fundamental building blocks will help you build out your workflows and connect all your software. We're going to jump in now to an actual workflow. So we'll hit workflows on the top here. And what we're going to do is you'll probably see an empty screen here. We're going to go to create workflow up in the top. That's going to open what we call the canvas. And there's a few key important details here. We've got the name of our workflow up here, which we can come in and edit. So we're just going to say test workflow, but you want to be as descriptive as possible as to what the workflow is doing. We've then got some tags. So tags enable you to easily filter and search through your workflows. So for example, on this one, we're going to tag it with demo. And if we go back, we've saved it, we'll go back, we can see it's got the tag on demo, and we're able to filter here by the demo tag. You can see our new workflows appeared on our home screen here. And to get back into it, we can click into it. So when we are in the canvas here, we have a few different other options. We have the editor mode, where we can create visually our workflows, which we'll start doing in a moment. And then we have our executions, which show us all of the history or the executions we spoke through before of this workflow. So individually in a workflow, you can see all of the previous executions and look through whether it was successful and what data was sent. It's a really powerful feature. If we go back to editor, there's a few more things here. If we make a change to the canvas by adding a first step, it will prompt us to save in the top right corner, or we can hit Command or Control S to save. We then have a test workflow feature at the bottom, and we'll cover this more later, but we can hit test workflow. And if we test that, it will run our current workflow that's saved in the environment on the canvas.
So now that you understand the basics of the workflow canvas inside n8n, we're going to jump straight into making your first automation.
Congratulations on making it this far. What you're about to do is create your first ever automation. And the first automation that we're going to have you create in a step-by-step walkthrough is a daily meeting summary of your calendar sent to your Gmail. So what you might see, for example, at the end of this is Happy Tuesday, and this will change to the day, it gives you the date, and then it summarizes all of your meetings in the diary. So just something simple and effective that can get you started, but actually will be useful in your everyday life. It will send a meeting summary every morning, 7 a.m. to your email, so you can just look through and get a summary of those meetings. And you can see for validation that in my calendar, we've got all of these different meetings which have populated in there in a really nice and easy to read format. So we're going to come into the n8n canvas, and you should be a little bit familiar with that now if you've gone through the getting set up stage prior to this. And what we're going to do is run through exactly how to create this really simple automation, and it shouldn't take long at all. And by the end of it, you'll have learned loads and have something really useful to use every day. So first of all, you're going to come into your n8n environment and you're going to hit create workflow. And at this point, we've downloaded the template. So we've got a blank canvas here. We're going to go into the top corner and rename this my first automation, or whatever you want to call it. Always important to name your flows. We'll go into the top right, click the three dots and import from file. And that means we can import the latest template that we just downloaded. That's going to appear in your canvas. And what you have here is the setup for this very simple automation in terms of notes, so that we can be guided through each stage. And then below, we've got the completed workflow. In case you get stuck, you can troubleshoot by looking directly inside any of these nodes, but we're going to build it out from scratch and replicate exactly that. So running over the workflow, we've got a couple of key stages that are important here. So we want to pull all of our calendar meetings every day and send them to our Google Mail in a summarized list. So we have a trigger, which is daily. So at 7 a.m. or 9 a.m. daily, we're going to pull our calendar invites and then send them to our email. Everything in between is taking the data from our calendar and making it look nice so that it appears nicely formatted in our email. So we've got a stage here which will combine our meetings and then format them. When you're building out your own automations, you will start by just having the daily trigger, get daily events, and send to email. And what you'll see by testing that is that it's not in the right format. So we've gone and retrospectively added these stages where we format the data nicely so that it appears in our email. So let's get started with the first node. We're going to go to the plus icon here, and we're going to go down to add another trigger. And we know that we want to run this daily, so we're going to run it on a schedule. It opens up the node, and you can see that we've got days here. We've got days between trigger that we can select. So we want it to run daily. And let's say for this one, we want it to run at 7 a.m. on the dot. So let's keep that. We'll zoom out and find the node, and we're just going to add it in here. And if we just highlight this flow here, and you can click the buttons and deactivate it. And the reason we do that is because we only want to test this new workflow. So we've hit here, click deactivate, or hit D on your keyboard, it will deactivate that flow below. Now, when we hit test workflow, it's going to test this trigger that we've just created. Great. Workflow executed successfully. We know that we are connecting correctly to our trigger. That's the first step done. We then want to get our calendar events. So we are either competent enough to type in Google and see all the options here, or an alternative is you can look through the different apps, action in app, and we will scroll down to Google and grab the calendar events. So we've got a node here for Google Calendar that automatically connects to our Google Calendar. It gives us a few actions to start on, but we can always change this in the node. But we know that actually we're just getting all of our events. So instead of creating an event or a deleting event, we're going to click the get many events here. Again, it opens up the node and it will pre-name it up here. You can change this name. And there's a few key sections here that you need to consider. The first is credentials. So yours will appear blank if you've not set this up before. And credentials are your passwords or your access to the calendar you want to connect to. So we need to allow n8n to connect to the correct calendar account. We then have different resources. So we can get events, we can get stuff from calendar, or make a custom API call. We're just going to go with events here. And then we have the various operations or actions that we just saw, but we've pre-selected get many events, which retrieve many events from a calendar. So you can see it walks you through each stage. We're going to select a calendar, but we'll come back to that. And then we've got a few other formatting options. So now, first step, let's get connected to our calendar. So setting up Google credentials, what you want to do is pull all of your different nodes in n8n for Google credentials into one sheet here, because it's quicker to just set them all up at once. We'll go into the Google Calendar node as an example. We will go to create new credential here. And you can see that we've got a few things here. We've got the client ID and client secret, which we need to fill out, and then the OAuth redirect URL, which effectively we're going to need as well. So you're first going to go to console.cloud.google.com, and that will bring you to a homepage. You won't have a project set up already if this is your first time. So you're going to go to the corner, hit test project, new project, and we will call this demo. Assign it to an organization. Any is fine. And that's going to create that new project up here. Once that is ready, we'll be able to select the project and go in and create those credentials. So we'll select the project. And this brings us to an OAuth credentials screen. And you can see that we've got no keys or no OAuth client IDs set up already. OAuth 2.0 is just where you see on a website the sign into Google button and you click that. So that's what we want to set up for n8n. So we're going to go up here to create credentials. And we'll go to OAuth client ID. To set up an OAuth client ID, we must first configure the consent screen. And it will bring us to this page here, which is a new update to Google as of Feb 2025. So we're going to get started configuring this. We will call this n8n, and we will add the email in the dropdown. We'll make it externally available. And again, we will make sure that that's the same email there. And we will agree to the terms, click finish, and create. The one key step that they've changed in this process, I'm going to show you next. So it'll bring you to this screen. What we now need to do is go to audience. We need to do two things. It's an external app. So we need to allow ourselves a test as a test user. So we'll go down to here to add users. We will go to here and put in our email, and we will save that there. So we've added the test user down here. We're also going to publish the app. And the reason we're going to do that is if you have it in testing mode, it will sometimes ask you to re-authenticate every 7 days. But if we have it published, it's not going to ask us to do that. So we'll publish that to production. We will then go back up to the navigation menu. We'll go down to APIs and services and go to enabled APIs and services. Click on the plus icon up here. And this is where we allow access to certain apps within the project. So we're going to type in Drive and we'll go to the Google Drive API. We will enable it to give permissions, and we'll do that for all of the apps that we want to give access to. So we've got Google Mail, Google Drive. So the next one, we will go back, type in Mail, search, enable, etc. We'll do the same for Calendar, and then Google Sheets, and just the same process there. Google Calendar API, enable, go back, Sheets. Those are the key ones that we usually use. We'll enable that as well. Then what we're going to do is go and create our credentials. So we'll go to the navigation menu, APIs and services, credentials, and now we'll set up this OAuth client ID. So we'll go to create credential, OAuth client ID. We will call it a web application, and we will say n8n as the name. And now here we're going to have to put in our redirect URI. So we'll go back to n8n, click to copy redirect URL here, and we will paste that into our authorized redirect URLs, and we will create that. It says it may take 5 minutes to a few hours to do so. We will then have the client ID and the client secret up here. So you just copy that, and we'll go and copy paste those directly into n8n, and don't share with anyone else your client secret. And it will pop up with this OAuth 2.0 sign-in button. So we'll sign in with Google. We'll hit the same account that we've put on the test account, and it will come up with Google hasn't verified this app, but you just need to go to advanced, go to elastio.app, or it might say a different server name, depending. We'll give it permissions, and voila, we've connected. So that is how to connect. You'll then have access, and you can see that it will now give me access to all my different calendars. You need to do the same for each of these Google apps. So you don't need to do the whole process again. You can just go into the Google Drive account, copy in the same client ID, client secret, connect, and save. So I recommend going through, once you've done the calendar, going through all of the different apps, so that next time when you load it up, you will just be able to hit the drop down and click to the correct app. Final recommendation is actually, if you go into edit, you can give these names. So say, for example, you had a personal account and a work account, give that a name, because you're going to go back and there's going to be a lot of different accounts in here if you're using multiple accounts. And that's it. Now that you're connected to the correct calendar and it's authenticated, i.e. it's allowed you to access that calendar, you can come down here and select the calendar you want to have access to. So mine is simon@scrapes.ai. Actually, I've got two credentials here. I want to access my personal calendar, which is Simon Coton 602. So I've now got access to that calendar, and it's going to predefine how many meetings it can pull. So 50, I doubt you have more than 50 meetings in diary, but if you do, you can actually just return all like this. It's then asking for times. So between what time period do we want to pull meetings for or events for? And they've got the little question marks here, which give you a bit of extra info when filling out these sections. But we want to work out the before and after. So we want events after right now. And it's predefined this by using an expression. You'll learn more about this later, but you can see the result underneath is now's date and time. So if you're looking on your screen, it'll be your current date and time. If you need to change the time zone and it's not understood correctly, then you can hit dot to local, and it will find your local time zone. But if it's correct, you can just leave it as $now. And all we're saying is access the now object. You can see, again, we've got these curly braces, which we'll cover later in expressions. But for now, you just need to know that you can add or minus time in a straightforward way by hitting dot, plus or minus, and then writing the amount of time. So we know we're collecting calendar invites for today. So it gives us, if we highlight it, how to fill this out. So n is the period of, n is the quantity. So for example, you could do 7 days and unit is the unit. So this will be days, hours, minutes. So we're just going to say plus and get rid of the brackets here. And we'll fill it out in this format, plus 8 hours. And make sure hours are inside quotation marks. Otherwise, it won't recognize it. And you can see now it's added 8 hours to my time. So we're saying we want all calendar events after now, but before now plus 8 hours. We're going to come back to the canvas. What we want to do is just drag this up here, and we're just going to connect it to our first node, and we can actually run that now. So at each stage, you want to be running this to see what the outputs are. So it's run successfully, and it's returned 7 items. So let's have a look at the items it's returned. You can drag and drop this middle section here to make it easier to read on your screen. So what you'll be able to see if you've connected it all up correctly are your different events that are on in the next 8 hours. And it gives you a summary here, the start date and time, and the end date and time in a timestamp format, who the attendees are, the creator, and just the description as well as the link. So you can pull in your automation or in n8n any of this information, and that's the power of being able to automate anything you want, is all of this information is readily accessible and really easy to pull. So what we're going to do next is go to the end stage, which is sending our email. So similar to what we did before, we're going to open this up and we're going to connect to Gmail. And you can see there's a lot of options here, but we're just going to send a message because we want to send ourselves an email. And right now, because we previously clicked on Google Calendar, it's connected it up automatically to our Google Calendar. And you can see, although it looks a bit complicated, all of the data that we just saw on the left-hand side. And you can see that in a table format too, in the same format that we saw before. So what we're going to do now is, again, make sure you're correctly set up with your credentials. So exactly the same instructions you followed for the Google Drive. Take the same credentials, i.e. the client ID and client secret, and add them in here. And that will make sure that it connects to the same account again. So for me, that's my personal Gmail. And we want the message, and we're going to send a message. So our operation is straightforward. It's already set for us. And I'm just going to send it to myself. So type in your own email here. And you can see that it's now just the of what actually the information we're going to send. So all we're going to do is type hello and then hi to ourselves. And the key here to understanding what this is going to do is going to be found by going back to the canvas. And you can see that we've got 1 item moving between the schedule trigger and the calendar trigger. We've actually got 7 items moving between the Google Calendar and our Gmail. Every time there's multiple items going into a node, it's going to send or activate it multiple times. So this would actually send 7 emails, each with hi Simon and hello subject. And I can show you that now. And you can try it yourself. It's just going to send 7 emails. If I go to my Google Mail, you'll see it's just sent all of those hellos. So we obviously don't want to send 7 emails, 1 per event. We want to send a combined one. But also these emails at the moment just say, hi Simon, hello. And actually we want it to contain the content of our calendar. So those are the 2 steps we're going to do next, and that will complete our automation. So the first part we'll show you is how to get this data into the email. So say, for example, we wanted the meeting name or meeting summary to be the subject line. We'd delete that in here. And there are 2 ways to do this. We could go to expression and type out a JavaScript expression, but that's actually not the easiest way. So what we'll do is just drag and drop this field across to here. And you can see that it's populated with my summary email. And I can click on here to see, because we've got 7 items, you can click through and see what all of them would be called. Inside the message, maybe we want to add the description. So instead of having this here, again, we'll drag and drop the description. So now, whenever I send these emails, if I send 7 again, in my inbox, each with a description of the event. So we're going to come back out here, and now we know how to send to ourselves from our Google Calendar. We're getting all the invites, but we basically need to combine them all together and format the data. So you'll notice as you build more automations that you effectively have the building blocks of an automation are what activates it, which is the trigger, what information are we getting and from where, which in this case is our daily events from our calendar, Where are we sending it to, which is our Google Mail in the send email, and how do we format that? And those are all of the building blocks to all of the automations you build. If you can understand those basics, then you can build out anything. So we're going to delete the connection here, move this across to our send email, because what we're going to need to do is combine all of these 7 events into one, so it's a nicely formatted email. So the next thing we want to do is format that data. So we know that it's coming in 7 different items here. And actually, you can see that there's a lot of data. And we actually just want the summary and the description and the times. So the best node for this, and you'll use this a lot, is called the set node, edit fields /set. And that opens up and you can see our inputs from our Google Calendar on the left-hand side, the transformations in the middle, and the outputs on the right-hand side. So we are just going to drag and drop 3 different fields. If you click in here, and in fact, you don't even need to click, you can just drag. So we know we're going to need the summary, so we'll drag that across first. We know we're going to need the date time within the start here, and we know that we're going to need the description. So we've pulled all 3 of those fields across, just like that, drag and drop across. But you could also define them here. If you wanted to change the names, that's fine. So let's call it summary, time, and description for ease. So we now have that data being pulled through. And if I double click into that, you can also just test the step directly in here. It will activate the previous nodes. So you can see now, compared to the left-hand side where we've got a load of data, we've just got the data we want to deal with. And that's what the edit fields or set node is really powerful at doing. So we've still got 7 items, but it's cleaner data. That's the first step. The next step is how do we get from 7 items to 1 item? And for this, we use an aggregate node. So if we go into the data transformation category here, you've got various nodes here that can split out data, do the opposite of what we're trying to do, or aggregate data, combine a field from many items into a list in a single item. So we're combining these fields, and what we're doing is we're putting them into a single item, as we know. But at this point, we're starting to think about what format we want our response in. What format do we want to receive as an email? So I've opened up an example of how I think we want to receive this data, and you can change this how you want. So it's just happy day. It's got the date in the title, in the subject line. And then we've got the different meeting start times and then the description or title of the meeting. We can also add description in here, but let's just keep it simple and do the time start and the time it starts and the subject. So if we go back into our automation and go into our edit fields node, you can see at the moment we've got 3 separate columns. We don't actually want description here, so we're just going to get rid of description for now, but we want the summary and the time. So we've got it in 2 separate columns, which is fine, but it's going to prove challenging when we want to combine those in an email. So what we should probably do in this edit fields node is actually just combine them beforehand. So what we can do is just copy and paste this from here. And because this is an expression, i.e. we can change it, it's dynamic, we can actually just copy that into there, put a dash between, and now you can see we've got the date time followed by the meeting invite. Another thing you'll notice is this date time format. So in n8n, you can click dot, and there'll be first we'll have to convert it to a date time. And then if we hit dot again, we can format it however we like. So we wanted the specific time of the meeting. So what we can do is click the link here. It takes us to a page of what values we need to put in to get out the example that we want. So we wanted hours and minutes. So if we want it to show the hours in 24-hour time. So we'll put HHMM. So instead of this year, month, date, let's just put our HH in capitals, MM, and we'll just put a value between. So now you can see in our result that we've changed that to 4:30, and then it's got the meeting name, exactly like we wanted. So we can now get rid of the time field because actually we're just summarizing a meeting. We'll test the step again, and you can see each output now is in the format that we want. We still have 7 items, so we're going to go back into our aggregate node, and actually now we're just combining one field, and we're going to test that step. And the reason we're doing that is because if you remember, the 7 items connected to the Google Mail will send 7 times, so we want to make it into 1 item. So it's now appearing as 1 item, and if you look at the data format, you can see it's in this object or this list. If we try to send that directly to Gmail, let's see how that works. So let's go into our Google Mail, and let's get rid of the subject and the message and start again. So we want the message to be the summary, which as you can see is this array object, which is just a list of all the different values. And then we wanted our subject to be Happy Tuesday, for example, with the date. So we know that we're going to need to put in an expression here to make it a dynamic expression. So go back to the page that we had before, and it shows us that if we put 4 capital E's, it will give us the day of the week. So we'll put our curly braces here. We will go down to now and click, and you can see it's populated with our date time. And then we're going to hit the format button like we've done before. And all we need to put in there is EEE. And you can see that that's populated to today. And then we will do the same with just curly braces, now, format. And we just want it to say the date. So let's put in year, dash, month, dash, day. And you can see that we've used capital M's here because if we use the lower M's, that would be the minutes. So we've used capital M's there, 11th of March, 2025. Great. So all we've done is dynamically populate the subject there so that each day when it sends to us, it's going to change. And all we're doing is just taking some JavaScript expressions, which look complicated, but actually just simple ways to write things that so that they change every single time based on the input. And the input here is just time, so our day. In the subject then, we've just got the drag and drop of the summary over here. And you can see that that will appear as this list in our email. So we're nearly there. We're super close now. We've just got one more stage and I'll show you why. Let's test our workflow. And we've run that and it's actually come up with an error. And this is part of the journey of building automations. You will have to troubleshoot at some point. So on the right-hand side, it will tell you the error summary. And then inside it's got a more complex answer of what the error is. This one's a little bit complicated, but I know that something that I'm passing through in the data is causing the error. And from my experience, I know that it's probably this object because it's not just a string or a set of characters. It's actually a bit more of a complex object. So from my experience, I know that I can type in json.stringify to turn this all to text, basically. And it's going to appear like this. Don't worry about too much of the details. This is not what we're going to do anyway, but let's test it. And now it's successfully run. We'll go back into the email and just check that we've received that. And now you can see we've successfully received an email with the day in the subject and the date in the subject. And then we've also received a quite ugly looking string inside the email here. And then afterwards, it's got this email was sent successfully or automatically with n8n. So what we're going to do is just the final stage is putting this in a nice looking list. So we'll go back to our automation and we're also going to remove this attribution down here. So to remove the attribution, we can go to add option, append n8n attribution, and we will turn that off. That will remove the attribution. To get it from a list to a nicer format, what we're going to do is add what's called a code node. So we'll bring up the code node here. And for sake of this demonstration, actually, what we're going to do is just copy and paste this code node that I'd pre-created, and we're just going to run through it. So the code node is for functionalities when n8n doesn't have a pre-configured way of doing something. So one example of that is where we've got this list, which looks lovely here, but you want to send it in a format that the email will display it with a new line every time. So all we're going to do is have a look in the code node. On the left, we've got our inputs, which is our list. So if we look at the JSON format, it's just this list. And all we're going to tell it to do is take the input items. And like I said, don't worry about the code here. It looks more complicated than it is. Everything with a double dash here explains exactly what it does. And later when you do the full beginner course, you'll learn exactly how to write these code nodes and why they're important, but they're infrequently used. But I just wanted to show you that in this example. So we take all input items from the left-hand side, which is our summary and each item inside it. We say, okay, take the summary from the array, which is just this list, join the array elements with new lines. So basically saying just add a new line every time you come across a new item. And when we're writing that technically, all that's doing is adding a \n on the end. And that tells the computer when we send it via email to put it on a new line. That's all it is. And then this is just in case that doesn't happen, throw us an error. That's it. So if we run that, you can see it's returned a formatted list that doesn't look much better in here because it's got these \n's, but it's removed all the curly braces, etc., the array here. But once we send it to our email, if we run that workflow now, we will just come into the Google Mail and update this to our formatted list. So what we'll do is we'll just drag that over here. And you can see, if we open this box up here, that this is what it's going to appear like in our email, which is exactly what we wanted. So let's run the whole test workflow. Let's open up the email. And there we go. We've just received the email 0 minutes ago, and it's listed all of our meetings. So we have one small final stage, which I've just noticed here, is these are not in chronological order. So let's go back to our workflow. We'll go back to the Google Calendar event. And what we're going to do is just add the option order by start time. You can then resend that and you will get exactly the same email. And to make that happen every single day, all you need to do is change this flow to active. And now it will continuously run every single day. And you can see by going into executions all the historic logs of runs. And that is it. You've made your first automation. Congratulations. This is a huge step on your journey to automating a lot more in your business. And by getting this far, you should really be proud of yourselves.
So again, well done on making your first automation. That one was definitely the hardest. Everything gets easier from here. And now we're going to jump into the 13 nodes that you need to learn and you need to understand to get 80% of the value from n8n. That's literally it. So n8n has hundreds of nodes, but 13 of those nodes are going to give you 80% of the value. So let's jump in and just learn those nodes now. So let's talk about the 13 nodes here. And we'll start with the execution essentials, as I've called it. So there's a few conventions when you're starting with n8n that you need to know and are really important when you start building out more complex workflows. The first is flow direction and order. So we have some sample nodes here to demonstrate this. If I have like a trigger here, and we'll talk about triggers in a second, and it's connected to multiple flows. Firstly, if it's connected to just one flow and we run that, everything runs from left to right. So you can see how it's run starting with this manual trigger and running left to right. The second thing here is actually if we connect it to multiple flows, where we have flows at the top and flows at the bottom, everything at the top of the flow will always run first. We can demonstrate this by running the top flow, which you can see is run here. And the second flow is still running at the bottom here, where we've just got some example data and a wait node. However, if I drag this up to the top here, you'll see that actually this executes first because it's at the top of the flow. And then it jumps down to the second flow, which executes last. You can probably see when those two run at the same time, actually they're not running at the same time. And this is called sequential execution. So by default, n8n executes nodes synchronously, i.e. one after the other, not in parallel. So when we run this, it will run the top flow first and every node executes individually, synchronously, one after the other, and then it will continue to execute those. If we have these connected up to the same node here, you'll see exactly the same behavior where it will run the top flow first to its completion and then run the bottom here. The next thing you need to know that nodes will run once per input. So if you have 5 inputs, it will run 5 times. And you can see this demonstrated here where we have some example data, which is just some lead data, which we'll continue to use throughout this demonstration. And you can see we've got this nested data of different leads. So if we look at the schema output here, we can see that this is a leads array and it contains information of multiple leads. So this is Sarah Johnson and we've got Michael Chen, and each of those lead components are contained inside this JSON array here. If we decide to split that out into individual components, we can see that now we've got a structure that's more familiar with a database table where we have each person or each lead in a separate row. And once we split that out, it's no longer in one combined array, i.e. one item, it's now in 5 items. And then when we hit this condition here, which is if a condition is true, you can see that 5 items are passed into this if node. And we can actually see in the run here, or the first run where it received the top branch, actually it processed 5 times this condition. So for each input, it processed it once. The second thing you'll be able to note here is branching. So you can actually split workflows into multiple paths using conditions. So say, for example, this data was being passed through in the top here. We might have a condition that says, if before this date, take this action. If not before this date, then take a different route. So we're able to actually branch and take different conditions, almost like if this, then that actions, some deterministic actions based on the data itself. And then the final thing that's really important around conventions is that your workflows will start as inactive up here. But actually, if you want it to be activated by external data, then we need to come up here and we need to click this toggle to activate the flow. But we can only do that when we've got a trigger that needs to be activated externally, like a webhook trigger, a time-based trigger, etc. And without activating it, none of this will continue to run unless we are manually running it in our test workflow node here. So with that being said, which then are the most important nodes that you need to know to get the most out of n8n? We'll start with some of the basic triggers. Now, you've already seen this manual trigger. This manual trigger you'll continue to use again and again. It's very straightforward. It's basically when you click this test workflow button, the manual trigger will run. That is as simple as that. They've also got this test workflow button that's connected to the manual trigger itself. You will use this continually throughout testing. We then have a cron trigger, or a schedule trigger as it's called in n8n. And what we're able to do inside the schedule trigger is define at what interval this is going to happen. So for example, we could say every 1 day at at 5 a.m., we are going to run this workflow. And to make that happen, we then need to activate the workflow like this. You can see we can now activate it because this has been turned on. So this is useful for things where you want to run something at a specific time. Maybe you have a daily report, a weekly check, something like that. You will always use things like schedule triggers. And you can even get as complex as doing a cron job, which is defining exactly which day, month, hour, second that something is going to run. But mostly you're just going to use the inbuilt seconds, minutes, etc. to run those. The next trigger that we've got are app events. So we use n8n a lot to connect to our external apps like Airtable, Google Drive, OneDrive, Dropbox, Outlook. And actually, this is why workflow automation is so powerful, because we can connect to all of our business software. So we've got an example of the OneDrive trigger here. And inside the triggers, we've got this on app event. So this runs the flow when something happens in an app. And here we use an example of OneDrive. So say something is updated in our OneDrive, we can basically ask OneDrive every minute or hour every day, the same as the time-based trigger here. But we're saying check a condition every X minutes. And we're saying the condition here is going to be a new file is created or a new file is updated. Or in your Google Sheet, this might be a new row is added or data is changed. So pretty much any condition you can think of can be activated specifically through a specific app. So let's say Google Sheets. We click on the Google Sheets node here. We've got 3 triggers: on row added, on row updated, or on row added or updated. We can trigger an action, which would be, in this case, our workflow. So those are the core triggers that you'll end up using in n8n and need to understand. We will then look at universal data processing. So you will start a flow with some sort of activation trigger. It always needs to be started with a trigger, i.e., why should this workflow actually start? This universal data processing is all about what should you do with the data that you receive in order to transform it. So we've got our leads data again here with Sarah and Michael, and there's a few key ones you'll see again and again in your workflows, and I use continuously. And once you understand these, you'll understand the 80% of what's important in data transformation and how to use those. So we've got this leads database, and let's just run this through here. We can see that inside our schema, which is a view of the data that's nested. So we've got this leads here. So that's that leads array here. And inside that, we've got individual items, or it's nested in an object effectively. So each lead is split into this lead and then the index or the number. So for example, we've got Sarah Johnson, which starts at 0 because all of our indexes start at 0, or you can see it in a table, but you can see it's one object still. Now, when we're coming to process that data, we often want to flatten the data structure in order to be able to turn this into a data set where it's split into rows, for example. So right now it's one giant object that has a nested structure, and you can see that in here. It's a nested structure. But if we wanted to flatten that data structure, as it's called, we would use this split out node, and you can see if we run that exactly what happens. So we've gone from one giant data array in here to individual rows where we split out that, and we can decide based on the inputs for how we're going to split that out, and we can decide also which fields we want to split out there. You might have the inverse problem where actually you have all of these rows of data, but in some cases you want to group that all together. Say you're passing that data set through into an AI node or an LLM chain where you don't want to pass 5 items in. So we spoke about earlier how each item is processed once by a node. If you actually just want to pass in the data set as a whole, so the whole leads data set, then you might have this data to start with in rows, and you want to aggregate that data. So it's more like the input we had to start with, which is actually grouped together, and you can process it in one go rather than running a node 5 times. So in this case, we'd use the aggregate node, which actually pulls together again the leads back into this nested structure. And you can see we've got exactly the same as we had before because we've aggregated all of our data into a single list and decided to include all of our fields there. If we wanted just the name, then we might say, let's just do first name here. We'd have to name it exactly how the input data is. And it's just going to give us an aggregated data set of those names. And we can effectively put anything here. We could put second name as well. And we'd run that through. And sorry, it should have been last name. And you can see now it's aggregated just those values. So that is 80% of data manipulation in terms of flattening and merging that data set together. And you will continue to use those a lot. We then have the set node, or edit fields node, as it's now called, which is a way to effectively create and modify data fields. And you will find yourself using this a lot when you have a large set of structured data coming in. You might only want to call out specific fields that you want to process and move on, so you're not processing too much data. And for this, we'd use the set node. So if I pass in the split out data here, what we might want to do, for example, is manipulate the data in some way. So say, for example, that we want to make full name from this first name and last name because we want to send these leads an email with their full name. Then what we would do is we would just create a new field in this set node. We'd call it full name, and we would effectively turn this into an expression which says I can now receive dynamic values from the data that I'm receiving. And I would literally just drag and drop the first name, and I put a space between them and the last name here. So you can do as much data manipulation as you want with JavaScript expressions here. But the point is we can actually manipulate data or only pass through the data that we want with these set nodes. So say I wanted to pass through the full name as we've got up here and all other data fields as well. If we process
that, you can see we've now got everything, but also the full name column at the end. So we've added to our data there. But say I just wanted the full name and I wanted to get rid of all data. If we had thousands of rows, then we might want to strip out the data to just the bits we need. And I might say, okay, actually, I just want the full name and I'm not going to include any other input fields. And I'm just going to pull the full name here. And we can add as many fields as we want. We can also drag and drop them over here and they will automatically populate with the fields that we want. So say we wanted full name and email only, we could do this with the set node. And it's a really powerful way to strip out the data and kind of clean it or manipulate it to exactly how you want. We've then got the if node. So you will see so commonly, we've got to make a decision where we branch in two directions. So if this condition is true, take this route. If this condition is not true, take the other route. So we would just have a condition connected here where if the full name, that shouldn't be an expression, is equal to Sarah Johnson, let's say, let's specify Sarah Johnson here, then it's going to be true by default. Everything that is not Sarah Johnson is going to be false by default. And you see that's come up with all false there. And that's because I've not actually pulled in dynamically the full name column here. So this is now comparing the full name column to Sarah Johnson. And you can see that that is now true for one branch and false for the other. So any items that are in the true branch can take one condition up here and any in the false branch can take a different condition and do different actions off the back of that. So that's really powerful. Another way to do that is the switch node. We're not going to cover that today, but that's if you have more than two conditions and you use a switch node to say, if this condition is true or if this condition is equal to this, then take one of these 4 to 10 routes instead. But the point here is conditional branching. You can take different actions based on the route. Now, the code node is the last one in the data processing that you might have to use. And this is when you need custom manipulation of the data for more complex transformations that are not available inside the n8n nodes. And you can often use something like Claude or GPT to help you craft these. And I'm going to show you very quickly how you can just craft this code node very easily. So let's say that actually we're going to put a comma, just for argument's sake, between the first name and the last names here. We're going to pass through all of the data. So now we've got the whole data set, but we've got Sarah, Johnson. And what we're going to do is get rid of the if node. And we're going to say all of the data that's going into this code node, we want to take the full name and we want to strip out the comma. So this is something that would be harder to do with traditional nodes because it's more complex. We're pinpointing an exact character that we want to split by. But once we open this code node, we can say we want to run it once for all items that come in. We want to choose the language. I commonly use JavaScript because that's what I'm familiar with. And then it will populate with an example that says loop over the input items and add a new field to the JSON of each one. So the example basically loops over all the items and we can see it here and adds a new field called myNewField1. Now, if we wanted to, for example, strip out the comma, then we're going to need to find the JavaScript to understand where the comma is in the field. We're going to need to point it to the right field and we're going to effectively have to strip out that comma and call that a new full name field. So for simple use cases like this, I would go to Claude, I would copy in this code example and I would say using this format and I would copy an example of the JSON data. And I'd say in n8n code node, help me create a node to strip out comma characters between a first name and surname and populate into a new field called full name new. And then I would copy the data set in. So I've basically said, this is what I want to do. I've copied the data set in and using this format from n8n code node. And then I've copied in their example. And what that's going to do is spit out a draft code node that I can go and very easily put into here and we can test that. So I'm going to copy that directly into the code node. And this is how I would build all code nodes. And you can see it's put some comments in here. So it's looking for the comma, it's going to remove the comma and any extra spaces. It understands because we pass in the data that we're basically going to grab the full name field here. So it says item.json full name. And when you distill this, it might be quite complex if you're not used to JavaScript. You can start to read through and understand each of these because it's for us. And let's give that a go. And it's done exactly as we said. So full name new column, Sarah Johnson, Michael Chen, Jessica Williams. So we've used that for some more complex data manipulation. And you don't need to write these from scratch. You can start basically troubleshooting with something like Claude and actually get 90% of the way there. So that is the code node there. And I will put those all back. Once you understand those concepts for universal data processing, that is actually the time where you will spend most of your time when you're building out complex automations, either for your business, yourself, or your clients. And is often seen as the hardest parts. But once you understand those nodes in its entirety, that is actually honestly 80% of it. We'll talk a little bit about connectivity and APIs. So when there is not an inbuilt node for a specific app, so say, for example, we've got Google Drive in here, that is a specific inbuilt node for a specific app. But when we do not have that, we need to connect to an API or connect to a web page, and we use a HTTP request to do so. So this just allows us to connect to any external source through one single node. So you use HTTP requests a lot to connect to different API endpoints if it's not one of the 1,000+ nodes that are already inbuilt to n8n. There are two most commonly used request types or methods for HTTP requests. The first is GET, and as it sounds, that retrieves data. And then we have POST, and as that sounds, we send data or we post data to a service. So I've got an example here that will make this very straightforward. straightforward. And then we'll talk about how you authenticate it. We've got dummyjson.com/products. And if I go to this web page here, you will see that this is literally a site designed so that you can make fake HTTP requests or API requests and retrieve dummy product data to populate your service. So this is going to give us basically a product endpoint, which is just a URL we're grabbing from a bunch of product information if we request information from it. So we've got down here, get all products, and it tells us we need to fetch from this URL here, which is our endpoint that we're grabbing it from. We go back to n8n. All we're going to do is copy that into the URL column, get rid of the quotations around there. And because there's no authentication required, i.e. we don't need to prove that we are who we are, then we can just actually run that. And what that's going to run is it's going to give us a bunch of product information. So you can see Essence Mascara, a bunch of information around the actual product, some reviews. And this is all fake product information that we're just pulling from this service. And you can see it's in one massive nested object like we had before. So if you were going to use this product information, you might want to use the split out node like we had before. And then you can see it's got all of this information. So actually a lot of information pulled really, really quickly from there. So that is how to grab data. And you'd use this if you wanted to grab data from an external source that is not available inside n8n. You just need to figure out the endpoint, and that would commonly be in the API documentation. Now, if we wanted to post data or send data, we could find one here that says, okay, if we wanted to add a new product, then we're going to need to send it to this URL endpoint. So we've got this dummyjson.com/product/add, and I'll just duplicate this so that we've got it in the examples. So this is going to be our post request because we're sending data, and we're going to post in that new URL. So this is if we are sending data to an external database or API system or system. When we're connecting between systems, we are actually sending data to update it in a different place. So if, for example, here we're going to add data, then it tells us we need to use the post method. So it'll always tell us which method we need to use anyway. It tells us we need some headers. So when we send a request, we have these things called headers, which basically just tell the receiving system or computer what kind of information it's going to receive and where it's coming from. So the authentication here, which we'll touch on in a minute, it will tell it in the headers what kind of authentication key is coming. But in here, for example, we've got the content type as a header. So we remove these quotation marks, and we're just saying that we are sending data in this format, application/JSON. So we are sending JSON data, which is our structured object data that you saw before. We're sending that. By default, n8n actually sends it as JSON data. So you wouldn't need to put in this header type, but I've shown you so that you can see other header types. And then that is it for the headers. You can see the headers section there. Inside the body, we're actually going to send the product data itself. So you can see here BMW pencil, and it's just said, turn this into a string or a set of sentences or characters. You don't need to worry about that. So we'd actually send the body here if we're sending data. And n8n makes this really simple because actually all we're going to do is say, okay, the title, which we know is an attribute of this product, we'll say BMW pencil. And actually, let's give that a go. And what that response has told us, so we get a response from the system, is actually we've added that to the system and we've given it ID 195 with this product attribute. And we could add as much as we wanted. And I'm sure we could add some other data as well. Maybe they have price. Let's see if we get a rejection there we go. It's because it's an open system, it allows us to effectively put in any attributes and it will always receive a positive response. You will sometimes get back here a negative response, which often means you've sent the wrong data or you've mapped it to the wrong field. So say price didn't exist on the other side and I was trying to send it as price, then it would get cancelled and tell me I need to try again and rename the field, and the errors would come up there. The final thing about HTTP requests are authentication. So if we were sending to a service where we would conventionally have to log in, we'd often have to use API keys or authorizations like passwords, and we might use these generic credential types. And credentials are just our way of proving that we are who we say we are in order to add data. So the most often one you'll use for this is a header authorization. Like I said, this gets put into the headers automatically, so we don't need to add it here in the headers column. We would create a new credential, and inside the service API documentation themselves, it would usually say something like, we need to enter in the name authorization, and 90% of the time it's authorization like this. And then inside the value, we'd put, most commonly, we'd put bearer, the word bearer, space, and then we would paste in your API key, which you'd be able to grab from the service. This would appear as obstructed like this, obfuscated rather, so we wouldn't be able to see it. But what that means if we're saving it in there is that actually in future, we can access that through header auth account 3. And you can see I've got a few examples in there. And there's lots of different examples that I've used in the past here. But if you go into any of them, you'll be able to see that this was the header name. I go into Firecrawl, you've got authorization and then bearer / the key. But it means that everything is obfuscated when we send it because it's saved as a secure credential here. But in this case, we didn't need to prove who we say we were because this is a demonstration website. Now, on the other side of connectivity and APIs is when we actually receive ourselves data from an external service. So if we're not requesting it, i.e. we're not sending a HTTP request, we can actually get other services to send it to us and we receive it via a webhook. So you can think of this as a
HTTP request in reverse, we receive that data that's sent to us. So for example, we'd have a webhook trigger here, which if we go into that has an address, a webhook URL, exactly the inverse. This is the URL that it's going to send data to us. So we can see this is a GET request. And what we do is we just click to copy this webhook URL. So if we're running this in test, we would literally click this here in test, and we can go to a service like Postman, which is basically for testing different API endpoints, etc. We can try and send a new request, and we'll send a new request to ourselves. I go to test webhook. In here, I'm able to send a mock request, and I'll post in the address that I want to receive that request to. And we will just say, okay, inside the body, let's add some form data. Let's call it test, and let's say hello. And we can add binary files, we can add PDFs, anything like that, any form data we want. And what we're going to do is we're going to come out here and we're going to say listen for test event. And what we're going to do is send that request. Okay, so we tried to send data for post requests here. We tried to send something in the body, but this is actually a get method. So this is a good example of where we'll stop listening here. We'll turn this to a post request because we're receiving data. And actually, let's just make sure that we're sending it to the right address. And let's activate that test event again. And we should receive that test hello here. So it's saying actually it's sent the data. And you can see we've received information from the headers. So like we said, it's basically told us information about the system that's sending it, including the content type. And then we've received in the body here the hello that we sent. So basically, you can send predefined sets of data from external services to a webhook and receive that data and use that often to actually activate a workflow. So a good example of this is maybe somebody purchases your product through Stripe. You are getting Stripe to send you information via webhook. So you don't need to request it every minute from Stripe. So they will send information to your webhook, and that will then activate your workflow. Then the response to webhook node is effectively what information do you want to send back and when do you want to send it. So when we have this response to webhook node, which we need to use when we have a webhook trigger, we could have this at the end of the flow, which says actually just respond with all incoming items. We could say respond with the first incoming item. We're basically telling the service that we've received their response successfully and we've communicated that back to them. Once you get your head around all these HTTP requests and webhooks, you're honestly 90% of the way there. We've then only got two other core sections to discuss, starting with storage solutions. So after you've manipulated your data, you've grabbed data from external data sources or received it from external data sources using a HTTP request or webhook, you've manipulated it using these universal data processing, then one thing we're going to need to do is actually use some sort of storage where we're actually sending our data to. So if we're not sending it to an external surface, you'll often be connecting to maybe a Google Sheet or an Airtable or a database that you use or Notion or any of those storage solutions. So the most commonly used ones are Airtable and Google Sheets, but the same concepts apply here for multiple. So if, for example, we were going to grab data, let me just bring that node down here, we would effectively have this leads data again, which we'll use as we're familiar with that. And we'd need to process the data and then add it into a Google Sheet. So if we're doing it for something like Google Sheets, then we need to make sure that we create the sheet first. So we'd open up the Google Sheet node and we have an option here, document action, to create that spreadsheet. And that is just this here that I've renamed. And we're creating a document and we can give it a random name here. And what we're then going to do is append the data into a Google Sheet. So we're going to say, okay, based on that Google Sheet ID, let's append that data. So for example, let's run this now. And this is an important error here to take note of. If you're testing multiple nodes like this and you've not set up the others correctly, then you just need to go here and actually deactivate that node or hit D on your keyboard. It will deactivate those nodes which are causing errors. Any of these, let's just deactivate so that we can make sure we can run through this. So if we hit test workflow, it's going to run through. It's now created a Google Sheet for us. So it's given us a spreadsheet ID and the properties of the spreadsheet. We have our leads data there, which we've then split out into our individual rows as we saw before. Now what we want to do is actually store that data somewhere. So what we're going to say is, okay, we're going to grab the document that we created before, which you can see in this schema view here is actually in here, this create sheet document. We are going to put in the spreadsheet ID here. And that says, okay, grab the spreadsheet that we've created before and add this data. And what we're going to do is we're going to append the rows of data from the last node, which you can see are our individual leads here. You can see that in the data here are individual leads from the last node. And what it's going to do is just put it into the specified sheet. Now, if we've already created a sheet, we don't need to do the create sheet stage. We can actually just link it up to a specific URL or from our list. Because we're creating a sheet as we go here, we're going to say, okay, put that information to sheet one. And instead of mapping the columns manually, because there's currently a blank sheet that we've created, it's got no columns. What we're going to do is just tell it to map the columns automatically. But if there's a blank sheet already and we don't have these names in here, like ID, first name, email, company, etc., then it's not going to add any data to the sheet because it's not going to be finding the column headers. So what we need to do is tick this option, handling extra fields in input. And we're going to say, okay, for every new column, when they don't match a current field, insert it as a new column and add that data. So let's run that and we will open up the Google Sheet, which you can do directly from in here. So we've got the items split out. Let's open up
the Google Sheet, and you can see it's automatically added those new columns for the fields that it didn't have before, and it's added the data to a sheet in a more familiar format that we're comfortable with. So once you've manipulated the data using these steps up here, you can actually then put that into a usable format for yourself. The exact same applies for Airtable. It's just Airtable is more of a database than a sheet. So we would choose which base we want to access, etc., and add that to a database or storage solution that we can use. You so commonly in n8n will need to add this to a usable format like Google Sheets, etc. Same applies for any other database. Similar concepts, just different operations in here. We can also do things like manipulate the data, receive the data, only change the data when an update is needed rather than refresh and append new data every single time. But we're not going to cover that here because you just need to know that you can add it to a database and grab information from that database. And equally, you have on the other side the Google Sheets trigger, which will effectively be if a new row is added, then we can use that as a trigger to start a new workflow here. And let's just deactivate those here. And then we will look at the last of the 80/20, which is, of course, AI integration. So we have two core sets of nodes in n8n. They're going to be most important for you if you're actually leveraging AI. So the LLM node, or the basic LLM chain as it's called, you can access through here, through AI, and we go into the basic LLM chain, is exactly the same as if you were talking to ChatGPT, although we enter our message inside this source for prompt, we define it below, and we put it into this user message field here. Now, when would you use an AI node versus just using the if this then that logic? Basically, when judgment is required. So if your flow is going through and if this condition is true, do this. If this condition is not true, do this instead. If that traditional deterministic logic is not going to be good enough, i.e. you need some judgment in there, that is when you would advance your workflows using AI, and not until that point is true. You don't just use AI to process things that you can process through normal workflows. So traditional nodes work perfectly for examples like if this invoice is greater than $1,000, send to approval. You don't need AI to do that, but it falls short that when you need that sense of judgment or human judgment in there, because they fall short if you have an example like if a customer email suggests they might cancel, then flag for retention. So it's going to read the language in a customer email and flag for retention. Now we could say if they say this specific word, then flag it for retention, and that would be deterministic. But if we are saying actually understand the sentiment of the incoming message, whether it's positive or negative, and therefore flag it in an appropriate way, then that is how we're going to use this. So as an example here, we're going to use the sentiment, and what we've got is an incoming input, which is a customer message. And here we said the customer service is awful. And inside the basic LLM chain, like I said, we define the prompt below and we put it into this user message here. And if I just deactivate this and connect the chains, let's run this input so we can see exactly what's being input here. So we've turned this into an expression again, because we want to take the customer input from here. And all I've done is a very, very simple prompt here. Determine if the incoming message is positive or negative and return a summary of sentiment and reasoning. So we're asking it to make a judgment, and then we've actually grabbed, and you can do this by grabbing this again over here and pull it in here. And that just puts the input inside here. So now you can see if you open this up, this is actually what the LLM chain is going to receive. Turn a sentiment and reasoning. And then we should probably say something like the input is the customer service is awful. And that's going to process. There's a couple of things else you need to know to use the basic LLM chain. The first is the model that you're connecting to. So I tend to use OpenRouter, which allows me to connect to any of the different models and change them really easily through one credential. So for here, we're going to use GPT-4o Mini, which is an OpenAI model, but you can also use things like Claude, Anthropic, Gemini, any model you want to use here. And the second is our structured output parser. So if we require a specific output format, we can tick this box and it will have this additional output parser here. And we can say, okay, let's give an example of what output we expect. And therefore it will give us in that output. So here where we're saying return a summary of sentiment and reasoning, we might say sentiment and reasoning. And we might say as an example, positive. Now we might say the customer seems enthused about the service as the reasoning. And we're basically suggesting that the LLM should return its outputs in a similar format to this. And I'm not sure I spelled sentiment right there, but it doesn't matter for the example. So let's test the workflow, and it runs through that structured output parser. And now you can see in the output, it's actually given us a JSON output, an object of sentiment, negative, reasoning. The phrase customer service is awful indicates dissatisfaction with the service provided, clearly reflecting a negative sentiment. So what we've done is taken a non-deterministic flow here and made it more deterministic by actually getting the LLM to make the judgment for us. That is where you want to advance your workflows here. There's also an advancement on this output parser, which is an auto-fixing output parser. So if you have more complex outputs, what you do is you connect up your model here, you tell it this is the output parser I want, and then the auto-fixing is just going to say, keep running until you get this damn output. Don't stop if you haven't got this output format, and it will continue to run. So it might run several times, but it will save you from it erroring out every so often. But we don't need it in a simple case like this, where the judgment is very limited. Now, the only other thing you would use here is an AI agent. So AI agents are so overused when they don't actually need to be used. You can often use a basic LLM chain for 90% of the AI work. And then even before that, you can use workflows for so much more. But an AI agent you would use in the case where you need to have an ongoing conversation with memory, for example. So record chat memory. You'd use it in the case where you actually needed to access certain tools. So say this was not about sentiment, or say it was about sentiment, and we actually wanted to draft an email off the back of that back to the customer, or a message back to the customer in our inbox, then we would connect it to something like our Gmail tool, and we would tell it in the prompt to draft the message inside our Gmail tool. And we would put this tool as to send a message or draft a message or whatever we wanted to do, label it as something. And we would then basically in the prompt tell it to actually use that tool that it has connected to take those certain actions. So you only need to use an AI agent here when something more is required. It needs to do some thorough thinking and interact with itself. It needs data access. It needs tool access. It needs to access its external service. Before that, you're just going to use the basic LLM chain, and that's going to get you 90% of the way. So all of those concepts are going to round up the 20% of nodes. They're going to take you 80% of the way to creating excellent workflows and also empowering them with AI integration. Now that you understand those 13 nodes in more detail, we're going to talk about one of the things that tricks most people or trips most people up when they are building AI automations, and that is working with the data. So when you're working with business data, you need to understand how to take it from one system and put it into the next. And that is all about data transformation. But most tutorials don't tell you that 90% of automation problems you'll face will actually just be data problems. And if you know how to connect apps, but you can't make the data work together, your automation will ultimately fail. So in this video, I'm going to show you all the core data transformation concepts inside n8n that will help you solve almost every problem you'll ever face with real examples you can use right away to make your automations better. So let's get started by talking about what JSON data even is. So JSON is effectively the language of data inside n8n, but not only n8n, it's also the language of data across the web. So it stands for JavaScript object notation, and it's so commonly used because effectively a couple of reasons. It's super lightweight, so it takes up very minimal storage, and that means we can transfer data between services very quickly, which is why often data loads very quick on the web, but it also takes up very minimal storage space, so it's cheap to transfer and store as well. You'll see in a minute when we look at some actual JSON data how human readable it is. And once you understand the core concepts of the keys and the values and all the terms around JSON, it actually becomes very easy to manipulate that data. Another reason is it's very easy. And like we said, it integrates well with web technology. So a lot of websites are built fundamentally using JavaScript on the underneath. And therefore, if we're using JavaScript object notation, it interacts well or integrates well with the web technology. So n8n have chosen to adopt this as well for all of the data that goes through the n8n nodes, even to the point where the n8n nodes themselves are actually just JSON data structures that appear in this nice visual format that's easier for us to see and interpret on screen on the user interface. So at its fundamental core, JSON objects are made up of key value pairs. So keys are like the labels. So we might have keys of like name and email, and values will be the associated values for those keys. So it might be John or Simon at email.com as the values. It's commonly shown in this structure. So we have the open curly braces here, and then we have the keys. So we have name and email, and then we have the values there. So you have the keys, and then you have the colon, and then in quotation marks, you have the actual values associated with those keys. And you always separate these by commas between each key value pair. So this is effectively a JSON object, a very simple JSON object. And sometimes they're this flat structure where we have just one level of keys and a comma separating them. Or sometimes you have nested keys. You have, for example, here where we have name, we could have full name. And one thing I forgot to mention is actually it's always closed off with the end curly brace as well. But inside the nested JSON object here, we could have potentially multiple objects inside. So we have the overall object, which you can see denoted by the curly braces here. But inside we have full name. Then maybe full name is made up of another JSON object, which is inside this one, or nested, we call that. And it has first name and second name as two keys inside that. And then this is also a key as well. So this is a key, full name. And then the JSON object, the whole object would be the value in this case. But that value or that object is made up of more keys and values. So once you understand those terms, you'll see in the next step how we actually dig in and retrieve data from these objects. We've then got a rule for no duplicate keys in objects. So you can't have a JSON object that looks like this, where we've got an opening, a closing, and then two of the same keys. We can't have name, email. If you need to represent multiple instances of the same key, i.e. you have John and Simon in this case, then you would use an array. An array is slightly different. If I hit that down here, you'll be able to see the array is denoted by these square brackets. And inside the array,
array, we effectively have these JSON objects. So we have two JSON objects that are separated, but together they make up an array or a list. So we have the name of John and the email of John in its JSON object, and then we have the name of Simon and the email of Simon in its JSON object. But both of them are contained in this array structure. An array is just represented by these square brackets, and it practically on screen, or in easy terms, means it contains a list. So we have multiple of the same key value pairs in that array. It's important to know those two different structures, the JSON object and the array, because actually the objects or the data inside it are accessed in different ways, depending on whether it's inside an object or an array. So let's have a quick look at the example data we've got in here. And if I just make that example data a bit bigger here, you'll be able to see that we effectively have an array of lots of different people here. Ignore all of this in the middle. We're just looking at on the right-hand side, the JSON data structure. If we were to view it as a table, you'd effectively see inside each key, the values here. So immediately I can see there's one value associated with the ID key. So user01. And if I go to JSON, we can see that ID user01. But if I look at the table, I can see actually there's three values or nested keys associated with name. So we've got name, which is broken down to first, middle, and last. So in the JSON data, this will be represented as exactly as we just saw. Name is the key, and then the value is actually another JSON object with keys and values respectively. So first name Alice, middle name Beatrice, last name Carol. And you can see that we have this complex data structure with people information that is broken down. And some of them can get really complicated. We can have all of these nested parts in here. And we have the theme, the language, the notifications. And in itself, we've got inside notifications, we've got another object, which is email, SMS, or push. And inside, you can see by the indentation, we've got another object, which is enabled and then schedule. And then where we have zeros and ones, it denotes that it's actually an array. So if we go here and we look at the JSON object for preferences and we go down to the push notifications and see schedule, you will see these square brackets that we saw before. And all of this will make sense in a second. So we have the preferences object. And then if we go down to notifications, we have another object inside that, which is the push notifications. And then inside the push notifications, we have another object again. So nested, nested, nested. You can see that we can nest as much data as we want in these data structures to enable it to be easy to read and interpret. You can imagine this would be really complicated to understand what is linked to what if we had that flat structure where we have all of the keys on the same level. And you can see the indentation here shows that it's nested inside it. So we've got push notifications, and then inside the schedule, we've got these array brackets, which is our list, meaning we've got multiple schedule values here. We've got 8 till 12 and 2 till 6. And you can see that in effectively this view as well, and also inside the schema view. So inside the schema view, we can see the data outputs or the data structure. So it only shows us one value. So here we have multiple users. We have 3 items. So we have user 1, user 2, and user 3. But actually inside the schema, we just see the data structure. So you can actually see these data structures broken down. So name, we knew we had first, middle, and last as nested objects in there. And this cube denotes that it's an object. Inside contact, we have email and phone. And then if we go to the preferences, you'll see inside preferences, which is an object in itself, we have the notifications object and we have the push object. And these are all individual JSON objects nested inside each other. And then this symbol here with the dots and the lines suggests it's actually an array. And you can also tell that because it's got an index value. And we'll cover how to access the index values in a second. But all you need to know is the index starts at 0. And for every value it has along here, it will go up in 1. So this is the first value inside the schedule array. Don't worry if that's been a little bit confusing so far. We'll actually start retrieving some data now and show you how to pull data from these nested objects. So let's now talk about actually retrieving the data so we can use it. And for this, it's called expressions in n8n. So expressions tell n8n where to find and what to do with your JavaScript data or your JavaScript objects or your JSON data, as we call it. And it will appear something like this. And we'll go over some examples of how to retrieve the data. But we've got these double curly braces, a $sign, and all this effectively means is we're accessing the JSON object and we want to grab a field from it. And some common use cases that you can probably relate to here are we might have a bunch of names and actually we want to just grab the first name inside the customer details. Or we might want to take a date that's a string format, i.e. text, and turn it into a date format or remove some characters from that date. Or we might want to combine some information. So if we're writing a personalized message, we might want to combine first name and a second name. So we have hello first name, second name, rather than having to manually write that every time. And we've got 2 ways of referencing items inside these expressions. We've got dot notation and bracket notation. So if we open up the set node here, we've got some examples using our example data where actually we can use dot notation to grab a contact. So if we're looking at the JSON objects here, exactly as we just saw, we can effectively grab any of this information. So if, for example, we wanted to get the first name of the contact or the user in this field, we would do our $JSON. And down here, you can see all of the values or the results
result of the values that are coming through in real time. So if I open this up, we can see exactly what result we're pulling here. So if I'm just referencing the JSON, I'm pulling the whole object, and you can see that it actually calls it an object here and says, okay, the object is made up of IDs, names, and we've got all of the data that we saw before. And each of these as well is for each person. So we have 3 people in our example data. If I click to the right here, I can see that we've got Bruno here, we've got Alice, and then we've also got Carlo here. So I can see the results of each of those. If I want to grab the information, let's say I want to grab Carlo's middle name, then what we're going to need to do is look at the data structure on the left-hand side and see which objects we want to grab from. So I can see that this is an object name, and we use dots to say, go inside of that. So I'm going to go inside the JSON, and actually it pre-populates all the fields that I can access here. So I can see already we've got this name object here. So I can click on that, or I can type in name manually, and it shows me now actually, okay, inside name, it's another object, and we've got first, we've got middle, we've got last. So exactly the same as we put before, we can say dot, and then actually let's grab the middle name, or I could just manually type it, last name, and you can see that that will pull the correct values. Let's see why it's not pulling the last name there. Perhaps he doesn't have a last name, for example, in that data set. When you go back to name, we can see, yeah, the last name was blank, so it's going to pull an undefined value or a null value there. So that is one way to dig into JSON objects, and an easy way to see this is in the schema, like you saw before. Another way you can manually do this is actually just in n8n at least, pull this across here and say, okay, it actually says exactly the same as we saw before, JSON.name.middle, but it's good to know how to manually write this. Another way of writing this is bracket notation. So if, for example, we wanted to grab the name here, and it's just another way of writing it, we could say, okay, inside of JSON, we want the name. And again, that's going to show us the object down here, and we want the middle name. And I've got an extra square brackets there, but I have to take that off, and we get Lopez again. So you can see those are 2 different ways to access the same data. And all we're trying to do here is get the right data to work with, because once we understand how to get the data, we can then do something with it. Now, if we have an array, and remember arrays are those things in square brackets or a list, then you can reference them in another way. So n makes it really easy to grab these at first. And by the way, if you're using a fixed value here, you will not be able to pull any of these values. If I try to put in the curly braces and do $JSON here and the fixed value, it's not going to pull anything, because it's basically saying pass this as a string. So what we're actually passing is these characters and not the data. But as soon as it becomes an expression, you can see it pulls the data. So it has these pre-built in as well. So if we look at our notifications example, we had notifications or preferences, notifications, push, and then schedule. So we had inside the preferences object, inside the notifications object, the push object, there was then an array inside that. So let's try and dig into that. So if we use our dot notation, and we can start typing preferences, and it will appear there, and we can say notifications, and then we can finally say push, and you can see that this is still an object. So if I open this up in the big window here, you can see inside push, which will look on the left-hand side as well, we have enabled and we have schedule. And inside that object, we have an array, which is schedule. So if we type in dot schedule, we're accessing the final part before the array. So you can now see that it will show us we've got an array of 2 objects, which is effectively the first object in here and the second object in here. Now, even if we type in dot, n8n is going to show us the options we have to actually use this. So we can grab the first object inside there, or we can grab the second object, or we can use this and grab both of the objects. So let's try typing dot, and you will see there's a few different options we have in the drop down that automatically appear. If we click first here, it will return the first element of the array. So for example, in quick brown fox, it will return quick. So let's try that here, and it returns our first value, which is 8 to 12. We can also return the last value of our array, which is obviously 2 till 6. And then there are other ways to also grab that. And this is where the indexes come in here. So we can see that if we wanted to grab the first value, another way of writing that is actually just putting the square brackets and 0. So you can see schedule square bracket 0, and that gives us 8 to 12. The next index would be 1, which is 2 till 6. And then if I try to access an index after that, which doesn't exist, it would appear as undefined here. If I wanted to return just the unique values in the array, say we had quick, brown, and quick, then it would return quick and brown. We also have an easy way to do that using unique, but for us, both of them are going to be unique. So it's going to return the entire array as well there. We've shown you accessing the last item and accessing by index. And then now we'll talk about a more complex object access. So you can see inside the metadata field here, inside devices, which we can see is an array, we have device 0, device 1, and just 2 devices there. And you can open or close all of the fields inside that. So if we wanted to access the information inside the devices array, then what we're going to need to do is access the specific array index, or use our dot first, etc. there, and then access the object inside of that. So it still works exactly the same if you're accessing an object inside a nested array. So you can see inside the JSON, if we go down to what this looks like in terms of the curly brackets, we've got the metadata object up here, Then we've got a devices array, which lists multiple objects. And we see inside that we've got a desktop, but because this is an array, we've got multiple objects inside that array. So we can still access those by using that dot notation that we learned before. Now that's how you access data inside an array and inside an object, or both of them combined. Let's now talk about how you actually transform data. So taking data and actually transforming it, combining it together. And this is really powerful because actually we're not just going to be accessing data in n8n. What we're going to be doing is actually using that data and using it in a certain business use case. So for example, we've got here an example of us writing a message to a community member. So if we wanted to make this dynamic, in fact, I'll show you the fixed first. If we turn this to fixed and then open this box here, you can see that we're just outputting characters. So we're outputting all of these object characters. Hi, jason.name.first. Thanks for joining us. We're excited to have you as part of the community. Your registered location is, and then you can see we're accessing multiple values as part of that. So if we were to make a personalized message to the 3 users in this data set, and don't forget this can be applied to hundreds or thousands of user data, then we would turn this into an expression. And now you can see in our result here, if we open it up, that jason.name.first now becomes Alice. And then the registered location is actually Alice's location. Her phone number is the phone number inside that. So we're able to reference those specific values and pull them into a personalized message, i.e. making our messages dynamic, meaning we can repeat this for thousands of users with no additional effort once we've set up this JSON data correctly. So this is an example where we might be creating personalized emails as an example. Now, another way that we could do this, and you saw this previously here, is actually we can combine it with just plain text. Inside this expression here, we can build this out to be a long expression made of text combined with other expressions as well. And you're able to do that inside n8n. Here, we are showing some examples of if we were to take multiple values and combine them together. So the example we said earlier was combining a full name using jason.name.first, which is this value here. And then say we wanted to add the middle name in here as well. We would add that in, but you can see in the result, there's no space between them. So n8n will interpret this as no space between them. So if we add a space, it will interpret it as a character and therefore add a space between them. Now, another way of writing this is actually having one larger expression. So compared to having multiple expressions here, which is quite cumbersome to write, but easy to drag and drop, you could have one larger expression, which says jason.name.first plus, and then we could put in any characters here and we'd see this appear. And if we added a space again, it would add a space. But what we're really trying to do is add a space between the names here. And all the plus symbol is doing is saying concatenate or string together these different string values between those. And this works because they're all the same data type. So that then gives us the same result of Alice Carroll. So if we were to add the middle name in there, we would add another JSON. And you can see now they're all incorporated inside the wider JSON brackets. And we'd say .name, .middle. And then if we wanted to add the space in again, we'd add in a new space and then we'd add a plus on the other side. And that would give us the name there. You can see that if I do one of these incorrectly, that it should do. Yes, right. So this middle one now is undefined because it can't find the objects that we're referring to. So we need to make sure that that's correct. But also if we were to take away a bracket here, it's effectively just going to not find our result or not call it an expression. And that's why this format is somewhat great to understand which ones it cannot find, because here this has appeared as successful, but showing as Alice undefined. Whereas this one here, if we get rid of that and leave that as invalid, we immediately can see that actually the last name was not found. Whereas here in the same scenario for 2 names, it appears as green. So let's talk about more complicated expressions here now that you understand how to combine them. So we've got handling undefined or empty fields here. So say, for example, we want to get the subscription plan from the fields here. And if we go to the table, we can see inside the subscription plan field that Alice has the pro plan here, but then we see the other 2 users actually not on a subscription plan. So how do we get it to effectively show us a given value when it is undefined? So if I remove this here and we're just digging into the subscription plan, you can see for Alice, which is the first index or the 0th item or 0th index, we've got the pro plan. But then as soon as we go to the next user in the list, we've got undefined and undefined. So undefined often causes errors in our data. So maybe, for example, if there's no subscription plan, we want to say something like no subscription plan. And a way to write this in JavaScript language or n8n specifically inside the expressions is actually just using this double question mark syntax. And syntax is just the way we write it, which is, does this JSON.subscription plan value exist? And for the first one, that will be true. If it exists, then great. If it doesn't, let's give it the value of none. So it's just saying, does this exist? If not, which value shall we give it? So we can see that it exists for Alice, which is the pro plan. And then actually the second user, who is Carlo, does not have a subscription plan. So we write none in here. And the same for our third user down here, or so Bruno and Carlo. So that is one way to write, if this doesn't exist, then do this. this. We can do the same with multiple expressions here. So say, for example, the last name does not exist, and we can grab the middle name. So you can see this is just an expression here that actually Carlo has no last name in the settings or in the data set. So actually, if we go to Carlo, who is the second item or the third user here, you can see that instead of undefined here, where we had an undefined subscription plan, it's actually now empty rather than undefined. So if we were to ask this question, does he have a last name? The answer would be yes. The last name is a blank name because there's a value in there that is effectively an empty character. And if we go to the JSON, we can see this inside name. If we go and scroll down to Carlo, we can see that it is defined. It's just a blank value in the last name. So this expression doesn't work anymore for what we were trying to achieve. Whereas you can see his subscription plan doesn't exist as a field at all in his data set. Therefore, it is undefined. We can't access that data inside the object. So what we would do in this case instead is to actually use these vertical slash notation to say if json.name.last is not empty, then give us json.name.middle. So it's just using this slash notation. So if we're using question marks, the value exists, whereas this says if the value is empty or does not exist, then grab this or use this value instead, which for Carlo's example is Lopez, which is his middle name. Now, if we were to, for example, try to achieve the same with an array here, we would effectively need to do the same, but give it an array value. So we try to achieve the json.tags here, which you can see is undefined or does not exist for Carlo at all. We can't see the tags object, but the one I just showed you was actually Bruno's, which is an empty array. So if that does not exist, then let's say again that it is an array object, but it contains the value none. So Bruno's would still appear as an empty array because it was empty, whereas Carlo's was undefined, i.e. the data object or that key value pair did not even exist in his data. So what this will mean is Bruno still appears, Bruno's number one appears as the empty array. We've got Alice who's got values in there, but then it also handles the case where actually Carlo has no tags array. So we've made sure it's an array by putting the brackets around our none value. And if we took that away, it would effectively be a string value, not an array, which might cause us problems later down the line because the other users have an array for that value. And there's another way to write this as well, which is actually if it's empty, and this is just an inbuilt expression inside n8n, if empty, it's going to check the json.tags value and then say if it is empty, then it's going to put none there. So it's exactly the same, but writing it in a shortcut way for n8n. Now there's also conditions that you can do with expressions. So we talked about how to access undefined and empty fields there. Conditions takes you one level up from that. So say, for example, we're combining two strings here. That works absolutely fine. But maybe we want to put an if condition. So usually we'd come out here and we'd add an if block and we'd connect that to a condition and actually say, if the data set has this thing to be true, then we're going to output a certain answer. But you can actually build those inside our set nodes or our edit field nodes here. And it looks a bit complicated at first, but all we're saying is if we want to determine whether they have an email address, i.e. if the contact.email field is not empty, then they do have an email address, then that can be written as an expression inside here. So you don't need to have them on separate spaces like this. But what we'd effectively do if we recreate it below is we'd open our curly braces there, and you can see immediately we've got this if condition, which is if, and then we say our condition, we give the value if that is true and the value that is false. So if we're talking about their email here, we'd say if, and then we'd find the email and we can drag that in, if the contact email, and that's the value we're checking. If it's equal to, and we use double equals to say that it's exactly equal to that value, and that's just JavaScript notation. If it's equal to blank, then actually we don't have an email. So we put a string there that says no. But if it's not equal to blank, i.e. there's a value in the email, then we do have an email. So has email would appear as yes in that case. And you can see if we go through the examples and come out here, we flick through the different items, then the various contact details might have varying emails or no emails in there. Another way to write this more manually is effectively writing the JSON expression and then using this question mark notation. So instead of using our inbuilt if, we can effectively write $json.contact.email to access the email value. If that's equal to blank, and then it's the question mark says, is it true or is it false? So the question mark is saying, is that json.contact.email equal to blank? If it's true, i.e. it's blank, then we're going to write no. And then we put the colon to say what the other option is. And the default option there is yes. So if it's not blank, then they do have an email. And that's just a JavaScript expression on how to write those as well. An extension on that, which you might use, is actually you can simplify this. Whereas we're saying we're just looking now for the field. We're not looking for whether it's blank. We're now saying, does the field exist? Yes or no, true or false. And that is done in binary, which are ones and zeros. 0 would be false, 1 would be yes. So we've got, okay, json.contact.email. Does that field exist? So actually, I just removed that. We can see that it's empty for number 1 or number 0, does exist for Bruno, and it's empty for number 2. So 2 of those actually would be false. So we put a single question mark and then we put yes or no there. So what we're effectively saying is, does the email exist? If it exists, then yes. If it does not exist, then no. So it's just another way of writing the same thing as we did above, but we don't have to put an equal sign. We're just comparing it to true or false. This is effectively saying, is this true? Is the json.contact.email existing? Is it true? If it is, then yes. If it's not, then no. And we can see this directly shown as a Boolean value, true or false, by just using the .toBoolean function, which will show us true or false there. So the last area, which is really important to master the data transformations, is understanding how to split data sets, how to join them together, and then how to merge those as well. So if we have multiple data sets that we want to merge, merging those as well. So we'll quickly run through exactly how to do those as well. So let me bring over my manual trigger here, and we're going to operate with a different data set this time. So we've got a leads data set, which is effectively a JSON object in here. You can see denoted by the curly braces, but it's got a leads array inside. So there's only one object in here, which are individual leads. But because, as we said before, we've got duplicated keys like first name, last name, email, company, it's effectively inside an array. So each of these is lead 0, lead 1, lead 2. Even though they've got IDs 1, 2, and 3, we're talking in the indexes 1, 2, and 3 of the array. So we've got this inbuilt split out node, and you can see if we run this step that we effectively have the schema of what we just spoke about. So there's a leads array, and it has lead 0, lead 1, and lead 2, as well as multiple more leads. And you can see all of the different attributes or parameters as part of that here. But sometimes when we operate with data set like this, you'll see that it's actually very nested. And what we want to do is just make it easier to access all of the data by flattening, or doing what we call flattening that data structure. So all I want to do is actually, instead of this being in one giant object, I want to turn this into a table that's really usable for me, where we have ID, first name, last name in the column headers, rather than just leads in the column headers, because that's not very useful when I want to use it. When I want to use it, I want to use it in a database or a table, and that will be easier for me to visualize and use if we had first name, last name, email, company up top in the table names. So to do that, we're going to use the inbuilt split out node. And what we're going to say is, okay, we want to split out all the fields. And in here, we put the name of the input field to break out into separate items. And if we wanted to do multiple fields, which we don't have here, we would separate multiple fields by column names. So what we're going to do here is we're just going to pull in the leads here. And that's going to say, okay, actually what we want to do is split out all of the individual items in the fields. And we're going to include no other fields, because actually all we're doing is breaking out every single field inside here, inside leads. So if I wanted to do this for ID, for example, let's see how that splits out. And you can see that's jumping into the array here. So it's jumping into the first object, or the 0th object here. So all that's going to give me is number 1, because what we're saying is split out this specific one here. But if I say split out leads, then what that's going to do is actually, it may not look very different, but we've now got these individual JSON objects outside of an array. And now if I look at the table view, it's more obvious the change that's been made to the data structure, which is now we've got exactly what we needed: first name, last name, email. And the table view is much more usable for me here. So I can then take that and then pull specific fields very easily from the data. So if I wanted first name and last name, I would pull just first name and last name over here. It just makes it a bit easier to manipulate, versus if I were to try and manipulate the data directly from this leads, you're going to see that it's significantly harder to pull that information and pull it for every single lead and not just one of them. So if I try to pull first name and last name, you'll see it's going to jump into, again, the 0th item of the array. And that means if I try and pull a full name, it will literally just pull Sarah, because we've effectively told it a lead on the first item in the array. So to save us having to do that, we would effectively use this split out node, which does the hard work for us, splits it out of an array or flattens the data structure. And what we're then able to do is just say, okay, all I want to do is grab the first name of every single object, or every single object in this larger array. And therefore we'd get, if I go to full name in here, we'd get the individual names broken out there. The opposite is true. Sometimes we want to combine the data back together. So for example, we now have this table of data, which is great if we want to treat and manipulate each of these on an individual basis, but actually is more difficult if we want to pass all of the data from this structure in one group into an LLM to analyze it, for example, or into a data sheet where we take all of that data at once. So what we're going to do now is actually use the aggregate node, which is an inbuilt n8n node, and we're going to aggregate all that item data into a single list, and we can call the output field whatever we want. But because we're just reversing exactly what we've done, we're saying actually we are outputting the leads here, and what we're going to do is just run that here, and you will see it's put it exactly into the same JSON data structure as we had, just aggregated everything from the table, and you can see the table view is exactly like we started with. So sometimes you want to take the table data and aggregate it together, so you have one data set that's easy to send somewhere or use in an LLM field as an aggregated data source. We can also choose which fields we want to include. So let's say a first name, and all that's going to do is grab the first name from every object over here and actually just aggregate those into a single list of first names, which you can see there. So that is how to flatten or unflatten data. And the final thing we're going to show you, which you'll actually use quite often, is merging data sets. So here we've got two examples of data from different systems or potentially from the same database that we can link together by a certain field. So I'll show you an example of the data. We've got our leads data that we just saw. So we've got all the information about our given lead, and maybe this is in our CRM, but then we've also got a separate set of data, which actually might be our lead interactions. So this is actually how many times they've interacted with the resources on our website, like our automation guide, our ROI calculator, have they attended a webinar? So actually totally different data, but still to the same email address. So you can see how I might want as a business to combine that data together. So what we do is firstly, we'd use the split out nodes here, and let's just run this through. What we can see is actually we're going to split out that data. So we're going to split it out and flatten it exactly like we did before into different table rows. And this one hasn't worked because actually we need to rename the split out here to lead interactions. And what we're effectively doing on the second one is splitting out exactly the same. So we've got the individual leads and their interactions, and we can tell a lead by their email. And also we have up here a lead by their email. So we can see how we might merge these two data sets together to be one bigger data set. We then can use the merge node from n8n, and there's different modes we can do here. If we wanted to just combine the data together, then we can append them together. So we have effectively 10 items now on our output. But what we're going to see is we're going to see actually for our output, we've got Sarah Johnson here, and we've also got Sarah Johnson here. So ideally we'd combine Sarah's data together. If we appended it, then Sarah Johnson is going to be missing most of the information apart from all of the lead interaction information. So what we'd want to do in this case is actually combine where they match. So what we're saying is actually the fields to match are both called email in our case. So between our, if we go to the schema, we can see the split out one and split out two, we can see that the field name here is email and the field name in the split out two is also email. So we're saying if split out two and split out one match on email, then keep the matches and merge the inputs together. So we should now get 5 output items, and you can see it's now the lead information, which we had before, but then we start to also have the lead interaction information and how they've interacted with that information. So you can see how we've taken data from different data sets, but a common data field, i.e. email, and actually merge those together using the merge node. So we've got one combined data set that we can use together. If we wanted to then combine that into a bigger data set, we could say, we'll call this lead data. And now we'd have exactly the same as we saw before, one merged data set or one merged JSON with an array per lead. So we have the individual lead data for Sarah there, and then we have Michael's there, and exactly like that. So we've then gone full circle, been able to merge the data and also put it back into our JSON structure if we need it in that usable format. So that rounds up 80% of what you need to know, if not more, around the data transformation concepts that you'll continue to see again and again inside n8n. If you understand these concepts, they will drastically improve and speed up the way you build your automation workflows for yourself and for your clients.
Uncovering phase 1 of this course so far, which covered all of the 20% of n8n that will give you 80% of the value. If you're interested in an extended learning journey, then come to school.com/scrapes. And inside the classroom, we've got a complete AI automation masterclass, which builds on what you'll learn in this video, and also an agency launchpad, which focuses just on packaging and selling. So inside the AI automation masterclass, we've covered some of the ticked modules here, but there's lots more material. And then in future weeks, some things we will not cover in this video. We'll talk about confidence in workflows, so how to troubleshoot and configure automatic backups for your workflows and your clients, how to actually never start from scratch and have some predefined templates that you use again and again, how to set up your client environments if you are interested in selling to clients, and then a lot more material here that is covered. So now let's jump back to the workflow canvas and we'll go back to the basics and actually start building out a system from scratch, step by step.
Now, when you come in here for the first time, it's easy to get overwhelmed with the number of options available. We're going to break them down now into 4 key categories. These 4 key categories will make it really simple for you to understand how to build out your first workflow. If we come back to this blank canvas here, so delete any nodes we've got on there, then we can add a first step, or we can click the plus to open the nodes panel here, or alternatively, we can just hit tab on our keyboard. That opens up the options for the first node. A node is just an event taking place on a canvas. So that could be how we activate a workflow first. So we're always going to need to activate workflow somehow, whether that be a manual trigger. So we'll open up the manual trigger, and the manual trigger is mainly for when we are testing things. This just means whatever is attached to this first manual trigger node will always become activated when we hit the test workflow button. There are other ways to trigger a flow, and that will be the ways you use in production. So we might have on an app event where we've got different software that could trigger. So for example, Airtable has a trigger on new Airtable event. Whenever something happens in Airtable, that will trigger a corresponding reaction to whatever we connect this to. We'll remove the Airtable node and we'll go back to the triggers. We might want something to run once daily, so we can add a schedule trigger and determine inside the trigger itself how often or how frequently we want it to run. If we remove and go back to the triggers, we're now getting to the less frequently used triggers, but also important on a webhook call. Now, this may not make sense immediately, but we can pass data from an external service to activate our workflows, and that's what a webhook is. And we will go into full detail later on APIs and webhooks and how to use those. They're not as complicated as they seem. And then we've got a few other triggers on a form submission. So n8n actually allows us to submit a form through its user interface that starts off a workflow and will pass in the details from the form. We can activate workflows from other workflows, so we can trigger one workflow from another. That's really important for scalability and reusability in our workflows, and we'll cover that later. And then finally, we've got on chat message. So we can actually have a chat window in the screen, and we can type a message in here and it will activate workflow here. Once we have a trigger, so we'll just put in the trigger manually as we're testing for now, the node will enable you to connect to other nodes. That's where we come on to the second element of this, which is action. Actions are how we connect to all of our business software. So we might use Google Sheets or Outlook or Slack or Notion. We need to take an action to connect to our business systems. And as you can see on n8n integration page, they have pre-built 1028 integration. And then any that are not pre-built already, we're able to connect to their API. And that makes this effectively able to connect to anything to everything. Really, really powerful software for all of your business needs. We're going to go through some of the key actions in a moment, but the first action is connecting to a platform that we're using in our business. So back in the n8n canvas, we have our trigger, and now we're going to connect some actions and see what actions are possible. So when you open up the nodes window here, we have different categories. We have advanced AI, which we're not going to cover right now. We have action in an app. So what we just covered was that we can connect to any of these apps. We have data transformation. So this is a specific action that takes place on the data we're using. So for example, we might take data from our Google Sheets and manipulate that by adding some data or removing some data or stripping out some formatting of some data. That is what the data transformation nodes are for. And then within Flow, we're able to also execute conditional logic. And what that means is if our data meets certain conditions, we can branch it and take an action on it. If it does not meet certain conditions, we can take an entirely separate action. So it means we can interact in the canvas with the data from our software that we're using in our business. We then have some core nodes. So these core nodes are just made up from these four categories anyway, and they just contain some of the most popular used nodes. And then newly, we have human in the loop, where we're able to get feedback from a human when we're using AI. Finally, it gives us the option of multiple triggers, which we will cover later, but this gives us the option to add a second trigger into our workflow, so that not only can we have a test workflow trigger, but we might have a scheduled trigger, we might have a when executed by another workflow trigger. So there could be multiple ways to trigger our workflow, and all of them can be active at once. The fourth tip is around connecting easily to any of our software platforms. This is the easiest way to do it. So we're going to hit tab again or hit the cross and open up an app. And for the example, we're going to use Airtable. So we know we use Airtable frequently. So we're going to click on the Airtable node. We have now got to select the action, but this doesn't restrict you from changing the action in future. But for the sake of the demo, we want to search our records in order to pull all of our records from the data. And there are other actions that we can take. So if I go back to the canvas here, you can see that this is totally not connected to our test workflow. So if we were to run test workflow, it's not going to run Airtable node. So what we need to do is just click the cross and drag it over to Airtable. The next part is how do we actually connect to an Airtable that's outside of n8n? So you can see on the left-hand side, we've got inputs here. In the middle, we've got our software that we want to connect to, so Airtable, and we make transformations in the middle here. And then on the right-hand side, we've got outputs. So it's a three-way sequence that we can visually see our data flow through. So we can see what we've received into Airtable. We can see or take actions on that data in the middle, and then we can see exactly what that's returned in our outputs. But first, before we see the inputs and outputs, we actually need to connect to the system. So inside of every node, you'll have a series of tasks that you'll need to complete, or a series of steps where it will ask you to choose a drop-down in order to select the most appropriate action. The first one is always going to be a credential to connect with. So right now, we do not have it connected to any Airtable that we have externally. So here it might appear empty to you, and you're going to create a new credential here. Now, these will be different app, but they have the same core concepts, and always n8n have some really useful documentation linked. So you can go directly to the documentation for that specific node, i.e. Airtable, and see exactly where to access the different credentials. So for Airtable, we need a personal access token, and we can get that by going to the personal access tokens page, opening that up and clicking create a new token. It's then going to give us this page, and we're going to just, for example, call it n8n test demo. And then back in the credentials, it will tell us what scopes we need to add to our token. And the scopes are just what access are we giving that token? Is that token able to read our records? Is it able to write to our Airtable? Is it able to delete records? All of these things we need to give it the right scope so that it's able to perform the right actions on our behalf. So we're going to add data records write, data records read, and schema bases read. So we've added those three scopes, and now we need to tell it what tables is it able to access. So we've got to add a base here. So if we click add a base and scroll down, it will give us all the different options for connecting. You can see I have a lot of different bases here. So to do this, we need to have already set up a table. If you go into Airtable and set up a demo table, you can see I've set up a base here, scrapes.ai tutorials, and then we've got two tables, financial and demo data. For now, we're just going to use the demo data table, and we're going to put test name, random notes, assign it to me, and it's in progress. So what we now need to do is connect this table to our access token, or to connect our access token to this table. So if we go back to the Builder Hub, we go add a base, and we know it was called scrapes.ai tutorials. That should now appear there. Once we create the token, we've then given it permission to access that table. And I'm going to copy that here by clicking here. And we're going to go back to our workflow where we were setting up our Airtable token. All we're going to do is paste into our access token field. And critically, we're going to rename this because you'll have too many otherwise that are named token 1, token 2, token 3. And when you come to use them in the future, you won't have any idea what platform they relate to. So we'll give it a sensible name like Airtable Test API token, and we'll save that. And that should confirm then in green if it's successfully connected to our software. There we go. Connection tested successfully. Perfect. We can leave from there. So we come back to our Airtable canvas, and we've connected up our test workflow trigger to our Airtable node. And you can see that's got a name Airtable. Now, tip number 5 is about visually seeing the inputs, the transformations, and the outputs. So what we're going to do is we're going to fill out in the middle here some options in order to pull our data. So right now we're receiving no inputs because we've got the test workflow trigger, which is just pushing an empty set of data to our Airtable. But what that will enable this to do is run the Airtable node. So right now we're searching for a record, and we're going to search. But like I said, we can change any of the methods here, and they've all got a description underneath. So we want to search or list all of our records. We're going to connect it to a base, and this is all Airtable specific naming. And each node you connect to will have specific names for here, but Airtable uses base. So we're going to connect to the list, and you can see that's now given us access to that. Whereas if we had not filled out this correctly and given it correct access, this would not appear in the list, and we'd have an error at this point. So now we know we can connect to the base successfully. We will choose the demo data table, and we're not going to filter by anything, so we want to return all of our records so we can test that step. And you can see on the right hand side, it's now returned the records that we just put in the table. If you want to visually move these records, you're able to click and drag and drop all of these different fields, and we can now see much clearer the outputs, which was the test name random assignee. You'll notice that this is in a strange format. So this is a JSON format, and tip 6 is about managing all of the different data formats and understanding those properly. So tip number 6 is interpreting table data, JSON data, and schema data and figuring out the difference. And it's actually really simple when you distill it to its principles. So to make this easier to understand, I've expanded the data set, and we've got now name, task, and status. And I've put in some demo data in our Airtable, and we're going to pull that data using the test step. And you will see we have a full record of all 20 items in our JSON data table. You have this on the inputs as well, but because we've got no inputs at the moment, we can't format those. So table first is a really easy way to visualize your data. That's how we conventionally see our data in a business. We normally see it in a spreadsheet table. Each row is its own unique set, exactly like we see it in Airtable. So this is the way that a human would probably interpret it. The schema, you can see, just distills it to a single record. And the reason for that is the schema is just understanding our fields in the data rather than the data itself. So this tells us that we've got an ID field, a created time field, a name, a task, and a status field. The A next to it just symbolizes that it's a certain data type. In this case, it's just a string, which is just text. All of them are just text. You may notice that we didn't have ID and created time in our initial fields. That's because they're hidden fields created by Airtable itself to help us manipulate those records, which we'll come on to later. But it's got the name, the task, and the status that we had before. So you can see the different fields there. Now, JSON, in contrast to our table, does not display things in rows, but instead we get the full set of columns within these curly braces, and that is identified as a unique JSON object. It effectively flattens our table into smaller level objects that we can then manipulate easily. So you can see we have an individual record relating to David Kim. His his task to optimize database queries and the status there. And that will be a record in the database here. JSON is really good for data inspection. We can see the full 20 items. We've got multiple pages here. Table data is for quick data scanning and spotting trends. So you can see easily that this is easier to interpret. And then schema we can use if we're just looking for a certain field name. It's much easier to read that off here than a complex JSON structure. So schema, we can just grab either the data type or the field name from here. Now for tip number 7, we're talking about mastering static data and working with static data. So we're going to connect a node up to the Airtable. And this is a node that you're going to use so frequently called a set node, edit fields or set. So it allows us to just pass data or extract certain pieces of data from our software or our business use case. So we're going to open this set node and you can see it opens up with this edit fields node. Again, we've got the inputs, the transformation we want to do and the outputs. Really simple data visualization. So it gives us the option to drag input fields here. But all we're going to do actually is we can see the outputs from the Airtable have now become the inputs for our set node. We're going to click in this box and it gives us options on our fields that we want to pass through. So inside the name here, we're just going to put test name. We're going to give it a data type. So we've got the 5 different data types here. So we've got a string that's something like a text, self-explanatory. We've got a Boolean, which is a true or a false. We then have some more complex structures, which are like our JSON objects that we're passing through. We have an array, which is in square brackets, and we have an object, which could be a JSON object like the one on the left-hand side. So for now, we're just going to pass through a string and we're just going to say, hello world. So at this point, we're going to hit test step again. And that's going to run the previous nodes, pass through the data and pass through new data, which we can see is passed through as test name, hello. Now, you're probably wondering at this point, why is it run 20 times? We just wanted to pass one hello world through. And it's because by default, all of the nodes in n8n operate on a per input basis. We've given it 20 records from Airtable and we've run it 20 times. If you want it to only execute once, you can go to settings and you can hit execute once. We'll test that step again and it will just execute it for the first item only and will output hello. So we're going to turn that back off and run that again. And you can see that we've received the hello, but we've not received any of the Airtable data that we wanted to pass through and transform. So there are 2 ways to do this. One is by including other input fields and we tell it to include specific fields or all, so we can pass it through that way. But the whole point in using the set node or the edit fields node is that we actually just want to take 2 things through, the name and the task. We're not interested right now in the status. We just want to take those 2 fields only. Now, tip number 8 is where it starts to get really valuable if you're a business. There's not many times you're going to be passing static data through, like hello world. You might have a fixed value, like an API key that you're passing through or something like that. But the majority of use cases, we want to use n8n because we want to transform our data or take it from one platform to another. And that often requires using dynamic data. So we're going to remove this in the set node, include other output fields. We're going to run it again, and it's just going to come through with our 20 hello worlds. What we're going to do is first look at how do we include dynamic data just by writing it. So we want to take the name and the task through to the next stage. So we're going to copy those out and we're going to call the first field name, and that's going to be a fixed field. And we're expecting a string because it's a name. And the value in here, what we want to do is say, okay, I want to pull every time for all these 20 records, this name field. And there's 2 ways to do that, but they both involve expressions. The simplest way to do that is to drag from the left-hand side in our inputs across here and drop it in the field. And you can see it pops up with a result here, which is for each of the records, it gives us what the value would be. So it's like an indicator of what that's going to look like on the other side. The second way to do it is to reference by name, and it's one and the same. So if we were going to do this from scratch, we would say name again, and the value in here we'd need to switch to expression. Then every time we reference data in n8n, and this is just by default, we have to hit shift and 2 curly brackets, and that will open up our expression. It prompts us immediately for all of the different values that we might want to reference. The most important for now for us is JSON, which as we saw before is the data that we're passing from one node to the next. So if we click on JSON and it's $JSON, and that's just referencing the entire object of the previous node, the Airtable output. To see that in greater detail, there's this little button here. You can click on that. And on the left-hand side, you've got our expression, JSON, and on the right-hand side, you've got the full object, the JSON object that we're passing through. We can see that for each record here. So that just visually shows us exactly what we want to be passing through. Now you can see that this is the full object. And actually, we just wanted to extract name. So the JavaScript for doing this is just dot, and that enables to access an item within an object. And then we can get prompted with the different fields we can extract here. And in this case, we wanted to grab name. So we're just going to hit name, and you can now see we've got the result we wanted. Another way to reference this, instead of using the dot, is square brackets and then single quotation marks around the field name. That is an alternative way to do it. They're just different ways of referencing an item or a field within an object by JavaScript. So you just want to stick to one convention, and I conventionally use dots. Now, dots are only good when the field name is a single word with no spaces. If it was first name, for example, and I'll go back and change the data object in a second, then dot first name with a space is not going to reference the correct value. I've gone back and changed the values to full name. So we're just going to run that again. And what we're trying to reference now, you can see these have all failed because we've changed from name to full name. But if I open that back up and try to reference a full name, it's going to automatically, instead of the dot convention, use the second convention, which is the open square brackets, the single quotation marks around. And that successfully references. If I try to do the dot method, it's not going to find it and it's going to show up invalid syntax. So just different name ways to reference. I would always, by convention, make it a single word, either by connecting the name like this or putting an underscore in between, just because I prefer to use the dot notation. But with your business data sets, you don't always get to decide that, and you can use the other method instead. But like I said, if you type out JSON and then hit the dot, it will still give you all of these different options. And if you click on the full name, then it will actually automatically pre-fill that for you. We can see on the right all of our results for those. So tip 9 is an extension on dynamic data and mastering dynamic data. And this, I promise you, is going to save you a ton of time when you're creating workflows and having to go back and edit them. So we just passed through the data for the name and we had $JSON full name here. JSON only references the previous node. So often you'll come in here and you'll add another node between those. So we're going to open up the options here. We're going to add a second set node here, and we're going to connect, delete connection, and connect that up to the set node. And we will just call this middle, just to indicate it's the middle step here. So now we are passing our data through a node between our Airtable and our edit fields node. So anytime we reference this JSON, we're actually now referencing the previous node, which is no longer the Airtable, and it's now the middle. So say, for example, we don't pass any values through this, or actually we'll pass just a test. We'll call it test. It will pass through 20 tests like we saw before. But now we want to access in this next field the full names from the Airtable. Now, because JSON only references the previous node, i.e. middle, we can't actually access that from here. So how do we access that? There's two ways. Again, there's a drag and drop style, which is probably the easiest way to do it at first. So we can go to the schema view and we can actually see all previous nodes. So in here, we want to grab full name. So inside our expression value here, we can just drag and drop our full name and we'll be able to break down the wording here and how to build those from scratch. But you can see that it's pre-filled everything we had before, JSON.fullName or JSON brackets full name. And then it's also appended this beforehand. But if we run that again, you can now see we are actually still retrieving the names as well as the data from the previous node. So that is the first way to do that. The second way is actually writing it again. So if we write in here name, how we do that is, again, we open our expression, we open the brackets. Immediately it tells us to reference the previous node using JSON, but we know we want to reference an earlier node here. So we scroll down and we know we want to grab data from Airtable. So you hit Airtable and it's given us the object from Airtable. So now, again, we need to go inside the object by hitting dot, and then we will hit item, which just grabs an item inside the object, and then dot again to access the object or what value we want to grab from the object. And then it's exactly the same before, .json. And then if we hit dot, it gives us all of the values inside the object. We hit full name and, well, we've got exactly the same as we had before. Knowing this is actually super critical. It might seem menial, but you will go back and you will edit a lot of your flows and you will add nodes between nodes where you didn't have them before. And it will cause a lot of headaches if you don't name like this from the start and you just use the .json format. You will get these undefined errors all the time. So starting from scratch, I would recommend highly naming it like this, and it will save you a lot of time in the long run. You now nearly have all of the core fundamentals around handling data between nodes. You understand triggers, you understand what a node is, and you understand the inputs, the transformation, and the outputs. When you're handling large data sets, thousands of records, like you often do in a business, this next one's going to come in really handy, and that is about pinning data. So inside our Airtable node, you can see that we've got our inputs, our transformation, and our outputs. We've got the table data, the JSON data, and the schema data. And then we've got two fields over here. We've got this edit field, which is great for testing. You can go into edit and you can edit any of these values. So we want to say this is done, and that will actually save it as done. So we can just quickly edit values rather than going back to our original data source if we just want to test something out. The second thing is pinned data, and it's automatically pinned that because we've edited it. So if we go back and we unpin, pinned data allows us with thousands of rows to save a lot of time when we're testing. It also enables us to take values from our workflows that caused an error, and it allows us to rerun that through the flow. So you'll often come up with errors, and actually you can go and push that data back into our test environment here. But for the sake of this, pinning data is just storing data in that node so that we can rerun on the same data. If you're running thousands of rows of data, it's not going to execute as quickly as it does now. So you can see it took a couple of seconds already with 20 records. With 4,000 records, it will take 10, 15, 20 seconds, and that adds up when you're testing. So what you want to do is just come in here, pin data. So the node will always output this data in instead of executing. So it's basically like storing the data, and it has this little pin icon, and you'll see how quickly this executes now. Immediate, basically. So when you've got 4,000 rows or lots of data, which you will have with your business systems, pinning data is critical for testing. Now we're nearly at the end of the core concepts and the fundamentals of n8n. Then we can get into the real nitty-gritty of building out workflows once you've understood these basics. The next one is important because at some point in time, your nodes will fail. So the next one is about retries. So inside our Airtable node here, we'll unpin the data, and we'll go back and we'll execute that workflow again. So this executed successfully the first time, but this won't always happen, in particular with AI agents or HTTP requests or services that are less reliable than Airtable. We're going to want to implement some retry logic. So inside our settings here, we have a few different options. We have always output data, which we're not going to worry about now. We have execute once, which we've covered already. And then we have retry on fail. So this says if it's active, it tries to execute again when it fails. So there's no reason we wouldn't turn this on, because if we're reaching out to Airtable and for some reason the server responds with something that means our data doesn't come back, then this whole workflow is going to fail. And all of the execution that we worked for up until that point is not going to be worth anything. So if we click this on, retry and fail, it gives us the option to change the max number of tries. So if it fails, it will try 3 times and it will wait 1 second between tries. I normally just leave these as the default values. Sometimes if you've got rate limits or other things like that, you can stick it up to a higher wait between retries. And then you get the chance to say, if an error does happen, do we want it to stop the workflow entirely? But in this case, if it can't grab our Airtable data, then there's no point in it continuing. And we want to make sure that on the error, it just stops our workflow and throws an error. We will cover later way more around error handling because it's super critical for business implementation. And we'll cover these different options. But the 3 different options are stopping the workflow completely, continuing and passing that error message as a regular output, or continue and passing that error message to a different branch. So say we wanted to record that error somewhere in a log, then we would use this last one here. If the Airtable result wasn't important, then we would use continue because the error would not stop the workflow from continuing. However, it's critical to our workflow here because we're trying to grab tasks and full names. So we actually just want to stop the workflow when that happens. Tip 12 is the most overlooked part that I've seen in all templates on the n8n template library, on YouTube videos. This is so critical if you're delivering client projects or you want your workflows to be maintainable. And that tip is naming consistency. So right now, if you were somebody in a business and you came to this workflow, would you be able to tell me what happens? So we've got when clicking test workflow, we've got Airtable, we've got middle and edit fields. So from looking at this, I have absolutely no idea what this workflow is going to be doing. We're going to cover this in way more detail later when we talk about client standards and consistency in this. But to start off with, the basic fundamentals are naming your nodes. And the way you do that is you go into the node itself by double clicking. And up here, we've got the edit icon here and we can rename here. So it's important to have consistency in naming so that you can revisit workflows and you understand the logic of your workflows, makes it way more reusable. For me personally, I follow a convention that makes it easy to reference the node, but also describes the action taking place. So all nodes will have the symbol of the software. So we've got the Airtable here. If we bring in Google Sheets, you'll see that it has a Google Sheets symbol here. So I don't necessarily feel the need to reference the service name within the node. However, you can if you wish, but the fundamental actions that you will use with a service are getting data from the service, i.e. reading data like we did from Airtable. It's posting data to the service, and that is actually sending data to the service. It's updating. So that's partly posting, but actually we're checking if the record currently exists, and then deleting. You could be removing data from that service. So this is also the convention you use with API requests, which we'll touch on in the API mastery section. But for now, just treat those as standards for naming nodes. So instead of Airtable here, what are we actually doing? We're getting the task records. So we might call this get task records. And if we name that and come back out, now immediately it's so much more obvious to me as an outsider looking at this, what I'm doing. I don't know exactly what the tasks are, but before it said Airtable, now I know we're getting some sort of record from Airtable. I've put this in Pascal case here, which is where you have 2 names that are both uppercase next to each other. You could alternatively have spaces between them. So we just have normal case like this, or you could have camel case like this. It's entirely up to you what convention you use. I just use Pascal naming to make it easier to reference those previous nodes. You might want to call out specific things like triggers with a separate naming convention. So instead of taking an action like get, post, update, and delete, you might want to call this a manual trigger. And the way I do that is just calling it out with an underscore. So I have manual underscore trigger. We then get task records. We then set values in the middle. And then again, we're setting values, but it's not very descriptive because we're not actually taking many actions with those. But for this one, for example, we are getting the name. So we'll call it get names. You can see now that's immediately more obvious. We've not got to the point of adding notes to the flow yet, which is entirely possible and recommended. But the starting point is making your nodes easy easy to look at and understand exactly what they're doing without having to go into every single one. It's fine when you have a workflow that's this small, but I'll show you an example now of where it's not going to be okay if you have that. So I've jumped into an example here of a template in our school community where we pass financial documents. Now you can immediately see I've used this naming convention on these nodes, and it's immediately obvious, even if you took away all of these nodes, I'll just take those up there, it's immediately obvious on the outset what is happening. So we have some sort of Google Drive file trigger. We're then obtaining the file, we're extracting data from the file, we're formatting it in some sort of capacity, and then we're processing it one by one and using an AI node to extract data and update the financials into Airtable. So immediately, without any notes, I can see from the names of these that we are taking data from a file, we are extracting and formatting that data, and then we are uploading to Airtable. So your client will also think the same. If they have access to the n8n flow, they will go in here and they will be able to immediately understand at a high level what the workflow is about. Really, really important. That brings us to the end of the core concepts section of the course. We'll now get started and dive deeper by building out practical business use cases using your data. We'll now get started and dive deeper by building out practical business use cases using your data. So we're going to use an example of an invoice parser. We're going to build that out and talk about the data fundamentals now. So before we start building out any workflows, a good first step is to understand and plan out the workflow that you're going to build, just so you understand the logic that you're going to follow throughout. You'll obviously make iterations as you go through, but it's a really good starting point, especially if you're working with clients, to plan out exactly what the flow would look like, make sure you're on the same page, and then move forward with the first version of the flow. So to do that, we're just going to use some sticky notes. So we're going to open the nodes panel again. And if you type in sticky, then you'll get the sticky notes. A shortcut to get to this is actually just the Shift and S, and it will open up a sticky note. You can see that there's a few options on here. We can change colors. So I always just use white as a standard for informational notes, purple for supplementary, red for things have to change, but it's entirely up to you. You can use whatever you want. This is written in Markdown format. So if you double click into the note, the double hash just says that it's a heading or a second heading. If you put one hash, it becomes an even bigger heading. So you can see that 3 hashes will be even smaller. So that's just some Markdown for you. And all we're going to do is just plan out the steps that we think we're going to use in this template to make sure the logic flows correctly. So if we're passing financial invoices, we know that we're going to need to get a file, and that's probably going to be our trigger. So either going to do that from G Drive or Gmail. And in this example, we'll probably pull it directly from Gmail to show you the example. So our first step is like, how do we retrieve the file? Or how do we retrieve the email? The next step, we're probably going to have to do some pre-processing. So you'll see in a minute that there's loads of data that comes through in an email, and we want to strip out all of the irrelevant data because that makes it really easy to clean to work with. So we're going to have this pre-processing node where we just do some data formatting. Once we've formatted that email or file, we're then going to want to extract key information from the email or file. So we'll just put key info, and that might be the invoice name, the supplier name, the invoice number, the price, all of the information that we want to pull. We'll do in this stage. Once we've got the clean data, we'll then extract that key info. And we're probably going to use an LLM or an AI agent to pull that data because it's going to be able to interpret multiple different file formats and multiple different emails and pull consistent info from multiple emails. We're then probably going to want to put that into our database. So once the information is extracted, we want to output data into our database. So actually, you can see already that we've got the outline for this flow. Now we can move on to actually building the first version. These steps may change, but it gives you a good idea visually of the different categories you'll need and therefore how to start building this out. So for the first part of building out our invoice parser, we're going to come back to our workflow here and we're going to remove everything that we currently have. So instead of having a manual trigger this time, we're actually going to be monitoring emails or a Google Drive folder. So what we're going to do is get rid of the manual trigger for now, and we're going to click the plus icon. We're going to open up, let's go type in email, and we've got Gmail here. Let's set up Gmail to show you how to set up the Gmail trigger. And you can see there's one trigger, which is on message received. So every time a message comes in, we will be monitoring that. We've got, when we open this, a few different settings. We've got to connect to the correct credential. We've got the poll times, so we can monitor every minute. And there's no disadvantage to monitoring every minute, given we are on the self-hosted plan for n8n. So we get unlimited executions. It just takes up server time. And then we are monitoring for messages received. And then for now, we won't simplify the response and we'll see what we pull in. If you hit test event, that's going to pull in your last email. So right now we are monitoring a Gmail from mine, and that's going to pull in my latest email received in that inbox. Now, what you can see on the right-hand side is we are in the JSON format, but you can see a lot of different data. You can see inside the JSON, we've got all of this different information. We've got the ID, we've got what thread the email was part of. We've got all of these headers. We've got the HTML content, so the pure content of the email. You can see this is like an overwhelming amount. And even if we go to the tables format, you can see that we've got all this information. And even the text inside the email comes as this big block of text that's really hard to read. So what we're going to do now is understand how to strip out the bits we actually want and take that forwards for processing. So setting up Google credentials, they've recently changed this on n8n, so now you have to do a few more steps. But I'm going to run through how we do it for Gmail. It's exactly the same for Google Drive, Google Docs, Google Sheets, etc. You just need to set it up once and then for each node, and then you can connect your nodes. So we're going to go into the trigger here or the Gmail node, and we're going to go up to credential to connect with. And we're going to set up a new credential. And you see it asks us for a few different things. So we've got the redirect URL here. We're connecting using the OAuth 2 method, which is just a standard that's used across the industry to connect to different accounts. It's effectively where you have the Google sign-in page. That is an OAuth. We then have two values that we need to go and collect, which are the client ID and client secret. And then we can rename this as usual here. Gmail account test, we'll name it for now. So what you're going to do is you're going to go to console.cloud.google.com, and you're going to come into this window and you will be able to see the navigation menu on your left-hand side. You'll be able to see APIs and services. We're going to go to enabled APIs and services. If you've not previously set up a project, it will probably prompt you at this point to set up a project. But if you have set up a project before, it will just pull you into that project. You're then going to actively enable which APIs we want our project to be able to access. So I've already got them enabled, but you're going to enable APIs and services. You'll type in things like Google Drive, and we'll click on that. And instead of saying manage here, it will say install or something to that effect. You're going to click that to make sure it's installed. We'll do the same for every app we need. So we'll type in Cal, again, Google Calendar API. We'll install again, install all of those. So then we've got Sheets, we've got, all of that stuff, Mail. In this case, we're going to have to go to Gmail API and then install there. So great, that's the first step. They're all installed. We're going to go back to APIs and services. The next thing is setting up our credentials. So we've given it access to the relevant APIs. We now need to give it access to our account. So we're going to go up here and we're going to click on create credentials. If you've not done this before, your OAuth 2.0 client IDs will probably be empty. So you're going to go to create credentials and OAuth client ID. If this is the first time you're doing this, it might ask you to set up an account. Just follow the steps through, and then once you set that up as an external web app account, you'll be able to come back to this part in the tutorial and set up this client ID. So we then have create OAuth client ID. We're going to choose a web application because we're just connecting it to n8n. Let's just call it n8n test demo here. You can call that anything you want. Now, this is really important. We're going to need to input our authorized redirect URIs, and that just enables the server from Google Cloud to connect to our n8n nodes. So we're going to go back into our test workflow. You see this OAuth redirect URL. I'm going to click to copy on the right-hand side. We go back. We're going to add that as a authorized redirect URI there, and we're going to create. That's going to appear then with our client ID and client secret, which are the values we need to take back to our environment. So we're going to copy that. We're going to go back, paste them in here. Oops. So we'll take the client secret, we'll go back, and then it's going to prompt us to sign in with Google, which we're going to need to do to just validate that. So I'm going to sign in with the account that I'm on at the moment. Click advanced, and then go to elastio.app. This might say something like render or whatever your service is hosted on, but we're going to go to it. It's then going to ask us to confirm the access and the permissions. Brilliant. Connection is successful. If we go close that window, we'll go back to here. We now can close that and we're all connected to our account. We fetch the test event. You'll see we're pulling in an email from that account. So we're just going to pull that trig up to our planning so that we have it in our first planning stage. And we're going to go into the trigger and we're going to pull the latest email. And I've just sent an email to myself with an invoice so that we can process something that's actually useful. And you can see inside the email, we have a bunch of formatting, which will show up as HTML code in our email, which makes it really hard to read. And then we have important information that we're going to pull from the invoice, like the price, the provider, 11 Labs here, different invoice numbers, and line items, which we can all break out in our data when we process it. So we've got the node open here for the Gmail trigger, and we're pulling that email directly through. So I'm just going to use what we used before and pin the data so that our data doesn't change, and so we can test with consistent data. And you can see on the right-hand side, we've got the output in a table format, but you can see that this email contains a lot of supplementary information that's going to make it hard to process for both us as a human and for the LLM later on. So what we actually really want to pull is just the text from the email and any key things like the subject, which might give us some references to what it is, who it's from, all of the key information like IDs, thread IDs. But there's a lot of supplementary information that we're not interested at all in here. So I'm going to show you how to strip that out now. So we're going to open up and click the plus icon here. I'm going to use our trusty set node or edit fields node. And we're basically just going to cherry pick the fields that we want to pull through. So one of them that's immediately becoming obvious is like, we should probably have who it's from. So it's going to auto-fill that, and we're just going to have from. And instead of naming it JSON, we're going to use our rules around proper, and we're going to call it Gmail trigger.item.json headers from, and you can see now it's pulling that email. We're going to also pull the subject. So we'll drag and drop the subject and do exactly the same there. Then in case we want to reply to the email in the future, we're going to need the IDs and the thread IDs. So we're going to pull those across as well. Then we're going to pull the text as HTML. And you can see that's a load of code here and not the actual text in the email, but it will contain the text in the email. And the reason I'm pulling it text as HTML is that I can show you in the next stage that if you don't have something that already strips out the HTML, there is a way to do that by yourself. I will also just pull the text, and we'll update these nodes so that they all reference the naming, so that if we add any nodes between them, they'll be easy to, they will continue to reference the correct node. And we can always come back in future and put another value in here. But for now, all we want to pull from this great amount of information are these things and focus on those things. That's why the set node is really powerful for doing that. It can strip out just the things you want to look at. And then we'll just call it set email values to correspond with our naming. So once we have that, we have then, if we test step, pulled just the values we want. And we now have a much cleaner format of data to work with than the previous. So we have the values as HTML, and I'm just going to quickly cover what HTML is and what Markdown is. So we've got a page open out here from dev.to, and it visually shows you what Markdown looks like. So we've got a list of headings here, and like we said before, the hash represents different heading sizes. So your first headings will be single hash, second headings double, etc. You then have these bullets or dashes to do your list items. And then there's other syntax like double star for bold text, single star for italic text. Now that is really easy to read and a really useful format for both us, but also a really good format to pass it into an LLM later down the line. And then we have the foundation of web development, which conventionally uses HTML. So if you open up the console for a given web page, you'll see that there's lots of these different HTML tags like head, etc. Like this head, these are XML tags that open and close. So we've got head and then the close of the header. Within that, we've got page title. Now, when this is written in HTML, it's much harder to understand and looks like this text here, long, very confusing, all of these different tags here that are hard to read. Whereas when it's written as text, much easier to read. It's still got these characters in, which represent new lines, but actually we can much more quickly identify the actual useful information from the text here. So the way we can do that in n8n is actually if we open our tabs here, we've actually got a convert between Markdown and HTML node. And all we're going to do is just inside the node have HTML to Markdown, and we're going to drag and drop the text as HTML. And you'll see it will actually give us the same text as we've got here. And this is just to show you that if you're ever dealing with HTML formats, you can convert it directly using this node rather than relying on the Google node to convert for you. And if we scroll down to the results, you can see that we've received the data here as a much more readable, stripped out the HTML set of values so we can see actually the content of the email there. And that's how we're going to pass it into the LLM later on. So we've processed that data and it's now in a much more readable format. We're now going to move these steps across and actually just check that we are outputting the correct data. And this is going to conclude your first automation completely from start to finish. And we're going to take in an email, we're going to clean the values, and then we're going to output it to Airtable now to show you how easy that was to make your first automation. So we're going to connect a node here, and we're going to type in Airtable. We're going to open up that node, and what we want to do is just create a record. So for each email we're processing here, we just want to create a new record. We're going to go back to, we can see the data that we're receiving in. We've got our credential already set up earlier. And what we're doing is creating a new record. So we're going to choose our tutorials base that we set up earlier. And now we're going to go back to Airtable to set up an appropriate table that contains all of these columns. So from subject, ID, etc. So we're going to come back into our Airtable and create a new table. But when we click plus here, there's a quicker way to do it. So if we hit the 23 more sources and we go down, we've got paste table data here. And now we're going to type in the values that we need for our columns. So we have thread ID from subject text as HTML. And I think we had text, which was stripping out the HTML there. So we're just going to go auto to text delimiter. And it's going to appear underneath that we've got these different field headers, and we're going to import pasted data. And you can also, and then it's going to ask us where we want to import it. We want to do it to a new table. It's going to treat them all as long text fields, and we can actually change the data types up here. So thread ID is probably going to be a string. Subject, again, single line text. Text as HTML is going to be a long text, and that's also going to be a long text. So we're going to import those, and that will create the table quickly for us. Now we've got all of the different values that we need. We're going to go back to our workflow, and we're going to hit refresh list up here, and that should now appear as imported table. I forgot to rename it, so we'll come back here and we will rename that to emails, and then we'll go back to our workflow, refresh the list, and we will go to our emails table. So there's two options here. We can map the columns from our data to our Airtable manually. And this is what you normally do because you don't always have the same naming convention from your data sources to your other data tables. Or if you know the columns match exactly, you can just map them automatically. So from will search for from exactly the same case, so both lowercase, in our Airtable. And if it finds it, it will create that, or it will add the value to that. But you're mostly going to use map each column manually. So we're going to do it manually here. And again, it's as simple as dragging and dropping from these over here to the correct field. So we've got subject in there. We'll grab thread ID and put it in there. Text as HTML and text. We're then going to rename the node to post records, post emails, and that just tells me that we are pushing our emails to the Airtable database. We'll then give that a run and see if that's successful. Okay, so it's come up as successful, and it tells us in our output the fields that have been added to our Airtable. So if we go back to the Airtable, we can now see that we have added all of those fields directly to our Airtable, including the full text of the email. So immediately we can see all of the information from that email, but you can see it's in a pretty poor format. But that is your first automation, getting from an email directly to pasting that in Airtable. Well done on getting to this point. Like, the first one is always the hardest, and you've done a really good job if you stuck to it to this point. We're now going to expand on this, figure out how to format and process the data, and actually get it to something usable for your business to pass invoices, whilst also learning all of the steps it takes to be a master at n8n fundamentals. So we'll come back to our workflow. And again, we've completed a really cool first automation here. So we are taking an email from our Gmail that we've connected up. We are extracting only the values we want and need from the email using the set node, and then stripping out all the complex HTML formatting. And then we are posting that to our Airtable so that we have a record of every single, or we could have a record of every single email that comes in. To activate that workflow and actually have it run continuously, we'd hit activate up here. And this might give you a warning the first time to say that this will run continuously. But what that means is now every single minute an email comes into that, it will be processed through this step. And those will all appear in the executions log that we mentioned earlier. So you can see all of the successful test executions we've done. All of the production executions will also appear in this log. So you can see the historic runs of that. However, the thing that we did not do there is cover how to handle different file formats. So in the Gmail trigger here, we've actually, if we fetch the test event again, we're actually pulling just text values from the email, and we're not pulling the attachments, which were PDFs attached to the initial email. That's what will cover now. So to resume our flow, what we're going to do is just copy and paste everything we had below so that we've got our initial automation still saved. And then below, we've got a new automation, which we'll start working on. We'll delete these out by highlighting them in delete. But to stop any tests from running on the top flow where we're already done with testing, what we're going to do is just click onto this and hit deactivate or D on your keyboard to deactivate each of these, or we can highlight the whole lot and deactivate or reactivate with D. So we're just doing that so that we can focus on testing our next flow where we're actually going to deal with multiple data formats. So we're going to get rid of our convert to markdown because we just did that as an example. And we're also going to unattach our post emails, and we're going to put that later on in the stage because we're still going to need to post to Airtable later so we can reuse that node. You'll notice now I've copied and pasted. We've got ones appearing by each of the node names. That's because no node name in n8n can be exactly the same as another. So if we want to make this look cleaner, then we'll give it a more specific naming convention. So this would be, now we're looking at files, not emails. Perhaps we'd say set binary values or set file values. And you can see the ones disappeared there. So to get the file from our email, we need to go into the settings of the message received. We need to go down to the options, and you can see this download attachments. We need to switch that on, and we will fetch a new test event. It's going to warn us about unpinning the data and that it's going to override our pin data. That's fine. We'll do that for now. So we've now pulled our attachment data inside this Gmail trigger, and immediately you can see we've got a new data type, which is binary. And we've got some sort of attachments here, attachment 0 and attachment 1, and the options to view and download them. So let's download one and have a look. So we've opened up that attachment, and you can see it's an invoice addressed to me, and it's got lots of different details about the invoice. It was issued on February the 2nd. Here's the invoice number. There's a total. There's a link to pay. All of these line items here, we're going to be able to, by the end, extract and put into an Airtable base so that we can reconcile our invoices just automatically from our flow. So we'll go back to the flow, and that was attachment 0. Attachment 1 is just another version. It's just a receipt version of that same attachment. But going back to the different formats, you can see we've got a new format. So we had the table, the JSON, and the schema. All of those still exist, but we've also got the attachments, which appear as binary files. If you're not familiar with the term binary, binary is how computers interpret data. So this file would be made up of millions of ones and zeros, which the computer's then able to read and translate into something that's readable for us. So a binary file, so all attachments and file formats that we have that aren't text will be binary. That includes your docx files, XML files, text files, sheets, Google Sheets, all of PDFs. All of those will appear in the binary section of the format. And n8n is able to download that file, and then we're able to use the data inside that file to get what we need. So to make sense of the text within the binary file, we need to convert that from binary to a format that we recognize, like text or JSON. We're going to open up the nodes here, and naturally we're going to go to the data transformation. We're going to scroll down, and there's a convert data section, which is all about converting files from one format to another. And we can see this extract from file says convert binary data to JSON. So it gives us all of these different options in here. And we know that we're extracting from a PDF here, and we're extracting values from a PDF in order to turn them into text so that we can process them into our Airtable. So this node will open up, and again, you can switch file types in this operation here, and the input binary field will always be called data by default. So we'll leave it as is. We'll drag this node down here. We'll connect it up to our flow. And what we're going to do now is run our tests. So we'll come out to the canvas and hit run test workflow. So we've come across our first error. Problem in node, extract from file. This operation expect the node's input data to contain a binary file, but none was found. So what I'm reading from this, and you can see it inside the node itself, is that the previous output of this it expected a binary file to be able to convert, but no binary file was found. Make sure that the previous node, i.e. the set file values, outputs a binary file. So basically, the error is saying there's no binary file in what you've passed to me. And that's because in our set file values, we're just passing text. We're not actually grabbing the binary file. So if we wanted to grab the binary file, there are two ways to do this. Let's disconnect it here. We could connect it directly to the binary file that's from the Gmail trigger, and we could run that, and that would now successfully run. And we'll come back here and we will run again. And you'll see that we've got another error. And the reason for that is what I just said was actually incorrect. They do not always call it data by default. It's sometimes, especially if it's coming from a Gmail trigger, called attachment. So what we're going to have to do is either put an attachment prefix here called data, or go into our extract from file and specify that we actually want attachment, one of the attachments. So for some reason, when we put in attachment 1, it's going to give us attachment 0, and attachment 0 is attachment 1. I'm not sure as to why, but the fields are just lined up that way in n8n. But we know we want to just process attachment 0. So I'm going to put in attachment 1, and you'll see from the output that that's going to give us attachment 0. Normally, most of the time, you'll be dealing with one file at a time. So it would usually be from a Google Drive, in which case it would be called just data. And it most of the time is just data. But when you're pulling from the Gmail trigger, it's important to know that we can update this binary field name, and it's just going to be whatever's up here. So we can see attachment 0 has been passed through. Now, here comes the importance in referencing the node names correctly. So inside set file values, we made sure to reference all of these names correctly, which now means we can actually put this node between them, and set file values will still continue to work. Whereas previously we would have had JSON dot, which then would have errored and not found any of the values from our text. So we've now got the text values from our original email, as well as the file values. If we click in the extract from file, you can see our output is the binary file, but also it's actually translated that like we wanted into text. So we've got all of the text from the actual invoice attachment of the email, not just the email itself. Now, if we consider our table again, we saw how unstructured all of the data was within the text that we retrieved. So we got rid of the HTML formatting, but still there's unnecessary spaces everywhere. It's really hard to read. And we don't want to pass those. Firstly, we don't want to look at those in our Airtable because that's really hard to read. So we want to strip those extra unnecessary characters out. And the second thing is when we pass it into an LLM, we are paying per character or per token that we send into the LLM. So we want to reduce our costs there. So what we need to do in n8n is strip out all of that unnecessary formatting to make it really easy for us and the large language model or AI or ChatGPT node to do that. Now, there are inbuilt ways in n8n to do that. If we go into our set file values node, we go to the end here where we've got text and we hit dot inside the object, then it gives us some suggestions on how to edit this. So we can concatenate it with multiple things, but we don't want to do that. We can remove our markdown values. So if it's markdown, then we might be able to just remove all of the markdown formatting. We can remove tags. So this is another way to remove the HTML or some of the HTML. Then we've got things like replace, where we can replace certain words or certain key values with things. There's a whole bunch of things that allow you to edit, like trim the end, trim all spaces, etc. But what we want is a catch-all to remove all of the unnecessary formatting that's made it through here. So you're not going to be able to do that easily within these functions or within these additional options that we can put directly in the expression. So what that's going to require is a separate code node. If we go into the plus icon here and we go into the core, there's a code node in here, and you'll see that this is some JSON formatting. So again, we've got our inputs on the left, which are all our values. We've got the code node in the middle. And on the right, we've got our output. For anyone that's not done any code, don't be alarmed. This isn't as difficult as it looks. And we're going to use ChatGPT or Claude to help us create these nodes for us. And I'll show you exactly step by step how you do that. It's really simple. So first, let's go over this. We've got a mode. And by default, it runs once for all inputs. We're only considering one input here, so that's fine anyway. Or we can run once for each item. And then we can choose JavaScript or Python. I just choose JavaScript because that's the stable version here. And you can see it says loop over item, input items, and add a new field called my new field to the JSON of each one. So it's saying we're taking this JSON from our inputs and taking an action on it. So if you've not done any code before, all this is saying is for each item within our input, which we've referenced by calling the $input.all, take this action. And that is it. We're then saying, okay, at the end, return everything you've got. So if we run this, it's going to return what we currently have plus a new field called my new field. So you can see everything we've currently got. And then we've got my new field is equal to 1, exactly what we've asked it to do. So I would not worry about manipulating this directly. I'd worry about the business logic behind what you want to do. So we said before that we want to take the text that we've received and strip out all of these /ns, which are new lines, new spaces, and all of the unnecessary formatting here. So what we're going to need to do that is understand a concept called regex. And I've asked Claude to explain it simply because actually it's quite a unique concept. So we have an example with a phone number here, and you can see it's got some parentheses and an exclamation mark. However, we just want to strip out the numbers. So it's given us some code here that actually gives us just the stripped out numbers. It's saying, okay, to clean the phone number, we're going to pass in the phone number and we're going to apply this manipulation on it or this regex formula. And this pattern means match anything that's not 0 to 9 or not a digit and replace it with nothing. So that's where we've got this. Some common patterns for stripping out characters are removing all the spaces, removing all punctuation entirely. We may not want to do that because we're dealing with numbers. And if we remove all the full stops, for example, then we will we'll change the value of certain numbers. And then lastly, you have more of a catch-all, which is remove everything except letters and numbers. The point in this is there are certain terms or phrases that you can use inside regex that will strip out exactly what you don't want. You don't have to go Googling all those. There's a really simple way to do this. And to do that, we'll just come back to here. We'll copy and paste the example that's given every time. We'll come into Claude again. We'll paste that. And at the top, or ChatGPT, if you prefer. This is just the simple way to do it. Create an n8n code node in the below format that takes in text with unwanted characters and strips out new lines and all formatting except commas and full stops. And it's asking it to do it in this format, so it will return it in the n8n structure. If you're referencing a certain field, and in this one we're referencing text, we should also mention that. The field input is called text. That's going to return us probably a 95% version that we might need to modify slightly, but you don't need to know the code to do all this. So it's returned the JavaScript function, which we can just copy from there. And it says, okay, this will replace all new lines with a single space, remove all special characters except commas and periods, convert multiple spaces into a single space. If it doesn't work the first time, just bring the new code back into Claude and re-prompt it or re-ask it for what's missing, and that you will get there eventually. It's a very simple, quick way to create code nodes without having to write them from scratch. This is JavaScript code, so it is fairly readable by looking at it. Again, we're taking items from all the inputs, and we've got what it's called dirty text, which is the referencing our text field. And there's a good job we told it about what the input was. And then it's saying, okay, take the dirty text, replace the new lines with a space. So this is the regex here, replace it with a space, remove everything except words, spaces, comma, periods. So you can actually find this regex expression online if you want to make this yourself, but instead Claude just came up with that really quickly for us. So we're going to run that, and it's going to output a cleaned version in clean text. If we scroll all the way down to the bottom, we've got text, and now our text output, you can see, has none of the formatting that we have on the left-hand side. It's stripped out all of the things that we asked it to, really simply. This, again, is not 100% human readable. It's still got some invoice links, etc., but it's a lot more readable than the left-hand side, and it reduces our token usage when we pass it to the AI node. Finally, on the code node, we will just rename it to what it's actually doing. So we'll call it format text, and we will save it there. The next top tip is around using conditional instructions. So what we mean by that is we may want to process the binary files in one way, or any emails that don't have binary files, i.e. just text emails, in another way. So how can we get it to route those based on the inputs to take different actions on either? So what we're going to do is come up and add a node in here, and we want the flow category and the if. So we've got a few different ways to do this. We could filter out conditions. So if we're only looking for emails that have files in them, then we could filter out the ones that don't. However, if we want both emails, but we want them to take different actions, we can either use the if node or the switch node. So for this example, we're going to use the if node, and it opens up with these conditions. So let's wire it up, and let's wire it directly to our Gmail trigger. You can see at this point that we can have multiple routes directly from one node, and n8n will process those sequentially from top to bottom. So if I put the if node first up here and I run that, it will actually run that if node first and then the nodes down here. So it processes top to bottom and left to right. So it processes that if node first. Once that's run, it will then run the second branch. If I put that if node down below, it will run the first branch that's above it and then the second branch. You can see the top run and then the second run. And again, left to right will always run first. So in this case, we actually want to process them differently. So we will consider if the Gmail trigger has an attachment, then we will take route 1. If it doesn't, then we will take route 2 and process it differently. So inside the if node, we can see the inputs on the left-hand side as usual, the conditions in the middle, or the transformations, and then the outputs. So at the moment, we've got no conditions. So what we're looking for is, does the input, the Gmail trigger, contain an attachment? So on the conditions here, we've got a few different options. We've got names that we can refer to from our JSON data. So for example, again, we can pull in, we scroll down, say we want to exclude all emails from a certain address. We just drag and drop the from address into the top, and we say whenever the from address is equal to, and then we can fix this to any email, then that condition is going to be true, and it's going to pass in the true branch. Whenever it's not equal to, it's going to be false. So if an email comes in from that email address, it's going to go to the true branch and be processed down this path, which we can connect to any node, or if it's not, it can be connected to another node. So here, we'll just put, is it from example@email.com? And it's going to go down the false route. And you can see it's gone down the false route because actually it was from Simon at. So what we need to do now is just identify the condition that is having a binary file attached to it or not. So inside here, we just stuck with the default, which was string. So we're comparing string values here in the from address and the from email. But actually, when we consider a binary object, it is in fact an object type. So we're saying, does that binary object exist? And we can just reference the binary value directly. And we can do that by putting the expression brackets, and we will say Gmail trigger dot item. And if we hit dot again, it will give us the example of JSON or binary. And you can see that's lit up green to suggest it does exist. If file exists, we'll call that, then go through the true branch. So you can see it's now gone through the true branch because actually there are files existing with this email. So what we might say is, if the file does exist, then okay, we're going to follow this route, which is extract from file, etc. However, if an email comes in where it does not exist, then we're just going to process directly the text from the email. And what we're saying here is actually take one route if a file exists, take another route if it doesn't. So if a file exists, we're going to extract the data from the file and format that. If the file does not exist in the input, then we're going to follow this false branch. So at this point, you can see that we've now connected 2 nodes up to a single node. And you're probably wondering if this is possible at all. How will the format text react? So in this case, we're only ever going to have one input going into it. So it's either going to follow the true branch for if it does have attachments and go into the format text, or it's going to follow the false branch, set the file values from the email, and then go into the format text. One thing I didn't mention was the if node will pass through all of the data from the input. So we know that if we're referencing it from the previous node, it will be exactly the same. So yes, this can work, and it's only going to be processed one at a time. The only way it can work, though, is if this node receiving both inputs is handling them exactly the same, i.e. they're named the same. So we can see in the set file values, we are outputting text. And from the extract from file, if we just run it again, it's also in the JSON data, outputting a field called text. So the inputs to format text are always going to be called text. And if you remember in the format text code node, we said reference the node name, reference the field name text. So it doesn't matter whether it comes in from this branch or this branch, it will be processed. We'll never be going down both branches at once and have the trouble of receiving two inputs at once. So we know that a node can handle multiple inputs as long as it has the same reference from the previous value, like text in here. However, what if we do have two inputs and we want to process both those at once? So say this if node didn't exist, and we'll just get rid of all the connections here. And say the Gmail trigger actually, when it triggered, followed both paths. So one path we were extracting the data from a file if it existed, and another we were setting the file values, i.e. just pulling the text. How does that work? Because now we're processing two lots at once. So this works correctly for the same reason, because actually we've called it both text. And actually in this case, it's output two items, which we can see in the runs here. Run one is the binary file, but also has our stripped out from the binary file. And run two has run through it, which is just the text from the email. So we're actually able to get both here. However, if this format text required both inputs to be completed before it runs, then what we'd have to do is introduce the merge node. We go across here and we go to flow again. We've got merge. So if we drag over the merge node and delete these connections, the merge node will effectively allow us to combine or append or manipulate our two inputs, and we can add more inputs inside here, up to 10. And the options it gives us here is to append them. So if we run that, we'll have one after the other. So it'll effectively be two sets of table data in two different rows. If we combine them, we can choose a field to combine by. So we might want to match up two sets of data. We'd use the merge node for that. And we can write the field names in here. And if they have different names, mark that. The outputs from that we get to choose. We could have both inputs merged together, so all the data in one row, or we could have just the data from one. We just want to pull the input data from one. We don't have to just combine by matching fields. We can combine by position. So if we've got two inputs and there's only one initial email, then actually it might make sense to just combine by position. And what that will do is just combine all of our fields together. But in this case, it would combine all of our matching fields together, so text. But in this case, if we combine by position, because we've got a field called text in our file input and a field called text in our email text input, we'd probably lose some of that data if we combined it by position, and it would just have one text output. If you wanted to get more complex with it, you could run an SQL query to do the merge, but most of the time, 99% of the time, you don't need that. Append and combine will work. There is one final option, which is choosing a branch. And this allows us to just wait for both branches. So sometimes we want two branches like this to both complete before we pass through the item. And therefore, we'll just use this merge node to actually take both of the inputs and wait for all inputs to arrive, and then just output everything. And it's just an easy way to wait for all data to execute before we pass through. But in this case, we don't actually need the merge node because our format text handles it directly. So we're going to delete that out. We're going to reconnect those up here. So every time we run this automation, we are going to be flooding the server memory and actually adding more and more data to that memory. You can think of it like your brain. You can only hold so much in your memory before you get overloaded and you can no longer do any tasks. The same counts for our server. If you are hosting on n8n cloud, i.e. directly through n8n, then you probably have a significant amount of memory. If you are self-hosting, you've chosen the amount of memory that you want to use. And if you are handling thousands of rows and you keep running these test workflows, they will continuously be appended to the memory and stored more and more and more until you come upon an error where it tells you you have no memory or not enough memory to perform the action. A simple tip to prevent this is actually between the test workflows, you can go down to the bin icon and click that, and that will delete the current execution data and remove it from your memory. Super simple tip, but actually will save you when you come across that error. Now, one of the most powerful features of n8n is that it can handle multiple inputs at any one time. So we are pulling here our emails every single minute. And some of you, if you have a lot of emails coming in, would actually be processing more than one per minute sometimes. Say some 2 emails came in 1 minute, then they would also be pushed through this flow at the same time. Now, sometimes that's okay with some flows, but ones where we are processing heavy amounts of data, we might want to spread out those so that we're only processing one file at a time, getting that through the loop, getting it done, and then processing the next. And that's why loops are a really powerful feature of n8n, one that you'll end up using a lot. So we'll open the nodes panel here, and in the flow, we've got this loop over items, in brackets, split in batches, because that's what it used to be called. We're going to click that node open here, and you can see we can choose the batch size in here. So we're just going to choose a batch size of 1, and it's the loop over items node. You can see sometimes that when you connect in the middle, if you've clicked a previous node and then you connect a node in the middle of the workflow, it will just throw it on top and connect it to a bunch of different things. So I'm just going to cancel that, click somewhere random on the canvas, type in loop again, and bring that over here so it's disconnected. You can see that loop comes as a 2-node piece. And the reason for that is it's almost like a demo of the mini loop that you need to take. So we've got the loop over items node here. We've got the loop, which is you need to replace this with the nodes that you want to loop over. And then after the final node that you want to loop over, we return it back to the loop to process the second one, or the third one, or the fourth one. So it's just going to process them one at a time. So the easy way to do this is to delete that node, delete that line, and now we have the loop items, and we're just going to disconnect these, and we'll just consider this flow where we've got a file only, and we're going to connect that there, put that in the middle. So now the process that we want to do is actually data format on that individual one, format the text, and then output to our Airtable. So we're going to attach those all together and loop it back round. So now for every minute, if multiple emails come in here, we've got 2 emails, then we will only follow this. Then we will follow this loop per each email rather than 2 emails going into here and extracting the files, 2 in here, 2 in here. It would just separate them into individuals, which will prevent any problems. This only is important where you want to process them individually. So because we're going to include an LLM node that processes the input, we want to just do it for that specific email and just handle them separately. So we're going to add that loop there. I'm just going to disconnect so that we can run the next part of the flow, but we essentially got to the point where we'd extract from a file, format the text. We are nearly there with creating a full invoice extraction and processing workflow. We've got one key stage next, which is how do we extract the info? And for that, we're going to use the AI nodes. So if we come into the nodes and we go to advanced AI, we're first going to run over what each of these mean. If we come into the nodes and we go to advanced AI, we're first going to run over what each of these mean. So AI agents, you've probably heard a load of different definitions of AI agent, and you're thinking, what the hell is an AI agent? And how is that different from things like ChatGPT, AI workflows, AI nodes? There's so many different terms. And here I'm going to distill the exact differences between all of those terms so that by the end of this module, you'll be really clear on exactly what an AI agent is, what an LLM is, what are the advantages for your business of using an AI agent versus an LLM, and what are some good business use cases that we could use an AI agent for versus a non-AI agent for the various areas of your business, customer support, sales, operations, document processing. We're going to cover it all. So we're going to start off with what an AI agent is not, because that probably makes it clearer given what you already know. So you'll probably be familiar with ChatGPT. ChatGPT is just a layer on top of a large language model, or what we call an LLM. It takes our queries as inputs and it produces outputs. So we type our message in and it gives us an output. And the way that works is a large language model is trained on billions of parameters and lots of data. It works by predicting the next most likely word in a sequence. So we ask it a question, It then uses its training data to provide an answer of the most likely words in that next sequence. So the next concept we're going to cover is really, really important in distinguishing between an LLM and something like an AI agent. So we're going to cover agentic and non-agentic workflows. And once you understand this concept, you'll understand that AI agents always fall within agentic workflows, but you can also have agentic workflows that don't have AI agents inside them. So a non-agentic workflow is like prompting ChatGPT or typing a query into ChatGPT, and we call this zero-shot prompting or non-agentic workflows. Something like, please type out an essay on topic X from start to finish in one go without using backspace. So we are prompting the large language model, and it's giving us a response based on its training data. An agentic workflow breaks down that task into multiple subtasks and makes decisions based on the data, but also decisions based on the research that it conducts. So an example of it breaking down subtasks here might be write an essay on electric cars, and then it's asking itself, okay, do we need any web research to support that? And perhaps it's going out and actually grabbing that research from a tool that's connected to it. Then it's writing the first draft based on that research. And then it's, in the next step, considering what part needs revision or more editing, and actually then telling itself, okay, these are the bits we need to edit, and editing it itself. So instead of this single linear flow from start to finish, the agentic workflow breaks down the different subtasks and actually thinks and revises based on the information and feedback that it's provided back to itself. And this can be inside one singular AI agent that's giving itself steps and planning out a task, or it could be multiple LLMs chained together in order to create a sequence of feedback or a sequence of decisions. The important part here is that while both of these use AI or can use AI, the agentic workflow exhibits agency, i.e., becomes agentic through its ability to make decisions and adapt its strategy based on the content it encounters, rather than following a fixed processing path. So it's able to make decisions dynamically based on the inputs and take dynamic paths based on that information. That will all become really clear in the next few examples. We're now going to cover a business example. If we were building out a workflow, what would it look like side by side if it was agentic versus non-agentic? So we're going to use an example where we're building out an invoice parser. So we're receiving in an email with an attachment of an invoice, and actually we're processing that invoice and extracting the key information like supplier details, total price, invoice number, and various details based on that attachment. That attachment can come in any format. So it could be a PDF, it could be an XML, it could be a docx, it could be the text inside the email. We have two flows here which represent how that could be done in a non-agentic way, and on the right-hand side, how that could be done in an agentic way. So on the left-hand side, we have a single linear flow that takes our email, an AI node or LLM extracts all of the information from that template, and we are looking for template matches, i.e. supplier number, invoice number, VAT references. It's going to extract all the information that it can from that text, and then it's either going to take a linear path of, okay, was it a success? Yes, we'll add it to our database. Was it a success? No, then we will flag an error. But no further action is taken from this. It's from start to finish, non-agentic because it's not making any decisions. It follows a simple linear path from the email receipt to storage or error handling. There's a single LLM extraction attempt. So it doesn't matter what type of content has come in. If this is only built for PDFs or only built for text, then it's just going to try and extract based on the information we've given it. And it's not going to adapt its approach. It's just going to be a one-size-fits-all approach, try and pull the text from the PDF, but if it doesn't have the functionality to do that, then it's going to fail. We then have a binary success failure option, so we have no option there to retry the process. And then it's going to try and match a fixed template, regardless of what format the invoice comes back in. So in summary, it makes it non-agentic because there are no decisions or adaptation in the flow. There's no feedback loop where it's iterating on its own understanding. It can be connected to tools, but no decision is made based on the input of what tools to use. And this example, we've not connected it to any tools. And then there is a fixed output every time, same output. This contrasts to the agentic invoice parser, which you can see when we go through, makes decisions and provides feedback to itself. So we receive the email in, we're then classifying the content, i.e. understanding what data format is it in? Has it come in as a PDF? Has it come in as text? Has it come in as XML file? We're then passing it to the AI or LLM node here. And this could also be an AI agent. We'll come on to the specifics of what makes it an AI agent. And then based on the content it's received, it's then taking a decision. Okay, I've received a PDF, so I'm going to take this route. So it's making a dynamic decision based on the inputs. Okay, I've received an image, so I'm going to go and scan the image using an OCR tool. Or I've received text, and therefore I'm going to take this route. So it's dynamically making that decision based on the input data. Whereas previously in the non-agentic flow, it was just a linear flow. It didn't matter what the input was, it would always take the same actions. We've then got a validation step. So we will have another AI or LLM node that tells us and feeds back to the previous step. Was that attempt successful? If it wasn't, then we have the chance to actually do it again and feed it back into the dynamic field extractor. So in summary, this is an agentic invoice parser because it features multiple extraction routes based on these different file types. It includes confidence-based processing and actually feeds back information to itself to make sure that it's correct. It has access to these different tools, so it can actually dynamically choose which route to take and which tool to use. And importantly, it can refine its own strategy to improve extraction success. So based on the feedback, it can run again to make sure that we've got a successful run. So the thing that makes this agentic is, yes, there were decisions on actions to take, and it took those decisions. Yes, there is a feedback loop, i.e. it can process its own output again in a second run. Yes, we can connect it to tools again, like the 3 we've connected to. And most importantly, it's got a variable output. We're not expecting a fixed output. When we've got variable inputs, we're expecting variable outputs. So we're going to go across now and understand how this presents itself in our workflow automation software, n8n. So when we consider our workflow automation platform, n8n, we have a bunch of different options. If you open up the nodes and open up AI nodes, you have a load of different options you can see down this right-hand side. I'm going to explain now what makes some LLM nodes versus what makes some AI agents, and we'll cover the specifics of what is an AI agent within an agentic workflow. So the LLM nodes, going back to our agentic versus non-agentic workflows, LLM nodes and workflows can be agentic only if you make them. So if we have feedback or decisions, or we chain multiple of these together to create dynamic routes and actions, then they will be agentic. But they also cannot be agentic. If we just had one basic LLM chain, we're effectively using that like we would ChatGPT. We're just inputting a message and it's retrieving a response and giving us an output based on its context. I'm going to quickly run through now all of the different LLM nodes that you can use and which ones you'll most frequently use for automating your business workflows in n8n. So I've put them all on the canvas here so you can see exactly what they look like. And they're all connected to one single OpenAI chat model, but you can actually connect these to individual models. They don't have to be OpenAI, they could be any other platform, but it's just for demonstration. These are all connected to one model because you can actually do that. Now, on the right-hand side, what you'll see in the tools bar are the different options. And each of these options have been created so that it's easy for you to understand which one you'd pick for a specific use case. But under the hood, it is effectively an LLM with a different system prompt designed to do a specific task. So take, for example, the information extractor. This says it extracts information from a text in a structured format. So this is just an LLM node, or we're just sending a prompt or an input to something like ChatGPT and a model of ChatGPT like 4.0 mini or 3.5. And it's just told to extract information. And inside that node, we tell it what information and what text to extract from. We then have the sentiment analysis tool, which again is told, okay, we need to extract the sentiment of neutral or negative from the input text. And that's really useful when you want to understand from a large piece of text or customer feedback whether things were positive, neutral, or negative. We could do the same with just an LLM prompt. We just change the prompt and give it more information about what makes a positive text, what makes neutral text, what makes negative text. But these are predefined nodes with prompts already made for us that make it easier to do certain actions. We then have the text classifier, which again is just a prompt that says, classify this text into distinct categories. And it will have underneath some clear examples of categorizing that text. But at the end of the day, it's just an input and an output based on our input text. We then have a summarization chain. Same here. We're contacting an LLM. We're using an LLM to summarize a block of text that we pass in. And then we have the most generic basic LLM chain, which we'll probably use the most because it's the most flexible and we can adapt the prompt to how we want to see the output. We can give it clear examples, etc. The basic LLM chain is a simple chain to prompt a large language model. So this is the same as going to ChatGPT, choosing the model you want, like GPT 3.5, and putting in a set of instructions, a role, some examples of the output you want. We can do that all in the basic LLM chain, but it's still not an AI agent and not necessarily an agentic workflow. We can use this basic LLM chain, and it can be in a non-agentic workflow. If we've got that linear flow, there's no feedback, there's no actions, and there's no decisions being made based on that information. If it's just a linear flow input, LLM output, then it's a non-agentic workflow. And for all of these LLM nodes that we've covered here, none of them can connect to tools. None of them can look at historic messages they've received, so they have no memory. And none of them can perform function calls. So they are simply input text and output text based on the content that you provide and its training data. We finally have the question and answer chain, which looks a little bit like an AI agent because it has a tool attached to it. So we can actually attach a memory to it or a database like a vector store. And this is an LLM chain designed to answer the input questions based on the attached documents. So this would be in the non-agentic workflow and LLM category because it's a linear flow. We're not asking it to make decisions based on the data. We're asking it to retrieve data based on our inputs. So you can see there's quite a lot of LLM nodes in n8n, but they're designed to make it really easy to do specific tasks. But if we want to keep it more generic, then we're going to use the basic LLM chain and create our own prompt. And that's still a really powerful tool. And remember, these can be agentic workflows or involved in agentic workflows only if you make them make decisions, have feedback, attach them to tools, etc. But they also cannot be. They can also just be LLM nodes if that's what you need them for. And the idea behind this is we are trying to leverage the best thing for what we need for our business. There's a snippet I took from the n8n documentation here, which I thought was a really powerful sentence that distills what an AI agent is versus an LLM. So while LLMs only process input to produce outputs, AI agents add goal-oriented functionality. They can use tools, process their own outputs, and make decisions to complete tasks and solve problems. So they've got a little table here of the features of an LLM versus an AI agent, and it just simplifies the view of what each of those does. So again, an LLM does not make any decisions. It's just generating text based on our input query, whereas an AI agent is actually looking to complete a task and making decisions on how best to complete that task. So yes, it's making decisions. Yes, we can connect it to tools and APIs. And it's given two clear examples at the bottom here. So an LLM can generate a paragraph, whereas an AI agent actually could schedule an appointment. And the reason we progress to AI agents over LLMs is when we want them to perform complex real-world tasks where they actually make decisions on our behalf. So we finally got to it, AI agents. Understanding all of that is really important to understand exactly what an AI agent does. So I've got this great graphic I found made by Cobus Grayling, and I saw it first on LinkedIn, and it distills quite nicely everything we've spoken about so far that would make something an AI agent. So we've got the user input coming in on the left-hand side. Then we've got the LLM. So we always have some sort of LLM interaction here. However, the difference here is that the LLM is taking decisions and also able to access certain tools. So for example here, it might have access to the web. It might have access to certain tools like a weather API, a maths library or calculator. It might have access to a document database like a RAG database. It's then going to make an observation and based on that observation, understand if it's completed the task or not. And often it won't have completed the task on the first go. And we're actually going to cycle back and speak to the LLM again, which is going to give us the next set of tasks that we might want to take. So it might now say, okay, we want to search the web for more research, or we want to edit the content we've currently got. What tools do we need to do that? It's then going to pass the observation, and it's going to cycle through this loop, probably multiple times, especially for complex tasks. And when it observes and understands that it's actually completed the required task, at that point, a final answer is reached and it will send the output. So instead of just an LLM, where we'd have the user input, the LLM straight to the output, we've got this observation and decision phase, that could include multiple external tools until the final answer is reached. And it's able to iterate on its own understanding as we go through to get to a better output. So you might be wondering at this stage, when in our business would we use an AI agent versus just using an LLM? And we're going to get to that. But first, we're going to cover the AI agent nodes inside our workflow automation, n8n. So contrast to the LLMs, if you have an AI agent in your workflow, then they are agentic workflows by nature because the AI agent is making those decisions, taking action connected to the tools. So we're going to run over the key AI agent nodes within n8n and how you use them and why you use different ones. So the most familiar agent will probably be this tools agent. So inside our nodes, we can type in tools agent or AI agent, and it'll be the first drop down within the AI agent. So the description for this is it utilizes structured tool schemas for precise and reliable tool selection and execution. It's recommended for complex tasks requiring accurate and consistent tool usage, but only usable with models that support tool calling. So there's a couple of key things we can take from that description. The first is that we use this for complex decision making that might require external tools. So on the left-hand side, you can see that we've connected this tools agent to a series of different tools. The first is a database of memory. So we might use this to understand what a user has queried in the past. Say, for example, we're a customer service chatbot. We'd have that memory here. We might attach a company knowledge base to that so that it can search the company knowledge base and find the appropriate answer. We've then attached some more functional tools like an email workflow. So we can connect up other n8n workflows that conduct specific tasks. We might, for example, have an auto emailer that is emailed based on the user query. This tools agent might have the ability to schedule calendar invites, and we'd prompt that inside the LLM prompt, telling it what information it is likely to send to the calendar. But again, it is an AI agent, so it might be able to interpret from the input data, one, if it's missing any information, but two, if it's got all the information, what information it should send through. And inside these nodes, when we go and build them out, you'll see that we're defining specific input parameters that we're sending to these tools. So for example, a Google Calendar, we know to set up a calendar invite, we need to know several key bits of information. We need to know who it's with and their email. We need to know what the invite is about, and we need to know the time. So the AI agent, the tools agent here, is able to determine that info or work out whether it doesn't have the right information based on the user input, and then use the tool if appropriate. And then finally, we've connected it to a HTTP request. So we're able to connect it to any API that we want. And this might be to pdf.co for document processing. So say we receive a document in, it might understand at that point that we want to merge or split out a PDF and actually use that tool. But the key thing here is it's making a decision based on that and providing itself with feedback on the success of what it has done so far. We then have the second most commonly used, which is a conversation agent. This is most similar to our LLM chain, but the difference here is we can give it a conversational memory. So this is great for chatbots, customer service chatbots, things like that, or company knowledge chatbots, where we want to retain memory of what the user has said before. So we can connect it to a memory, like a computer memory buffer memory, but we can also connect it to all the different tools that we mentioned. And on the right-hand side, you can see a sample of all of the different tools that we can actually connect it to. It includes things like Google Mail, Google Calendar, Calculator. There's a lot of different tools, and they are always bringing out more tools that we can connect these agents to, making them even more powerful out the box. And any that we cannot connect to, we can usually connect to through the HTTP request tool, through the APIs. There are some other AI agents that we've not touched on here that are available inside n8n and have each their own capabilities. You'll use the tools agent and the conversation agent most, but if you have specific tasks, then you might use the functions agent, which is excellent for tasks requiring specific structured outputs and specifically working with OpenAI models because they support function calling. You might use the plan and execute agent, where actually your task is more planning based and you need to solve multi-stage problems. And the agent is able to iteratively work through that problem, give itself feedback as it works through. The React agent is similar, where it combines reasoning and action. So where we require careful analysis and step-by-step problem solving, then a React agent may be good for your use case. And then finally, if we want to interact with our SQL databases, then an SQL agent is specifically trained on generating queries, SQL queries, to reach from our database. So all of this theory is no good if we don't know how to apply it in certain situations. So we're going to go through now a few different business cases where we might use a non-agentic workflow, an agentic workflow, and what an agent might actually do in that scenario, just to give it some life and help us understand exactly how we might use this in our business. So we first have a customer support workflow. So we want to enhance our customer support processes, and we're going to do that using workflows. We could have a non-agentic workflow, and this might be where we have a linear flow. A chatbot follows a predefined response template. So we have a series of questions and answers that it's able to use, some fixed escalation paths based on certain keywords that trigger it. So this might be a chatbot that's just trained on our FAQs, but isn't able to think on its feet and able to perform more actions than just sending escalation or returning an FAQ answer. If we were to make that agentic, the things that we might include are a human feedback loop. So we might be able to escalate to a human who gives us feedback, and then our agent or workflow is able to adapt to the human's feedback. We might have dynamic response generation. So it's able to think about, based on some context, what it should respond rather than sticking to the predefined response templates. And then we may have different scenario routing based on things like, does the customer want to place an order? We will take this action with the customer or send them down this route. Does the customer want to escalate to a manager? We'll take them down this route. So it's able to think about what the customer is inquiring about and use appropriate routes or tools and dynamically choose those. And an AI agent within that might be able to use those different routes that we mentioned, so multi-channel support management, but also use its understanding of sentiment analysis to understand how do we prioritize these queries coming in. Going down to sales, we might have manual lead qualification for a non-agentic workflow with fixed outreach templates, whereas an agentic flow might be able to work out a lead score based on the inputs and dynamically choose the route that lead goes down and choose a personalized approach for that customer. And the AI agent may help with that lead qualification and scoring, as well as personalized outreach or meeting scheduling. For content creation, you can see it follows a similar gist, which is non-agentic workflows may be creating content based on our template inputs, whereas an agentic flow may be able to conduct real-time topic research and optimize and change the templates based on the content or research. The AI agent, as part of that, might be doing the topic research, conducting web searches or SEO research, as well as referring to our brand voice guidelines and able to dynamically adapt our content to the brand voice. And the final example we have here is document processing. So again, non-agentic would be a linear flow with no feedback loops. And we covered this in the invoice parser as part of document processing. An agentic flow would be able to dynamically extract data based on the content that's input, based on its understanding of what we want to output. So if, for example, we told it to split the PDFs, it might reach out to the split PDF API and understand that it needs to perform that action and understand whether that action has been performed correctly and whether the inputs we received in the first place were in the right format to do so. So that rounds up AI agents, agentic workflows, and non-agentic workflows, as well as how all of these things can be used to enhance certain processes in our business. Now, coming back to the context of what we actually need AI for here, we are processing some data from a file and trying to extract key info using an LLM or a large language model. So we could use something like a prompt, but like I said, most of the time, we're actually going to use an LLM chain where we can give it a set of instructions and tell it, these are the different items I'd like to look for in the email. Please extract those and put it in a certain output. And we'll run through that in a moment, how we get a certain output and what the prompt looks like. We don't necessarily need to give it any tools. We're not outputting data into different tools like a CRM. It's all going into one place. We don't need any web search. So we're actually not going to use an AI agent in this case, and we're just going to use a basic LLM chain. So we're going to drag that up here. And the first thing you'll notice that we've got is a model down here. So we're going to open up the node, the basic LLM chain, and you'll have two options here. You'll have connected chat trigger node, which will be there by default, which means we can pass in a chat message from a previous window as the system prompt. So the prompt is just what you would normally type into ChatGPT or Claude. It's just the message you're asking it to, or the task you're asking it to perform. We're going to define that below, and it will just appear as this text field. And you can see we've got these warnings because nothing's been filled out. You can see here, we've got require a specific output format. For now, we're going to leave that as not ticked, and you'll see the variable outputs you get and how to correct those. And then down here, we have these additional options. It will start with none, but by default, we will add a system message. And the system message in prompting is there to tell the system or to tell the LLM model what role you would like it to perform, the inputs you're going to provide for it, and the expected outputs, as well as the style it should use. And then all we're going to define in the user message or up above is what inputs we're actually providing to it. So we're going to want to pass the text in because we're going to extract key info from the text, which has been pulled from our file. It's important to note at this point, you cannot pass a binary file into the LLM. It only understands the text that we pass into it. And that's why it's so important early on that we pre-process that data and format in this way. So that actually, when we pass that text through, you can see it's very clean text that it can just read through and extract key info from. Now, you'll see a lot of contradicting advice around how to prompt properly, but also lots of useful advice. You need to work out the style that suits you. For me, I fill most of the information in the system message, and then I tend to just put the inputs directly. Once the LLM understands what its role is, what the outputs I'm looking for, the inputs are the only thing I put in the user message. But try out different methods, see what works for you. You can add all of this prompt into the user message in the text up here, or you can add it all into the system message. It's entirely up to you. So I've got a prompt, if I open up here, that I've previously used for an invoice parser. So I'm going to paste that in to save us some time. But what we're going to do now is run through the important details in this prompt. So I've effectively given it this role. Given the following invoice in the invoice XML tags. So I'm going to pass in an invoice or the text of an invoice, extract the following information as listed below. So I've told it what its role is. If you cannot, there we go, we've got a mistake, find the information for a specific item, then leave blank and skip to the next. Sometimes LLMs can get stuck if they can't find certain information we've asked it for. This just gives it an out so that it will not keep searching and will save its time and just jump to the next. Not all of these are required, as you'll see. I've then got a bullet point list, which I've done with stars because that's markdown format. But again, this could be a numbered list for you. It could be dashes. It doesn't matter. It's still going to interpret it the same, but I just tend to use markdown because LLMs are trained on markdown. So we've said, gather these items, the description, a short 1 to 2 line description of the invoice, e.g. monthly database usage for Superbase. The reason I've given it examples is because you should treat a prompt like you are training a human how to get the same output. So if you were to just give these items to somebody you were training without giving them examples, you would probably get variable results. Whereas if you give them an example of what good looks like, then it can consistently relate to that example and actually pull more relevant information. So examples in your prompt are really key to getting it to a really good output, consistent output, which you need for business use. So we've told it to pull a description. We've told it that we want a type. So I've given it some options here. You can either choose monthly recurring, annual recurring, or single payment. So we're referring to invoices here. So most of mine fall under one of these. And I want to know when I'm reconciling it, was it a $399 single payment, or is that a monthly recurring thing that I need to check out? We then pull key info around invoice date, payment date, because it's not always the same as invoice date, the invoice number. And you can see I've specified that these are required, and the LLM chain or the model that we connect it to will understand that it needs to pull those every time. And then we've got lots of different information that we're pulling from that invoice. And you can go in here and change it and remove things. But we're effectively specifying all of these different things that we deem important to pull from the incoming text if it finds it in the incoming text. I've then added this almost like a catch-all, additional information you deem important that isn't included above. And then we've said additional important information such as payment terms, payment methods, tax exemption references, delivery terms, special instructions. So things that it might not pick up in those categories, but we might want to know when we're reconciling invoices, it actually pulls. So you can see I've given it clear examples of things I want it to pull, and that is all in the prompt. But you can see there's no inputs here, but we've told it to expect an invoice input inside of these invoice XML tags. So to make that really clear, we're going to go into the user message up here, and we are going to add these XML tags, so the opening and closing tags here. And again, you don't need to work with XML, that's just a preference. You could instead just say invoice or just pass in the text and it would understand that that is the invoice. But I prefer to just specify in the system prompt and then call out the same things, because when you've got multiple inputs, that becomes more important. So we're going to give that a run now, but you'll notice that it will not run. You'll notice that we're missing one final thing, which is a model to connect it to. So down here, we can click plus on the model. And on the right-hand side, we get given the options for all of the different model providers that we can connect to. So ChatGPT, for example, uses OpenAI. It's a model from OpenAI. Anthropic gives us Claude, Google Gemini. The majority of times you're going to use OpenAI or Claude. And a way to do that is actually to use OpenRouter instead. So if you've been keeping up with AI news, you'll notice that there's a new model coming out every single week. All of the providers like OpenAI, Anthropic, DeepSeek are all competing against each other to get models out that are better and faster and better at certain things like planning or research. There's lots of deep research nodes coming out at the moment. So you want to stay as a business model agnostic and use a platform that enables you to switch models very, very quickly and very, very easily. So instead of hard coding these models like OpenAI chat model into here and being stuck with OpenAI and having to update our API key or update our keys when the model changes to the better model changes to a different provider, we can use something like OpenRouter, which in n8n has its own model, and we can use OpenRouter to connect to any model we want with one single key. So if we go to OpenRouter's website, it says a unified interface for LLMs. So you can access any large language model or thousands of them through one key for very minimal costs, basically the cost of what it takes to use that API through the official routes anyway. And on here, we can go to models and it will have all of the lists of models, but we know that the ones we conventionally use are ChatGPT, 4.0 mini, or so if we type in 4.0 mini, that will appear below. And you can see that if we click on it, it will give us all the details around costs. So it's $0.15 per million input tokens and 0.6 per million output tokens. Treat tokens like characters. So 15 cents per million is going to be hundreds of pages for 15 cents. So running this automation is going to be extremely cheap unless we have hundreds of thousands of invoices coming in. Models that are better at writing, like Anthropic's Claude 3.5 Sonnet, is much more expensive. So you can see it's $3 per million input tokens. So I recommend starting with a cheaper model, seeing how it performs, like 4.0 mini. And then if it's not performing up to standard, you can switch the model. That's the beauty of OpenRouter. So we're going to go into our OpenRouter chat model here, and we're going to go to the credentials, and we're going to create a new credential. And you can see up here that we can rename it again. So we'll say test for demo, API key OpenRouter. Obviously, you'd use better naming than this, but we go back to OpenRouter, and you need to sign up for an account first. So once you've signed up, sign back in. So once we sign back in, on the top right-hand side on the drop-down, you can go to keys and set up your new key, and we'll create a test demo key, and it will show your key on screen. We're going to copy that key, and I'll delete this afterwards. We'll go back to test workflow, copy and paste that into our API key, and then once that's saved, that will confirm that our credential is ready to use. You need to make sure that you've got enough money in the account. So you need to go to credits and make sure you top up $5 to $10. You can see 14 days ago, I topped up $10 and I've only used 90 cents since then. And I use this consistently every day for various things. So very cheap if you use the right models. We'll come back to the test window and we're going to come in and refresh the list here. And this will give us access to all of the different models. If you're experiencing this issue, which I've been facing with the OpenRouter model, there is an alternative way to access OpenRouter, which I'll show you now. So I've just tried to run it and it's come up with an authorization failed error. So actually, I'm going to show you how to use OpenRouter. But if yours also doesn't work, then you can use it through the OpenAI chat model. And what you can do is create a new credential with that same API key we mentioned before. If we come in and open the credential, then you'll see here's where we've put our API key, and the base URL you need to change to update to be OpenRouter and not OpenAI. So it's this address exactly, OpenAI/API/v1, and that will be enough to connect to OpenRouter. And then instead of from list here, if that doesn't show up, we can copy the model name from here and we can put it in as an expression, but it should show up here from list and allow us to pick GPT-4o Mini, which is the model we were going to choose. So now we've connected that up. Let's just name that OpenRouter so that we're clear on what it is. And we'll delete this OpenRouter official node. So now we've connected to a model, we can actually run it. And now that we've run it, you can see it's come out with our first outcome. So we've got the file, we've processed that into text, and we've actually then returned an output to actually output all of the text we've asked for. So it's given description, the type, the invoice date, the supplier name, and the invoice number. And we can go and check the invoice number ends in 0004 against the actual invoice. If we scroll up, we can see that the invoice number is in fact that correct invoice, and the total amount due is 2640. We'll go back here, and it's recognized the total price is 2640. So it has actually pulled all the information we need, all the information we've asked for, or where it can, pulled all that information. However, if we ran this several times, it might come back with different headers. Although we've told it in the prompt to specify all of these outputs, we've actually not, it still is using its own judgment on what to return because we've not actually given it a specific output format to require. So if you click the require specific output format, we're then going to tell it exactly the output format we need. The way it's outputting right now is not any good for us for inputting consistent data into our invoice system or our Airtable where we're storing the invoices, because we then have to break up all of these different fields again by split lines, and it wouldn't be easy to do that consistently. The output we've received here is a text paragraph, and to extract consistent data, which we need for our business to pass and reconcile invoices, we'd have to split all the different fields here. So there is a much easier way, which is actually just specifying a JSON output for the model to adhere to. So every time it gives us the same output format and make sure that that's correct before it outputs the data. So we're going to turn this require specific output format on, and that's going to give us a second thing to connect to here. We're going to click inside that, and we've got three options here. We've got the auto fixing output parser, which is the one we're going to use. And what this does is automatically fixes the output if it's not in the correct format. So we're going to specify an output format that we want, but this will automatically fix it by calling it the LLM again, rather than us having to tell the LLM, that's not right, try again. It will do that automatically, and we don't even need to prompt it to do so. And then the other two are an extension on that, which are what type of format do we want it to return in. So we're going to click the output, auto-fixing output parser, and you can see that we connect a model and an output parser again. So the model we're just going to connect to our OpenRouter model, and the output parser, we then open that up, and we have two options. We can return the list we can return the results as a list of separate items, or we can return a structured JSON format. I recommend using the structured JSON format because then consistently we can return the same data every time, and it's really, really accurate. And that's something we need when we're reconciling invoices. We need the exact fields to be present each time. So there's two ways we can generate this. The first is from a JSON example, like below, and we've been dealing with JSON data all throughout now. Or the second is to define the schema manually. We will just do the first one to show. So we're going to put in description here, and we're going to put in total paid here. And all we're going to do is tell it, give it an example of $20 in total paid, and the description is 11 labs bill. So we're going to run that now. And it doesn't matter what we specified now in the prompt to output, it will fix the output to be just those two fields. So you can see now in the output that it's output as we expected, description and total paid. And it's, given the description there, and total paid is 2640, which is extracted from the text. So that works well. If we want to pull all the fields that we specified in the initial prompt, which you can see were a lot, description type, invoice date, payment date, etc., then we could go through and write all those fields out. The alternative to that is generating it from a JSON schema. And the benefit of generating it from JSON schema is that you can be more specific with the type of data being passed through, and also whether the field is required or not. So you can see this is more complex, and it's a JSON schema format. Don't worry about this being complex. There's a really easy way to generate it. If you copy and paste this into ChatGPT or Claude as an example, And you also copy in all of our inputs from the prompt, outputs from the prompt, and what we want to achieve or what we want to output, and say, take these outputs and turn them into a JSON schema like the attached JSON schema, and include this as an example. It will then come up with a JSON schema in this format that's really specific and consistently gets good results using our LLM. So I'm just going to copy and paste in the JSON schema that I previously made from that. And you can see it's got all of our different fields here, all of the different nested fields, and also specifies whether things are required and the data types like strings, dates, etc. And that's important when we're passing back into our Airtable because we need to match the data types there. So if we run that again as a test, you will see that the LLM will start running and it will call the OpenRouter model and also check against the required output to check that it is met the requirements, and it will show green once it's met the requirements. So we'll now go to the results of that, and you can see it's got a much more detailed line by line JSON format that has all of the fields that we asked for, including supplier name, customer name, any additional information, etc. So we are at the point now where we've almost implemented a full document parser with just a few key stages. We've also covered the key fundamentals and the key building blocks in n8n workflows and how to connect those and pass through the inputs and outputs, as well as how to manipulate data. In the other workflows that you end up building for your business or for other businesses, you will use all of these fundamental building blocks at a certain point in time. The fact that you've got this far means that you're already ahead of 90% of others that are building using n8n. So well done for that. Now let's do the last step of connecting your data. So the final step here is connecting back to our database or our Airtable where we're going to put the data into. So we're going to go to Airtable and we're going to open up a new table and import, like we did before for the emails, a table called financial or called invoices or whatever, and give it these fields: invoice number, description, invoice date, payment date, type, total price, currency, line items, purchase order number, supplier name, supplier VAT number, additional info, and invoice URL. The invoice URL is only going to be relevant if we are pulling that initially from a Google Drive file. So because we're doing this with Gmail, it's not going to actually populate with anything useful. But if you're pulling from a Google Drive in a future workflow or you want to replace the trigger, then the invoice URL will link you directly back to the invoice. You're going to see our results populate exactly like this once we run the flow and once we've mapped the fields. If you want access to the Airtable to just copy it directly, as well as the finished workflows, then you're more than welcome to join the school community. It's school.com/scrapes. And then within that, within the community, there is a classroom section. You can go to the free course and there'll be all of the core concepts that we've covered today, and there will be all of the templates within those. So just find the appropriate lesson for this one, and there'll be a template attached to the bottom that will give you the fully working flow. Anyway, back to the flow. Let's go back to our n8n flow, and we now know we have the output. So what we're going to do is connect our previously made Airtable node, and we're just going to need to map those outputs again. So it's no longer going to be post emails, and it's going to be post invoices. And you can see all of the fields that we had before are no longer relevant because we need to update the table we're putting it to. So mine is called financial, and then again, we're going to map each column manually. And we have all of the columns from our basic LLM chain output that we can just drag and drop into that. And remember for these that we want to make it future-proof by just adding in the actual node name. So we've got basic LLM chain .item.json and then the field. So we can drag and drop and then update those. So I'll go through and add those now. Whoops, that's the wrong one. So I'll just make sure it's the correct field. That's invoice number now. So we'll come back into the node and you can see I've mapped all of those data fields now, referencing the basic LLM chain outputs. And what we're going to do is just test this step. Okay, so we've tested this step and it's actually thrown an error. And this will happen often when you're running these. So it says cannot pass value 26.4 for field total price. So this will be more often than not, a data type issue. So in our scrapes table, we've got a total price, which we've given a data type of a long text. So we've called this a string. However, when we were creating the structured output parser, if we go to total price, you can see that we've given it a data type of number. We've done that with a few other things as well. So there's two ways we can tackle this. One is the slightly easier way, which is to add options and typecast the responses. So this just means that the Airtable API will effectively attempt mapping the values that we're passing to it to the fields that it has. So let's try that first. And actually that's done it successfully. It's effectively converted our number that it's received into a string value in our table. And that's fine because we can manipulate that in Airtable directly. But you can see that it is now put in the correct values for our invoice that we've been processing. So it's got even a breakdown of all the different line items as per the invoice, the supplier name, VAT number, additional information, etc. Now you can notice the above invoice is one I've already processed in the past, and actually they've got the same invoice number. So there's two things to note here. One is that it's adding records and not updating records. So if we want to do that, we can go back and do that in a second, because actually we don't want duplicate invoices appearing here. The second thing is that actually some of the information has changed between the first time we ran it, monthly recurring, and the second time. And now this is just the state of what LLM outputs are like. It's not always going to perfectly identify that information, but it does 95% of the job for us. You would know by reconciling this invoice that actually it's a monthly recurring cost, not a single payment. And actually then you change that there. It's also misidentified the currency here as GBP versus USD. So again, it's not perfect, but it does 95% of the job so that we can just come in here and reconcile the invoices on a monthly basis. So we're going to go back to the Airtable and just make sure that it's updating instead of adding a new record. And then each time it will check invoice number and it will append or change the details on that invoice directly. So we're going to go up to here. Instead of the operation create, we're going to have create or update. It's going to give us one additional field here, which is columns to match on. So like we said, we're going to match on invoice number. And actually now this has changed to invoice number using to match. And if we delete this row here, you'll see that this will change to a single payment. This will change to GBP like we saw before, because it's just updating this invoice. So go back here, you can see the automation has come in here and it was changing all those values. So those are all updated. It's now updating or appending if the invoice doesn't exist. So really, really useful business tool that you have just created from scratch. And that concludes the second automation that you've built completely from scratch. And this is a really powerful one that takes into account a lot of different concepts that you will reuse again and again when you're creating new automations using n8n.
So that concludes phase 2, where we've now talked about building out a complete system. We've done that from scratch. We've talked about AI at a basic level and the difference between an agentic workflow, a non-agentic workflow, AI agent and a non-AI agent, and just an LLM chain flow. We're now going to put that into practice. And we've actually done just 3, like scratch the surface on week 2 of the complete AI automation masterclass inside school. So again, if you're looking for an extended journey, then definitely check out the school community linked in the description. But what we're going to run that onto now is an AI and agentic deep dive. And inside that, we're going to start off by one of the most important elements, which is actually just prompt writing. So we're going to do a quick 101 on how to write a decent prompt in order to get high quality outputs. I'll then show you a community resource that we have, which is the prompt agent, which generates prompts for you. So once you understand the theory, you can get them automatically generated and it will speed up your development time. And then we'll move on to more advanced concepts. We'll start building out an agent from scratch, which is a complete calendar booking, editing, and deleting system. So a complete calendar agent from scratch, including all the troubleshooting steps. And then finally, in the agentic and AI deep dive section, we will cover how to actually obtain business data and put them into a database that's then retrievable using an AI agent, or what we call retrieval augmented generation, as well as alternative methods to that. So let's jump into section 3 right away with prompt writing.
Hey guys, I just wanted to show you a quick video around how to write a really clear prompt. So I've been going back and forth lately with writing a ton of AI agent prompts, LLM prompts, the lot. And actually, I've never had a consistent structure to the way I write prompts, but I've come up with something that's easy for me to remember, and that is the critics structure. So this just outlines a simple way to remember exactly what you should include in a prompt, and it's applicable to both LLMs and AI agents. And I've simplified it here for you to make it easier, and I'll include an example prompt that a prompt generator has generated with this structure. And by the way, you'll soon have access to this prompt generator, and it's outputting some really good prompts, as you'll see. So the first thing to mention is that we've had to switch up constraints and role just to make the word critics work, but that everything else is in the order that I'd include it in the prompt. So we actually start with role, which most people are familiar with, and you're answering the question there for the AI is like, what am I an expert of? You establish the purpose of the agent and the overall objective. So say for a scheduling agent, we might say something along the lines of, you are a scheduling agent that schedules on behalf of Simon, and you return a success message after you've created an event. We then have the constraints, which are effectively the rules it needs to abide by. So we define boundaries, limitations, and guidelines for operation. And again, with a scheduling agent, this might be, don't schedule any meetings unless you've confirmed it with me or the user. And we have a list of constraints that the LLM must follow. We then have inputs. So you should tell the LLM what it's expecting to receive and in what format. The more detail you can give, the better. We are going to receive natural language queries from the user, and it might specify a date, attendees, etc. and we'll give a clear example of the format of that input. We then have tools. So this is an optional part of the prompt format. And for something like a tools agent, like a scheduling calendar agent, we would tell it exactly what resources it can access. And it's not just the resources like Google Calendar, it's the functions inside that. So Google Calendar is the tool, but actually the tools include, okay, it's a create event function, it's a delete event function, an update event function. It's not just Google Calendar, it's the functions that we can access within that calendar. And each of those would be an individual tool connected to our. We then have the instructions or task list, which is effectively an order of tasks. And the way I break this down is for each tool, you'd have a specific set of instructions. So for the create event tool, the instructions might be, okay, number one, obtain details of the event from the user. Number two, create the event in the calendar using the create event tool. And number three, return a success or error back to the user. So for each tool, we'd break down those specific set of tasks individually. So delete event would have a different set of instructions, but all within the instructions part of the prompt. We then have conclusions or output format, which is what output format is it expected to provide. We sometimes use the JSON output parser to define this. But if it's something like a natural language query, we might just be defining what type of information we're returning back to the user. It's really important here to treat the prompt like you are training a human. The more information you can give it around clear examples of what great looks like and what bad looks like, the more success you will have with the outputs of these prompts. We've then finally got solutions, which I guess is another way of saying error handling. So it's what do I do if I don't get the information I expect to? So for example, if a user says, book me a meeting, it doesn't have any event details, attendees, dates, etc., then what should the LLM do in response to that? And actually, that might be something like, reach out back to the user to get specific information. So I hope that breaks down a clear prompting structure for you guys to follow.
So now you know and understand the fundamentals of writing a good prompt. I'm going to show you in this optional module how to accelerate your prompt writing. So say you need to build out an AI agent or an LLM chain with a very long prompt. Often that takes a couple of hours to refine and iterate. But this agent that we've pre-built in the community for you allows you to just create a base level prompt, which takes you 80% of the way. It's a real shortcut for actually creating decent prompts straight off the bat. But like I said, it's optional. It's part of the community package. So it's in school.com/scopes. Inside our business template library here, you would go down to the prompt agent here, and it's got some information about the prompt agent. But what we're going to do is click on the link here. We're going to download that prompt engineer workflow. We're going to open up a new workflow inside n8n. And all we're going to do is go import from file and drag that in, and there it's going to appear, and it will probably have a few red boxes because we'll need to fill out credentials. But we're now going to run through exactly why this is going to speed up your agent prompt development process.
And we've got this introduction to the prompt agent where it tells you it's going to return a complete prompt full with inputs, tools, constraints, error handling scenarios, output format, etc. So the whole package that you're going to need for a prompt. And I've not seen yet a consistent agent like this that outputs not only LLM prompts, but also prompts that are fit for tools agents in n8n. And that's exactly what this is going to give us. So we need to provide a short summary of the goal of the prompt, and then it's going to give us a few questions. So for this demonstration, we're just going to talk about a content repurposing agent. So say we want to go from a video to a LinkedIn post. Let's use that as our scenario and see what we get. So for the goal of the prompt, we put something really generic, a content repurposing agent from video to LinkedIn posts. So kept it really broad and high level. Does it need access to any tools? So we've got options here. We've got yes, if we know that we're going to access any tools, and a tool might be web search, it might be LinkedIn. So in this case, we're probably not going to need access to any tools because we're taking an input video and we're outputting content to LinkedIn. So we just need it to polish it up a bit. The next question is around tools. So if yes, what tools should the agent have access to? And then we've given some examples here, web search, Google Calendar, etc. But we don't need that for this. And then what are the expected inputs? So we know that we've got video input, and the expected outputs are a LinkedIn post. So as you can see, super generic. Took us about 30 seconds to fill this out, maybe less. And let's click next. What it's then going to do is start running, and it's going to actually then come back with a series of questions, up to 3 questions, to help refine the detail of our prompt. And it's going to help us go from a really broad prompt goal to a specific output by asking us the right questions. So it says, answer the below clarification questions in as much detail as possible. And then it's given us our original query back, a content repurposing agent from video to LinkedIn post. Is there a specific tone or style you want the final LinkedIn post to reflect? So you can see how it's building out its logic around what things it would write in the prompt. So we're just going to write informal with some emojis. And we'll click answer. We've got the second question: what key elements or sections from the video should be emphasized in the LinkedIn post? And because it's a LinkedIn post and it's short form content, we're just going to say focus on one key theme from the video. And then it says, are there any length or formatting constraints for the LinkedIn post? It's a good question. Let's go out and find out. So the character limit for a LinkedIn post is 3,000 characters. So actually we can feed that back into our tool. And you can see how that's now building up a picture of what our prompt should be like. So we've come in here into the n8n workflow, and you can see that we've got this form trigger that we just ran through. It's then going to ask us some clarification questions in a loop. So it comes up with 3 questions that are specific to understanding the goals of our prompt. And now the prompt is being generated in a specific format. Super simple 3-stage process. And it's going to return to us our complete prompt. And if we take a look at the outputs here, we can come into the return form and we will open up the outputs here. And this is our complete prompt. And you can see from really broad goals that we input at the start and answering the clarification questions, it's now built out a really comprehensive prompt that's going to give us a really strong starting point, which is often the hardest part when you're writing prompts. So let's run through and see what it's actually given us here. You're an expert AI content repurposing specialist that transform video content into engaging LinkedIn posts. So it's given it a really clear role. You identify key themes, condensing complex information into a social media format. You excel at adapting content to LinkedIn specific platforms. So we've not told it any of this. This is what it's come up with by itself. It's then given us some constraints or requirements. And you can see it's pulled in our additional information about 3,000 characters, but also told it to have an optimal length. Without us saying anything, it knows that the first 200 to 250 characters need to be the hook or the most compelling. And it's done that without us having to tell it that. So it's probably done a web search on LinkedIn posts to find that out for us. Maintain the original message integrity, and it's input today's date. And it's even put a comment at the end here: do not include direct calls to like, comment, or share. So we don't want our post to appear spammy. It's then given us some clear inputs, so the video content itself, and then some optionals around additional context that we might want to feed into the agent when we're generating this content. It's then given us a really clear set of instructions: process and analyze the video provided, identify the core themes, craft a LinkedIn post, review and optimize the post. So from really broad goals, it's come up with a step-by-step that the agent can follow. And this is a really powerful format for working directly with LLMs and tools agents. It's giving them that step-by-step that it can follow through in a logical process and iterate and work on that. It's then got conclusions, which is our output format. And it's told it to deliver a well-crafted LinkedIn post that covers a bunch of different criteria. And then finally, we've got these solutions, which is effectively our error handling. So for example, if the video contains multiple equally important themes, I'll ask the user which one to prioritize for the post. If the post exceeds character limits, I'll suggest areas to condense while preserving key insights. So this additional section means that if we were to run this AI agent, it would be doing its own error handling and not error at all of these different scenarios, because it's gotten out, it's got some assumptions that it can follow instead of having to come back to the user. So you can see from just a really broad prompt and not really knowing what we wanted to get out of it, it's come up with a 80 to 90% starting point that we can go and test in an AI agent by just coming in here, copying that whole content, taking it to a separate node. Let's say it's an LLM chain. We define this below, hit expression, open the window and paste it in. There we already have our complete AI agent within about a minute of work, which is going to massively speed up the rate at which you can build these agents and focus on the important things like connecting the right tools and prompting it to interact with those tools. So you may be wondering at this point, how did it come up with that prompt and what rules is it following? So I'm going to run through now the best way I've found to prompt tools agents that uses an acronym, critics, to cover all of the key elements that make up a really solid prompt, the prompt. Now, the prompt is where we tell the AI agent or an LLM like ChatGPT the rules that it needs to follow and what it needs to return to us. So I've thought long and hard about different acronyms that could make this easy, because actually a comprehensive prompt contains quite a lot of information. And the best one I could find was critics. So we're going to go through each of those steps, but it's a really stable prompting format for creating prompts again and again for these AI agents and even for LLMs, just minus the tools. So I've simplified each one here, and we'll start with the one that most people are familiar with, which is role. we had to switch around the C and the R to make a word, but the only two that are not in the correct way we lay it out in the prompt are the first two, which we switch around. So we'll start with role or scope. And this is essentially asking or telling the AI what it is an expert of. So in our case, we're telling it is a scheduling agent, and its overall objective is to schedule meetings on our behalf. We then have constraints or rules, which naturally are the rules it needs to abide by. So this is where we set the boundaries, the limitations, and the guidelines for our AI agent prompt. So an example might be, don't book meetings without confirming with us first. We then tell it what it's expecting to receive in the inputs. And if you can, it's always best to include examples as we go through these to make it really clear. I treat this as if you were training a human to do the same task. What information would you need to provide to them to make it really clear exactly what you mean? And then the AI agent is going to fill in the ambiguity by making assumptions. We've then got tools. So this is specifically for tools agents, and not all AI agents and not all LLM prompts will need tools. But if you do, it's what resources can I access? So an example here is if we wanted it to have access to the web and web search, then we'd give it a web search tool like Tavily or Perplexity. But in our case, that's going to be the Google Calendar tool, but not just the tool, it's the functions that we're calling from that tool. So we've got create event, we've got check availability, get events, delete events, and all of these different tools that's able to access and use in different ways. So we need to explicitly tell it what that tool or function is for, and therefore it will know how to use it later in the tasks. So the next part is actually telling it the order of tasks it's going to follow. So a good way to structure this is for each tool, giving it a step-by-step, okay, you're going to create an event. So the first thing you're going to do is check the user input for any attendees, the description, and the start and end time of the calendar invite. You're then going to call the create event tool to create event. And finally, you're going to return a success message to the user. So that is our instructions for that specific tool. And laying it out on a tool by tool basis makes it really straightforward. One, to read, and two, to follow that task list exactly. The more specific we can give instructions to our prompt and to our LLM running it in the back end, the more success we're going to have when testing this out. And the last two are really critical. We've got conclusions, which we sometimes call output format. And we give really clear examples of what output we're expecting here and the expected response formats. And then finally, we've called this solutions, which is the solutions we need if we come across an error. So it's also error handling. And this answers the question, what do I do if I don't get the information I expected to receive? So for example, if somebody asks to create an event, but they don't give any details around time, attendees, name, etc., then what should the model do in response to that? Should it make it up? Probably not. It should actually reach back out to the user and request more details. So an easy way to remember this is critics, and it's a really clear prompt structure. Now that you understand how to write a clear prompt, and you understand that the prompt agent is actually working through all of these different categories, let's take a look at the key themes in this automation and show you exactly what's happening. We have three key areas. We have the trigger. So we are using an n8n form to trigger the request here. So inside the form trigger, we've got the form description here, and then we've got all the different fields in the prompt request that the user fills out on the next page, like we saw at the start. So we've got what is the goal of your prompt? Does it need access to any tools? What tools? Expected inputs and outputs. And you can see that that carries through, and we combine that into a query that is then sent for clarification. So all of those questions are combined here from the previous node, and that's sent to the first LLM call, which is a clarification LLM. And we're using o3 Mini for this. And before I show you exactly what that is, I just want to shout out Jim Lee UK on the n8n templates library that inspired me to use the form trigger and ask these clarification questions to get more detail. I think it's a really awesome approach. And you can find it on the Host Your Own AI Deep Research Agent on the n8n template library. It's an amazing template itself, but in particular, I love this starting point where it asks clarification questions back to the user in order to gather additional detail for the research or for the prompt. It's a really powerful tool and very clever implementation. So thank you, Jim, for that. So what it does is effectively we've got a prompt in here, and we say, given the following query from the user, ask follow-up questions to clarify the inputs, outputs, use of tools, but we've told it only ask the things that you don't understand from the input. So it can ask up to 3, but it doesn't need to if it understands. And then we've put the input queries in here, and you can see that all of our input information has gone into that input query there. So that's what it's asking clarification questions on. And we're using O3 Mini because it's able to logically think through all of those different questions and consider aspects that maybe we haven't before. In this structured output parser, we're telling it to output questions effectively. So inside the questions, we split out each individual questions, run that round a loop, and we're actually using the next form page to ask that specific question as it goes through. So that's the first and second parts that effectively get all of the information that's then fed into our prompt agent tool to write a really comprehensive starting point for our prompt. So inside the prompt agent tool, you can see, again, like all tools agents, like all LLMs, we've used this critic structure with role and constraint swap round. And we've effectively told it is a specialized prompt generator for creating structured prompts for AI agents as well as LLMs. And it's going to follow this critics framework. And we explain what the critics framework is inside the prompt. We've then got the constraints, so the rules it needs to follow, always maintain the critic structure. Then we've got some rules around tool parameters. So format tool parameters clearly with indentation. We've got this never assume tool capabilities without confirmation. So when it generates the tools in here, you'd have a tool for each function that the prompt would be able to generate. So say, for example, we're creating a calendar scheduling agent. You would have several functions. You'd want one that connects to your Google Calendar to create events, one that connects to delete events, one that wants to get your availability, so get events. So you'd have several different tools. And it should never assume tool capabilities without going and checking that first with the web search that we've attached to this. So the web search down here searches using Perplexity, and it passes in a search term to go and search the web for information about the tools, for example. And we've even built out the ability to edit an existing prompt. So you can paste in here an existing prompt and actually turn it into that critics framework and have it clarify certain things about your prompt. If no tools are needed, like we suggested at the start, then it's going to skip the tools section. If tools are needed, it's going to build out each individual tool like this. So we're going to have a web search tool, a create event tool, a delete event tool, etc. And each of those, it will make an assumption based on its own knowledge and research on the web, what input parameters it would need there. And then again, we've got really clear instructions, how to complete a critics prompt, rules for handling incomplete requests, rules for refining existing prompts. And each of these individual functions has been separated into a separate set of steps. So we've got 1 to 9 here, 1 to 4 here, and 1 to 4 here. So it understands which set of instructions to follow. And if we had multiple tools in here, it would build out instructions for each individual tool, and that's how it's laid out. We've then got the last two sections, which are conclusions. So ask it to return the complete critics formatted prompts with all required sections, switch around the C and the R, so role always comes first. And that's what we're used to. And then we've told it about the formatting, XML tag structure. So we've got these opening and closing tags that just denote the starting and ending of each section. And that is because LLMs have been trained on XML tags. So it's a really clear way to tell the prompt that this is the start and the end of our instructions, for example. And then we've got some error handling scenarios. So if the agent type is unclear, don't return a prompt, ask for clarification instead. If the tools are not specified, suggest appropriate tools based on its own knowledge. And if the user provides an existing prompt, analyze it and suggest improvements, but don't change the core functionality. And then finally, we pass in the query. And that query is effectively what we are telling it to make a prompt of. And you can see it's made up of our initial query with all the information about goal, access to tools, expected inputs and outputs, but it also contains all of the clarification questions and answers, which builds out a much better picture of what prompt it needs to start generating for our AI agent. And then the final thing is we then return that to the form. And that just displays the prompt on the actual form. You can just go directly to the form URL and actually test this out once you've installed it in your environment. The last thing to mention is we've included a chat trigger, which skips the whole stage of having to ask clarification questions. I definitely advise going through the form trigger because it asks you the right questions to build out a complete prompt. But if you know what you're doing with prompting and you don't need those clarification questions, you can actually just go directly through the chat trigger. And I'd recommend doing that if you were editing an existing prompt, and then we'd just activate the buffer memory so that we could interact back and forth with the agent that would update our existing prompt. Feel free to head to the school and grab the template, but I hope that helps you speed up your AI agent build.
So now that you're well equipped to actually produce any prompts for LLMs or AI agents that use tools, we're going to move on and actually build from scratch your very first fully functioning calendar AI agent. So let's jump straight into it.
Now, before we start building out any AI agent or any automation flow, the first key stage is always laying out your flow, understanding what the goals are of the flow. And in this case, we're building out a calendar scheduling agent. So understanding the goals of that agent in particular and what we want it to do. With that will come our inputs and outputs. So understanding what information or data we are passing in or what's coming in from the user, and then what we are expecting as the output. Similarly, what is actually going to activate this? So is it going to be somebody talking on the phone? Is it going to be somebody sending a message to this AI agent? What's actually going to trigger that flow? And then what are the backups in case it doesn't work? AI agents don't always work 100% of the time. All the inputs are poor quality. So what do we want the AI agent to respond with if it doesn't have the right information? The second areas we're going to cover are the elements of an agent. So we will go through which specific agent we're going to choose for this and why. The prompt, which is what we want it to do or the instructions we're giving it. What tools or resources it needs access to. So does it need access to web search? Does it need access to a calendar, for example? What it remembers, so its memory. Do we need the previous messages from the user stored here? What model we're going to choose and why? And that defines what it should specialize in. So do we need a planning agent? Do we need the basic GPT models? What do we need and why? And then response, like what is it going to give us back at the end? We're then going to cover in really clear detail the easiest way to write a clear prompt using the acronym critics. Now, I've tried to find a lot of different acronyms for a clear prompt. This one has resonated with me and it's one I've been able to remember and talk about why it's essential and how to write it well. And then finally, we will define within that prompt what parameters or what information we're passing from our agent to the tools that it's using. So in this case, how do we get our AI agent to interact with our calendar? What information does it need to send between the calendar and what information comes back? And once we've done all that, we will end up with an AI agent that looks similar to this. So we'll have a trigger on the left-hand side. We'll have a tools agent that's able to store user conversation history, but also check the calendar that's attached for availability, and therefore create events on the user's behalf, update events on the user's behalf, and delete events. So this is something core that every business needs, and that's a calendar scheduling agent. But we're going to go and build that step by step by assessing all of the different questions we've covered here. So first, when I build my flows, I always like to just understand the goals of the flow. So this is a business-friendly calendar scheduling agent, and the purpose of it is to chat to it and tell it when I want it to send a meeting invite and put that meeting invite in my calendar, but also need to be able to check availability so it doesn't book over anything, update availability if I want to change the meeting, and also delete events. I want it to be able to manage my calendar, but do so by me telling it what I would like. So that also answers the trigger. We are going to have a simple chat trigger, and we're going to do that by going to the plus icon up here, and we will start with a trigger. And instead of triggering manually, we're going to just choose on chat message. And this trigger will run the flow when we send a message to the chat trigger. So we'll be able to test it live in this environment here. And because I've already got one chat trigger up here, I'm just going to disconnect it from the flow we've already built and bring it down here. So when we double click into the chat trigger, you can test the chat and it will come up with the chat window down here. And that will enable us, once we've connected it up to an agent, to chat directly to it. So we're just going to hide the chat for now. Then we need to understand what are my inputs and outputs. So for a calendar scheduling agent, we are going to be describing the inputs in natural language. So for example, book a meeting with Simon at 2 p.m. until 3 p.m. And the output is we are expecting the agent to interact with our calendar, check our availability, and come back with a response confirming or denying that it's completed the action. And then what are my backups in case it doesn't work? If I don't provide clear enough inputs, then I would like the agent to tell me I need more information from you. Or if it fails, I want to know that it's failed. So with any AI agent build or automation build, I would always use sticky notes to first architect the flow. So if we go up here on the right-hand side, or you can press Shift and S, and you can actually get a sticky note. And I just use a white sticky note to label the different elements of my flow. So we're going to call this the trigger, get rid of the text there. And there we have our trigger. We know that that trigger is going to be connected to some sort of agent. So we're going to copy that, Control-C, Control-V, and we're just going to say that this is a calendar agent because we know we're building out something that can manage our calendar, and you can call this whatever you want. And as you can see, as we build this out, we start to touch on all of the elements of a given workflow or given agent. So we know we're going to have a calendar agent in the middle here, and we know that we want to give it access to some memory. So the reason memory is important in this case, if it asks us a question back, then it needs to remember the previous context that we've given it. And therefore we'll have some memory. We know that it's going to be connected to some tools because an agent can't book a meeting in our calendar or delete one out of our calendar without having access to our calendar. So we're just going to label up that for tools. And conventionally, you have the agent in the middle here, and then everything that's connected or it has access to below. But it's up to you to decide how to lay this out. We know that we need our AI agent connected to a model. Without a model, we won't have a LLM in the back to run our query. So we'll just call that one model. And we know that we're going to receive a response. So with the chat trigger in n8n, when we send a message and we receive a response, we don't need to put a response node on the end. The message will automatically get sent back to the chat. So in this case, we're going to leave out this response node. And then we come around to picking the agent. So we covered all of the different types of agents a few minutes ago. But if we open up the nodes panel again, go to advanced AI and go to AI agent, we'll be able to choose the one that's appropriate for our use case. And like I mentioned, tools agent is the one that is used the most and will be the one we're picking for this use case because we need to connect it to multiple functions in our Google Calendar. So we're going to click tools agent here, and then we have the chance to define where we tell it what we want it to do. So you can either have the source for the prompt in the connected chat trigger, so the prompt coming directly from the chat trigger. However, we're having the user query sent from that chat trigger. So actually we want to define the prompt inside this node or inside the window. And for anyone that's watched my previous videos before, you'll know that I will always rename every single node. So it's really clear exactly what the node is doing. So we'll call that calendar agent. And we're going to talk more about prompting in a moment, but for now we'll come out of here. You can see immediately that when we've set up this tools agent, it's given us exactly what we've set up below, which is access to a model, access to memory, and decide which tools to connect it to. So we've got the agent. We'll cover in a second what it has access to, but first we need to talk about what it remembers and what it should specialize in, so the model and the memory. So the key elements when choosing a chat model, if we click on the plus icon here, is just which LLM do we want running in the background and controlling our AI agent. Now listed on the right-hand side, there are all of the different providers that are inbuilt within n8n. So we've got Anthropic, so you can use a model that's really good at writing, like Claude, 3.5 Sonnet. You could use the model that's blown up recently for planning, which is DeepSeek R1 or any other DeepSeek model. Or we could use the traditional OpenAI GPT-4o Mini for quick and cheap responses. Or alternatively, we can connect directly to OpenRouter, which is a service that allows us to connect to all of these different models with one API key. If you're not familiar with that, then check out the full course where I cover all of this and how to connect to OpenRouter. For now, we're just going to use a basic model from OpenAI. The key for a tools agent that we're looking for in terms of model is that it needs to support function calling. And what function calling means in practical terms is that the AI or the LLM recognizes that when a user asks a query, that it needs to contact an external tool or external API or external software and is able to pass the parameters to that external software and receive the response. So for example, if we were to ask this AI agent what the weather was in London today, it knows, or it should be able to recognize that it needs to contact an external weather API or web search in order to gather that information. And a tools agent needs to be able to support that. Most of the models within OpenAI do support that. So we're just going to use OpenAI today. And you're either going to connect in your OpenAI chat model with your OpenRouter credentials or your OpenAI account. To set this up from scratch, you need to go to create new credential. It will fill everything out for you. So we have the base URL, leave that as is. And then to get this API key, you can go directly to OpenAI. So we're going to go to platform.openai.com. And that's going to bring us to this page, which is their documentation platform. And on the right-hand side, we've got the settings here. We're going to click the settings. And on the left-hand side in the menu, we've got API keys. Create a new secret key here. Give it a name like n8n test demo. And we're just going to assign it to a default project. And we're going to create a new secret key. And that secret key is the API key that we're going to copy directly back to n8n and paste into the API field. We'll jump back to our window here. We'll paste that in. We'll click save, and that will light up green to suggest it's connected successfully. And then we'll come out of that. And once you have that, you'll have a model to choose from here, and it will give you a list of models. And you'll see that they have a ton of different models that we can connect to. I'm actually connected through my OpenRouter account, not my OpenAI account. So it means I have other providers on here too. But you'll be able to find GPT-4o Mini in the list, and that should be sufficient for what we need. And it's the best value model. And it's the best value model for OpenAI for the power it gives us. So we're going to choose GPT-4o Mini, and we're going to come out of that, and we'll put that inside the model. And we're just going to rename that to tidy it up, OpenAI. Now we have connected up the model. We're just going to connect the chat trigger directly to our agent, and that will just pass our chat input to our agent. So we had it on define below in the source for the prompt, but just to test, we're going to change this to connected chat trigger node. And all that's going to do is pass through the message from the chat trigger, because we're going to need that to tell it what to respond to when we change that to a prompt. So let's go into open chat, and we're just going to type hello here, and then it's going to start spinning, and you can see that it's using the connected model, GPT-4o Mini. And at the moment, it's just like an LLM. We're just telling it or giving it a query, and it's responding directly to that query. So it's going to come back with a response to us. And on the left-hand side, you can see it said, hello, how can I assist you today? So it's come back with a response. On the left-hand side, we can see our chat window. On the right-hand side, we can see everything that's been completed here. So it's the logs from the calendar agent node, and you can see it's contacted OpenAI. It's given it this input, the system message, which is by default, you are a helpful assistant. And it said, okay, the prompt was hello, and given us back the output. So we can see all of the inputs and outputs of the LLM chain there. So we know it's working now. We're going to need to update this so that we write our own prompt shortly. But one thing we can do now is just change this back to define below, because we're going to write our own prompt. And now that we have some inputs on our left-hand side, we can just drag and drop the chat input here, which was our hello, into this window. And that is our user input. And as with all of these nodes, I like to rename them to their specific names and call them dynamically by adding the node name at the start, .item, .json, .chat input. So you can see this is still just hello, the input. But what we're doing is referencing that specific node. So if we put any nodes between them, it will always reference that specific message on the input. Now you'll see that if we ask this, what was my last message? It will run again, but because it has no memory, it won't actually be able to recall our last message. It's not storing anywhere what we said to it previously. For something like a calendar agent, that's really critical, because we might go back and forth a few times with the AI agent and give it feedback so that it can adjust what it's doing for us. And true to form, it's come back and said, I'm sorry, but I don't have the capability to recall past messages. Each session is stateless and doesn't retain history. So we need to add that functionality by the memory. So we'll click on the memory toggle, and we've got a few different options here. The two that you'll use most commonly are the window buffer memory, which stores it directly in your server memory. So you don't need to access any external services. It's all stored right here. And it's such a low amount of data anyway, that that's actually really easy to set up and use, and good for this use case. And the second one is Postgres chat memory. You might have a database elsewhere that we actually store this history in. And the difference between those is one stores it on a short-term basis. So the last 5 interactions, say, which is the window buffer memory, whereas the Postgres chat memory could be for a use case like a customer service chatbot, where we want a historic record of all conversations with a customer, and we'd store that elsewhere in a Postgres chat memory. But for today, it's just a calendar agent, and we're going to use the window buffer memory. So we'll click on that, and it will open up this node. On the left-hand side, you can see our inputs. On the right-hand side, you can see our outputs. Now we are using the chat trigger, which automatically comes with a session ID. And the way that n8n stores the memory here is by session ID. So each chat has an individual session ID. So if I close the window and come into a new chat, it will have a new session ID here. But if I keep the window open, the session ID will stay the same. So we've got to tell the memory node where it needs to look up our previous conversation history. And it does that by reconciling session ID against session ID that it's stored. And if it finds a session ID that's stored, it will have all the memory of that, the last X interactions. We can choose the context window length down here. So for argument's sake, let's just call it 10. So it retrieve the last 10 interactions we had. If you had something like a customer service chatbot, you'd extend that. So this is pre-configured to set up automatically and pull the session ID from the chat trigger node. So we don't have to touch anything here. If you were to have a different trigger and you wanted to store memory, then we'd need to define a specific key or session ID that would be stored with the data we're passing in. But for now, we just need the connected chat trigger node. And we're just going to call that memory n8n for simplicity. And we're going to drag it down to the memory. We'll now send a message and we'll say the numbers from 1 to 9. And you'll see that when it runs through, it lights up green for every interaction and lists the number of interactions. So actually there, it's interacted with the LLM model once and our memory twice. And again, on the right-hand side, you can see these interactions and the inputs and outputs. So it has stored the values of our input here, 1 to 9, the system message that was present in the LLM, and any formatting instructions that were given, but we've not given it a specific output format, so we don't need to worry about that. And it's just given us an output to say that it's loaded the memory variables, and then it's saved the context into our memory here. Now, if we ask what was the last thing I said, it will be able to recall from the memory by retrieving that. It understands and calls the memory, which in this case we can treat like a tool, and it works in exactly the same way. It will load up by using the action load memory variables, the previous chat history. So you can see down here, we've got the content of the previous chat history from the one message we've sent it. But it also stores the response it gave us as well. And finally, you can see that it's worked. The last thing you said was 1, 2, 3, 4, 5, 6, 7, 8, 9. If you need any other help, let me know. So that is how to connect memory and why it's important. You will need memory in 99% of cases where there's a user interacting with the agent. If it's just something like a static data file being passed to the agent, then you might not need memory. But if it's a user interaction, then we often go back and forth, and therefore we need memory. So we've now got memory and tested that. Let's move on to what tools our agent should have access to and what tools are available within n8n directly. So on the right-hand side, we've got the nodes panel here. We'll go to advanced AI, and down here are other AI nodes. We can see all of these different things, but we're going to focus on tools, which are as utility components providing various functionalities. What that actually means is accessing a tool that's external to our flow. So that could be something like Google Calendar in our case. And there's a few different recommended tools, which are the most frequently used here. We can actually call other n8n workflows and get those to run to return the results. So you can see how that's really powerful if we have a separate flow set up. We can write some code with JavaScript or Python to perform an action on our behalf. We can use a HTTP request to connect to an external API where there's not a tool already pre-configured. So for example, if Google Calendar was not a tool within n8n already, then we would be able to call its API using this tool, which means you can connect to almost anything external with these tools. Makes it really powerful for a business. We've then got vector stores. So we won't go too much into details about vector stores, but they're essentially databases where we can retrieve information. So for a business use case, you might have your entire company knowledge base stored in this vector database. A query would then be sent to the vector database, and we'd do a semantic search. So we'd want to find similar results to what we're querying. And for that, we'd use a vector database. And then we've got a list of other tools, which you can see is really, really comprehensive. We've got things like Airtable, Asana, Bubble, if you're building your software using no-code tools like Bubble. We've got ClickUp. We've got ConvertKit. So lots of pre-configured tools already in n8n, and these grow every single week. But the one we're going to focus on today is in the Google suite. We're just going to focus on Google Calendar. So you can either scroll down to that or you can search it directly in the search nodes bar. But you can see for all of the different Google tools, we've got this connected. If you conventionally use Outlook, then there's also a Microsoft Outlook tool that has access to the calendar, messages, folders, etc. And it will follow a similar approach to this. But for now, we're just going to access the Google Calendar tool. And be careful not to confuse it with the Google Calendar node. This is just a tool that our LLM agent can have access to. So we'll click on the Google Calendar tool. And as usual, on the left-hand side, we've got all the inputs. In the middle, we've got the transformations. And on the right-hand side, we've got the outputs. We are going to connect it to our Google account. We'll go through a demonstration now of exactly how to connect a node to your Google account using the example of a Google Mail node, but all of them are set up in exactly the same way. So setting up Google credentials, they've recently changed this on n8n, so now you have to do a few more steps. But I'm going to run through how we do it for Gmail. It's exactly the same for Google Drive, Google Docs, Google Sheets, etc. You just need to set it up once, and then for each node, and then you can connect your nodes. So we're going to go into the trigger here or the Gmail node, and we're going to go up to credential to connect with. And we're going to set up a new credential. And you see it asks us for a few different things. So we've got the redirect URL here. We're connecting using the OAuth2 method, which is just a standard that's used across the industry to connect to different accounts. It's effectively where you have the Google sign-in page. That is an OAuth. We then have two values that we need to go and collect, which are the client ID and client secret. And then we can rename this as usual here. Gmail account test, we'll name it for now. So what you're going to do is you're going to go to console.cloud.google.com, and you're going to come into this window, and you will be able to see the navigation menu on your left-hand side. You'll be able to see APIs and services. We're going to go to enabled APIs and services. If you've not previously set up a project, it will probably prompt you at this point to set up a project. But if you have set up a project before, it will just pull you into that project. You're then going to actively enable which APIs we want our project to be able to access. So I've already got them enabled, but you're going to enable APIs and services. You'll type in things like Google Drive, and we'll click on that. And instead of saying manage here, it will say install or something to that effect. You're going to click that to make sure it's installed. We'll do the same for every app we need. So we'll type in Cal, again, Google Calendar API. We'll install again, install all of those. So then we've got Sheets, we've got, all of that stuff, Mail. In this case, we're going to have to go to Gmail API and then install there. So great. That's the first step. They're all installed. We're going to go back to APIs and services. The next thing is setting up our credentials. So we've given it access to the relevant APIs. We now need to give it access to our account. So we're going to go up here and we're going to click on create credentials. If you've not done this before, your OAuth 2.0 client IDs will probably be empty. So you're going to go to create credentials and OAuth client ID. If this is the first time you're doing this, it might ask you to set up an account. Just follow the steps through, and then once you set that up as an external web app account, you'll be able to come back to this part in the tutorial and set up this client ID. So we then have create OAuth client ID. We're going to choose a web application because we're just connecting it to n8n. Let's just call it n8n test demo here. You can call that anything you want. Now, this is really important. We're going to need to input our authorized redirect URIs, and that just enables the server from Google Cloud to connect to our n8n nodes. So we're going to go back into our test workflow. You see this OAuth redirect URL. I'm going to click to copy on the right-hand side. We're going to go back. We're going to add that as a authorized redirect URI there, and we're going to create. That's going to appear then with our client ID and client secret, which are the values we need to take back to our environment. So we're going to copy that. I'm going to go back, paste them in here. Oops. So we'll take the client secret, we'll go back, and then it's going to prompt us to sign in with Google, which we're going to need to do to just validate that. So I'm going to sign in with the account that I'm on at the moment. Click advanced, and then go to elastio.app. This might say something like render or whatever your service is hosted on, but we're going to go to it. It's then going to ask us to confirm the access and the permissions. Brilliant. Connection is successful. If we go close that window, we'll go back to here. We now can close that and we're all connected to our account. If we fetch the test event, you'll see we're pulling in an email from that account. So we've now set up our Google account. All we need to do in this Google Calendar tool is connect to the appropriate account. So mine is scrapes.ai Google Calendar. And there's a few different options that we're going to run through per tool here. So because this is a pre-configured tool, i.e. it already existed within n8n, these have a bunch of options that are really simple to define. If you're using something like a HTTP request, then you have to do a bit more work to define and make sure the correct parameters or the correct data is sent from our AI agent to our node. I'm also going to show you a way to shortcut getting the data where you can get AI to define the data for you so you don't have to do any work. But first, we're going to cover how to do it manually so you know the concepts behind it. So we've got here the tool description. So it's by default as set automatically. And because this is a node built by n8n, I'd always leave it as set automatically. But if you go to set manually, you can actually see the description here. And it just says consume Google Calendar API. And the description is to explain to the LLM what this tool does. The better your description, the more likely it is to be successful. So here it says to consume the Google Calendar API. So whenever you need to make a request from the Google Calendar API or tool, then you go through this tool. So we're going to turn that back to set automatically. We've then got resource here. So resource is specific to Google Calendar, and it's what function we want to be using here. So if, for example, we want to check availability, then our resource is going to be calendar and the operation is going to be availability. However, if we want to create an event, then we're going to need to choose the event resource, and Google Calendar have defined these different resources. And then we've got different operations here. We've got create event, delete event, get many events, update an event, or even a custom API call if there's a function that's not here. But everything we need is here to do this. So for our calendar agent, we want to check availability, and we'll always do that first. We then want to create event if there is an event available, and if not, we'll go back to the user to suggest that. We then want the opportunity to update an event and then delete an event entirely. We're then going to select the calendar that we're creating this event for, and it will load up, if you click on the drop down, the different calendars from this credential that it has access to. And down here, we've got the different calendars available. So we're going to click Simon@scrapes.ai because that's the calendar we want to check. We've then got the inputs that we're going to send. So when we're creating an event, we need to pass certain parameters or data. We need to tell it when the start of the event is, so a date and a time, and also when the end of the event is, which must be after the start. Now, these are predefined for us. So it's use JavaScript expressions here. And if we click down this button here, it will show you exactly what it's defined. So we've got this $sign, which is a dynamic expression, and we've put now, and that just shows us on the right side exactly when now is in a date time format. And then again, we've got another JavaScript expression for the end time, which is now plus 1 hour. So effectively, if we sent this, or if we left the tool like this, every time we asked it to book a meeting for a certain time, it would not pass the correct parameters. It would just book it for now for an hour long. So in order to pass the correct parameters, we need to use a different expression. And there are two ways to do this. One is the manual way, which we will show you. And the second is a way where we let the model define the input parameters here. So let's do it manually at first. So let's get rid of this and let's open our curly braces. And you can see all of the suggestions here. JSON will pull from the previous node, which in this case is the LLM data. However, what we're going to need in this case is a from AI method, which is a specific method set up in n8n for tools. And the description here is populate this with the parameter passed from the large language model. And in simple terms, that just means what data are we passing? So remember, we're talking about the start time of the meeting. So we're going to hit tab or click on from AI to open that. And inside this JavaScript expression, we're going to fill in these parameters. And you can see it pops up with a view on what parameters we want to pass. And every comma separates a different parameter. The question marks mean they are optional. So it will continue if that does not exist. So if, for example, we just wanted to pass the start time, then we get to define what that is called. There's no specific naming for that, but we want to make sure later in our prompt we're referencing a specific value. So let's call it start time and keep that as a connected word. We then get the opportunity to pass a description. And if you scroll down on this help tag, it gives you all of the information here. But it's a description of the parameter or the argument we're passing. And it's a string, so it's going to be text. And we don't have to define this. This one's quite obvious, start time, it will understand that. But for more complicated ones, you're going to need to know how. So we will say the start time of the meeting, just so it's really explicit for the model. We can then define a data type. So if we scroll down here, we've got the type. Is it going to be a number that's passed in? Is it going to be a Boolean, i.e. a yes or no? Is it going to be a string? And in this case, for simplicity, we'll actually leave that as blank. And there's going to be no default value for the time either. And one thing here, it showed up red, is I forgot to put quotation marks around my key value to show that it's a string. So now it's turned gray because we have no prior inputs to validate it on. So we're happy as long as it's not red. And later we can see the parameter that was passed in. Let's do the same for the end tag here. So we'll do $from AI. Let's use the same terminology, end time of the meeting. Now that is the harder way to do it. And this tells us exactly what we need to be sending in our prompt. So exactly what we need to tell the LM to be sending, the start time and the end time. And by the way, just as a reminder, this start time and end time is a date time. So it includes the date as well. But actually, if we wanted the model to work out what the start time was, rather than define a specific parameter start time, we could just click on this new functionality, which is let the model define this parameter. And it would say defined automatically by the model. And then we've got a description in here, which is the start time of the meeting, which has been pre-populated for us. So we'll keep one as defined automatically by the model, and then the second one we'll keep as ours. And then down here, we've just got some Google Calendar settings, use default reminders. We're just going to set that as true. And then if you want to send any additional fields, these are all the key ones that you might use. So for example, attendees, this is a really critical one. If we want to set up meetings with certain emails, so we'd fill this out from AI or attendee email to be more specific, emails of any other people mentioned, if they exist. And again, we could let the model define that based on our input. And then there's a few specific settings. One thing that you might want to do is set up what's called an R rule, which is a repeating rule. So if you wanted this meeting to be put in once a week, every week, then you'd need to put in this R rule. And the key here is we'd have to define in the prompt exactly what terminology to use for R rule if we wanted to send that as a parameter, even if we let the model define this parameter. But for now, we're going to keep it simple. We're going to delete that, and we're just going to have attendees create event using this calendar. Here's the start date and time and the end date and time. And we always rename the tools like we do with every node to make it really explicitly clear exactly what's going on. And we'll call this create event. And it's as simple as that to create a tool. So we're going to go through and create the other tools now and connect that up. Once that's done, we'll need to then define the prompt. We've got a really cool acronym for the prompts that will help you remember the perfect tools prompting structure, which is critics. And we'll go through exactly what each of those steps are and why they're important. And then we'll see it run in action with our calendar agent. So let's go through and connect the other tools. So we have got create event tool now. We can just copy and paste that here. This one we will call delete event. And as it sounds, we will just go down to the operation and we'll click delete event. So here we know that we need now to input the event ID. So again, that's going to be something we define in our prompt. And here we're going to leave it up to the model to define this parameter. And the way it's going to get that is by pulling the events from our calendar. And the only additional option here is send updates. So by default, it will send all notifications to all guests. That one's really straightforward. Let's connect that up here. So now we're getting a really good picture of the inputs we need to define and the tasks that we're going to define in our prompt. So we've got the start date and end date for the create event, and we've got the event ID in order to delete an event from our calendar. We're then going to have the update event. Whoops. So we'll go to Google Calendar tool, and we'll go to the operation, and we will click update event. And now again, it's given us the options. So we're going to connect to the right calendar again. And again, it's needing the event ID. So it's going to need to be able to pull events, and we'll let the model define this parameter again. So that means that AI is going to tell this tool when it passes it what the ID of the event is. And the way it's going to do that is using another tool to check our event availability. So we'll call this one delete event. No, we won't. We'll call it update event. And then let's check through all the update fields. So if we wanted to update the description or leave it open to update the description, then we'd add that here. And again, we can either define that here with $from AI, description, event, or something similar to that, and then say the description of the event. Or we can click the button on the right-hand side. Super quick way of letting the model define this parameter. Now, what I would say with letting the model define this parameter is you're leaving it open more to chance if you don't give it a good description of exactly what it is. But the models are getting smarter, and they're able to now pick out the correct options 6 to 7 times out of 10. But if this is something you're going to rely on for your business, you probably want to lay out exactly these parameters here, and you can add other fields as well. For example, a crucial one might be the start and end time. Those are the things we're going to update the most. But for ease and speed, we're going to let the model define that and see how well it works. And we can always come back and update it. So we'll keep it at description, end, and start, dates and times. And that is our update event. So we'll pull that over here. And you can see now we're racking up a bunch of different tools that we're going to need to tell the agent how to operate with. So when we were defining those, a thing that we saw was that actually for a bunch of these operations, delete event, update event, we need to find the ID of an event. So we'll keep on the event resource, and we'll go down to get many, which retrieves many events from a calendar. So the way I'm imagining we'll retrieve the IDs is by pulling all of the relevant events in that time span and finding the relevant meeting, or the AI will do this for us, and therefore pull the ID of that meeting. You'll be able to see its interactions in the logs when we go through and test it. So we're going to retrieve many events from a calendar here. And now it will give us the option to return all of our meetings or just like a max limit. So we probably only need the 10 most relevant. But again, we're going to define that it needs to take from the inputs the window which that event is between. So if I'm saying update my Monday lunch meeting, then it's going to need to define the before and after parameters to work out which events it's going to pull. So it should then pull, for example, after 11 a.m., but before 3 p.m. And there might be a series of events, and it's then going to have to select which event from that list, and therefore the associated ID that corresponds to the meeting I want to update. At this point, you're probably thinking, how is the AI going to understand, if it pulls 4 meetings, how's the AI going to understand which one to update? And this is how we talk to it in the prompt. So it's almost like training a human. We will tell it that if it needs to update an event, it should first pull all of the events using the get event tool, and it should return that to the user with a list of events. And then the user should confirm which event they were talking about. And you can see where the memory comes into play here. If we want that back and forth interaction, we need the memory so that the AI agent understands what conversation has been previously had, and therefore we're able to take the correct ID and send that to the other tool, which is the update event tool. So we'll call this get event. And again, for now, we'll leave these as model defined for speed. We'll see how it performs. If it's performing badly, we'll come back and we'll define these. So we've now got a bunch of different sequences. Get event is almost like a helper tool to help us delete events and update events. We can then update and delete, and we can create events. The final thing that's missing here is finding out whether we're available at that time. So we're going to copy and paste one of these again. And this time we'll go to calendar on the resource and availability, if a time slot is available in the calendar. We will let the model define this again. If you don't want to, you can use the from AI functionality, and we can specify a time zone. I'm in GMT, so it should default to what your n8n server is in. And we're just going to call that check availability. And you should be building up a picture at this point of how we go and tell the agent what to do. So before every action of create event, we should be checking the availability. If we're updating an event, we should be checking the availability. So this is going to be a crucial node or crucial tool for our AI agent to use at several steps along the way. And we're going to need to tell it that in the prompt. So we've got all these tools here. So we'll just expand the box. And now we have a really nicely laid out flow. We have a calendar agent in the middle performing the actions. We have an input from a user on the left-hand side where we can use a chat here. And you can also connect this to your own inputs like a Telegram bot, an email, various different inputs. And I cover that in my full course, all the different triggers. We then have the model that it's going to use to connect to all the tools. We have that chat history memory. And then we have all the functions that it's able to do. So we're able to create events, delete events, update events, get events, and check availability. Just going to make these all consistent. Now comes the final piece of the puzzle, which is prompting. So we've got all the information we need now apart from the prompt. Now the prompt is where we tell the AI agent or an LLM like ChatGPT the rules that it needs to follow and what it needs to return to us. So I thought long and hard about different acronyms that could make this easy, because actually a comprehensive prompt contains quite a lot of information. And the best one I could find was critics. So we're going to go through each of those steps, but it's a really stable prompting format for creating prompts again and again for these AI agents and even for LLMs, just minus the tools. So I've simplified each one here, and we'll start with the one that most people are familiar with, which is role. We had to switch around the C and the R to make a word, but the only two that are not in the correct way we lay it out in the prompt are the first two, which we switch around. So we'll start with role or scope. And this is essentially asking or telling the AI what it is an expert of. So in our case, we're telling it is a scheduling agent, and its overall objective is to schedule meetings on our behalf. We then have constraints or rules, which naturally are the rules it needs to abide by. So this is where we set the boundaries, the limitations, and the guidelines for our AI agent prompt. So an example might be, don't book meetings without confirming with us first. We then tell it what it's expecting to receive in the inputs. And if you can, it's always best to include examples as we go through these to make it really clear. I treat this as if you were training a human to do the same task. What information would you need to provide to them to make it really clear exactly what you mean? And then the AI agent is going to fill in the ambiguity by making assumptions. We've then got tools. So this is specifically for tools agents, and not all AI agents and not all LLM prompts will need tools. But if you do, it's what resources can I access? So an example here is if we wanted it to have access to the web and web search, then we'd give it a web search tool like Tavily or Perplexity. But in our case, that's going to be the Google Calendar tool, but not just the tool, it's the functions that we're calling from that tool. So we've got create event, we've got check availability, get events, delete events, and all of these different tools that's able to access and use in different ways. So we need to explicitly tell it what that tool or function is for, and therefore it will know how to use it later in the tasks. So the next part is actually telling it the order of tasks it's going to follow. So a good way to structure this is for each tool, giving it a step-by-step, okay, you're going to create an event. So the first thing you're going to do is check the user input for any attendees, the description, and the start and end time of the calendar invite. You're then going to call the create event tool to create event. And finally, you're going to return a success message to the user. So that is our instructions for that specific tool. And laying it out on a tool by tool basis makes it really straightforward. One, to read, and two, to follow that task list exactly. The more specific we can give instructions to our prompt and to our LLM running it in the back end, the more success we're going to have when testing this out. And the last two are really critical. We've got conclusions, which we sometimes call output format. And we give really clear examples of what output we're expecting here and the expected response formats. And then finally, we've called this solutions, which is the solutions we need if we come across an error. So it's also error handling. And this answers the question, what do I do if I don't get the information I expected to receive? So for example, if somebody asks to create an event, but they don't give any details around time, attendees, name, etc., then what should the model do in response to that? Should it make it up? Probably not. It should actually reach back out to the user and request more details. So an easy way to remember this is critics, and it's a really clear prompt structure. So we're going to go on to an example prompt that I've created in this format for our calendar tool and go through each aspect and look at the important parts, and you can replicate this yourself. And then we'll test the tool in action. We can actually run through a prompt that I made before for this exact calendar agent and understand what's good about it and go through this format again with a practical use case. So we'll go down to our calendar agent here and we will just open it up, and you can see I've been doing a test here. If we open up the prompt within the text, I've just copied in a prompt that I pre-made. And by the way, this has been pre-made by a prompt generator that I'll be showing you guys soon. And as you can see, it's creating some really, really clear prompts. They're not perfect, but if it provides a really clear starting point, then we can easily iterate it to make it suit our business needs and make it really easy for us. So we've got the role here. You're a Google Calendar agent responsible for managing calendar events on behalf of users. Your purpose is to schedule, update, and remove meetings while following best practices like checking availability. I've then given it some context. You are connected to Simon's calendar, who is asking you to schedule meetings, so it understands who it's scheduling for. We've then given it the constraints, so things that it needs to abide by and guidelines. We don't want it to delete events without explicit confirmation. We want to respect working hours. It should verify the date and time formats before creating events. Otherwise, if it tries to send it in the wrong format, that's going to cause an error with the Google Calendar. And it does that by looking at the data format that the tool is expected to receive and therefore trying to format in that manner. We've then given it the context of today's date. So without doing this, it will not know that it is today. So we've used the JavaScript expression for now there, and you can see on the right-hand side that's populated with today's date time. I've then given it some queries based on my experience. And the way you'll build this out is you should always start with a base prompt, test it for edge cases, test it for the mainly used, most frequent cases, and you will see when it throws errors. You will get errors. That's part of building out AI agents. The skill in building out AI agents is being able to prompt in an effective way to go around those errors or provide more information to stop those errors happening as frequently. So a specific one here is if a user specifies a day, e.g. on Thursday, it might not understand at first what date that's talking about. So assume it's the next Thursday from today's date. If a user asks to check availability at a specific time, like 8 p.m., assume a before time of 1 hour before that and an after time of 1 hour before that. Because if they're going to specify 1 p.m., if they're going to specify check my diary at 8 p.m., it needs to check the availability of a before and after time. So there needs to be some assumptions made about the inputs it's passing to that check availability tool. And then for vague user queries, clarify details before continuing an action. So those are our basic constraints there. We then move on to tools. So like we mentioned in the critics structure, each tool is actually a function. So the tool that we're connecting to on all of them is the Google Calendar tool, but actually the tools here are our functions. So we've got create event, delete event, get events, update event, and check availability. So 5 different functions, which correspond, if we go back out, with our 5 different tools here. For each of those, I've specified what parameters we're passing in. So we already discussed node by node what each one would take. So for example, the start time is required for a create event. The end time is also required. We could put an assumption in here that if an end time is not specified, assume the meeting is 30 minutes long. You can see how we're feeding it more context as we go through and tailor the prompt to our specific needs. So we're passing in the required start time and end time. And I've also passed in a specific format here. The way you can find this out easily, the AI might be able to assume the format already, and we could be okay with that. But for tools that are less built into n8n than Google Calendar, what you can do is go to perplexity.ai. And perplexity.ai is a web search engine. So it has access to API documentation. Here we're just connecting to the Google Calendar API documentation. So I would say, if I wanted to create an event, what format or date format would the start and end time be in? And it would return something like this. And we could then just take that from Perplexity, copy and paste it in here. Nice, easy way to specify specific ways to send data. Because if it's sending it in the wrong format, like we mentioned, it will fail. And we might see that when we're testing. We've then got the delete event. So to delete event, you need to get the event ID. And actually, we're not going to worry about doing the send update. So we're going to remove that here. To get the event ID, it's going to need to use get events as well. But that's not something we define in the tools. It's something we define in the instructions for deleting meetings or events. We then have get events, and we tell it retrieves calendar events with parameters. And I've just put a little note here. It's useful for getting event ID, which we know is useful for updating events as well as deleting events. Again, we've passed in the before and after times in that same format. And then we move on to update event, which will update calendar events and pass in the following parameters. Again, the event ID is required. And then we've got a few things that we might want to update: summary, description, start time, end time. Now, there's a few things here that we've mentioned, like summary and description in create event and update event that we didn't have initially in our tools. So we'll go back in a minute and add those. We've then finally got check availability. And I had to use Perplexity to understand how this works. But check availability will retrieve busy slots between that time period. So we specify before and after time. So say the user is saying, check my availability between or on Wednesday, it would specify a before and after time. And the Google Calendar tool would return all the busy slots within that period, and therefore is able to send the user what times they are not available, or in reverse, what times they are available. We then have the instructions, which are the order of tasks. And like we said, for each tool, we define, okay, these are the set of instructions you need to follow. So for creating meetings, we're going to collect the event details from the user input. We're going to check for conflicts using the check availability tool. We're going to then create the event with create event tool. And we're going to confirm a successful creation of an event there. For updating meetings, we're going to identify the event to update using get events, and suggested that we need the event ID. We're then going to retrieve the current event details, apply the requested changes using update event, and confirm changes before we submit them. We want to go back to the user and confirm that those are the changes they want to make. For deleting meetings, we want to identify the event to delete using get event, again, the same, and then follow a similar path to updating meetings, confirm the deletion intent, execute delete event, verify that it's been deleted. Then we have 2 more use cases. Getting meeting info. We want to collect the event details from the user input. We want to use get event to return events between those times, and then return to the user the event information. And similarly with checking availability info, we want to collect event details, use the check availability to return events between those times, and let the user know about the events. Arguably, we could consolidate the get events and check availability into one single tool, but here we've kept it as 2 separate. We've then specified the inputs, which is a natural language request for calendar actions, and said some of the things that could be included. So meeting title summary, start and end times, date, time zone, attendees, which might come as emails, and the description. And then the final couple of things, we've said, okay, these are the outputs we expect. Confirmation messages for successful actions, clear error messages for failed operations, event links when events are created, summaries of upcoming events when requested, conflict notifications when scheduling issues arise. So a clear action for all the different paths that we could take. And then finally, some solutions or error handling scenarios. So if event creation fails, we're going to retry with adjusted parameters. If a time slot is unavailable, let's suggest alternative times by again using getEvent, and a few other clear error handling steps. And then finally, we've put in the user query. So remember at the start of this tutorial, we had the chat trigger.item.json.chat input. We've just pulled in that chat input inside this user query just to force the input into the prompt here. So the final thing I'll mention are these, what are called XML tags. So you can see I've got an opening tag and a closing tag here, written like opening tag, which is actually the closing tag. And all that does is tell the LLM that the information between those two tags, those XML tags, are the conclusions or the inputs or whatever it is. It's just an easy way for the LLM that's trained on things like XML tags to identify clear sections in our prompt. So you can see that this prompt was actually written by a prompt generator, and actually it covers a lot of the functionality we'll need, but you never know how it's going to perform until you actually go and test it. So let's go and test it and work out what we need to refine in our prompt. So the moment we've been waiting for, let's go back and actually test this thing out and see if it's any good outputs. I also, whilst I was off there, I've also made one change, which is inside the settings. I've got an on error continue using error output, and all that will do is send the error to this branch so that it doesn't stop the workflow, but actually just gives us the information about the error so that we can go and troubleshoot from there. So let's start off by asking it to create an event in our calendar. We're just going to share the calendar here. This is the Simon at Scrapes calendar, which is new. And there are no events in this calendar so far. So we'll come back and check that after we've created an event. So we're going to go back to n8n, open up our chat. And the first thing we're going to do is ask it to create an event tomorrow at 3 p.m. until 4:30 p.m. with the title test event. And let's just leave it at that, quite ambiguous. So it's now, we've hit enter, it's now running the event. So it's checking the previous chat history, it's checking the model, and it's now said it's executed correctly. However, we can see that there was no response. Make sure the last executed node outputs the content display here. Let's go in and look at the error. So the error here is received tool input did not match the expected schema. So what this means, and this is the most common error when you're using tools agents, is that it's trying to send data to a tool, but the tool is rejecting it because it's not in the right format. So there's two things we can review here. The first are the inputs we're sending, and the second are what is expected. So if we go to create event, we know in here that we are expecting a start time to be sent and an end time to be sent. In our prompts, we know we've specified a start time and end time. So it's not that we don't have the information. However, we've also specified to find the attendee emails from the user input. So this could be causing the error because we've not specified there's no other users. So let's try and go back and see if that's it by going back to the chat window. And we've got an error again. So part of this process is trial and error. I went away to do a bit of troubleshooting on why we got an error. And I ended up changing the model that we originally set. So originally we set it as GPT-4o mini. I've now upgraded that to a more expensive, but still reasonably priced GPT-4.0, which has better reasoning and therefore can probably understand the instructions we're giving it a bit better. So we're now going to give that a go with creating an event. And we'll say create an event for 2 to 2:30 p.m. tomorrow with just me to test just with a solo person for now. We can see it's using check availability, using create event, and it's come back with successfully scheduled for 2 to 2:30. Tomorrow, you are the only attendee. You can view the event here. So if we go to the calendar, you can see that it's incorrectly assigned the event. So it's actually put in 9 till 9:30. So we'll go back to our agent and look through the logs to understand what actions it took. So we passed in the OpenAI prompts, and the event went through correctly, 2 to 2:30 p.m., just me. We then have check availability. So it actually sent the correct start time and end time by the looks of it, 2 till 2:30. However, what I can see here is it's, I think, in the wrong time zone. So it's 7 hours out of my time zone. So what it's done is incorrectly looked at the time zone. So what we're going to do is go back to the prompt and just make sure that we specify the time zone in here. And I'm just going to put the dot to local because I've already set my time zone in the settings, and that is now correct for my time zone. But to double check that, you can go up here into your own settings and actually just put your time zone. So I'm Europe, London here. And we're just going to save that. And we're going to try that again. And you can see it's checking availability, and it's saying it's created an event tomorrow, the 27th of Feb, 2 till 2:30 p.m. And great, it's created that event now. I'm the only attendee. It's in the correct slot in the diary. You can notice it's got no description, no title or anything because we haven't specified that. So if that was critical for us, then we just add that to the prompt. So let's go back into the prompt. So to simplify this, when I was testing, I removed all parameters apart from start time and end time. Let's add a summary, which is the title. Let's add a description, which is obviously the description of meeting. And let's also add attendee, which is the list of attendee emails. Now let's try and just run that without including any of that information and see if it runs. We'll first double check in the create event. And actually you can see in this create event node that actually it's received all this information and sent this through. So you can see it's got the time zone in here. It's got the start, it's got the end date. And at the time we had no attendees. So we'll add some fields here, one for the description, and we'll just let the model define that. One for the summary, we'll let the model define that as well. And then inside the prompt, in the constraints, we'll just say, give each event a summary and description, even if not provided. Great, so we'll just try that again. But first, we want to just check if the check availability is working correctly. So I'm going to ask it to create an event where we've already got an event to check the availability. And it's told us correctly that 2 to 2:30 is unavailable and suggested some other times. We're free during 1:30 till 2 and 2:30 till 3. So we'll do scheduled 2:30 till 3 p.m. And what that should hopefully do now, okay, it's come back and said, give us additional information, 2 to 2:30 p.m. I'm the only attendee. Let's see if that schedules for us. So it's added a private work session tomorrow, 2:30 till 3, and we can check that in our calendar, and that's now in. And it's also put a description in there, personal work session for Simon. Great. So it's actually now taking on our feedback in the prompt and implementing that. The point in showing you those errors is that your prompt's never going to be perfect first time round, but the way you interact with these AI agents is you start with a basic model, you do some testing, you figure out what the errors are telling you, and then you refine the prompts in order to make assumptions or get the AI agent to make assumptions around certain models, and you get closer and closer to what you need for your business specifically. So I'm starting to test out some of the different functions that we have. So I've asked it what are my events on tomorrow, and it's come back with, here are your events for tomorrow, event at 2 p.m., private work session at 2:30 till 3, an event at 9 p.m. And if we check our calendar, those are all correct. So the get events is working correctly and it's restoring those. On the right-hand side, you can see the logs of exactly what it's pulling. So it's pushed in any event, and it's done this by itself. We've not given it any prompt to any event after midnight tonight and midnight tomorrow. So it's successfully identified that. Let's now try and get it to delete event from our calendar. So first it's getting the event, and it's found the event in our calendar. So it's scheduled from 2 to 2:30. Here are the details. It's followed our prompt, which says always confirm before deleting events. Confirm with me that that is the right event. So let's say delete this, and you can see that we've hit another snag here. So let's go and investigate that. So inside the delete event, it says the resource you're requesting could not be found, which suggests we're trying to find an event that doesn't exist. So where this event ID is defined automatically by the model, we're clearly passing it an event ID that doesn't exist. So let's go back and check the logs. You can drag the logs up like this, and I can already see the error. It's passing in a random event ID because if you look down the nodes or tools used here, we've not checked or got any event details, and we need to use get event to delete an event. So let's go and check our prompt again, and let's just add a bit of details. So let's say obtained from using get event tool, the event ID, and then in deleting meetings instructions, we've got identify the event to delete using get event, confirm deletion intent with user, execute delete event, pass the event ID from get event. So you can see we're just making it a bit more specific so that when we get these errors, we're troubleshooting them one at a time and we're getting closer to the expected outcome. And then once we have it all working, we have a consistent prompt that works consistently. But we start with that base prompt and work our way from there. So let's just ask it to try again. And I expect it will probably fail again, but we will see. Okay, so actually it first tried to delete the event and it failed because, again, the resource we were requesting could not be found, and it passed in this event ID, which it might have made up because it didn't perform the action of get event first. But then critically, as an agent, it's able to then think about it. It's then said, okay, what do I need to do? I need to use the get event to find events tomorrow. It's found events in the diary, and you can see that we've got the ID here, which ends in C54. And then actually, it's then done the delete event action again and passed in the correct thing. So let's go back to our calendar, and hooray, we've actually deleted that event. So you can see again how iterative this process is. We might want to go back into our prompts and just make sure it doesn't run delete event first and actually just upgrade that there. And I'm just going to, in the instructions for deleting meetings, add an instruction that says run get event to get the appropriate event ID to pass into delete event. Just made it more explicitly clear. Confirm the deletion intent with the user. Execute delete event. Pass the event ID from get event. Verify successful removal. So let's see if second time round it runs better. Delete the 2:30 to 3 p.m. meeting tomorrow from calendar. And that's come back as failed. And it's basically run get event. But I'm just looking into the logs now. And we've got the same thing with the time zone where it's actually checking between 2:30 and 3 p.m., but in the wrong time zone. So let's go back and just reiterate in the prompt. And you can see how temperamental these are. And we're just going to put always use UTC time zone in our prompt here. And we will try it again. Okay, great. So it's actually found it this time, 2:30 till 3 p.m., private work session, given us the description of event details. Let's delete and see if it runs the correct order this time. And it's come back, given us an error message saying it couldn't do it. Let's try it again. And again, 2 errors in a row. So let's go back into the prompt and see if we can fix this once and for all. Okay, so I spotted a problem which probably has been caused in the prompt where we are telling it a time zone in here, which is why it keeps trying to do a different time zone despite telling it to do UTC. So I'm just going to remove the -7 off the back here. That's my fault there. And then I've also added a new constraint. When deleting or updating events, you must always check with the get event tool for the correct event ID. Never make it up. Let's give it a go again. Again, I'm showing you this to reiterate that you start with a base prompt and you work through all the problems. It's never going to work first time. It's part of building out an AI agent that's actually going to replace a significant part of your business or your day-to-day, or reduce the hours you're spending on specific things. So actually investing the time now to get it right will pay dividends in the long run. So it seems to have successfully done that now. So go back and it's removed that from the calendar for tomorrow. So we've tested create event. We've tested delete event. We know that get event now works and check availability. Let's create a new event in the calendar for tomorrow with an attendee. And let's ask it to update that event, but also check our availability to check the final use case for this. So we've said one-to-one with Simon, email tomorrow at 3 p.m. And we know in the prompt it assumes it's going to be half an hour. So let's see what it does. So it's checked the availability and it's now creating an event. And it says it's put in a one-to-one meeting with Simon Coton, one-to-one meeting with Simon Coton in the description. Let's go to our calendar. It's in there and it's invited me to the event as well. Now we know that's in the diary. Let's ask it to tell us what meetings are in tomorrow. And it should just run the check availability now, or the get event. And it's correctly identified the 2 meetings in the diary using the get event. This shows us that actually maybe the check availability is a bit redundant. So let's go back to the prompt, and it's showing us that actually, like we thought, there's probably no need to have both functionalities, and we can remove one from here. But I'm going to leave it in now so that when you grab the template from the school community, you can have a play around with this and decide whether you want to stick with get event or check availability, because they return different things. But the great thing is it returned the meetings in the diary. So we know that they're there. Let's try and update one now, and let's give it more of a curveball task by trying to add a new attendee. So we've asked to add another email to the 3 p.m. And you can see it's come back, added the new email to the one-to-one meeting. It got the event. It then updated the event correctly using the event ID. But if we go to the actual meeting, we can see that it's still only one attendee. So we've got a bit of a false positive here. It's saying it's successfully added them. But when we look in the logs, it's got the correct event, but it hasn't actually added them. So let's ask it, who are the attendees? And it's correctly identified that there's actually only one attendee, which makes me wonder in the update event if we have the right parameters being passed. So if we go into the update event node, we can see that we're passing a potential change in description. change in end, change in start, but actually we've not got anything around attendees here. If we let the model define this parameter and then save that, we'll also double check what we're supposed to be passing in to our update event, and we'll add attendee, and let's try that again. So it's always worth double checking these things because occasionally you'll get a false positive like that. Okay, and it's now returned the meeting confirmation and said that we've added a new attendee. And if we go into the actual meeting, this time it's added successfully. And we can see that through the update event. We can see that the output included this second email. So now that's successfully working. We have a fully working calendar agent with a refined prompt that can create events for us, delete those events, update the events, get availability, all through a chat window. It's super simple to connect this to something else like Telegram or WhatsApp to be able to just manage your own calendar by word, by voice, directly through this interface here. This isn't quite production ready, but actually for your business use case, if you go into the prompts here, you could definitely test the edge cases out here and get it to production ready, probably within an hour of prompt refining and testing. So there we have it, your first very own useful business calendar agent. If you want to grab access to the template.
So I hope you enjoyed building out that agent and seeing the trials and tribulations as we encountered various errors on the way through. We're now going to move on to use case scenarios where you might need to access certain business data. So where our previous agent was working with a calendar where it had a short, succinct amount of information. Often when you're building these workflows on behalf of clients or on behalf of your own business, you have vast amounts of data that you want an AI agent to be able to access and leverage. And one of the most common methods for doing this is called retrieval augmented generation, or RAG. So let's jump into what is RAG now.
So we can split up RAG, retrieval augmented generation, into two parts, the retrieval augmented, which we'll cover in a second, and generation. So I'm sure you're familiar with ChatGPT. And when you talk with ChatGPT, what you're doing is getting a large language model to generate an answer for you. So for example here, whenever you type a query in, you're always hoping that it's going to come back with a good answer. Now, the problem with standard generation is that actually there's two key issues. The first is that it's out of date often. So for example, inside ChatGPT, the general knowledge of the training data only runs up to June 24. And the second thing from a business perspective is that it has no access to source data. So if you were to ask it a question like, tell me about my business growth in Q2 of 2024, you'll know that it doesn't actually have access to your data. So the retrieval augmented part of RAG is actually designed to solve that problem. So the retrieval augmented part means that we can add context to our LLM question to give it that additional information so that it can come up with a contextualized answer. So for example, that might be feeding in our business documentation so that the LLM can use its intelligence and answer based on the context of our business. When you use an LLM with RAG, or retrieval augmented generation, all we're doing is adding that context to the prompt and telling it when it answers our question to refer to that data first. So it always checks that source data before it gives us an answer. So you can see how this enhances the context in which the LLM answers. And it also means we get rid of the two problems. We have a source of data where it can pull information from, and it's completely accurate in terms of date. We can update the data source and our LLM will have access to the latest data. So how do we actually set this up? So there's a few ways we can pass the business context. And we think about it like this. When you type a question into ChatGPT, you've effectively got that initial prompt, which is your user query. But somehow we also need to provide it with that business context. And often that can be pages and pages of data. It could be your customer service training manuals. It could be legal documents. It could be any other source of data that you have in your business. So this can be vast amounts of data. So we have a few options to feed it in to the prompt. And the first is just feeding that data in every time. So imagine you're prompting ChatGPT. You've often gone to another tab where you've got some data that you want to work with and pasted that directly into the prompt with ChatGPT. Now that works for a small amount of data, but what you're doing is feeding in that data every single time. And we know that ChatGPT and LLMs operate on a token basis, and that token window has been increasing over time. So we've got some examples here with GPT 3.5, which was one of the earliest well-known models from OpenAI. And you can see that it had an output token limit and an input token limit of 4,096, which is approximately equal to 3,000 words. So not a huge amount when you want to consider all of the business data that you work with. It's about 6 pages. As models have progressed, you can see that some of the latest models have a much greater token window. For example, GPT-4o has a token window of 96,000 words or 128,000 tokens. But you also pay per token. So per million tokens, you're paying $2.50. So the more data you feed in to every single question, the more it's going to cost you. And when you're working at scale in a business, we obviously want to reduce the number of tokens we're using every single time. So that's where we come to the traditional RAG and CAG. So we'll go through RAG first. So you can think of RAG here like feeding in the data little by little. And you can think of CAG as feeding in the data all at once. But the difference here than what we discussed before is everything is put in a temporary store, and you can ask multiple queries and it's only fed in once versus putting the data in every time if we're inserting it directly in the prompt. So in terms of RAG, there are two key stages. We have the ingestion stage, where we're effectively taking our large business documents and we're putting them into a store. And then we've got the retrieval stage, where we're asking our questions into ChatGPT or an LLM, and it's referring to that context from our store and then using that to answer our question. So the ingestion and retrieval. We're going to run now through exactly how that works and what the benefits of using something like RAG are for your business versus something like CAG, where we feed it in all at once. So in the ingestion stage of RAG, we have our large documents, which might be our entire company knowledge base. And the first thing we need to do is split it into logical chunks. And this is what we call chunking. So we're going to come down here to this chunking section, and we're effectively just splitting into fixed size chunks, like 200 to 500 characters, content-aware chunks, like paragraphs or subsections of a certain set of documents, or an even more granular chunk, which we call recursive chunking, for documents that are heavily hierarchical. So think about technical manuals, laws, things that have lots and lots of subsections within subsections. We might use this recursive chunking to split it out into its individual sentence lines. For fixed size chunking, it could be that we store our customer service guide in Notion, and we know that roughly one block pertains to a particular FAQ, like how to reset your password, steps to troubleshoot login issues, and we actually just separate it like that. In our content-aware chunks, we could have certain separators like inside a product manual. We could have key headings that we could say, okay, on every heading, split the document. And then we talked a little bit about the legal documents and splitting on every single subsection within a section. But in essence, chunking is just taking large documents and splitting it into manageable chunks so that when we come to retrieve it, we can find it really efficiently, and it saves the LLM digging through the whole set of data. So we've got the large documents, we've split them into chunks using one of the methodologies. We then have to store it somehow, which is where we come to vector databases and vectors. Now, they sound complicated, but they are actually very simple to understand. So each of these chunks, i.e. this could be a paragraph, it could be a sentence, it could be a section of 500 characters, need to be searchable for our LLM. So that's this index stage. And what we need to do is embed it in a database. So if we scroll down here, we've got an example of what embedding looks like. So in a traditional database, we're able to search for exact matches like man, woman, daughter, son, but we have no relationship between those values in a traditional database. A vector database changes that by representing each of these values in a 3D plane. So you can see on the example here, we've got banana and pear, which are nothing alike in spelling, but similar by meaning, and they would be closer to each other than Apple phone, which semantically means something entirely different, but obviously has the word Apple in. So we call this embedding, where man and woman here, or banana and pear, become a specific vector within our vector database, or this spatial relationship. And they do that by converting them to vector values. So you can see here as an example, we've just got these digit values, which represent characteristics of the input word. This means that when we come to retrieve the context around our business, our query also needs to be embedded using the same embedding model in order to retrieve the data that's most similar to our query, which is exactly what we're doing when we're retrieving the data from our vector database. Now, I won't dwell too much on the embedding models, but there are different embedding models for different use cases. So for example, if you were looking for text similarity, like matching customer questions to FAQ answers, then you might use a model that's particularly good with finding similar text versus other embedding models that are domain specific that have heavier context in certain domains that are particularly complex, like legal or medical texts, you'd need to go to a much more granular level if you were to build a specialized vector database retrieval. And all we need to do as businesses is understand that there are different models, and some of them are better for our use case. In something like n8n, which is an AI workflow automation program, which we teach people how to use in the community, they have all of this set up already for you. You just need to select the one you want. So it's actually very, very simple to use. So let's go back up here to RAG. So we've got the large documents, we've split them into logical chunks, and now we've converted those chunks or embedded them as vectors into our vector database, and they're stored in chunks, which means each chunk has a vector position and also has the business context stored with it, which means it's really efficient to search because we're actually just searching by the vector, not by the information itself, but it's then able to pull that information. And one thing I didn't mention here was the ingestion happens once or every time we update the data. So it's a single event process that we continue to update in the vector database. And then when it comes to retrieval, a user asks a question inside the LLM or the ChatGPT interface. Like we mentioned, it converts our query into a vector so that we have a semantically similar vector position. And it then uses that vector position to do a similarity search, which pulls the 5 or 10 or 15, whatever we choose, most relevant bits of information that match the wording in our query. And the important thing here is it's not looking out for particular words, it's understanding the semantic meaning of the words. So that then goes into the vector database, pulls the top most relevant context back, and adds that into our prompt for the LLM. So the LLM is then able to use that top 5, 10, 15, or whatever bits of information and add that context to its answer when it's answering us. So it will give more accurate information than if it were to generate an answer without the context. Now, the benefits of something like RAG is that it's easy to update the business data and it's very scalable. We can make this vector database huge to cover all of our business data. The fact that when we ask a query, we have to go and retrieve that information from a vector database makes it a bit slower in its retrieval. And it's also a bit more complicated to set up because it's got all these steps we outlined in the ingestion and retrieval. Now let's have a quick look at the alternatives or the most popular alternatives. There are still popping up lots of different ways to supplement your prompt with your business data or your context, but CAG or cache augmented generation is one of the most popular techniques. And I'll tell you exactly why that is. If we go back up to the token limits and costs here, RAG has been really popular since GPT 3.5 came out. Because if you think about it, we're feeding this business context back into our prompt. So say we have a prompt that's 100 words long or 50 words. We've then only got 2,900 words left to use in the prompt. So if we did something like CAG where we throw all of our business data in, it wouldn't be able to handle it. It would not be able to handle it. However, as models have advanced, you can see the token limits have vastly increased to the point where Gemini Flash 2.0 for 10 cents per million input tokens, super cheap, allows 1 million input tokens. And I can see this is incorrect here because it's not 6,144 words. It's significantly higher than that. It would be closer to something like 800,000 words based on this. And I believe the average novel is 96,000 words. So 10 times that we can feed into our prompts now for relatively cheap, which is why CAG is becoming more popular. Because, to remind you, CAG is not about feeding in the information little by little. It's about feeding in everything at once. But instead of putting that in every single time into the prompt, all of our business data, all of the documents copy pasted into our prompt every time, it caches it or it stores it temporarily in the backend so that it doesn't need to reprocess it every single time you send the query and take a long time. It's got that context cached in the backend inside the LLM so that once we've stored it once, it's stored in a really efficient way that our LLM can just reference the context that we've stored there. So it makes the ingestion and retrieval a lot simpler than RAG because all we've got is our large data set, which we ingest into our LLM. So we store it in a cache and we can do that through something like n8n. It's stored in the context of the LLM temporarily. So whenever somebody asks a question, and if we ask 10 questions, it's going to use everything it's already got, but also all of the context from the backend. So the benefits here are it's easy to set up, it's very quick to retrieve from, and it's more accurate because it's got the full context. Versus RAG, where we're pulling the 5 most similar bits of information, it doesn't always get it right. However, some of the issues with CAG, for example, when we're using it in a business context, is it's harder to update it because we've got to update a large document store, but also it's not suitable for an extremely large set of knowledge. We've still got to store that in the context window of our LLM. So if we're surpassing the token limit still, it's not going to work. Now, RAG or CAG, which one should you use for your business? And how do you actually implement these so that you can give your AI context and your business context? Well, we're going to cover that in an entirely separate video, as well as some of the ways in which we can enhance the quality of the retrieval of these different methods to make sure that when we're pulling information, we're pulling the most accurate information. So let's jump into making our first RAG. And I've opened up the n8n environment here. And if you're not familiar with n8n, then check out the full 4-hour masterclass that I've done that takes you from complete beginner through to an n8n intermediate level. But assuming you're familiar with n8n, we've opened up a new workflow and we've got our image in here of the RAG stages. So we've got the ingestion and we've got the retrieval. So we're going to build out step by step each of these stages. And we're going to show you which tools to use at which stage, what bits are important, but most importantly, when you're using it for your own business data, which I'd recommend whilst you follow this video, use your own business data, not the examples that I use. You're going to see some of the limitations of standard RAG demos. And in this video, we're going to cover exactly how to get past those limitations. And some of those will be around not giving enough context when you're splitting it into chunks. Others will be around updated data and how to make sure that your data is continuously updated and you're pulling the right information. And we've got a few other limitations that we're going to cover as well. So let's move on to the ingestion phase. So we've got our large documents. And for this first example, we're going to use some publicly available data. So we've got the Netflix investors page up here. And we've got the 2024 annual report, 2023 annual report. So multiple years of annual reports. So we're just going to download one as our first example of data we're going to upload. So I'm going to save that. I'm going to come back to the workflow. I'm just going to click the plus icon here. And what we'll do is we'll just start with the manual trigger. And we know that we've got to split these large documents into chunks. So first, we're going to need to get the document. So as an example, we can retrieve this from Google Drive. So I'm just going to go and create any folder in my Google Drive. And inside that, I'm going to upload the Netflix file. And then I'm going to take the link of the document. I'm going to make sure it's shareable. So anyone with this link can access this as a viewer. I'm going to copy that link. I'll go back to our workflow. And the first thing we're going to do is search for a Google Drive node. And what we're going to just do is hit the download file function. I've already connected to my Google Drive here. But if you've not previously connected to your Google Drive, I cover that in the 4-hour masterclass as well. Or I've got a separate tutorial on how to connect your Google credentials that you can check out. So we can either go from lists, so we've got all of our files listed, or here we just grab the URL. So let's put in the URL of the specific file, and we will cover later how to load in files as they're put into a certain folder. For now, we'll just do a demonstration with one Google Drive file, and we'll call this download file. So let's first test this step, and it's always important to test as you go along. Great, it's downloaded the file. We've got this as an output here as binary data, so we know that we're accessing the file correctly. If we go back to the diagram here, we've got our large document. We now need to split it into chunks. And if you remember, we've got to do that by using an embedding model to turn our document into data and then in turn into vectors. So right now, this is a binary file, so we haven't actually extracted any of the text from the file here. So let's click on the plus icon first, and we'll go to Advanced AI. And it's not in the initial list here. It's down here in Other AI Nodes and down here in Vector Stores. And at this point, we've got to choose which vector store we want to work with. So my preference is Supabase. So Supabase is free to use, and you're also able to store metadata or information about your data, a bit more context, so that we can retrieve it. Another popular alternative is Pinecone, but I find it a bit easier to load in, but harder to retrieve the correct information. So let's go with Supabase Vector Store. And in the actions here, we've got add documents to Vector Store. We've got retrieve documents, but obviously what we're doing is we're adding documents here to the Vector Store. So inside the Supabase Vector Store, we're just going to go to Docs up here. And this is to set up our project. So we'll go to Quick Start for setting up your Vector Store. And you'll see that this has an SQL command. You don't need to worry about this too much, but basically we're going to need to copy this. We're going to need to go into Supabase. You're going to need to sign up for an account for Superbase, confirm your account, and create a new project. So we're just going to create a new project here as an example, n8n demo. We'll give it a pass. You'll need this password later, so make sure you store it somewhere. And that's going to spin up the project. It may take a few minutes to spin up that project, but in the meanwhile, we're going to go and set up the credentials that we need. So we're going to copy these credentials here. We're going to go back to our RAG agent. We're going to come up here and click create new credential. You can see we need two things. We need a host. So we've copied that URL there, and you can see that that's in a similar format, and we need the service role secret. So if we come back into Superbase, we're going to go down to project settings, and then we're going to go to data API to get back to this screen if it's taking you off. And then the secret that we need to take back is this service role secret here. So you're going to click reveal, and then you're going to come back to n8n and paste that service role secret in there. We're just going to save that. And I'll change the name of this to Superbase demo. And you can see that it's now gone green. It's connected successfully to our Superbase account. Now we need to create the tables in Superbase, our database, to enable us to load data in. So again, this is why we went to the docs, the quick start for setting up your vector database. And this is where we need the SQL command. Copy that. We're going to go back into our SQL editor up here. And all this allows us to do is copy paste in this SQL command. And all this is doing is creating tables that's able to receive our vector data that we're going to embed and send. So to put it simply, the documents that we are splitting up into chunks, they need to go into some tables. We're just setting up with this SQL command or SQL command, the ability to receive the documents in certain format. So we're going to run that down here. That's going to run and it's going to appear success, no rows returned. And if we go to the table editor, we'll see that it's now set up a documents table with ID, content, metadata, and embedding. And that is the vector database set up. It's ready to receive our documents. So if we go back to our n8n environment, and now if you refresh up here, you should be able to see two tables in here, documents and RPC match documents. So we're going to load them into documents, and we're going to leave the embedding batch size as 200. And this is just the number of documents we're sending in a single batch. And all we're going to do here is come out into our dashboard, and you can see that there's two things that we need to add here. The first is our embeddings model. So to remind you, our embeddings model is what splits up the data we load in or the question we ask into vectors. So the embedding model just works out the semantic meaning of the words it's receiving or the data it's receiving and assigns a vector position to that. Now, there are specialized embedding models for certain things, but for your everyday business data, you're just going to need something simple like OpenAI embeddings. You're going to need to make sure you have an OpenAI account set. So you're just going to go to platform.openai.com/API keys. Make sure you sign up if you haven't before. And then once you're in there, go to the API keys section, create a new secret key, give it a name, create the secret key, copy that. And you're going to go back and make sure that you create a new credential. You're going to put in the API key, leave everything else the same. It's going to do the same again, test. If it goes green, it means it's successful. And then we choose an embeddings model here. So now we've got to choose a model. We're choosing between the text embedding 3 large, 3 small, or ADA 002. Now, the easiest comparison I found for this was here. The only difference between them all is the granularity at which they split the documents and the words in those documents, the data, into different vectors. So the embedding small model has fewer dimensions in the vector database. So if you remember, vectors are placed on a 3D plane. So it's got 1,536 dimensions to that vector. So that would be individual numbers. It's significantly lower cost than the other models and still performs well on benchmarks. So think of the embedding small model as suitable for short, simple documents. So this might be your meeting notes, and you want to use this where you want to save a bit more money. The large embeddings model is as it sounds. It's bigger or represents a specific set of data by more vectors, which means we can search to more granularity. We'll get better results, and you can see that by the benchmark performance, but at the expense of more dimensions, which is going to cost us more. So the data here in the dimensions means that each vector we save has more data points around it, so that it's easier to search. We can have a higher accuracy search. And then the embedding ADA 002, I believe, is an older model, which was a budget-friendly general purpose tasks. So whilst we are looking at complex financial documents, you can see inside the Netflix documents themselves, we've got 84 pages of different documents here. So what we might want to consider is actually using the embeddings large model. Now, I'd normally recommend using a cheaper model and testing, but I think for such a complex document, I'm going to start out with the embedding large model. And we can test and see if that performs well, see if that breaks it up into enough granularity that we can search for specifics here. Now, the other aspect we're going to have to connect here is a document loader. So this will now solve the issue of the fact that we were receiving a binary file here, because we can actually tell this data loader that it's going to receive this binary file. But if you're receiving text, then maybe we would use JSON here. And we're going to tell it to load all the input data. And it's automatically going to detect the data format here by the MIME type, which is application/PDF, or we can give it a specific one like PDF. But let's let it auto detect and do the work for us. And then there's other information which we'll cover a bit later that we can add as some context for this data, such as metadata. But for now, we're going to leave it straightforward. So this document loader now, we have to tell it, if we click on the text splitter, how we want to split this document. So if you remember here, there are multiple ways to chunk a document. And I've got a summary down here. We could split it by fixed size chunks. So we take the financial documents and we say every 200 characters, split that and call that a vector. So this would be really useful if we had something like FAQs or procedures where we have like a question answer, e.g., how to reset your password with an answer, steps to troubleshoot login issues with an answer. But it's probably not going to make a lot of sense for our complex financial documents here, because we could lose some context if we split randomly in the middle of a line after 200 characters, say. We've then got context-aware chunking. For example, we could have a product manual in Notion, and there could be key boundaries to look out for, like subheadings. And the context-aware chunking says, okay, at every subheading, split the document. So we could have introduction to product features, step-by-step guide for installation, troubleshooting common errors. All has different headings, and it would split the chunks from the document based on those headings that we defined. So we want H2 headings or subheadings to be the split there. And then we've got finally recursive chunking, which is probably going to be the most applicable in our use case here. And it's optimal for layered documents where there's lots of subsets of information. This could be like where we have a legal document that has lots of subpoints under a law, or any information that's very hierarchical. And you can see this strategy is ideal for large, complex documents where users may need highly specific information, such as how to configure software settings. So that's probably going to be the best one to try in our use case here. So we've got the character text splitter, we've got the recursive character text splitter, and we've got the token splitter here. So we're going to go for the recursive. And now we've got several options in here. We have the chunk size and the overlap. So the chunk size is just at how many characters are we going to split. So let's just leave this as default right now, the chunk size of 1,000. And the chunk overlap is how much of the context needs to be in the previous chunk as well as the next chunk. So if we leave this as 0 here, every chunk will be an independent isolated chunk. Whereas if we add something like 200 here, it means the last 200 characters of the previous chunk will be the first 200 characters of the next chunk as well. So obviously this takes more tokens, but it means some context can be used between the chunks here. Now we are obviously setting these arbitrary limits and we're going to test it. It's hard to determine upfront what the best chunk size, what the best chunk overlap, etc. is going to be for your use case to give you the best results. But there is some way of making it a bit less technical and a bit less guesswork. And that's good to go to vectorize.io. Let's sign up for a free account here. And it helps you build RAG applications. And if we go into this run a RAG evaluation, it says test chunking and embedding models using your data. So all we need to do here, let's call it test, is upload a sample of our document if you're comfortable doing so. So this is our Netflix document. And we're just going to leave it on the default settings here. And we're going to start the RAG evaluation. It's going to run through our document, test it on certain benchmarks, and come back with some suggestions on which would be the optimal embedding model, the chunk size, and the overlap for us. So we don't have to do the guesswork here. It's going to do a lot for us. And this is why we do these tests. So I've run the test. It's come back with different benchmarks around relevancy, i.e. it's tested it on certain things and said, using this embedding model, the chunk size and the overlap, how relevant were the results it returned when it was asked a question. And you can see it's asked it 27 questions based on the data and said, okay, the recall here is very high, 0.9519. The recall is actually higher on the large embeddings model, but the relevancy of the result was much higher, 0.65 on the small model. So actually it's suggesting here that we go with the embedding small model as it has the best balance. So let's go back. It said 50 for the chunk overlap, 500 for the chunk size. But actually, we're going to switch out this embeddings model now because it's recommended the small for the best combination of recall and relevancy. We're just going to move this over here. So that might be quite a few new terms there, but you can think of this as just we're taking a document, we're deciding what methodology to split it into chunks. We're choosing a model, i.e. an embeddings model, that determines the specificity at which we recall certain data from our database, but at the expense of cost. So if we go large, we have a higher cost, but can be more specific. We've used vectorize.io to tell us that actually small is good enough for this data set. And then we've said, okay, we want to split this document. And we've chosen the recursive because recursive means that it will start at the highest level separator. So in this case, it might be paragraphs. And if those paragraphs exceed 500 characters, it will then go down to the next separator. So it might be a chunk size of 300 because the paragraph is 1,000 characters long. So it says, okay, the paragraph was too long, but to retain context, we're going to go down to the next separator, which might be subheading within the paragraph. It might be full stop. It might be new line. And it basically will then split out that paragraph, but keep those paragraphs adjacent to each other in the database when we load them in, so that we've got that context and that flow, as well as choosing 50 characters of overlap. So we've got context between the previous paragraph and the next paragraph. So a lot to take in there, but what we're going to do now is load that document into the database. So we're downloading the financial document. We're going to load it into the database and show you exactly what that looks like. So let's go ahead and we'll just test the workflow. And that's now downloading the file again. And it's now starting to load that into our Supabase database. And we will go into Supabase and we will see what that looks like once that's all loaded in. So it didn't take long at all to load in, and it's loaded in 667 individual items here. And if you go into the output logs here, you can see every single bit of content it's loaded in. So these are the equivalent to what we call the chunks. And it's also loaded in this metadata without us asking to. And you can see it's got metadata about the whole document and also which lines it took from the document. So this will be 34 to 35. That was 29 to 33. So loaded in some really interesting data that we'll be able to search on that. And you could see we could make this a bit more specific and we could have changed the title of the document to give it a bit more info. But let's go into Supabase here and refresh the page. And what you'll see are the 667 records, like we said. And you can see, if you look at some of the contents, for example, here, it's taken the table of contents and it's split that chunk in this content row. It's a chunk into two because we've gone over the 500 characters limit. So you can see here, we've got the context up until item 7. And then the next one, we've got item 7A, and that's that next chunk. The next one's got up to item 16. So you can see how different vectors store different pieces of information. It's got the metadata stored and it's saying, okay, we've stored this line to this line from the document. And then it's also got the embedding or the vector representation. So this is really crucial, remember, because we've turned this text here into an embedding. And the reason we've done that is it's really efficient to search similar embeddings if we're looking for certain terms. So say, for example, we would ask, and we can try this, what is the table of contents of the document? That query would be embedded into a vector, and the vector position would be similar to all of these similar chunks that have table of contents. It would be able to efficiently find those in the vector database and say, okay, spit back to the user the most relevant information, and it would pull back, for example, the table of contents rows here, and we can try that. But it's great to visualize it inside the database and have it with this metadata here. So for a very simple use case, that is the ingestion stage that we talked about there. So actually, once you've done that once or twice, it's very straightforward. Let's open up a note here, and let's just call this ingestion. I'm always very keen to label everything clearly and have clear run-throughs so that when I revisit these documents or workflows, I know exactly what's going on, and it's good practice to have. Let's cover the retrieval stage now. So we've loaded the document into the database. Let's take off this test here. Let's copy this note, and let's just start creating our retrieval journey. And remember, we've loaded this document into our database so that when we ask for certain information from an LLM or AI node, that information is going to be returned back, or the most similar information is going to be returned back so that our LLM or something like ChatGPT can use that similar information to give us the right answer. So we're going to need to create a prompt that says, okay, based on the user's question, retrieve the most similar data points and use that in your response to answer my query. So very straightforward if you set up a chat node before, but here it is as a graphic representation. We've got the user question. It will be embedded as a vector exactly like we saw before. It will then be used to search the vector database and return that for an answer. So what we're going to need to do is attach a chat query. So where we can answer questions. So a chat trigger, sorry. So that's just going to enable us to easily test this inside our workflow environment, because we can open a chat here, say hello, and it will run and it will send that chat message. We then need to connect an AI agent to this that's going to receive the chat input from the chat trigger. And you can see already that we tested. It's passed through the hello as chat input. But we're going to give it a specific system message. Instead of a "you are a helpful assistant," I've crafted a very brief prompt here that you can copy out. You're a Netflix 2024 financial document assistant. So we've been quite specific here with our first example, but you'll see how we can apply this to more broad RAG use cases going forwards. Your job is to answer questions using the files in the vector database. Check the database first, search for similar text chunks using RAG. If you find matches, use them to answer the question from the user. Always say which chunks you've used. So we just want it to tell us the chunks so that we know it's using actual data. And if no answers found, say, I couldn't find this in the Netflix 2024 documents, never guess or invent answers. And then we've got an example response here. Netflix grew revenue and streaming services by 25% in 2024 with a reference to the chunks. So we've given it an out and we've told it the steps it needs to take, because this is effectively a tools agent that we need to connect to the vector database. But first, let's just connect it to an OpenAI model. And let's just use GPT-4o Mini for this first example. We want to give it a simple memory just so it remembers what questions we've asked it. We can also set this up with Postgres, but we're not going to cover this right now. So we'll have the simple memory. It can remember the last 15 messages we've sent to it. And that's going to read the memory before it answers any questions to check it's not duplicating answers, etc. And then within the tools, the vector stores are quite high up on the list. We're going to retrieve from our Superbase vector store. And you can see that this opens up. We've connected to the same credential. And we're retrieving documents as a tool for an AI agent. And that's exactly what we're doing. Let's give this tool a name. Let's just call it the vector store. Let's just call it documents. And then we can just use the description that's already here. Work with your data in Superbase vector store. And then from the tables, we're going to just say you're going to retrieve from the documents table, because we saw in our Superbase that that's what we're pulling. And then we're going to tell it, don't pull more than the 5 most similar chunks, and pull the metadata as well. If we wanted to select certain metadata and pass in metadata in the message, like say we had a 2024 document and a 2023 document, we might pass in metadata when we initially load the documents here. So we add to the default data loader here, metadata, and we might say the or the year or of that specific document. So that's all we're going to do there. We're now going to connect an embeddings model, and we need to use the same embeddings model, because if you remember, the embeddings model is going to convert our query into a vector. If we're using a different model, it's going to be looking for a different set of vectors, so it won't work. So we'll connect our embeddings model, and we use the small model as it's suggested in vectorize.io. And let's just run that to ask a query. Let's say hello to check it's working first. And perfect, it's come back. How can I assist you today? If you have any questions about Netflix's 2024 financial documents, feel free to ask. So let's give it a spin, and let's ask it about the table of contents in the document. We know that that's something that's stored in the database. And what we can see if we go into here first is we can see inside the Superbase vector store, the response of the 5 most relevant pieces of information it's pulled. So, and you can see it's pulled multiple vectors where the page content contains table of contents. And it's finally in its 5th chunk pulled these various titles like business, risk factors, unstaffed comments. So let's see what it's actually pulled here. So it's got part 1 and part 2. It's got business, risk factors, cybersecurity, properties, and it's gone all the way up to item 5. I know for a fact by looking back at the document, we'll search table of contents. You can see it's effectively read this section and started pulling these. So it's pulled these correctly, but it has not included all of the, if we go back and we tell it that it's able to retrieve up to 20 most relevant, if it will have a better result here. Because from the outputs of the actual vector store, we can see that it's pulled 5 chunks, but that wasn't enough information. So maybe we need to pull more. Okay, and now it's given us 5 parts here. It's given us part 1, part 2, part 3, and part 4. Sorry, 4 parts. And said this information was sourced from chunk 12. So let's go back to the document here. Let's go into part 3. We've got directors, executive officers, and executive compensation. But we can see from part 3, it's not pulled all of the information. Let's have a look at part 4, item 15 and 16. And again, from part 4, it's not pulled all the relevant information. And then if we go into chunk 12, it seems to have made up that it was pulling from chunk 12. So this highlights one of the limitations of conventional RAG. And I've seen a lot of demos. And part of the reason that I am creating this video is I've seen a lot of demonstrations on YouTube in particular, where they have this small document that's loaded into the RAG, and it's very easy for the RAG to pull the correct information. But when you're dealing with business data, you often have large documents, more than 84 pages that we're dealing with now. And I wanted to highlight the limitations of RAG and show you how you can overcome those using a few different methods. But first, what we're going to do is we can see it's not brilliant at returning full lists like the content section, but let's give it a few more queries, see if it can perform well at pulling specific details from the data, specific details that we'll look through the Netflix to find. So one of them is, let's look for streaming revenues. Let's look for revenues. In fact, what we'll do is we'll go back, and this is a good way to test it, because we might not know the exact name, and that's the point in a vector database search, is actually we can just search a term that's similar to streaming revenues, and hopefully it can pick out the right data for us, and then we can find that in the document itself. So we'll do tell me the streaming revenue for 2024, and that will go and search the database, and it's come back straight away. The streaming revenue was 39,000,96, which represents a 16% increase compared to 2023. And it's even given us a reason. It was driven by an increase in average paying memberships and price increases, which makes a lot of sense if you use Netflix. So let's search that number. And there's 6 results that we can see that have that number. And you can see streaming revenues was 39, increase is 16%. So that's exactly right. It's pulled the specific information. And again, there's just several sources that back that up. So that's great. It's performed really well there, pulling specific information from that 84-page document. And you can see that's like 67 pages in, and the first instance is 22 pages in. So perform really quickly. And that's because everything's stored as a vector. I have a feeling these chunks are not correct though. 5, 12, and 15. Chunk 5 is here. Nothing to do with it. Again, nothing to do with it there. And again, nothing to do with it there. So it's kind of just making up the chunks, which is fine. We don't need to know the chunks, but let's see in the return if we've got anything to identify the chunks here. And it doesn't seem like we do. So we've got some metadata information around the different lines. So maybe for now, for ease, because we don't need it, let's just remove that from the prompt. I'm going to ask it a more generic question. Give me the streaming revenues breakdown per year, and let's see what information it can pull now. And it's managed to pull the different years that it has on here. And because it's got memory, this simple memory up here, if I just ask something generic, like give me a further breakdown, it will understand that I'm talking about those streaming revenues, because if we go back to the first here, we have the streaming revenues here, but it also has DVD revenues and all of this information. So maybe if I ask, give me a further breakdown of operating costs and DVD revenues for those years. And I'm amazed to see that they still made some money in 2023 from DVDs, but none in 2024. So it's finally out. So it's given us all the different operating costs here. So let's just check one, operating cost of revenues. And I think it's possibly multiplied this all by 1,000 by accident. But let's see if we've got this number. Cost of revenues. So it has understood the query there and pulled the correct number again. It's then got cost of sales and marketing. So that was on page 24. Again, we've got from page 25, some different costs. So it's understood that these are all the different costs, and it's gone down these different tables and extracted the values. Now, we're lucky that this PDF has all text values. And the way I know that is because I can highlight this row. If we're searching for something that's embedded in a table that's an image or a graph, then we're not going to be able to find it because it's not going to be able to extract the data correctly. So for something like this, a stock performance graph, we have some of the results in here, the comparison, but actually we won't be able to extract any information from the chart itself because this is an image, not text. So let's see if we search the 5-year cumulative total return versus the stock market, because that's what that was showing. And it might have some text underneath, but if not, it might not be able to answer the question. There we go. However, specific numerical values detailing the cumulative returns are not provided in the documents retrieved. If you have access to the performance graph or detailed figures from additional sources, that may provide the exact returns needed. So it knows that we have some sort of information in here, and it's given us what it can, but it cannot extract anything from that chart. If you were looking to extract information from the chart, we're not going to build that in here, but it's something we've touched on inside the school community, which you can check out in the description and the comments. But you'd have to use some sort of OCR, optical character recognition software. So that would take images and extract information from those images. A popular free to use one is Mistral OCR. And you can see it's got examples here of like a math textbook and what it returns in the OCR results. So you can even pull out things like formulas, but what it does is it converts all of this into text that you can use, so you can see how powerful a model like this would be if we were to extract the chart directly. And we cover more about OCR in the community itself. Let's ask it another question. What was the earnings per share? And we can see it's got a basic earnings per share of 20.28. Let's go back into the document. It's always worth checking something like this. And we've got the basic earnings per share from page 40, 20.28. So you can see from that small example of an 84-page document and it's a financial document with a ton of information, that although not perfect, the embedding model and the retrieval that we've chosen is actually pulling out really specific information. When we're really specific, it struggled a little bit with the context of what the full table of contents was, which is a potential limitation, and there's a few ways to look at that. So I'm just going to ask it again, what is the full table of contents for the report, so we can come back and revisit this limitation that we found before, again returning part 1 and part 2, and we'll see exactly why that limitation exists. If we actually go into the Superbase database itself, you can see that table of contents is clearly present in chunk 14, but when we move on from chunk 14, we've got no reference that this is actually part of a table of contents. Again, chunk 16, no reference, etc. So we're lucky that it returned these parts. And in fact, I don't think it even returned 7. Let's have a look back here. Yeah, it only went up to part 5, despite the fact that even in our chunk, it had up to part 7. Now, it should have returned the rest of that chunk for sure. That's just a bit of a mistake there. But how can we give something like Superbase more context so that it understands this is actually part of the table of contents? It's missing this context here. So when it's doing a vector search, it's finding the words table of contents or things similar to that effect, but it's not intelligent enough to allude that any items are table of contents pieces. And it's kind of right in doing so, because if you think about how this document's laid out, we'll have multiple other parts of the document which will be split up by items or bullets, and it can't assume they're all table of contents. But there is a way to help contextualize this. And we're going to visit Anthropic's contextual retrieval guide, which they brought out in September last year. And it aims to get around these limitations of lack of context within chunks. And it claims to actually reduce the number of failed retrievals by 49%. And first, it alludes to actually a much simpler solution that we've spoken about before, is actually sometimes you can just put the entire set of data up to about 500 pages in the material itself, of material in the prompt itself. Because if you're using something like Anthropic or OpenAI, all of that data will actually be cached inside the prompt. So if you're asking questions multiple times, the tokens will only be used once, because it will be sent into the prompt, because it will be sent into the LLM, cached in the back end, so that it's all stored there and can be easily searchable. However, it notes here that as the knowledge base grows, you'll need a more scalable solution, which is where they've come up with the idea of contextual retrieval. And contextual retrieval means that actually we're going to spend less because we're not having to cache 200,000 tokens, for example. And I think the best way to illustrate this is to go to Anthropic's example here, and you'll see exactly how we could use this contextualized chunk in our table of contents example as well. So we've got an example of some SEC filings here, and we've got an original chunk, which is the company's revenue grew by 3% over the previous quarter. And you can see that without any context yourself, you have no idea in what year, what quarter, and any of the context surrounding this 3% revenue growth. So the contextualized chunk aims to change that by comparing the actual chunk that we save, which is just this sentence, to the full document. So it looks at all the context that came before it and all the context that came immediately after it and says, okay, what does this sentence actually mean in context? And with the contextualized chunk, you get it's from an SEC filing on Acme Corp. So it's included the company name because this SEC filing report could contain hundreds of companies. And it's about their performance in Q2 2023. The previous quarter's revenue was 314 million. The company's revenue grew by 3% over the previous quarter. So you can see that actually having that initial context put on the start of the chunk, now if we were to ask about Acme's company performance, it would never pick up this original chunk, but it would probably pick up this contextualized chunk. So adding context into the data before we upload it into our vector database is a solution to get around the limitation that we saw of incorrectly retrieving something. And it's given an example here of how we'd actually prompt an LLM after we've chunked the document, but before we embed the vectors, we'd pass in the whole document as context and say, here's the chunk that we want to situate within the whole document, pass in the chunk, like this SEC filing sentence here, and tell it, please give a short, succinct context to situate this chunk within the whole document for the purposes of improving search retrieval of the chunk. Answer only with a succinct context and nothing else. So you can see how that would take us from the process that we previously had of breaking chunks down and embedding them straight away into breaking chunks down, adding context to every single chunk, and then embedding them afterwards so that the context is stored in the data directly and is relevant and searchable. So we'd go from something like this here, and we can see this in a moment, where we've got just random items from the table of contents, and it would say something like, this is part 2 of the table of contents for this type of document, etc. So we pass in the context, and then when we ask for the table of contents, it's more likely to pick it up because actually the context is there. So the semantic meaning is much more likely to be picked up. So if we jump back to the diagram that we had that showed RAG, I'll show you how the only addition here for our contextual RAG is that we're actually just inserting context before the embeddings here, but we're actually creating the context using an LLM stage. So what we're doing is chunking. We're then putting in, let's just call it a context LLM. So we say for each chunk you receive, give me the succinct context based on the before and after in the document, and then add that context into the chunk, follow the rest of the process exactly the same. So embed it in the vector database or create a vector for that chunk after the context has been added. That's the only difference. We'll go back to our workflow here, and I'm going to show you exactly how we can implement this here, and then we can test it on our contents table to see if that has made a difference. And when I was out looking for ways to recursively chunk the data without using the embeddings models here, without using the data loader here, I managed to stumble upon a video by Mahmout, who's got a great channel, definitely check it out. And he has this workflow that basically shows you how to implement this contextual RAG. Part of that that's important for this workflow, I've downloaded, and we're going to plug it into our workflow here and change a few things up to match our settings. But thanks, Mahmout, for coming up with this really smart way to recursively split, create context for chunks using that Anthropic prompt plus a bit more, and then summarize it so we can pass it in through the ingestion phase with the context. So we've got this snippet that we're going to start adding in, and we'll go through each node individually to show you what's happening. But we'll go back to the ingestion phase here. And actually what I'm going to do so that you have all of the workflows available is I'm going to keep this initial workflow up here, and I'm just going to duplicate it, and we're going to create a new table because we can always then refer back. And the retrieval we can keep the same because we can just change the table, but we can always refer back then to the multiple workflows. So this is the standard RAG that we saw the limitations of, but still pretty good. And this is going to be the contextualized RAG. So our data structure doesn't actually need to change because if you remember, the way we're going to insert it into the data is actually the content in the text field of Superbase in this content field is going to be exactly the same, but it's going to put the context at the start of the chunk. So it's able to be easily searchable. So it's going to have something like this, succinct context, and then original chunk or corrected version if necessary. Mahmout has already added some additional really useful information in here that he mentions in his video. He takes the standard approach by Anthropic, but you notice there were a few mistakes where a chunk would often split on a percentage or on a number and lead to you having incorrect data, which would then force the LLM to hallucinate with incorrect data. So by including this additional set of instructions, we're able to mitigate that, and it's able to look at the previous context and reconstruct any mistakes. So it says return the original chunk exactly as provided unless a correction is necessary. If the chunk contains an incomplete number, percentage, or entity, correct it using the full document. If part of a sentence is cut off, reconstruct the missing words. If the chunk is part of a table, include the complete table entry to maintain data integrity. So it's like, on top of adding context, don't chunk in the middle of really important context that needs to sit next to each other. Like, don't chunk half of a table. So for example, it might decide here that actually a relevant chunk is the whole table of contents, and then just add the context to that rather than chunking at every 1,000 characters in there. The other thing that's really useful in this workflow is the recursive splitter. So like I said, there's no inbuilt way yet in n8n to split your chunks. So this code node will help us we'll put in our chunk size and our chunk overlap, which I believe was 550. And what it will do is it will say, okay, let's try and split the remaining text into chunks. And it does that first, like we mentioned, recursive splitting is like looking for the different hierarchical levels. So first we'll try splitting at paragraph level. If that's not possible, split at sentence level. If you can't do that, split at word level, so it goes down the hierarchy. And then if not, it forces it to cut at a certain chunk size. So it goes through all the different hierarchies there to try and maintain as much context as possible. We're then going to just call it the chunks. And then those are going to be passed into our prompt, which you can see loads in the full document data as well as the chunk. And it's about adding the context to the chunk. So that's really straightforward. We'll just rename this to add context. And then the summarize afterwards just puts it into a format that we're able to then pass in to what this Supabase vector database expects. It's expecting a text input field, and that's why we call it text. We also pass in a separator because what we can do now on our second version of this is we will split the code. Instead of using a recursive character text splitter, which we're already doing in the previous stage to initially split the document, we're going to delete this. We're going to start with a character text splitter. And now we're going to say, okay, let's do 550 again. And then the separator is going to be this custom separator. And the reason for that is because we're saying between all of the fields and all of the data that we receive, we're going to add this custom separator, which is split. And this could be anything. This could be a exclamation mark, etc. But this is something that's not going to be naturally in the text. So it's good to pick out something like this, which is totally unique. And what we're going to be able to then do is feed in the split chunks already into our vector database, which is going to identify to split every time it hits this separator in the text with a maximum chunk size of 500. So if that all makes sense, let's move on to actually implementing it within our workflow and test out if it works on the table of contents. It's a really intelligent way to add context to our RAG. So we're going to implement it now. So one of the additional stages in the ingestion here that will improve our RAG ingestion is that actually we should allow it to have multiple inputs. So it might not necessarily be a PDF we're loading into our RAG. So by having this additional stage where we basically just stringify the previous data that's received, we're enabling our RAG to take in multiple document formats. So an additional node we're going to need here is extract from file. So in this example, we know we're receiving a PDF from here. So we'll have an extract from PDF node that we will connect to our Google Drive. And before, we said in our data loader that it would be a binary data type. Now it would be a JSON data type, and we're saying to load all input data. And that just means that we're now more flexible to multiple input types. So instead of having a PDF and always thinking it's going to be a PDF, we can load in lots of different types of formats. You just need to add those down here and then connect them to this document data. So say we also had, if I just copy that, say we could also load in CSVs, for example. Perhaps the file is going to be a CSV. So what we'd have to do here is say, instead of connecting both of these, we'd put a switch node in. So the switch node allows us to say, if the file type is this, then perform this route. If the file type is this, then perform this route. So if it's a PDF, go down this route. If it's not, go down this route, for example. So we'll connect the switch node and we'll give it another route. Disconnect this. Let's execute the workflow so that it can start and show us what the file type is. And if we go into the expression here and put $binary.data, so we're digging into the binary data here, and we just say file type, let's see what that comes up as. So that's showing PDF. So if that is equal to PDF, then we're going to go the PDF route. We'll copy that for our second route, which we said is the CSVs. If the file type is equal to CSV, then go the CSV route. And now you'll see on the output that we've got 2 routes that it can take. Let's connect PDF up there. Let's connect CSV down there. So now, based on our input type, it will decide a different route, but this document data node, or this edit field or set node, will just take the stringified version of the data, no matter which version comes through. The other thing we did before, which we said we would change, is we connected before to a specific file. Let's go and find the actual file drive instead. So say we wanted to monitor any file uploaded to the drive and make it dynamic. Every time we upload a file to the drive, it will upload the document into our vector store. Then instead of downloading that file directly, we will change the trigger from a manual trigger to be a Google Drive trigger. We'll go down to triggers and it will say on changes involving a specific folder, every minute, let's monitor, and we can say the URL of the folder here. And let's say when the file is created. So instead of this manual trigger, we've now got this new trigger. So let's delete the manual trigger. Let's try and run the new trigger. And let me try and find the folder from the list instead, as that doesn't seem to be working. It's connected to the wrong Google Drive, that's why. So let's go by URL again. Let's fetch a test event, and it should come back with that file. There we go. We've got one file there. And we can specify in here if we want it to do just certain files, but we don't. Let's leave it as all. And then we still need to download the file. But now instead of taking it by the URL, let's take the ID of the file from the previous node. And we'll pop the ID in there. And let's just check that that actually downloads before we go any further. Great. So that has downloaded. It's exactly what we thought it was. And now it'll be processed. And if we let it process, it knows that it's a PDF from the file type. And now we have issues here because actually the field we're receiving is called text, not data. So let's run that again. And I'm just going to pin this here so it speeds it up. We'll download the file. We can't pin that. So now it's successfully pulled all of the data. If we go into the JSON here, all of the data from our doc. The same would happen if it was a CSV. We could add more routes here. That was just a demonstration. So we've made the input to ingestion dynamic based on a folder. We've extracted the content from the folder and allowed for multiple file types. If we just revisit our document here, the next stage is splitting it into chunks and adding the context to those chunks. So that's where this new part of the workflow is going to come in before we eventually add it back into our vector database. And we're going to create a new table to add that into. So I've got to remember to do that. And actually, instead of creating a new table, I'm just going to go back into this table and we're going to delete all of the rows. We change this to 1,000 rows. Great. So we've got a clean table, so we can actually add that context into our table there. So what we're doing now is we are manually, with the code node, like I mentioned, splitting up our document into chunks recursively, i.e. based on the structure of the input document, which is the most appropriate method for most. We'll come back and we'll add notes to this workflow so that we can see exactly what's going on from a high level, but for now, we'll just test it out. So before we add any context, let's see what chunks it breaks up into. And it's a good idea to always test this stuff out. And let's just pin some data to speed up the tests here. So you can see that with a chunk size of 500, it's cutting off some important context between these chunks, and each of these numbers represents a different chunk. So hopefully the context that we're adding here will help. And you can see that it's split it into 730 chunks here, which is a bit more than we had before. So what we're now doing is we're adding context. And the reason we've chosen this Gemini model is because of the cost of it. It's actually free to use for a certain rate limit. And then even after that, it's incredibly cheap for input tokens. You get per million tokens in USD, the input is 10 cents. So incredibly cheap. One of the cheapest models that exists. And it's actually very good as well, especially for a simple task like this, where it's just categorizing information and adding a summary. So let's just pin that data as well to speed it up. And let's test the workflow. Let's fire it through Google Gemini and see what has been added. Let's check inside here that we're receiving the data correctly. So we've got the document data.item.json.data, which is correct. That's being received correctly. And then we've got the chunks being received like this as chunk. And you can see that on the free plan, it's 15 requests per minute versus the paid of 2,000 requests per minute. So we are paying a little bit here with the speed that we're able to do it at. So let me talk about a limitation here. So I've been waiting for around 10 minutes. We passed in 730 chunks, and you can see it's only done 87 items. So this is a good method if if you can wait for your data, if you're not precious about time. But you can see this extra processing stage where we add context does actually add a lot of time to the ingestion phase, which makes it quite complicated when you want to update the data rather than just load in data at once. So we'll talk a little bit about the options we have here for one, updating the data in our database directly, and two, what are the alternatives to RAG? So we're going to touch on CAG and how to set that up in n8n, because actually with something with less than 200,000 tokens, like it mentioned in the Anthropic guide, it might be better off and cheaper, particularly for large financial documents like this, to actually just use CAG, because they're not going to update very frequently. So all we need to do is load in the full context using CAG. So we'll talk about those limitations after we've touched on the results of this. An alternative here is we could just change the chunk size for demonstration, and that's what I might do in a second, change the chunk size and reload this. We'll limit the amount going in just so we can demonstrate that it actually pulls the correct context and adds context to it. So let's update the chunk size to 1,000, and let's actually have zero overlap, because if we've got context, then we don't really need the overlap necessarily. So we're going to unpin this data, we're going to rerun it, and we're also, just for the demonstration, going to add in a limit node, which will restrict the number of items that we pass through. Let's pass through, say, the first 50 chunks so that we're not waiting too long for a result. And let's pass that in there. So let's see how we get on with that. So this is now run with 50 items with 50 items being loaded in an added context. So we can see on the left-hand side the chunk that was passed in versus what the chunk now looks like. So we've got just this random stuff that was at the start of the document, and the context says beginning of form 10K, specifying document type, period, company information, file number. So we can see immediately that this is adding some useful context that if we were to query it, it would be much easier to find. So it's added that context. We then, if we search for something like table of contents, we'll be able to see, so there's 8 matches for table of contents here. And you can see that immediately the first one that we already picked up has table of contents for Netflix is 2024 form 10K. But also when we move on to the items that weren't in it before, so we've obviously increased the chunk size, so we're going to get more items in here anyway, but part 3 is still split by the chunk size. So we can see that item 12 is repeated twice because of the overlap here, but the rest of the table of contents has been included here. So we've actually got all of the different items from the table of contents. So hopefully now with that context, we'll be able to better retrieve from our vector store. So let's just pin that data so we don't have to rerun it. And you can see in the summarize that this stage, we've just concatenated the text here in one large field so that when we pass it into our vector database to store here, all we're doing is actually splitting it by the split separator, like we mentioned before, with a maximum chunk size of 1,000. So it should work through these, find where to split, like here, and split it into individual chunks, which will go in our database. So let's pin that data, and we will run that, and we will see what that looks like now in our Supabase vector store. And then we can try with the example that failed before and see if the context has improved our retrieval here for larger bits of context where we struggled before. Okay, so it's saying it's added our 50 items to the database. We'll come back in and we can now see that the 50 items are in the database and the table of contents here. And we have another table of contents here. So you can see that now it contains the words table of contents. It's going to be much easier to find this through a semantic search. So let's go up. Let's remove or deactivate our trigger here. And all we need to do, because we use the same table, is actually just refresh the chat here. So it's got no history. We'll make sure it's working. Great. It is working. It's connected to the table. And let's ask, what's the table of contents for this document? And let's just reconnect it back up. There seems to be an issue here. And for some reason, it just wasn't searching it wasn't searching the vector database at all. So I've just made it more explicit in the prompt here that we got to check the connected vector database documents. And the reason I've done that is in the Supabase vector store here, we've called it a documents tool. So I just want to make sure it knows that. So we've actually asked it what documents do you have access to. It's inferred that that's actually the table of contents. So it's pulled out all of the different items now from the table of contents. And let's see if it got them all. So let's go back to our actual document. Let's go to the table of contents up the top. And we've got 16 items here. Let's see item 12, security ownership. Item 12, security ownership. So now you can see that actually adding that context in has made it much easier to pull large sources of documents, where with a conventional RAG database, it would split that and not understand how to access that correctly. So I've come back in here while the camera's been off, and I've just cleaned this up a little bit, just so you know. So we've got the ingestion basic example that we showed first, and then we've got the added context here. So we've labeled up each different stage. We add the context to the chunks. That's the overall. We add the context to chunks, which we know is this second ingestion type. So we've got the file type switch here. We've got where we split recursively into those chunks. We add the context to each chunk and then add to a vector database. So it's just a bit cleaner and easier if we come back to this flow to see exactly what's happening here. So now we've run through a basic example of RAG, and we've seen that actually it can be pretty good if you choose the right embedding model, the right text splitter, which we've also covered as well. We've then seen that it's not great sometimes at returning long lists because it lacks context. So we've talked through how to add context to that, albeit that added a lot of time to our RAG ingestion process because we were having to process every single bit of information. So it would have been 733 items for just an 84-page document. So the ingestion phase, although had better retrieval, was a lot slower, but we were able to achieve better results. But there are still two ways to get around the limitations that we still see in this process. The first limitation is around that we update this static data once in our database, and sometimes we'll have data sources that we need to continuously update. So say we have company documents, company procedures, meeting notes that are edited after the meeting. We want to be able to update those as they come in rather than load them in statically once. So we're going to cover how to do that in Supabase in a second. And then the second area, which we'll move on to CAG for, is actually, this is a very slow way to do it. Can we do this cheaply and easily using cache augmented generation instead, which we'll explain after and show you exactly how to do that inside n8n. So updating data, we're going to move on to a different set of documents. So something like financial documents that are annual reports, you're only going to load in once. So it's not very good for this use case. But something like meeting minutes actually is a really good use case of something that would be possibly updated and we need to update. And we'd also load in multiple documents so we can tackle that use case as well. So in the Scrapes.ai school community, we run 3 weekly tech help sessions a week. And we've got 2 examples here of, can I just remove that? 2 examples here of key takeaways, but also full transcripts from those meetings. So we've loaded those into our Google Drive folder that we're monitoring, and we're just going to remove the Netflix one for now so that we just have these 2 documents. You know they're not PDFs, they're docx, so we'll also tackle how to handle those as an extension on this. But ultimately, the goal of this is to be able to update data directly in our Supabase vector database and show you how to do that. And there's a bit of a workaround in n8n because you can't actually update it very easily directly, and you've got to delete the old rows. So let's copy this workflow down here, and we will make amendments directly to this. For argument's sake, we don't actually need in this example to split into, add context to the chunks. So let's get rid of all of these stages and let's simplify the flow. We'll still have the earlier stages, which are the file type switch, because we've got to add a new one. So let's add a new one in here because we know that we're going to be processing docx. And we're also going to need to handle the case where multiple uploads could happen in a single minute. So we're going to need to add a loop here. And we'll just rename this to updating files, as this is our 3rd use case. And by the way, you can access all of these in the school community directly. If you just want to shortcut, see these directly, you'll be able to download the workflow in the school. But as with this video, you can just follow along and build it for yourself as well. So we've still got the Google Drive trigger, and let's unpin any data we have here. And when you're testing these, just make sure that we deactivate any other triggers here so that we're not accidentally loading in a file from up there. So let's fetch the test event from the same folder, and we've pulled through, and we can see actually this is the MIME type. So we can already set up this switch node here, And let's just test the workflow so that it extracts that and we can see the actual type that's coming through. Interesting. Okay, so if it comes through as a docx, it doesn't actually have the file type endpoint, but it does have the MIME type. So what we're going to need to do is just go back and update where we previously assumed this would be okay. Let's call it docx. This is the docx MIME type, which is just like the file type, right? And we'll go back and update these ones, but we just want to update this so that instead of file type here, it's MIME type. And that's more consistent anyway. So we've gone in and we've updated that. So for CSV, it's application/VND, and you can Google these, by the way, .Google Apps spreadsheet, and then the docx we'd already put in, and application/PDF here. I've also gone and updated it here in our previous node, and we'll connect this third route, the docx route, to here. And we're just going to pick extract from text file there, and we'll call it from docx. And again, it just follows into the data here, exactly the same as we had before. Now, when we're storing and ingesting this information now, because we're uploading multiple documents, what we're going to need to, and we need to update the documents, what we're going to need to do is add some metadata to our documents that are being uploaded. So let's just test that workflow, make sure it runs through correctly and extracts the documents. And again, there's a little bit of a error here. So because last time we used file type and now we're using MIME type, we'll change it to .data, but you can see here it's not extracting correctly. Okay, so a step I've just added, if we go back into the download file, inside here we've got Google file conversion. So it's actually hard to extract data from a Google Doc directly. So we've got this inbuilt property here called Google file conversion. We'll add a conversion and we'll say for Google Docs, let's convert them to text. As an example, we could actually convert them to PDF and send them down that route. But it means in this switch node, we should now say instead of this long complicated document format, the MIME type is text/plain, and we have changed the output to text there. So now it extracts that raw text correctly. And I'm just going to go back up here now that we've changed this to MIME type and change this to .data instead of .text, and that will now work when that's next run. So we've now extracted the meeting data. As you can see, this is one of the weekly tech call meetings. But as I mentioned, we're going to need to update the metadata here so that when we're loading in a document inside our vector database, we can retrieve information relating to a specific document or be able to delete it and update those. So inside our default data loader, inside options, we're going to click metadata here. We're going to add a property and we'll call it ID and we'll call it file ID. And then from the value here from previous nodes, we will just grab the ID. If we close up the switch, it'll be from the download file. There will be an ID in here for this file. That's on the permissions. Here is the Google ID. So it will pull the ID from the file we've downloaded, and that will upload that with the rest of the data that's uploaded. We're going to load in specific data here, and we're just going to call this JSON.data. So now we're loading in this data field with this metadata. And we can also add any other metadata that we want. For example, the created time. And you can see how this might come in handy if you can query the data by this metadata and say any files that are updated after or created after this time, do an action with that. So in this case, let's go back to our n8n database. We're going to delete the data that's currently there in our demo. And now we've got a blank table. And what we're going to do is now load in that data. And we're not going to use a text splitter this time. So we're going to delete that. We're going to use a recursive text splitter like it suggests. And let's just keep this at 1,000. And one additional bit of metadata that actually would be really important for us is the title of the file. So let's call that file name. And we'll pull in the name dynamically there. That's going to be really useful when we're recalling information from specific documents. We're going to keep the small embeddings model because these are very small documents as well. So we don't need to over process it here. And then we're going to do one final thing, which is add a loop node. And that means we can process multiple documents at a time. This one looks a bit crazy, but let's just bring it down here. Let's delete all the attachments, connect the loop here. So this means it will process, if we click in one at a time, go through this process, add it to the vector database, and then we'll connect that back to our loop. So a second item, if it comes in the same minute, will be processed separately. And then we don't need to do anything with the done here, because actually we're not doing any post-processing here. So we're watching that file there. And let's just test one upload to start with. So we'll execute that and it will go through the first document. And we can see from the output that 53 items were uploaded there. So it's split this document into 53 items, cover up the details there. But you see in the metadata, we now have this additional information. So we have the file ID, we have the type, we have the file name, and we have the created time. So if we go back to our build here, and let's go back to our Google Drive, and it's added in the April the 3rd one. So I'm just going to download this document, remove it from this file here, and then re-add it so that it will appear as the latest created file. So that then when we run our second test, hopefully it should pull through that latest file now instead. And there's been a failure here because the document type is different. So we're just going to open that up and then it will automatically become a Google Doc. We'll close that again and we've saved it as a Google Doc instead. So we're going to move that old one to the bin. We're going to run it again and it's now processing. So it's being added to our vector database again. And we'll be able to see our two documents. This one's been split into 58 rows. We'll be able to see our two different documents. If I change this to 500 rows, if I go to the bottom, you'll be able to see in the metadata that this is our other file name. So now we've got multiple files in our vector database. Let's look into how we search that. And then we can talk about how we update it if a file is updated. And we're also going to need to update our AI agent prompt. It's no longer a Netflix financial document assistant. It's just a document assistant using the files in the vector database. Check connected vector database first. Okay, great. So let's try and ask it what files it has access to. And you can see that it's automatically searched the metadata for us. And it knows from the metadata that it's got access to these two files. I'm just going to ask it for a summary of the April 3rd meeting and who attended. Don't include surnames. And then if we lift it up, we've got a summary here, and then it's given us a summary of attendees, which I was at the meeting, so I know exactly right. And it's given a clear summary there. So it's pulling information correctly, and that was from the correct meeting as well. So it's working well. Now, what happens if we go back into the chat here? And we actually remove me from the meeting. So we remove all evidence that I was from the meeting. Now, if we just do this directly in the document, and this is what you might do with your documents, you might update them, then it's not just going to update if we rerun through this process. What it's going to do is it's going to add the same named document as a new document, potentially, if we've got this file created trigger, or if we add a file updated trigger to activate this as well, then as soon as this is updated, what it will do is it will just load through this again. And all this is doing is ingesting files into our Supabase database. So if we did this, it would add the files as more chunks to the bottom of these 111 records, which actually would then be more confusing because when we ask that information, what files do you have access to? It would say twice that it has access to the same document, but they actually contain different contents. So the inbuilt functionality to do this in n8n struggles quite a lot. So we have to use a workaround. And the workaround for that is identifying the file ID, which we know we put in the metadata, and removing all rows from the vector database for that file ID or file name or however you want to do it, but we'll do it with file ID. So to delete the rows, we're going to add a Supabase node, and it's going to be delete a row. And we are going to connect that after the loop here, but before we download the file. So what we're doing is we're going to grab the ID from here, and we're going to match it to our metadata in the Supabase database. So we've got our demo account that we set up earlier. We're matching in the documents, and we're going to hit string here. And all we're going to do is say for our metadata, and this is just SQL terminology here that you don't need to worry about. It's just going to be the same every single time. If our file ID, which we called it in our metadata, is a match to the file ID that's passed in dynamically, which actually in our case is ID, then we're going to delete the existing rows that exist with that file ID. So all we're doing is saying, okay, if that file ID already exists, i.e. it's been updated, but the file already exists, let's remove all of that from our database before we import the new one. So let's just double check this actually works. And what we should see here is it recognizes that the file already exists and it deletes some rows from our database. So to remind you, we have 111 records here. Let's test the workflow. And it said, okay, it recognizes 58 items that have this metadata of file ID. These are the embeddings, the vector embeddings. Let's remove them. We'll go to the database. We'll refresh here. And this should now be 58 smaller. There we go, 53. So it successfully deleted our rows, and we'll just rename that. Which means if we update a document now, if the document already exists, it will delete all rows, but then it will continue as normal, going through the process, loop through the process, and add the new document. So if we were to remove, if we test it again, let's re-upload the workflow, and then let's actually test it in progress. And one setting we need to confirm here is actually if there's no matches to it, let's always output data so that it continues through the loop. So let's test the workflow again. Okay, and now it can't find the file. And the reason is we've not set the file ID here. It's trying to find the file ID from a previous node. So the way we can do this so that it finds the file ID from both the Google Drive file created trigger and the file updated trigger is using a set node here, or an edit fields node. So we're going to add that in, and we're going to connect it in the loop. And we're just going to say at this point to set file ID, and we'll pull it from the previous node, which can be either of the input types. That's why we've left it like that. That will still work because it's getting file ID from edit fields. We'll call this set file ID. And then the download file should now refer to this set file ID instead of json.id. And let's rerun that and see if that now works. So that will upload the document now into our vector database again. And then what we'll do is we'll go and remove some data. So that's now uploading, 58 items uploaded. Let's go back to the file itself. And right now, let's extract the meeting purpose. So if we ask in the chat, what was the meeting purpose? It will go and extract that. And there, the purpose was to hold a weekly tech session for scrapes. I'm going to go in here and update this to the purpose was to challenge everyone to a duel. So naturally, if we ask it again, it will not understand. It will also save this in the memory. So let's refresh that here. And what we're going to do is we are going to load in the document. And if the file has been updated, it's recognized that there is a file that exists with that. It's deleted those rows, and then it's come back and added it back to the database. So the best way to test this out is to actually just open our chat again and ask what the meeting purpose was. And we can see if that pulls back the new meeting purpose, which was the updated data. And it doesn't. So something's gone wrong there. If we check on, we're just going to run this again because it seems to have not updated the metadata correctly. Okay, I understand the issue now. Inside the delete rows, we did not update this to file ID. So now it will correctly understand if the file existed already. And it's saying the file did not exist already. So what I'm just going to do is just, we've had a few errors here. So I'm just going to delete all of these rows out and we're going to start. So let's just refresh the conversation. I've loaded the data back in. And it's still having trouble picking up the metadata. So there must be something wrong with the way we're grabbing metadata from the previous stage. So if we just test and upload, we can go and figure out exactly what's happening here. We can see that all of the metadata is being not found, probably because this is called file ID, but actually instead of taking it from there now, we can take it from our set file ID node. Where is it? Set file ID.item.json.file ID. Here we are. And we'll do the same for here, but change that to created time and this to set file ID.item.json.name. But what that means is we need to go and add created time and name to our actual set file ID and pull those fields through as well. Created time, name, and then like we did before, pull those through as an expression. So we've got created time there, and then we've got name, and that will just pull through from the previous step. So now we've updated all of those. It will understand which one is the 27th. We'll delete all the data again from our Superbase database, make sure everything is gone, and start again. Let's reset this. Let's test the workflow. It should now upload with the metadata. And it was never recognizing there was a file with the same ID because it couldn't actually search for ID because it didn't exist. So this should now have the correct metadata uploaded, file ID, file name. Great. Let's now ask it the same question, and that should come back with the new information, I hope. So let's go back to Superbase, and you can see that the meeting purpose is now to challenge everyone to a duel. If we go back, let's update this to the meeting purpose has changed. We will reload the document in, and it should now recognize that the file already exists. delete those rows and update the new information in that file, i.e. upload the document again as chunks, and we can see that it's now processed the delete stage, and it's now gone through and added that new file. So let's update this. Let's check the meeting purpose. The meeting purpose has changed. Great. So it has deleted it. It's taken the new rows from the file and then updated that accordingly. So we've now got a full RAG. We've learned about how to build out a basic RAG, the limitations of that. We've looked at how to add context to make the RAG perform better. And now we've also talked about how to update files directly in the RAG by deleting them, which solves the limitation of having static data, which you often don't have in your business. We will now move on to the final step of this, which solves the limitation of this taking a long time to do, which is cache augmented generation, or CAG, which is a newer, more popular technique. And I'll show you exactly how to do that in n8n with OpenAI and Claude. If we jump back to our diagram here, RAG is feeding in our data little by little. We've seen that now with the context. CAG, or cache augmented generation, is as it sounds. We add a large document into the cache of the LLM, i.e. it's processed once and stored as a very efficient set of data that's easily discoverable. We store that in a cache, and each time the user asks a question, it just refers to that cache, adds all the context. So it's like putting all of the context back into our prompt, but it's automatically cached for us to use fewer tokens and cost us less. The benefits of CAG is actually is really easy to set up in n8n. Very quick retrieval because we've not got to go through an additional source like a vector database, and it's often more accurate because it has all the context. The issues with it is when we've got documents that are harder to update, but also if we've got documents that are over 500 pages, say, maybe even less, and we're adding documents again and again and again. So say it's like a meeting repository, eventually we're going to overflow that meeting repository with too much context, and we'd be better off storing that in a RAG database where we can extract based on similarity searches versus trying to store all of that data and adding to that every single day inside a CAG flow. But the ingestion and retrieval stages all come together in CAG, so it makes it a lot easier to do. Let me just remind you why CAG came about. So when LLMs were first becoming popular, we had the models like GPT 3.5 Turbo, and you can see that the input token limit and output token limit were approximately 4,000 tokens, which equates to around 3,000 words. So that's not much context at all. That's about 6 pages. So RAG came about RAG became popular because actually the token windows were relatively small. And then the models that had a larger amount of token windows were more expensive. So GPT-4o, for example, had a much larger token window of 128,000 tokens, but actually it was $2.5 per token. So RAG was a way to feed in data little by little so that we'd save that token cost, but also respect the token limits of the smaller models. Fast forward to 2024 or late 2024 when Gemini Flash 2.0 came out, the token limits are now not the same as what they were. We've now got Claude 3.5 Sonnet with 200,000 tokens, and also Gemini Flash 2.0 accepting up to 1 million tokens, which is absolutely astounding when 96,000 words is a long novel. So you can see how 1 million of those is an incredible amount of context we can load in. Not only that, but it started to become cheaper. So Anthropic, Gemini, OpenAI all introduced ways to cache the tokens or cache the data that you put into the prompt. And hence, cache augmented generation was born, because actually we now have the opportunity to store the data in a cache that takes up a low amount of memory, and therefore only the tokens only have to be processed once for a set period of time, which makes it significantly quicker and easier than using something like RAG. And also you have access to all of the context now compared to when the models were initially introduced and you couldn't put this much context in. So let's go back and start building out a CAG agent inside n8n. And it's actually very straightforward. You just need to know how to do it. So there are different types of CAG. The one we're going to discuss today is prompt caching. So OpenAI and Anthropic use a technique called prompt caching, which effectively means it will cache a lot of the data automatically that's added into the prompt. So it actually makes it super straightforward to do in something like n8n, because if we structure the prompts in the right way, it's automatically going to cache for us. So I've just gone to OpenAI's docs around prompt caching here. And it's got a few key things for us to note here. So caching is enabled automatically for prompts that are 1024 tokens or longer. So it's actually quite a small minimum limit at which a point it will be cached. If we hit it with multiple queries, then how it works is it checks, the original prompt is passed in, the context is then cached. When we place another query with the same set prefix at the start of the prompt, it will say, okay, let's look up to see if that matches the data we've cached already. If a match is found, it will therefore use the cache response and feed that context into our prompt. And that will massively speed up the process of doing so. And that will massively speed up the process of retrieving that information, and as well as reduce costs because we only have to pay a small additional fee rather than paying for all of the tokens again if we've included a bulk bit of context at the start. If there's a miss, i.e. the start of the prompt is not the same, then it's not going to detect it's the same. So when we're in n8n, what we'll do is we'll just create this Google Drive trigger again. And I've just re-uploaded the Netflix financial document again, so the 84-page document. Hopefully it's not above the token limit for OpenAI. We'll find out in a minute. And to make it more visible, I'm going to open the OpenAI node directly, and we're going to say message a model. And any return from the OpenAI node will actually tell us how many tokens of that initial response was cached. So we're just going to choose 40 mini. And the important thing here is every single time the prompt has got to be exactly the same. And we'll just give it a generic prompt here. Use the below documents to determine a relevant answer. Do not make information up. We'll pass through the document in here, and then we'll also pass through the user query, which is going to change every single time down here. So here we will actually have the user query. So what we're going to do, we're just going to swap this out for a chat trigger actually. And we've already got a chat trigger in the window. So we'll go and grab that from up here. We'll drag it down because actually what we're doing is downloading a specific file to feed in here as an example. So we'll add in our extract from PDF stage, and that will return the data. And then inside our OpenAI node here, we're going to just dynamically pass in the text that's retrieved from the document, which in this case is the financial document, but also the user query. So we'll pull dynamically the user query.item.json.chat input, I believe. And now if we try to open the chat and run this, we'll update this to a URL. We'll feed in the URL of the Netflix document here. Now let's try and run it just with a hello. It will now download the file, extract the contents, and hopefully feed that in dynamically to OpenAI. And let's just check the information was actually fed in. So we can see that the document's been fed in correctly because it's got all of this 84-page context. Let's scroll right down to the bottom. Chat input was hello. Great. So actually, we can look, and now let's try and ask it a question. So before we were asking about the 2024 revenue streaming numbers. And we'll see the file we downloaded, it will be extracted, it will be fed into OpenAI, and we'll be able to see in the response, one, if it comes back correctly. So you can see that's the exact same number we had earlier. It's added the 000 again by mistake. It must be something in the document that's causing that, but it's actually pulled all the relevant information, and it looks pretty accurate. Let's go into the logs, and if you just make sure that there's no simplify output here, we'll run that again. And if there's no simplify output, we can see exactly how many tokens have been cached. So 60544 out of 60818. So actually only 156 tokens, which is probably the question we asked, have not been cached. So most of that query we've not been charged for. And we've got a little table here to demonstrate the actual cost of reading that back. So like we said, 1024 are the minimum tokens to feed in here. There's no storage cost because it's actually storing it for around 5 to 10 minutes. So this is for very short use cases, but there is an additional read cost, but it's very, very small, 0.00375 per use. And we're getting a 50% discount on the tokens there. You can also use it through a generic AI node through OpenAI. However, you cannot see the logs of how many tokens were cached. So I wanted to just show you exactly how many tokens were cached here. So you can see. But now we could ask multiple questions, and all of that is cached. So super easy to set up. If you want to do it through Anthropic or Claude 3.5 Sonnet, whatever, it's got the same minimum number of tokens, 1024. It's got an initial write cost, and again, a very low but slightly higher read cost per use. But the actual discount you get on a per use basis on the tokens is 90%. So say, for example, we had a cache of 10,000 tokens. We pay for it once to be uploaded and processed into the system. Then every time we read that cache, i.e. it confirms that we are trying to use that cache. We pay a read cost, a single per use read cost of this, of $0.015. But also all of the tokens that are read back, we pay effectively for those tokens again, but 10% of the price. So we get a discount of 90%. So we actually only pay for 1,000 tokens rather than the initial 10,000 in our example that we uploaded. So significantly cheaper. And you can see from our results here that it is much quicker to set up and easier to use than RAG. So the biggest difference with the prompt caching for Anthropic in particular is mainly in how we do it inside n8n. So within n8n's Anthropic node, we cannot actually use the caching function. So we need to connect to the API using a HTTP request. And inside the Anthropic docs, inside prompt caching, they give you a curl command for this request. So all you need to do is take everything inside the D here, take it back to a fresh HTTP node in n8n. We'll use the body type JSON, and then inside the JSON expression, we will paste in this. We can change the model to 3.5 Sonnet, whatever we want to do. But the one thing that's different here than a traditional request to the Claude model is that we've got this cache control type ephemeral, which just means that this text that we insert in here is going to be cached. So actually what we want to do there is pass in the full document. So let's turn this to an expression. It is an expression. So from the extract from file.item.json.text, that is the full text. And we just want to make sure that that is stringified, so it's not going to cause any errors. So we're going to just wrap that in json.stringify inside the brackets there. And that's just going to turn it to text. We'll remove the quotation marks so that we're not doubling up and causing a JSON error there. And then we are also passing in our user message. So instead of analyze the major themes of Pride and Prejudice, let's again pass in from the chat trigger.item.json.chat input. And I believe that should already be wrapped in quotations. If not, we need to wrap it just to make sure it doesn't cause any errors. So that is now wrapped. Inside the rest, we need to make sure it's a post request. We're sending to this URL here. You need to connect your API key through Anthropic, which is a predefined credential type. And you just insert your API key inside here. And then we need to make sure we've got the following headers: Anthropic version 2023-0601 and content type application/JSON. And if we now make sure it's connected to our extract file, make sure all other triggers are turned on. And now we're just going to ask about the revenue for streaming in 2024. And let's give that a run, see if it runs through Anthropic. And that's processing, and it's quite a lot of data, so it might take a little bit of time the first time it processes. But the next question we ask, it should be significantly quicker. And it's come back and it has given you the correct revenue, again with the zero mistake, but it's actually pulled back the correct revenue. If we go into the logs in here, we can see the number of cached input tokens. And the same applies again. Whenever we run a new user query through here, it should return a lot quicker. Give me a breakdown of revenue costs. And we're going to run that. And it should run significantly quicker this time. Okay, so we've actually reached our request limit because we just tried a second ago. So we just need to wait maybe a minute or so and rerun this. And I guess this is the danger also of using something like Anthropic through the prompt caching. You're also rate limited there. So if you've got a huge document like we've got here, 84, it worked through OpenAI quite well. We're being rate limited by Anthropic. It might be better off storing that in an updatable RAG and pulling it in a little bit at a time. But that being said, Claude 3.7 Sonnet has a high number of input tokens, but our plan only allows us to put 20,000 input tokens per minute. So that's where the problem is coming here. Because actually when we read back that data, it still gets input into the prompt. So we're exceeding our 20,000 limit. So back here, we've run this again and it ran fairly quickly. It's now come back with an answer of the different operating costs. So this does actually work. It just, we got rate limited because we'd uploaded such a large context window. So with that being said, let's sum up exactly what we've learned here today and what we've built out. So first, we built out a basic RAG, and we realized that with a basic RAG, we couldn't pull things like table of contents because when we were splitting up the documents into chunks, we often lacked context that meant when we tried to retrieve it, those chunks weren't retrievable with the right semantics. So we then learned how to create contextual RAG through Anthropic's method of adding context to our RAG chunks. And that worked much, much better for accuracy of retrieving things where we had chunks separated over several, or data separated over lots of chunks. However, we learned that actually with a traditional RAG setup, it works well with static data. But if you want to update it, you need to advance that. So what we did was we then went in and created a flow to update our RAG pipeline. So we did that by deleting the rows by deleting all chunks that were relevant to a document that had been updated by tracking it via its ID. We learned about metadata, but then we also learned the limitation of RAG itself is the slow or costly setup, and the fact that when you're retrieving, you have to go through an additional step to retrieve data from the vector database. That's when we introduced CAG, which is more relevant for smaller data sources, definitely, but more recent models that allow a higher token limit. And we learned how to do that in n8n. But we also learned that it was quite costly for large amounts of data. And it's also hard to update because we've got one set of data, and that set of data often expires very quickly. We didn't talk about a workaround for that, which is using Google Gemini, which is slightly more complex. But we then moved on to CAG for Anthropic, and we experienced, again, similar limitations to the OpenAI, very easy to set up, but slightly harder because we can't do it directly through n8n. But that's when we stumbled upon things like rate limits, which meant actually for large data sets, maybe RAG was better after all. Well done if you've made it to this point. You've really ended up building out a lot. We've got our CAG pipelines here, our updating files, our adding context here, and then back to the start where we built out the basic example of a RAG ingestion and retrieval.
Wow. If you've made it this far, congratulations. That is absolutely mega progress. We've covered a lot of the concepts that we cover in the school community around the AI automation masterclass. Everything that's ticked we've done so far. You can see if you want an extended journey, there's a lot more that covers specific deep dives on topics like APIs and HTTP requests, expressions deep dive, and getting confidence with workflows, backups, planning workflows from scratch, more about the architecture of creating good workflows, as well as how to set up clients. Now that we've done the agentic and AI deep dive, let's now talk about how to systematize and sell AI automations, how to package them up, what your goals should be. And this will be all around section or phase 4 of this course. So when you start packaging up and selling AI automations, there are various approaches you can take. And whichever approach you take will depend on the pros and cons of that approach and the fit with your background. So quite often when we talk about an AI automations agency, people have a vision where they are building completely custom workflows for every client. And this is something that I've done with my AI automation agency, is like completely custom workflows for every client. There's very little repeatability between those clients. So the only out of the box, so to speak, work that you can do is some consistent templates that you often use across clients and the knowledge around templating and templating standards. But 70% of the work, therefore, is going to be completely custom for those clients. And on the level of customization per client, this is the most customization. Now we'll talk about the pros and cons in a second of that. The pro of that is that actually it's often, especially as a solo business owner or a solo employee, it's easier to start here. It's easier to find a job, for example, on Upwork that has a specific problem that needs solving and build a custom request. It's much easier for people to get a custom request built for them. It also can command a higher price point because all of the work is completely custom. It can actually mean that you drive your prices up significantly higher because it's completely custom. But on the backside of that, it can potentially have much lower margins, like maybe 50% margins, because actually you're going to need more labor. So it's hard to scale this without scaling the number of your workforce or the number of hours that you're working. So that is building custom workflows. The lower end of customization per client is actually turning that into what we deem a systematized offering. So in an ideal world, in this state, if you're selling it and packaging it in this way, you've actually worked potentially with enough clients. You've worked potentially with enough clients that you've understood there are some core use cases that would potentially be useful across a certain industry or across all industries that can be used again and again. This might be an example of an SEO system that lots of different businesses would use, or a HR or recruiting system. So key functions that lots of businesses would use. You take the core functionality of that, package that up into the 80% out of the box, and then do a little bit or 20%, 20 to 30%, depending, of customization work for those businesses that you sell to. Now, the benefit here is you can command better margins than the custom workflows because actually a lot of it is repeatable, but you still need to do some of that work in the 20% customization. The harder part here is actually finding use cases that are fit for purpose. So how many business use use cases can you think of that actually could be packaged into that system and actually sold to multiple businesses? This almost assumes, if you're building a systematized offering, that you know of a given problem that can be solved in this way, or you've been inside of a business that has a specific problem. It's going to be much harder to start from scratch and work out immediately what is that systematized offering. In the same way, 100% out of the box or software as a service, that is effectively scalable, unlimited scalability, because you don't need to customize anything. You may have a product roadmap where you improve the product, but actually there's zero customization here for your AI automations that you're selling. And you could have those running on the back end via n8n. But again, you need to have some deeper knowledge, which you might get from working with custom workflows, then jumping to systematized offering, and then to SaaS, where actually, if you have a very clear use case, and with SaaS, it has to be a very clear use case that you want to pursue with that business, and you target that specifically. But what changes when you're building a SaaS versus this custom workflows is you're no longer advertising to the same kind of people. And actually, the customer acquisition channels are entirely different for SaaS. So if your strong suit or your background is actually in targeting individual consumers via Google ads, etc., then you might be well positioned to grow a SaaS. But if you are heavily B2B focused, then actually you might be better off at least starting building custom workflows. So you need to work out as an AI automator where you want to sit in terms of building workflows. You might even not want to sell these. You might want to build these for your own system and your own business. But if you want to package them up and sell them, there's various ways in which you can do that. You just need to reflect on the cons of each method. And actually, Alex Hormozy has a really good framework for understanding where you should start with this, which is which problem would you rather have? So if you are thinking about starting a SaaS immediately, do you have the skills and the use case to acquire customers for that SaaS? Do you know specifically about that problem? And do you have an edge that other people don't have? Maybe you have some industry knowledge or experience that other people don't have in that. If you do, then maybe SaaS is a good place to start. Or are you better at building high margin businesses where you need to scale labor? In which case, building a custom workflow or building an AI automation agency in its core may be best for you. Or maybe you want to start building custom workflows and then work your way down to find specific use cases across clients that you serve and cross-sell to those clients, the systems that you've built for other clients, where you can actually start systematizing that workflow. So at this point, you need to understand what your goals are in terms of building out and selling or systematizing and selling AI automations. But in this section or phase 4, we're actually going to focus around systematizing certain things and finding clients for potential systems, and also how to build out a complete SaaS marketplace using n8n as the background, just as a demo video of how you might work towards this. Because actually in the previous parts of the course, we've done a lot of this building custom workflows. And actually, I think the most value here can be gained in talking about how to systematize something or package up a given workflow and potentially find clients for that, and then how to build out a software as a service, and show you some examples of other SaaS providers that are using AI automations in their background as well. But right now, we're going to jump onto pricing, because it's so critical that you learn from the mistakes that I've made in underpricing myself.
The true cost of underpricing your automation services can be broken down into 4 different themes. Firstly, premium pricing commands respect. So when you buy something that's expensive or you perceive to be valuable or expensive, so when you buy something that you perceive to be expensive, you're making a decision there based on the value it's going to generate for you. So when somebody's services are priced highly, you perceive that as valuable, and therefore you expect a lot from it. When you're buying something that's very cheap or even free, which we'll cover in a second, you often forget about. So pricing yourself as at a premium commands respect from your clients, and it shows you're going to deliver. The price also affects client expectations. So if I am paying $5 an hour for a freelancer on Upwork, I expect to supervise that person a lot because they're very cheap, versus if I'm paying somebody $80 an hour on Upwork, I'm going to expect them to drive the work forwards without my supervision or with less work from my side. So pricing yourself much lower actually takes away a lot of the freedoms that you potentially want by becoming a freelancer or an agency owner in the first place. One of the things that I got stuck with was low rates becoming a price anchor for me. When you start low, other people can see that feedback on your profile. Yes, you might get a good testimonial, but your rates have always been lower. So people are more reluctant to pay you higher rates for the same work. But it also puts you in a position, if you don't time box your specific project, to actually then have to negotiate yourself up in price, which is a much harder position to be in than to start off and get a client at a higher rate. And then finally, free work gets forgotten. So how many free trials,
free guides, free resources have you signed up to that you've never touched again? And that's because we perceive it as not valuable. When something is free or given to us, we don't put the same value on it. If we're associating something with pain, like paying a high price tag, then we're making sure we're getting the most from that. So in the same respect, if you charge a significantly lower price, you're not going to command the same respect. Now, the clients at those low price points can often be your worst clients. They expect over delivery. But when you're priced at something like 5, 10, 15, even $20 an hour in some areas, people will expect you to deliver a significantly higher value than that amount. And let's jump onto Upwork and I'll show you exactly what I mean. If I'm on my freelancer profile here, I'll just type in something like n8n automation. And if we go to the less than $100, you'll see that lots of these are over-spec'd and undervalued. So n8n expert teacher and console. Hi, I need an n8n expert console and teacher that can talk about my current flows, but also help expand them. I'm willing to pay $25. So you want somebody to teach you what's going to bring you a hell of a lot of value, and you're going to pay me $25 to do so. So underprice and over deliver. That's what they're expecting here. And I'm just going to give some hard truths to some of these projects here. So bear with me. n8n automation specialist needed. Budget $20. We're looking for an experienced automation specialist to help us set up and optimize workflows in n8n. The ideal candidate will have a strong understanding of n8n's features and capabilities, enabling them to create efficient and automated processes tailored to our needs. So they want customized workflows. They're willing to pay $20 and they want intermediate level experience with n8n. You will be responsible. So you will be solely responsible for implementing and troubleshooting all our automation tasks to ensure our operations run smoothly. Clearly, their operations are only worth $20 to them. And the worst of all, this is a US-based client. So $20 is peanuts to them. We'll give one more example of hourly rates. If we put maybe $10 an hour as the max here, you get a good indication that lots of people are requesting these low value projects. Make.com developer with AI prompting experience, $10 to $25 an hour. AI automation expert needed. So one of the most valuable skills needed, $8 to $30 an hour. Now, if you're able to get the upper range, then this starts to become acceptable. But if you're applying at this lower range, it's a bit of a warning here for the client, despite their good reviews, that actually they're going to expect a lot from you for a low price point. And they're going to become your problem clients that you're going to want to get rid of later down the line. It's kind of crazy. You have a strong understanding of n8n AI applications in content creation and the ability to integrate various APIs. So previously, that would have been a software engineer role. You would never pay $8 to $30 an hour for a software engineer. In particular, the lower range under $20 an hour, never. And what that leads to is potentially worse feedback because they're expecting a lot and you're not getting paid a lot either. There's a very simple method to work out what your floor rate would be. And floor rate here is effectively the rate that you shouldn't go below to hit your consistent income goals. So as part of the agency launchpad in my school community linked in the description, we run through all of these steps with you to work out exactly what your income goals would be, what your non-negotiables should be, what you should charge specifically for clients. But at a basic level, your floor rate is the level that you should not go below. And you can work it out by saying, what's my monthly income goal? Let's add 30% to adjust for platform fees, for exchange rates, for Upwork fees and taxes. And that will obviously vary per where you are. And then divide that by the billable hours per month. And that gives you your floor rate calculation. So say for example, your floor rate is $3,000 per month, plus 30% would be $3,900. Divide by, let's say, 80 billable hours a month. So you only want to work 20 hours a week on this. Then that would give you something in the region of $40 to $50 per hour, which would be your floor rate. Now it leaves you with the question still, if your floor rate's very high, what should your rate actually be when you're going on a platform like Upwork? And you need to answer that question by doing some research. So there's two ways in which we can do this very quickly. The first is research our competitors. And the second is analyzing job posting budgets. So let's go back to n8n. And the first one we can do by literally getting rid of the filters here.
searching a generic term like n8n automation and going through, and let's do an hourly rate. And let's just assess what are within the first few pages, whether there's enough jobs hiring within our budget range. So we've got $10 to $25, we've got 8 to 30, and some of them don't show exactly what they're paying. But if we keep going through, we will see 30 to 60. So we're in that range. 10 to 40, 15 to 45. So we're on the upper range of this. $20 to $50, $20 to $30. And you can see if you go through the first 3 or 4 pages, $40, that probably hits ours. You'll be able to scroll down and work out how many of these job posts under terms that you would search actually fit your floor rate inside them, and therefore can work out whether that's reasonable. Now, the second way you can do this is to actually create a client account, which is free on Upwork, and you can effectively assess your competition. So if we go to hire talent and we search for talent, we can type in the same term, n8n automation, but also we can search by our location. So for me, this would be the United Kingdom. If I tick the UK there, I can go down and I can see the top rated freelancers doing similar things to me in the same country as me, because countries are treated differently in this respect. The US will command a higher rate than Asian countries in general. $40 up here, $42, $50 an hour, 30, 40, 60, 30, 40. So you get the idea that actually there's a wide range here, that my floor rate of $40 to $50 would actually fit quite well within the location I'm based, and therefore it would be realistic. Now, there are a few special circumstances in which you'd want to implement strategic discounting, as we've called it here. The first is if you have zero experience, you've not ever built an automation. By the way, I would not recommend applying to these roles before you've got something in your portfolio, something which we cover in the complete agency launchpad on how to get your first client. But if you manage to get a client just on board so that you can add something to your portfolio, then that might be worth doing a strategic discount to your floor rate. But I'd never go below 50% of your floor rate as a general rule of thumb. You need to make sure these have clear time limits. So if we go to my example, we scroll down my profile to the job where I was paid $10. This was a specific small project, n8n HubSpot trigger setup, that I knew, one, I could add to my profile, and two, it had a clear time limit. I knew it was one specific fix. Even though it took me a long time because I was a complete beginner, I set a clear time limit to that so that I wouldn't agree to this fixed price project and continue to work forever on it, or get stuck at a really low hourly rate below my floor rate. The last reason you might want to do this, which was my reason for doing this, was social proof or testimonials are the most powerful thing at selling your profile in your proposals to other people. So being able to work up to 100% job success, or a top rated badge, or even just getting 5-star reviews on your profile is absolutely critical to start building out a portfolio of clients. So in my personal opinion, it's actually okay to go below your floor rate for a one-off to get your first 5-star rating and help you propel up to higher rates. So you can see how quickly I moved up the rates to jobs that are like $125 an hour compared to when I lost $8 on my first job. So remember, when you're trying to land clients at fair rates using Upwork, quality proposals at a higher floor rate are significantly more effective than 30 lowball offers where you're going to get stuck negotiating up or wanting to leave that client. If you're not enjoying it because you're being paid too little, then you're not going to over deliver for that client, and that's going to negatively affect the social proof or testimonials you'll get as well. And something we touch on a lot in the agency launchpad is value focused cover letters. We need to talk about how to value the client's project and therefore charge them appropriately for that value you're delivering.
So now that you understand the true cost of actually underpricing your services or your systems, we're going to talk through, firstly, how to systematize and take some pre-built automations that you've built and actually find clients for those. I will share with you 3 proven AI automations that you can sell to any business. And these are solutions that will give them real results fast. It doesn't matter what field they're in. What we'll do today is we'll show you exactly what they are, show you how you can get them or build them yourselves, and also show you how you can sell them and find clients for them. So let's start with number 1. So the first is around content creation. So content creation is needed by absolutely every business. And this is the one that's actually made me most money in my time working with clients. People want to generate blog content, for example. They want research content. They want long form document generation. They want to repurpose content they've already got in blogs to social media posts. You name it. Content creation is the core crux of what people understand AI to be good at. And therefore, it's one of the things that is most demanded by clients, or at least in my experience of what I've seen. So when you distill it to a few key steps, this automation is actually very simple, or can be very simple. So if you wanted to build out a content creation system for a business, you would need some sort of topic input and planning. So let's pretend here like we are building out a blog post creation system in order to improve the SEO ranking of, let's say, an e-commerce website. So in the first stage, we're literally just giving the client or the user a way to input different topics that they think would rank highly, and almost like a topic plan that we can plan out which topics to talk about. And this could be also automated. We could be pulling from SEO content databases. But for now, let's just say that the user or the client has some topics in mind that they know that they target. They have a bunch of keywords they want to target, and we can use that to pull together a topic cluster or a plan of content to talk about or to write about. The second stage then is just AI content generation. So we take an input topic, and we'd probably use an LLM chain for this in n8n. And I'll show you an example in a minute. And all we'd be doing in this stage is actually generating the content. So a problem that I often see with this, is particularly with older models, is that if you want to write over X number of words, say you want to write over 2,000 word blog posts, then it often makes sense to have 2 stages of AI content generation. One is an outline of the structure of the content that's coming out the end of it. So say the paragraph headings or the headings we want to cover. And then the second fills in the details. So we almost have a content outline plan, which is an LLM chain that feeds into a second LLM chain. Or if you're using a more expensive model that has more comprehensive outputs like O1, then it might be able to do this just in one stage as well. The next 2 stages are just formatting output. So we take our content that's been generated by the LLM chain, and all we're trying to do at this point is get it into the right format so that it looks really nice on whatever platform we are delivering it to. So if this is WordPress, for example, we would look up the standards for WordPress and optimize based around WordPress. Or it could be Twitter, where we have certain constraints on characters, emoji use, etc. It's the same as LinkedIn. If we want to format it, we need to look up the standards for that platform. And then finally, it's distilled to distribution and scheduling. So we need some sort of way to plan in advance this content, especially if we're doing it in bulk, or if it's just activated on a day-to-day basis. And we'd use n8n to connect the right nodes for that as well. And whilst we're on it, there are a few different ways that you can create this system, or as I've put it, quick ways to bash these together, going from harder to easier. So you can absolutely make these workflows yourself. And I'll show you an example of one I've sold in a minute. Another great way to do this, really simple, is to go to the n8n template library. So say in this example, we are creating a blog post creation. We just go to n8n.io to workflows, and you can see there's 1,937 workflow templates that we can just leverage here. So let's go to blog creation, for example, and we've got 4 that appear here. And I'm sure if we go blog, it will return significantly more. There we go, 17 different ones. The first example is something exactly like we would sell to a client. And we can just buy Lucas's template here, which he says is an AI blog publisher, probably exactly what we're looking for here. So it automates SEO blog content creation with GPT-4, Perplexity AI, and WordPress. So if I click into that, I'm able to see the template. I'm able to zoom into the template and see exactly what it does. So here it uses some sort of tools agent, can pull from our client's brand brief, as well as the history of previous articles, and can create that content. We then add some Perplexity research, so it's probably making it more topical or fact-based. We then have one LLM chain for the content writer here, and it's the formatting stage then that we spoke about before finally we actually then distribute it onto the platform, which in this case is WordPress. So you can take a template like this, purchase it, or there's a lot of free ones as well, and adapt it, and then start selling that straight away. That is quicker than making it yourself, and you can also make it customized much more quickly. It's also then got some other stuff down here, creating a summary, because I think with WordPress in particular, you have an excerpt or a summary, but effectively it's just getting it into the right format. So it's that formatting and distribution stage. Then if we come back to this chart here, again, even easier, there's some client use cases where actually you might be able to just use an Apify scraper or a rapid API connection. So in the second example we're going to discuss in a minute, this would be a really good way to actually just quickly create a very simple automation that generates a lot of value for your clients. Say we're looking for an e-commerce scraper, we just go to something like apify.com, which offers pre-built actors, which are very easy to integrate with n8n. And we just type in Amazon product scraper, and you can see there's actually 45 that we can leverage here, but we probably want to use one that's highly rated, 8.6K monthly users with a 4.5 star rating. This one seems
seems pretty good. And you can see that actually it shows us the output. It's a sample output from the Amazon product scraper. And we would just use this, for example, if somebody wanted to scrape Amazon. And this would probably be a workflow of a few nodes, and we'd be able to deliver a lot of value for very cheap using something like n8n. Now, if we go back, the easiest way would actually be to join a community where they have templates like this. So for example, I run scrapes.ai, and inside the classroom, we have down here a business template library. And these are all plug and play templates that you can implement on your clients and will shortcut you hours if you're trying to build out this kind of thing from scratch. And there's 30 plus templates here that you can leverage. So in this example, we might go to create content for LinkedIn. And what we would do is we would download the template here and we'd open it up in n8n as a new workflow. And this is literally at the point where we could go and try and find clients for this exact use case or one close to it and be able to sell immediately. And it's a use case that's very, very common across multiple industries and therefore easy to sell to a lot of clients. So this template example, we take a topic cluster from a CSV file. We then scrape posts from LinkedIn. Again, we're using a third-party API like something like Apify. We use AI or an LLM to rewrite certain posts that fit our brand. So we can take successful posts from other content creators and repurpose them for our brand. We generate an image and add that. And then we even send it to approval. So you can send it to your client for approval. And then the approved posts finally get posted to LinkedIn. So if you're looking for the biggest shortcut, you can join a community like this or any of the other communities out there and actually grab these templates, which are ready to go and enable you to sell these automations very quickly from day one of starting your automation journey. So that summarizes the 4 ways you can quickly bash these together from harder to easier. You can obviously make them yourselves as well. So content creation is a huge one. And like I said, I've generated the most money from that $40,000 from purely content creation use cases. And I've leveraged a lot of those templates from the template library there. Now, number 2 is about lead generation. So every business that sells to other businesses or other consumers will need lead generation services that are probably already using some sort of lead generation tool. But often these tools are really expensive and companies are always seeking out more leads, better leads. And what we're able to do with our AI automations here is augment that process to make it really simple and cheap for them. But we can also price this then based on the value that we deliver. So this is a really lucrative way to sell an AI automation to business. Because if you imagine a lead to them is worth, let's say $20 per lead, then how much would they be willing to pay for that lead? Let's say pessimistically, they'd be willing to pay $2 to $3 per lead. And that still gives them a lot of gross margin on those leads. But for us as well, if we generate for them 10,000 leads, that's a lot of money that we can generate for them if we're doing value-based pricing. So to set up a lead generation workflow, I've again split it down into some simplified steps here, but we need some sort of data source. And that could be using something like Apollo.io, which is a tool to basically find engaged leads and also find all the contact details. We then need some sort of way to scrape that information, but also verify that that information is correct. So we could use an Apollo actor, again, like we mentioned in something like Apify. So if we go to search here, an Apify actor, you can scrape up to 50,000 leads per search URL from Apollo here. And all you pay is $1.20 per 1,000 leads. So this is an extremely cheap way to generate leads. And you can do this on behalf of a client or multiple clients, generate them relevant leads that they'd then be able to sell to as well. The important step here is contact verification. So there are lead verification tools, lots of different lead verification tools, which validate the emails that you have received and make sure that before you start or your clients start contacting these leads, they're actually valid leads for their business. At that point, if you've generated all those leads for them, you could move on in the workflow to generate even more value for them, which is actually automating the cold outreach to those leads, whether that be through LinkedIn, through cold email, etc. You can set that up through these AI automation services very, very quickly, like n8n. And that leads on to automated outreach ultimately. So if we go to the community, we've got exactly this workflow in the sales section, which helps us scrape leads from our business, which helps scrape leads for a given business. And we can filter that on exactly what their target customer is. And it also follows up by sending personalized connection requests on LinkedIn. So as an example here, let's download the template again. And if I remove this previous template, I can import from file. I'll import the LinkedIn outreach one. And you can see there's 3 different lead generation templates here. First, we get the leads using an Apify actor. We then store those leads in a database and Airtable. We then are able to connect with the leads. So we set up something like browser flow to enable us to literally log into the client's LinkedIn and connect to leads automatically with a personalized message that's tailored to their business. You can see how much value this could generate for a business that spends a lot of money on agencies that generate leads for them. And then finally, if we wanted another way to generate leads, we can pull post reaction from any community posts they posted on LinkedIn. And we can do the same process of connecting to those people with more targeted warm outreach there as well. But again, it's not limited to community templates. You can build this from scratch, or you could come to n8n/workflows and you see there's lots of different lead generation workflows that you can pull for free and adapt to yours or your clients' use cases. And we'll talk about how to sell these to clients in a minute. And then finally, the third one that every business will be interested in and is either doing this themselves already or would be interested in is competitor analysis. So what business do you know that doesn't have some key competitors that they want to monitor? So say we're an e-commerce business and we have all of our local competitors. We could target those sites every single day or every week or however frequently we want. We could work out what has changed in terms of content or pricing or marketing, or we could monitor their ads even and actually do an analysis that's summarized for us and saves our marketing team hours of manual work. You can see how valuable, again, this would be for certain types of businesses. And then we'd set up something like an alert and reporting system. So we've got something like this inside the community where we research competition. Now, this is a very high level one, but it takes a competitor name and we'll search their website for their latest findings every single day. And it will talk about market position, product portfolio, pricing, the adverts on their site, and it will be able to feed digestible insights back to the team. Again, this is something that you might need specific scrapers for. So if you go to something like Apify and say we want to scrape e-commerce stores like Shopify stores, we might type in something like e-commerce or Shopify, and there's a ton of different scrapers that plug and play out the box that we can set up very quickly in order to generate value for our clients. So from day one, you don't have to niche down. We've got 3 clear examples of content creation, lead generation flows, and competitor analysis flows that are very simple to implement, but also very valuable to businesses and not just specific industry, valuable across industries. So this is a great place to start. So let's talk a little bit about how you would actually find clients to sell. So it's all good and well saying these are the workflows, this is where you get them. But if you can't sell them, then what's the point? So yeah, there's no point doing this all if you're not going to be able to actually make money from them. And the idea here is there's 3 automations that you can actually sell to a lot of different businesses. So we've got a rough selling process here. So I'm actually going to change this around a bit because we wouldn't create a demo first. What we do is we'd look for market demand, because ultimately you might not sell, like the reality is you might not sell the exact template that you're looking for there to a client, but what you're trying to sell is something very close to it. So if a client that you find on Upwork or through other distribution channels is looking for something very similar, you can repurpose one of these templates, like the lead generation flow, the competitor research, or a content creation system. And you can have a lot of different templates that you just find clients that are looking for something similar to the templates you've got, make a custom adaptation for that client and sell based on the value it generates for them. So my first recommendation would be to actually go and search for clients on Upwork for these kind of tools or whatever templates you're using. It doesn't have to be these 3 automations. It could be ones that you've found on the n8n templates library that you think would be valuable for businesses. And you go to up and you can see that if we, for example, have scrape competitor or scrape e-commerce and we sort by newest, you'll see lots of different things down here. So if we put a minimum hourly rate of $30 an hour on this or search for project-based stuff, we can see that there's a lot of different adverts, for example, for specific scraper tools, developer needed for scalable email lookup tool. So maybe this is a little bit more complex, but we'd have to click into the advert and actually have a read and see if it fits our criteria of the template that we've got. But if you're monitoring these search terms on a daily basis, which you can automate, and we've got a template for, then it's actually very easy to spot opportunities that are associated with your templates. LoopNet listing scraping expert needed, lightweight web scraper, basic web scraper development. So all of these opportunities could be potential for our scraper and competitor scraping. Home Depot product data, so that's something we could get from Apify. Web crawling and scraping expert. Then if we search something like lead generation, this will probably generate a lot more. So if get rid of the filter there, sort by newest, apart from the featured one, which was 2 weeks ago, you can see there's lots of different postings here that are listed under lead generation. Let's go automated or B2B lead generation, sales and cold outreach specialist, lead list builder for new marketing company, lead generation, company has spent 30K in the past. So this could be a good opportunity here. B2B outbound lead generation specialist, lead generation with Clay AI, which is another AI tool, scraping emails and phones online. So that could be using the Apollo Apify scraper. You can see how there's a lot of different job opportunities here. And all we've looked at is around 15 different job opportunities. HubSpot, an automation expert for B2B lead generation. So if we jumped on these opportunities quickly, we could repurpose a template really easily. You might also not be bothered in hourly price projects and actually just be looking at fixed price projects. So sales and lead generation expert for European market, $1,000. Email list builder for Bitcoin Vegas event. LinkedIn lead generation specialist for real estate sales team. So all of these things you could use an external API or something like Apify, which has pre-built actors alongside our templates here. Very easy to repurpose these. So you can see there's a lot of those. And then if we go something like content automation, creative automation architect for experiential marketing, n8n expert, engaging scriptwriter for YouTube automation videos to join the YouTube automation team. And all of these jobs you could go into and work out how your template applies. And from that, we'd be able to create a custom demo for the client. So we are seeking an experienced n8n developer to build a powerful content funnel and automation system that streamlines both lead generation and customer engagement. So exactly what we just spoke about, lead generation, but also then you'd adapt your template for customer engagement. And once you've built this once, you can then repurpose that. You'd have a customer engagement piece that you can use for other clients. Design and implement n8n workflows to automate pulling videos from HeyGen and Google Drive. Perfect. So coincidentally, we've got a template in here. So this is exactly what I mean by repurposing template that takes personalized videos from HeyGen and uses 11 Labs. So we'd be able to take that template and adapt it. Build a dynamic content funnel that optimizes content distribution and follow-up campaigns. Set up rules to control which posts go to which platform. So multiple platforms. And once you set up the template for one platform, you've got it forever to reuse. I mean, there's no way somebody do this for $100. This is significantly more work than $100 worth. And you can see that with the low number of applications. And I'm sure all 5 to 10 of those people have come in significantly higher than $100 here. So you'd first find the clients on Upwork and work out which template that you could use to demo this. You'd then create that demo. So this might be an example of showing them exactly what you have already. So you wouldn't pre-build it for them. You'd get on Loom, film a quick 1 to 2 minute video, and you'd create a demo that focuses on business outcomes. So for example, for this n8n automation expert content funnel plus social scheduling, you'd grab the HeyGen template, and you'd also grab a template where you've scheduled posts to YouTube or Instagram. And what you do is you'd show on screen you running through the approach to their problem. Hey guys, I'm an experienced developer working with n8n. I've actually used some of the tools that you referenced in your application before. This template where I created personalized clone videos for a client using HeyGen, as well as this other client where I actually scheduled all their content and posted it to Twitter and LinkedIn. So I've already built the constraints out for that. And I'd take your requirements and we'd use these two flows to create your powerful content funnel and automation system that you're looking for. I'm confident that I can get this done for you, and I can actually start today. So if you've got any questions, shoot them over, and I look forward to hearing back from you. So something very, very simple where you're able to adapt a template that you've currently got, respond to a job really quickly, and make it personalized. It's going to help you sell this. And I'd always recommend starting on something like Upwork because it removes a lot of the barriers that you face when trying to sell through other channels. It's already got demand and people have a set budget for certain tasks. You'd also take a different route here and try and sell based on value. So if, for example, you already had the templates pre-built, you're actually selling to this client that you can build this really quickly because you've got a lot of the infrastructure already built, and that demands a premium. If you can deliver fast and high quality, that demands a premium as well. But the importance here that so many people slip up at this stage is to focus on business outcomes, not the technical solution. So an example of this, just focusing on the technical solution would be, hey, I built this video automation solution that pulls 100 videos from HeyGen. But actually to a client, that doesn't mean a lot. What they're potentially looking for is speed from the video creation all the way through to actually being able to use this content, and also the speed of you being able to deliver this. So if you say, I can actually deliver this in 3 days because I've already built 80% of the solution that I'll adapt and customize to your use cases, that's actually a really powerful way to sell this to a client because they're paying for speed. You can also demonstrate some of the videos that have come out of your HeyGen template. Rather than focusing on the fact you've built with HeyGen or this particular software, you can focus on the high quality content that comes out the end of it. So you're focusing just on that business outcome to effectively appeal to the value that the customer is going to get from this. Once you've built for those clients, you'll be able, and over-delivered using these methods, you'll be able to get testimonials, which ultimately is going to drive you more and more business and make this easier to sell to future clients. But you'll also be building up a template library as you go through this, and that will enable you to scale with those templates. Now, this was just a very high-level overview of 3 automations that you could sell to different businesses. But if you're looking for a community to join that has that pre-built template library that you can master already, it has the pathways to understand how to master AI automation without all the complexity of watching various YouTube videos, as well as an agency launchpad where we teach you how to sell to clients, including if you've got 0 reviews and 0 experience, then definitely consider checking out the link in the description. So hopefully that gives you a really good idea of how you can package up and potentially sell AI automations. Like we said in the beginning when we were setting goals, it's all about understanding use cases that businesses actually would pay for. And you can do that by doing a search on Upwork or finding clients through other outreach methods, a lot of which we teach inside the community. So now we're going to move on to actually a much larger project in how do you build out a complete AI marketplace SaaS from scratch using Lovable and n8n. So let's run through that now. And by the end of this, you'll be able to turn your idea into a full AI SaaS that you can monetize and sell to others. And by the end of it, you might just have built a fully working MVP version of your business idea 20 times faster than you could before at a very low cost. We'll show you some examples of what people are already building using this exact technology and how they're monetizing it to thousands of users. We'll give a simple overview of how the whole thing works, interacts with each other and each tool. And we'll give a step-by-step guide on how you can turn your ideas into a full app that you can monetize. So we're talking payments, data, website, backend, the whole lot you'll be able to build by the end of this. But a quick disclaimer, as you guys know, I try my best to give you all the information that you need to know without the hype, just practical solutions. So would you be able to build $1 million SaaS using this? Probably not. But that's why I recommend watching this video until the end so you can see what is possible and what's not possible and exactly how to capitalize on this opportunity, especially if you're like me and you don't have an insane stack of technical skills. So let's jump straight in with some examples of what you could build by the end of this. So we've got Agent AI first. It calls itself a professional network for AI agents, but it's a web app where users can add their own AI agents. You click into them. So for example, this company research agent, and you can pay to use that AI agent. So on the back end, that would just be an n8n automation, for example. And on the front end, the user is able to click through and put in some inputs and receive an output from our agent there. This website alone supposedly has above 500,000 users. And you can see this agent alone has above 25,000 tasks completed for that specifically. We've then got websites like Relevance AI, which is a very similar concept. Build teams of AI agents that deliver human quality work. So if we go to the agents here, we've got all sorts of different agents. For example, CRM enrichment where if you sign up, you can effectively input a prompt, input some inputs, link it to your data, and run that exactly in the same way. We've then got more specific marketplaces that are suited towards, for example, voice agents. So we've got retailerai.com. Supercharge your call operations with voice AI. So again, it's a similar product where they've got various specific voice agents that you can use, like receptionists, appointment setters, lead qualification. That's all on the front end. And on the back end, they're just running an automation that takes our inputs and gives back to the front end our outputs. We're going to build something exactly like this with 2 clear examples so that you can go away and build an AI SaaS marketplace for yourself or for other businesses. So let's look at how we're going to implement that. And this is all with 0 coding. So we'll run through step by step exactly what we need to do. But first, let's look at how the web app's going to interact with the different components and what those components are. So we've got a front end here. So the front end is just what the website looks like and the user sees on the front end. So if we go back to Agent AI as an example, this is the front end website for Agent AI. And every time we go into a specific agent, we've got another page in this URL that's part of our front end. So we're going to build out our front end with Lovable. And Lovable is your superhuman full stack engineer. So let's have a look at lovable.dev. And it's all about creating an app from an idea in as little time as possible with 0 code. So Lovable, we can prompt, like we do with an LLM or ChatGPT, to create a full stack web app for us where we can connect to all of our integrations in the back end. And we can start for free with Lovable. And then when we hit the capacity limits, we can upgrade to $20 a month. So for replacing a full stack development team, $20 a month, $50 a month is very, very cheap, and it performs very well, as you'll see. So we're going to have Lovable on the front end, and every page we click through on our website is going to be built by Lovable, but it's also going to set up those integrations with what we need on our back end to actually make this happen. So we've got the front end in Lovable. Now let's look at the back end. So 3 core features will make up our back end, and this will depend on what you want to build. For a full AI SaaS marketplace, we're going to need 3 things. We're going to need the AI automations running in the back end. And for this, we're going to use n8n. We're going to need a database that stores all of our user data so that users can log in and we can track their usage of the different tools and therefore charge them for it and make sure they're not exceeding their limits or credits. And finally, we're going to need some way for them to pay. So we're going to integrate Stripe with that. And all of those are going to interact together. So when a user clicks a button on the front end to log in, it's going to either force them to register through a sign-up route, which will put their name and their details in our database, in Superbase, or if they're already logged in and they're taking an action with a specific automation, then we want the database to update as that action happens. And similarly, when they first sign up for the first time, they're going to need to pay, and that's going to be through a Stripe link, but it's also going to be registered in our database, which is the middle linking to everything. And then finally, we need the automations to actually run. So we're going to use n8n for that. So let's have a quick look at each of these now before we delve into the specific automations. So we've got n8n.io here, which is an AI workflow automation software for technical teams. It effectively allows us to plug and play, drag and drop, and connect to all of these different softwares that we use, like Slack, Google Mail, our database, thousands of different software, but also connect to AI agents as well. If you're not familiar with n8n, then I'll link to my full 4-hour course, which covers everything you need to start building in n8n and everything I learned over 8 months of building over 100 automations in n8n. So that's where we're going to have our automations. Now, Superbase is effectively a database. So when you're using something like Airtable, that's also considered a backend database, but Superbase is much more scalable for web apps. So you can see here, build in a weekend, scale to millions. This is where we'll store all of our user data, including which users we've got signed up, but also their usage on different tools. And you can see as well here, Superbase is fantastic because you can get started for free. And then finally, let's have a quick look at Stripe. Stripe allows us to create quick, easy payment links and connect into different softwares. So Stripe is really good for things like international payments. So we'll use Stripe for everything payments related. Let's take a quick look at the automations. And I just wanted to quickly touch on how these are going to work and the technical infrastructure behind that, but it's actually really very simple when you understand the concepts. So they're all going to run by webhooks that are activated from our front end. So when we click a button, it's going to send the data to n8n, and n8n is going to receive that. That is effectively what the webhook is doing. It's receiving the data from the user clicking a button on our website. We're going to process the automations, and then we're going to send data back to display to the user, also using a return webhook there, so that our front end can receive all of the information pushed back by n8n. So today we're going to look at two specific examples that we can emulate from Agent.ai and Relevance.ai actual examples. So first, we've got a sales lead qualifier, which if we open it up directly on Agent.ai, it scores and qualifies leads based on scoring criteria. So a fairly generic overview there, but it costs 1 credit per execution and 4,000 people have completed tasks here. If we go through the process, it effectively asks us for an email, our criteria, and then returns this scoring criteria. We're going to replicate this on our own. And what we're going to input are a LinkedIn URL, criteria to score against, and it's going to output the same score against criterias with details. The second one, which is arguably a little bit more complex because we have to send a file, which is why I chose this as the second example, is extracting data from a PDF and summarizing. So if we go into relevance.ai.here, we've got a PDF studio where we can effectively upload a PDF file in the interface. It's going to send it to our backend in n8n. We're going to receive that file, extract information, summarize that information with an AI agent or LLM chain, and then return that information back to the user again. So we'll be dealing with more complex uploads there, and we might need some more complex tools in the backend, like an OCR tool to help read images off the PDF, for example. But ultimately, we're going to build out those two use cases today, step by step, so you can see how to do it. But this tutorial will give you the capability to build out any other AI or non-AI tools for yourself by showing you two clear, different examples of how we can use this and how we can set this up relatively quickly and maintain and edit it super easily. So now that we understand our infrastructure there, let's go down to the pathway that we're going to take to get there so that you can see what's coming up. First, we're going to figure out how to prompt Lovable to build the app that we want. We're then going to build out the automations in n8n. We're going to set up our Superbase database for login and for payments and prompt Lovable again to change a few things there to make sure that works. We're going to have to set up the infrastructure on Stripe directly for our payments. And then we're going to iterate and test with one of those automations. And then we'll move on to the second automation following exactly this same process. So the bulk of the work at the start is going to be done in Lovable. And I want to create a prompt that can help us create the full AI SaaS marketplace that's really clear. So I looked up a few tips on prompting for Lovable to improve the way in which I prompt. And I found this Lovable prompting Bible, which you can search for as well. And all I've done is gone to my favorite AI tool, Perplexity, which is a web search engine powered by AI models in the backend. So powered by an LLM. And I've written out this prompt to give us a starting point of the prompt we're going to enter into Lovable. So it's just a starting point. It's not going to be perfect. We're going to need to refine it. But I definitely recommend doing this as well. So we've got, I want a prompt optimized for Lovable, use the Lovable prompting Bible. It needs to be about developing a web app with a technical focus, clean homepage, so that I can have a similar look and feel. It needs to have a Superbase connection. Once users are logged in, they can see a page of the different automations that will be searchable. So similar to what we saw on our Agent.ai page, you'd have various automations, but also a homepage as well to get them to sign up. And once they're logged in, you see those different automations. I've then talked a little bit about the functionality. You really need to be specific with the prompt here and what functionality you want from it. So a few things that came to my head. We need a place to log in, which is stored in Superbase. So we're just giving it a heads up that we're going to need to connect to Superbase. You need, as a user, to use credits to use an AI tool. The third one is each AI tool has some sort of input fields. So we'll define those later. But now let's just say they have input fields. And once the tool is used, first thing is credits should be deducted. So it needs to interact with our backend here. To sign up, they'll need to pay $20 a month, which will be connected through Stripe. So again, laying the foundations that we're going to have an integration through Stripe. And once the tool is used, it should send the input data to the webhook address and receive back the output. So we're telling it it's going to send some data on the click of a button and also receive back data from a webhook at the end of it. So it's a very short, concise prompt, but I've laid out clearly the functionality and the integrations between the different services there so that Lovable can go and set up a really solid starting point for us to go in, test, modify, etc. And it's come out with this really clear guidelines. So it's a full prompt optimized for Lovable. And by the way, if you want access to these prompts rather than creating them yourselves, head to school.com/scrapes, come into the classroom, go to the plug and play templates for your business. And you're going to go to publish recently, which is all of the templates published in the last week. And we're going to go to AI SaaS Marketplace, and you've got all of the prompts down here, and then all of the n8n files to work with as well to make it super quick and easy. So let's head back to the prompt in Perplexity. We're going to copy that, and we'll just stick with this first prompt first. We're going to take that to Lovable. We're going to make sure that we sign up. I'm sure if we click enter here, it's going to tell us to sign in or sign up. So sign up for free, sign into your account. And then once you're signed into your free account, you're just going to copy paste that into the chat box there, hit enter, and it's going to start building out our app. So the thing that Lovable is going to do for us is start building out the framework in code without us touching any code, the framework for a full web app. So normally if you were to build this, you'd need a full stack engineer, or you need to be a full stack engineer yourself to be able to write out all this code. But Lovable starts by just understanding your core requirements and turning that, as you can see, into code. So it will start writing all the code blocks, and you don't need to worry about all of this. This is just telling you that it's starting to work on your idea. It's probably going to take 5 or so minutes to fully write out the code, but it's effectively powered by an LLM in the background that's specifically tailored to creating website designs, but not only the front end of a website, which are quite easy to already make using something like Webflow or Framer, but it will start to integrate the back end functionality for us. And you can see, for example, it's starting to create the Supabase connection here. So we'll let that all load up. And whilst that is loading up, let's go to Supabase and start setting up a project there. So you're going to sign up to Supabase, and then you're going to start your project. If you've got no projects already, you're going to be in this dashboard page once you've signed up for a free account, and you're going to click New Project, choose the organization that it should sit in, and we're going to call it something like Lovable Demo. You're going to then save a database password and choose a region, but just leave it as the default, I would. And that will start creating a new project in Supabase. We're going to later need to take the secret keys from our project in Supabase and give that to Lovable so that it understands what database to connect with. And whilst that's still setting up, we can go up in lovable.dev to the Supabase connection here. We're going to click Connect to Supabase. And what that's going to do, if you signed up for Supabase and you're logged into your account, is allow you to authorize API access for Lovable. So we're going to give it access to the correct organization, and we're going to authorize that. And at this point, you're not going to be able to connect to any of the tables, because actually, if we go into View Tables, we've not set up any of our database tables yet. It's just a completely empty database in Supabase. So we're going to cancel that, come back. Let's see how our project's getting on. We've had our first error. So Lovable is really good in some aspects and then can error out quite often. So all we're going to do is just try to fix, and it's then going to push the error back to Lovable in order for them to start fixing the error. And if this doesn't work, we're just going to simplify our prompt and work at it a little bit at a time, give it a simpler prompt to start with, and then add functionality as we go through. So let's go back to Lovable now, and it's actually identified the error for us and started a fix on that, and actually now output our first view on what our marketplace SaaS would look like. And it's not bad for a first go. We'd obviously prompt this to improve the UI, change the marketing copy, etc. We've got unlock the power of AI with a simple credit system. So not really selling the value there, but the description underneath is not bad. Access a marketplace of premium AI tools with a flexible pay-as-you-go credit system. No commitments, just a powerful AI at your fingertips. So it's really understood the brief and created this nice header on the homepage. It's then got a link to view all the tools with a little how it works. So purchase credit, select a tool, get results, which is exactly as we described. It's got a footer down here. Again, the color scheme needs a bit of work, but it's done a really good job. We've not had to build anything or build out any code. We've just clicked fix a few times and it's come here. So let's first click get started. And you can see that automatically it's thrown us to a new page, which has the endpoint register. And we would register our account here. And it's also potentially set up our Google. So up here, we can click to go back into the various different pages. Let's go back to register. And it's also set up these other pages. So dashboard, tools, pricing, billing. Let's see if we can access any others right now. Okay, this is a really good example of where it's implemented some security measures here. So we've tried to access the tools or the dashboard, and it's thrown us back to the login page, which is exactly what we want if we've got a paid service. We want to be logged in, or we want our users to be logged in before they can access any private pages. It's then given us individual tools pages. So this tells me that in the back end, we're going to have multiple tools, each with a unique page, but following the same structure. We've then got a pricing page. Let's have a look at that. Okay, and it's followed what we said, but it's actually given us a few different options here. Let's see if the sign up free button works. And instead of using the Google OAuth here, let's see if we can sign up using an email. Okay, so we've hit an error here. Error signing up, failed to fetch. what we will do is let's just come down here. And I have a suspicion that this is because we haven't connected to our Supabase yet. So now the website is loaded. Let's go up to the Supabase connection in the top right corner. We found the Lovable demo project, and all we're going to do is connect to that project. Great. So it's connected. Follow the instructions in the chat to complete the integration. So let's go back to the project, and it's given us some additional instructions to follow to connect to Supabase. So it's encouraged us to just keep building and given us a few bits of information around user accounts, login, etc. But the one thing we're missing is we still have no tables inside our Supabase database. So let's ask it to do a couple of things. Let's ask it to fix the login page, and that's still not working. So it wasn't a Supabase issue, or it potentially was because there's no tables there. So let's tell it the errors that we're facing, and it will go into the code and fix that for us. So let's go back to our school page where we have the implementation plan in here, and it already set out a plan for what the different tables should look like in Supabase. So if I copy and paste that, we'll go back to Lovable. The first one we've already put in, so login sign up is not working, either through Google OAuth or normal sign up. And then I've put the name of the error in, and then I'll put, we have no tables in our Supabase database. Here's an example of what they could look like. Add any other necessary tables. And we'll just paste in that Supabase example setup there. And we're just going to let Lovable run through that and see if we come back whether the login and sign up errors are now fixed. So this is where Lovable gets really powerful because they have the inbuilt integration with Supabase. We don't even need to go to Supabase to set up our tables. If we were setting up a project through Supabase, we'd have to go to the SQL editor. And this is an alternative way to do it. We'd copy and paste in these table schemas, which is basically the different tables and how they link to each other and the data types. And we'd have to paste those into here. We'd have to run the command. But because they've got this inbuilt integration, it gives us the different tables that we've suggested, along with access policies. And you'll need to go through these because they won't be perfect, and make sure that these access policies are secure before you publish. Don't treat this like a production-ready app. You still need to make sure that it's got the security policies, test out the website, test out all the different edge cases, see if you can break into your own website, because there may be a policy missing that means other people can access certain pages they can't, or people can access information from the database. So you need to go through it and check that as well, or use an AI tool to help you check those policies and understand what they mean. But we've got a few policies in here, like users can view their own transactions, user can insert their own transactions. So all it asks us to do is to apply changes. So that's going to create those tables in Supabase for us. So again, we don't have to touch a thing. And soon we'll be able to start building out the backend automations that can link to this. So first, let's just see if the generic sign up is working before we do anything around Google. So let's go to create account here. And it's come up with a cool little pop-up here, account created, check your email to confirm your account. And if we go back to our Supabase tables, so we can go to our database on the left-hand side here, you have a visual view. It's set up 3 tables for us. One is tools, one is profiles, so that'll be our users, and another is transactions. So you can see that it's understood and started building out what our tables should look like and the links between those tables. And if in fact we go instead to table editor, we click into profiles, you can see that it's created a new user under my email, and it's given me 50 credits because it said on the free plan you get 50 credits. So it's got all of the information we need to start connecting us up there. It's missing a Stripe customer ID because it hasn't forced us to go through a paywall, which we'll cover. But you can see that it is now working the front end with the back end, which is really awesome and taken no time at all. So let's go back to Lovable here and let's sign in. So I signed up as well with a different email address here whilst the camera was off, and we're just going to log in there. And that will hopefully take us through to a dashboard. Great. So what we've got here is a dashboard. It's come up with error, failed to load tools, because we've not actually created any tools here, but it's actually predetermined that we've got a search bar here to search the different tools. It's understood from our initial requirements that this is like a tools marketplace. We'll be able to pick some tools, spend some credits on those tools. So it's given us 50 credits for the free trial, and we've got different categories that it's assigned here. So 2 things we're going to need to do here. We are going to need to, 1, create some tools on the front end, but 2, be able to connect those tools to our back end, which we said we're going to build in n8n, and enable the connection between the front end and back end. So let's start doing that now. So we're going to go into our workflows in n8n. And once we're inside n8n, we're just going to go to create workflow. And just to remind you, the automations that we're going to build here, we're first going to build a sales lead qualifier where the inputs are a LinkedIn URL and criteria that we're going to score against. And it's going to output for us a score against certain categories that we give it using AI. And the second one is uploading a file, extracting data from that PDF and summarizing it using AI and sending that back to the front end. So within our workflow, we'll just call this lovable-sales lead qualifier. And all we're going to do is open up the tab here of tools, and we are going to click on the webhook. So we're going to receive a webhook from Lovable to this address, and let's first just test that that actually can be set up for us. So let's take the production URL from here, and we're just going to make sure that workflow is saved. And we're going to ask in Lovable to create two tools. And we're just going to say, create one tool, a sales lead qualifier with an input field of LinkedIn URL, and a second input field is a description of qualification criteria. These values should be sent to the following webhook address. And what I've done is taken the address from our production URL, copy paste this get address, but let's actually just change it to a post address because we're sending data. Let's leave all of this as is, but actually we can change this path here to sales-lead qualifier just to make it a bit more clean. Let's take that back to our Lovable environment and replace that webhook address. And then we've told it should display a descriptive text box with the webhook response when it returns. So what we're going to have here is the webhook that's receiving the data from Lovable when our user inputs and clicks next. We're then going to take some action. So for now, we're going to use the do nothing operation just to test it works. And we will have a webhook respond to webhook node, which will send the data back to our Lovable site. And what we're going to do is say respond with all incoming items back to the Lovable site. And in here, we're going to create a node or a set of nodes in n8n to qualify those sales leads. But right now, we're just testing that the connection works. So let's ask Lovable to create that. And it has the webhook address in here. So it's going to go ahead and start making that. And then whilst it's doing that, let's duplicate this flow. And just to remind you, we were extracting data from a PDF and summarizing it. So let's just call it extract from PDF. Let's duplicate that flow. And again, we have the webhook, do nothing, respond to webhook. And we're just going to change the path here to extract from PDF. We're going to copy the production URL. And we're going to just have to make sure that if we're using the production URL and not the test URL, that we've activated the workflow so that they can actually receive the webhook trigger here. So again, at this point, we're just testing. We're not trying to achieve anything in particular apart from sending the data from the front end, received, do nothing with it, respond with everything that it's received back, just to check it displays on the back end as well. So I've come back here and it's told me that the build was unsuccessful. If you click into this, it tells you what was unsuccessful, cannot find name, skeleton, did you mean selection? So there was just some build error, but what we can do whenever we get a build error is go up here on try to fix it. It's also given us a warning that a file here is getting too lengthy, but let's not worry about that. Let's just ask it to rebuild and see if it can get it done. So I logged back in and I noticed there were no tools showing and it's had the error failed to load no tools again. So I've told it that and it said, okay, the issue existed because in our database, there was no tools is featured column and it was relying on that to exist to show the different tools. So it's given us the SQL code to add some columns to the tools table so that it can then apply those changes. So let's apply those changes and we'll run it and we'll see what it comes back. Okay, so after a few iterations of just saying the tool isn't showing at all, it's added some sample tools to our tool table that are now showing in our, that we just accepted and told it to run it. And they are now showing in our dashboard. So we've got featured tools section and an all tools section, and you can see it's added 4 tools, but not the tools that we asked it to add. So let's go back up and just reiterate this prompt that we'd like it to create this tool. And then hopefully we can move forward with this tool and start testing it out. You can see that it's also assigned different credit amounts to these different tools, and it's done all of the user interface for us. So we don't have to worry about that. And it's even created descriptions, put it in different categories. So this is really cool and really quick. This would take you a long time to mock up by yourself and then create the database in the back end and all the data and the fake data. Whereas this has done it super quickly for us. Even though it's a bit back and forth, it's going to save you a lot of time if you want to create a front end website that interacts with the back end. So let's create this tool and then start testing if it interacts with our webhook. And one thing I will mention here is whilst we were going through that process, it asked me to upgrade and said I was nearing my daily limit. So if you're going back and forth trying to create something complex like this, you might have to upgrade to the $20 per month once, but arguably that's well worth it for the functionality you get and the time you're saving. We've now got the tool appearing in the All Tools, and it's given us a little description here. So let's click through. And what we can see here is we have a description, qualify sales leads based on LinkedIn profile and custom criteria. So very appropriate. It's got an about section, and we can see there's a few options here. It's a sales tool. We can go back to the dashboard, tells us about the credits per use, gives us another description, and then it has a run tool. Makes it very clear that we're going to use 8 credits to do so, but obviously we haven't set up the functionality to take away the credits. So I'll be interested to see if it does that correctly. It's got the LinkedIn profile URL with an example in here that we could insert. And then it's got the qualification criteria, which we enter a specific criteria to qualify this lead. So actually it's done a really good job of setting up this interface so that we can pass inputs in. Let's actually try and put some inputs in here. Let's add my LinkedIn profile just as an example and see if our webhook actually receives it. And we'll see this in the executions inside n8n. So I've added in my LinkedIn URL and just added test qualification criteria. Let's click Analyze Lead. It said it's processing, and it said there is a problem processing your request. Please try again later. Let's go to n8n, and it seems like something has run. So let me come back inside here. Inside our executions, we'll be able to see if the data was received. And the issue is not that the data wasn't received. It actually seems to have received the data. It's just that we had respond immediately rather than use the respond to webhook node. So let me just come in and change that to respond to webhook node. And we'll do the same on the other tool as well whilst we're here. Let's save that. Let's go back. Let's give it a go again. Analyze lead. And it's processing, and it's actually come back with an output straight away. So it's actually received a webhook response. So let's go into the execution. So let's see what's happened here and check that we're actually receiving the data correctly and that it's sending back correctly. So we've received the body, which contains the LinkedIn URL and criteria. So that's amazing. It's got all of these headers, which we're not really concerned about. It says that it's coming from the Lovable project, but effectively we are sending and receiving the data. And also we have sent back the LinkedIn URL and criteria. So we've sent everything back, and you can see that we've received the body back of the LinkedIn URL and criteria. So that's awesome. The webhook is actually working. So now what we need to do is build out the workflow to actually do something for us, like sales lead qualification. So whenever we want to use an app that we know isn't inbuilt into n8n, for example, here we are trying to scrape LinkedIn profiles, we're going to come to something like Appify that has a whole list of user-built nodes that we can connect into, or APIs that we can connect into. An alternative to that is finding a solution that's another external API that scrapes LinkedIn profiles or does the exact thing you need. But here, we've just got a list of lots of different options that we can connect to with one simple API call. So we're just going to type in LinkedIn profiles. That's what we're looking for here. And we're going to find a LinkedIn profile scraper like this one, 2.7K users, 4.8 out of 5. That seems like a good bet. You'll be able to try this for free. And with every plan on Appify, you get a free plan up to $5 usage for free. And you can see this one charges $10 per 1,000 results. So you could get 500 results on your account for free here. But when you're creating a paid SaaS anyway, you're going to have paying customers. So this might be easier than going out and building your own LinkedIn profile scraper. So let's hit try for free on this one. And I'll show you now how to set that up in n8n. So I've previously looked here and we've added some profiles. So we've got Bill Gates here and my profile here. And all we're going to do is we're going to go back to the lovable n8n backend sales lead qualifier flow. We're going to open up a HTTP request, which allows us to connect to any API. And we're just going to make this a post request because we're going to be sending data. We're going to find the URL. For this case, we don't actually need the authentication because I'll show you pass it in the URL. We pass our API key, and then we're going to send a body, which are going to be the profiles that we want to scrape for that. We're going to make sure that's JSON, and we're going to go and get that from Appify now. So inside the Appify scraper, we go to JSON here in the inputs, and you can see that it gives us the JSON that we need to pass back in our actor. So we're going to turn this into an expression because we want to change it to dynamic inputs in a moment, but we'll test it on these 2 profiles first. And then we're going to go back and we're going to hit integrations, use API endpoints. And what this is going to do is give us a few different options to run this endpoint, but it's also going to append our API token to the end. If you haven't set up an API token before, go into settings in API and integrations, create a new token, and that will be the token that's created. You probably have one already in your profile. So let's go back to the actor, use API endpoints, And we are going to want to run the actor synchronously and get dataset items. So basically, we want it to return the data and so we don't have to keep asking if the data is ready. We want it just run and return that data. So we've copied that here. We're going to paste it into our actor here inside the URL. And I will delete this token afterwards because you can see it just appeared in here as well. And that means we don't need authentication because it's already built into the request. So let's just test that and see if it returns the information from these two profiles successfully. And because we're doing two profiles and it was $10 per 1,000, this is going to cost 2 cents. And at this point, we're just testing if it works. And you can see it's returned all of this different information. If we go to the schema, you can see we've got the connections, number of followers, job titles, job descriptions. So a lot that we could use to qualify this person if it was a sales lead qualifier tool. So we've set that up in our Apify actor. So what we need to do now is say, okay, from the data we received from the webhook, scan that information and do something with it. So let's just start adding some notes. And if you've followed my videos before, I always add notes so that when I reflect back on workflows, I understand exactly what's happening. So we're going to have scrape LinkedIn profiles in here. And then we're probably going to have another step where we qualify that lead against the criteria that's input. So for that, we're going to need an LLM node, which is effectively being able to chat directly with with AI. And we're going to need to give it a model. So we'll give it OpenAI chat model. And we'll connect to OpenRouter so we can access multiple different models through there. If you've not set this up before, check out the full course where we run through all of this, including what is an AI agent, how to use different LLM workflows, and everything like that. But if you're familiar, this should be fairly straightforward. So we're going to receive the data. We're going to scrape the LinkedIn profiles, and we're going to qualify the leads. Just going to rename this. And again, I like to name all of my nodes so that they're really clear. So this is going to be qualify leads. And we're going to define below the prompt in which we ask it to qualify those leads and tell it what it needs to return in response. So inside the qualify leads, I'm just going to write I've just written a basic prompt. You're a sales lead specializing in LinkedIn-based lead evaluation. Your task is to assess each lead based on their LinkedIn profile, which is the input, and rank them against the following criteria: job title and role, industry and company fit, professional experience and skills. For each criterion, provide a score 1 to 5 along with a brief justification based on the provided on the available information. And then we will just give it the inputs dynamically, profile info, and we'll pass that in a second. And then criteria to assess against. And what we need to do for that is pass those in dynamically. So we can just go to a previous execution of this, a successful execution, copy to editor, and we'll be able to see the content that we passed in, the LinkedIn URL and criteria. So inside here, we are going to have the criteria from our initial webhook. Let's put that in here. And that's the criteria it's going to assess against. And then for profile info, we've got a couple of options here because we're going to receive potentially multiple profiles in a list. So what we want to do first is let's just test a single profile. So let's pass in the LinkedIn URL here inside the body. And you can see that that's populated dynamically. We just drag and drop that over. And then if we just have one, it's going to be relatively easy because we're passing through one here, one output here. So let's test it with one first, and then we'll show you what to do if you want to qualify multiple leads at once. So we need to make sure that we're pulling in the profile info here as well. So let's say from the webhook.item.json. And this, if you haven't done the full course, is just reaching into the previous inputs, .body, .LinkedIn URL. And you can see now, if we open this up down here, that it's passing in the profile info. That's actually incorrect. I need to pass in the response of the Apify actor. So let's just deactivate these. And what we can do is just run this so that it pulls the data from the Apify actor. And we've got an error here. JSON needs to be a valid JSON. So let's remove the speech marks from there. And there's still an error here. So let's dig into this. It will be the comma here. So let's put the speech marks back. You should have a comma between the items, but never at the end of an item that is never on the last item. So now you can see it's a valid JSON object. That's going to run and return the data, hopefully. There we go. We've returned the data. And now what we're passing into the qualify leads will be any data we deem suitable. So ideally, what we want to do is aggregate all of this information and pass it in as a single item. So what we can do is just go back into our prompt. And instead of doing this, what we're going to do is $JSON to JSON string, and that's just going to convert everything we've received into one parameter. There are other ways you can do this, like the aggregate node, or just pull the information you need, like the set node. But let's just run this on a test locally before we interact with Lovable. And you'll want to just pin the data once it's run so that you can pin it whilst you test, so you're not being charged every single time. And that will just run the same information. And it's returned multiple items here. Simon is the founder of Automake. As a founder is likely the key decision maker. So it's assessing against criteria, but obviously our criteria that we put in was terrible. It was just test criteria, but it should only be returning one item in the output here. So let's make that clear in the output format. And in fact, what we're going to do is a method where we can just return without a specific output format. So let's delete these and let's see, this time it will return one output format, but for multiple leads, we're going to make a few amendments in a moment. Okay, so it's returned one output format, and let's actually test this with a profile URL using the webhook, and that will actually respond to the webhook. Then let's add multiple. So let's go back to Lovable. We will go into our tool, and we're in the dashboard, and we'll go back to the sales lead qualifier. And if we go to run tool, we know that we can put in our LinkedIn URL and our qualification criteria. And let's unpin the data here, unpin it in this test, save the workflow. And all we're going to do is put in the LinkedIn URL that we want to scrape. So we've put looking for co-founders who have marketing experience to advertise our marketing tool to. So this is qualifying my profile against that. So what we're going to do is analyze that, and it's going to run through, and we'll see this in the executions of the tool. It will run through here. So it's going to scrape the profile. It's going to qualify my profile based on the information it receives against that lead. And then it's going to return that, hopefully, to Lovable. So we'll go back to Lovable. Yes, it doesn't look brilliant, but we can format that output. But it's got all the content, so the output is displaying. So it's returning all the data as we saw before. And it's given different scores. So actually, okay, professional experience and skills, score 3. Simon has a solid technical background with significant experience in operations and automation, true, but his marketing experience is not explicitly outlined in the skills or endorsement on his profiles. His past roles have involved scaling delivery operations and automating processes, which can translate to insights into marketing and user engagement. However, specific marketing skills appear to be lacking, making this aspect of his profile somewhat less compelling for advertising your marketing tool. So actually, it's done a really good job of kind of reading the profile, analyzing it, and returning that data. So you can see that you could offer a tool like this to a user, but one thing you've probably noticed is that the credits have not gone down. So something is not working in terms of when a tool is used, updating that in the database, which is really important when you're trying to charge users for a tool that's based on credits or number of uses. One quick thing we're going to do is just make this a bit more useful. I'm able to scrape multiple profiles at once and return information based on that. And then we will deal with the credits not updating and move on to our second automation before we finally set up the payment. What other tools you could sell with this kind of SaaS? So let's say we have a comma separated list as the input. What we're going to do is use the edit fields or set node. And we can just say, okay, based on the input, we're going to need to grab the LinkedIn URLs, but perform manipulation on them. So let's call this URLs, not URL. And we're going to say, okay, turn this into an expression. So it's going to be a JavaScript expression. And what we are effectively saying here is if you have multiple inputs under LinkedIn URL, which would come through our field, then we're going to separate by the commas. And then each URL, so each item in that, by comma, we are going to remove any white space, and then we're going to join it by these quotation marks, but also a new line between it. So it looks complex, but actually I've just used Perplexity to talk through the formatting that's in the input and the formatting that is the output. And it's helped me come up with this n8n expression that's going to work the job for us. So let's go with an example of multiple and check that just up until this point it's working correctly. So if we go back here and let's put in a comma and let's put in a second LinkedIn URL, and let's just use Bill Gates again. So we've got two URLs here. Let's send that to be analyzed. And for some reason, there was a problem processing the request. So let's go check if the problem was inside our workflow. I see. So because we've disconnected this response to webhook flow, it's not worked correctly. So let's just connect this back up and try it again. And it should now start processing that. If we come back to n8n, we'll see in the execution history what's happened here. So you can see that it's received multiple items and it's actually split them exactly how we need for our Appify input. So Appify has then got the incorrect input, but if we just drag LinkedIn URLs across here, that should work correctly. So in Appify actor, let's go back to executions. And this is a great way to test things, by the way. You can copy this to editor. And now we can see, okay, instead of putting this in here, let's just dynamically pass in the LinkedIn URLs. And we can see that it would populate exactly like we need in our Appify actor. Now to process multiple of these, so this is going to pass multiple items to our qualify lead, which is then going to pass multiple responses back to the webhook. So to pass it as one single response, so that we give a response based on all of our inputs. In fact, let's go back and test it and I'll show you exactly what it does. If we put input multiple, let's analyze lead, which is running the tool again, and that's processing. And you can see in the executions that it is running. And actually, that's worked better than I thought it would. I thought we would need some additional method here to get the response in here, but it's actually given us the response for both of those. So we've got that back in here. Now, obviously, the format that it's returning in is not ideal. And we could do some extra formatting steps, but for this demonstration, it's about actually passing that data back. We could do some extra formatting steps. We've got plenty of community resources about reformatting data, so we won't touch on it here. But basically, we've got our first SaaS tool that you could sell to other people, which is our sales lead qualifier. And it didn't take any time at all. Most of the time is in this setup and waiting for Lovable to run and then iterating back and forth with that. So that's really cool. Let's go to our second one here, which is extracting data from a PDF. What we're going to do is set up this one exactly in the same way, but touch on a few things about file transfers. And then we will look into the credit system and how to make sure that that updates so that your users aren't abusing their API keys, or so that you can charge credits for using certain tools. And then let's also look at applying a pricing gate so that users have to pay to sign up, and it will confirm in the back end that they're signed up and paying before it allows them to use the tool. So the key things you need to make it into a proper SaaS. So again, let's go back to Lovable and let's just test if we receive the binary data inside the webhook and also can send a file back, because we're going to need both of those functionalities potentially in the future. So we'll go back to the Lovable prompting. And similar to when we told it exactly what we needed for the first tool, let's do exactly the same for the second tool. So I've started prompting it here, and I've just decided to be fairly generic at this point and not give it much instruction. So I've just said PDF extraction tool, and it's identified in Lovable that we want to create a PDF extraction tool that can pull content from PDF files. And it said, okay, to do that, let's add certain things to the database. So let's approve those changes. The one thing we'll also need to do is enable a user to upload a file. So we might have to prompt it that as well. So let's see what this does first. So it's already said, now that we've successfully added the PDF extraction tool to the database, I'll create the PDF extraction tool functionality. So that's not what we want to do here. But we do need to allow the upload of PDF files. So let's see what it makes and then modify it from there. And as you can probably already tell, I'm regretting being so vague in my inputs. So I should have been more specific. I need the user to be able to upload the file in the inputs, not do the extraction itself. The file should be sent as data to the following webhook. And I've given it the webhook from our production URL, and we will update that there so that it can actually send the binary data file or the PDF to that webhook. Let's let it edit, come back and test the tool out. Whilst we're doing that, we will add the ability to download the file. So we've got the extract from file here. And if we're just doing basic extraction, we can actually just connect up this to the webhook, extract from PDF. The input would be called data. And again, we're just going to add an LLM chain because all we're going to do is ask it based on the inputs, summarize the content in the PDF. So we'll put notes on our workflow in a moment. But for now, let's just connect the same as we did before to OpenRouter or OpenAI, whatever your preference is, through there. And in the prompts, let's say to summarize the incoming PDF data. And obviously, if you were building out these tools, you want to add in your own prompts. This is just a demonstration of the capabilities of sending files to and from our webpage that we've built with Lovable. And we'll reference the correct data point in a moment once we understand the data is being sent through. So we know this is going to fail at first. It says the PDF extraction tool now uploads files directly to your specified webhook. When a user selects a PDF file and clicks the upload PDF button, it's sent to our webhook. And the response from the webhook is displayed in the text area below. Great. So let's go into our tools in the dashboard. And we've got PDF extraction, costs 5 credits. Again, given all the details here. Let's go to Run Tool, and it's given us an upload PDF file option, which is awesome. When we click it, it opens our most recent files. And let's go to this file in my Documents AI Explorer Roadmap, which is one of the files you get when you join the school community. It's like an onboarding guide. So let's see if it understands that file. Let's click Upload PDF, and we know already it's going to fail in n8n. So we just want to see what the error is there and also what data is being passed through. So a lot of this is going back and forth, just testing. There we go. The errors come up. And great, it's actually sent the PDF file, but it's called it file, not data. So all we need to do is either tell it in Lovable to change it to data when it sends, or just call this file, and that's absolutely fine. We'll extract from the file. Now we will be able to tell if we run it quickly again. And it's often better to just open this into a new tab because this keeps refreshing in this window. So you can open it in a new tab and refresh instead. It's probably going to save you a bit of time. If we refresh that here, we can see it's the correct tool. So there was an error there, which is probably coming from our n8n environment again. Yes, it was. And that's because we don't know what data is being passed through yet. So we can see that it's passing through this text field. So again, let's debug in editor, which allows us to see the previous executions. Get rid of this, and let's just pull through the text. All we want is the text. And let's take this to the top, summarize the incoming PDF data, and we'll call this summarize PDF. As we always want to label this up, we'll add a few workflow notes, and again, refer to the longer 4-hour tutorial on n8n best practice for the reasons in why I do this. But when you revisit workflows or create lots of tools, this is going to be super helpful for you to reference what's actually happening. So we'll have summarize PDF. We'll have extract from file, and it should just upload text in response. So let's try it again. Upload the PDF. That's going to process. Let's see if it comes back with a summarize response. And again, the formatting won't be perfect because it'll be the direct output of our LLM node. But here we go. We've got a file that says extracted content, but it's also put it in an output. The AI Explorer Roadmap is a guide designed to help businesses leverage AI and automation effectively. It talks through all of the different steps that are part of the guide. So we've now successfully passed a file from a front end to the back end, summarized it using AI, and passed the response back. The final thing I just want to touch on here is like what happens if you want to pass the file back. So I'm going to put this should also be able to receive an output file back if one is passed, and to remove the extracted content section because it already had an output. We're going to run that. That's going to update that for us. So now we've got two working, completely different AI SaaS tools in a very short space of time. You can see how quickly you can mock this up. If you come into the school, you can go into the classroom and the plug and play templates. And what you could do is use absolutely any of these to create SaaS tools for yourself. So we've got things like a meeting summarizer, so people could upload their meeting notes. You've got an email inbox agent. You've got scraping any website data. You've got the thousands of tools on Appify. You've got a voice planning agent, so somebody could upload their voice and it could plan something out for them. You've got competitor research, so you could input links. You can see the opportunities with all of these templates are endless when you combine it with the fact that you could then sell this as a product with dynamic inputs that will push outputs to your users. So it's really an amazing tool or an amazing tool set to use together. And I've created this with no experience in very little time. So we've come back now to Lovable, and it's saying the PDF extraction component now uploads PDFs to the webhook and it can also receive them back. So let's refresh our page here, and let's just go into our workflow here and test that theory. So let's connect it directly to our respond to webhook nodes. Let's just deactivate those. So the file should now be received and sent back. So let's see if that actually is true. So a lot of this is like back and forth testing to check things work, but you can see we've built a lot of different functionality, not just text back and forth, but also any files you wanted to upload. Really simple to do. So let's do exactly the same again. Let's upload the PDF, see what the response is. Interesting. So it's now come back and immediately it's downloaded the process document. So we have confirmed, if we look at the execution, that actually it did succeed. And what it's done is receive the file and send that file back. So we can send files back and forth as well. So let's just connect this all back up. And that is 2 working SaaS tools with very little time. This whole time we've been running on 50 credits, which is a big issue because if you're selling this to others, you want them to use their credits up as they're doing this. So we need to tell it. So we need to tell Lovable to take credits away when somebody's using it. And then also we need to implement a paywall with Stripe. So we're going to cover both of those now. So let's now talk about setting up a credit system that works. And if I just remind you of our diagram here, we effectively have the front end built So Lovable is integrating with our backend. We've got 2 automations set up, and you can set up any automations like this and prompt Lovable, set up the n8n automation in the background. And we've got 2 automations already set up inside n8n. And like I mentioned at the start, you can implement absolutely any automations and have this as a tool on your marketplace or as a SaaS separately. Those are running now correctly. We now need to tackle these backend steps, which is making sure that when a tool is used, we log the usage for that user in particular, but also on a tool level. And then Stripe, we need to connect our account so that we ensure that users have paid to sign up to our service as well. So let's start with the database and ensuring that when we're using credits, which are just arbitrarily assigned at the moment, but we could go back in and change that, they're actually counting on the database. And then once we've used a certain amount, it should then tell us that we need to upgrade to a paid plan. So we're first going to go back into the database project. We'll go to table editor and we'll just have a quick look through the tables here. So we've got 2 different profiles that have signed up. So those were the 2 IDs I signed up with. We've then got the tools. So any tools that we don't want to appear on our SaaS, we can remove here because actually we've not generated any of these tools. And these are just ideas it's put in for us, but we have made the sales lead qualifier and the PDF extraction. So let's delete those 4 rows from the back end. We'll refresh here, which is connected to our database. We'll go back to tools, and you'll see now that only 2 have appeared here. We might not want this featured tools section, but it's not a problem for now. And again, we could change the categories, but we're not worried about that for now. So transactions in here, we have an empty database. So you can see that none of the users have been added here. So whenever a button is clicked in our app, like say we use the sales lead qualifier, it should actually deduct those credits if it's successful from our account. So once we receive a response or once we click the button, we should make sure that it's deducting that from our account. So we're going to go back to Lovable and just tell it that that's not happening. So I said each time a tool is run, it's not deducting credits from the user's account. Also, the user that's registered doesn't seem to have a transaction registered in the table. So I know this from our transactions table. We've got all the data in here, but actually none of it is being registered. So let's go back and let's process that with Lovable. And that's going to make updates to that. In the meantime, let's head to Stripe, where we're going to set up payments. So you're going to need to set up an account in Stripe. And once you set up a Stripe account, it will give you some instructions on whether you want to start looking at one-off payments or recurring payments. So here we're looking at recurring payments. So say pay $20 a month, get 100 credits, etc. And whilst we've been away, it's fixed the issues of credit deduction and transaction recording when tools are run. So before we set up the payments, let's just test the credits here. So we've got 50 credits here. And if we go to the profiles, we can see that we've still got 50 credits on our profile in the database. So there's 2 things that need to happen. It needs to update in the database, but it also needs to update on our front end to show the user that they've used some credits. So we're going to refresh this here. And this says that it's going to use 8 credits per use. And in our backend database, we can see inside the tools that it's got a credit cost of 8 in there. So that's great. So we're going to run the tool. We're going to pass in the URL. We're just going to put some random criteria here, but because all we're looking out for is that it's updating our credits both in the database and on the front end. We will have to add logic to this that says if the user has 0 credits or not enough credits to perform the action, then they can't take the action. So we can see that this is not updated up here. Let's go to the database and refresh. And again, it's not updated here. Has it recorded a transaction? Yes, it has. So it's saying we used 8 credits and it gives us the input and the output, but actually our profile still suggests that we've got 50 credits. So the profiles has not been updated and nor has the front end. So let's go back to Lovable. So you can see how you pick apart these different problems and solve them one by one with Lovable's help. So I said the profiles table was not updated with the credit usage and nor was the display of credits on the front end, i.e. this part. And I've added here, make sure a user cannot use the tool, i.e. make them buy more credits or put them through the process to buy more credits if they don't have enough to perform an action. That's a critical step in our process because we want customers to be able to perform actions or guide them through the process to buy more credits to do actions. So let's send that. Let's see what Lovable comes back with and test that out again. Okay, so coming back here with a bit of persistence, it's now seems to be working. You can see it's updating my credits here. I just continued to say similar things about the database tables not updating. Eventually it got there. Let me show you exactly what it looks like. It's currently got a different issue, but you'll see these credits update. It will run, it will deduct the credits, correct amount of credits. The database tables will update. Let's see that update there. you'll see in the transactions, it's added a new transaction. However, it's not returned it's like refreshed the page too quickly and not return the output. So we're going to need to fix that. So we'll just say it updated the credits, everything's working, but I was awaiting the output, which never arrived basically. So we're stepping in the right direction. The other thing I want to mention here is we have functionality now to deduct credits, but when you're building out a credit-based system or any sort of recurring revenue-based system, the database tables need to have a fair bit of functionality. If you come into the school, I've included a section on setting up an effective credit management system, including the back-end prompt here, the front-end implementation, and edge cases. So you can come in here and grab those prompts, and that will help you speed up the process and remove some of those errors when we're going through and trying to add this to the UI, because it will give more specific information to Lovable about certain edge cases and not just deducting credits, but thinking holistically about how the credit management system works. Okay, it's updated the states here. So let's try and run this again. And let's analyze lead. Again, we're getting a similar problem. So it's not giving us our output. Okay, it is giving us the output, but it's throwing us back to the about page. So I'll just tell it to keep us on the run tool tab, and then it's going to make those edits. And then we're approaching our 0 on here, so we can test that as well. And at that point, we want to implement our Stripe payment link, which we spoke about previously before. We'll go and grab that Stripe payment link and integrate that as well. It should have updated that now. So let's go back to tools, try the sales lead qualifier, run tool, put in some criteria, analyze the lead, and it keeps us on the run tool. It's deducted our credits and it's going to give us the output. So it's now performing exactly as we expected. Let's start integrating our payment links here. So we're going to go back to Stripe. We're going to grab the link from our payment links section, and we're going to get Lovable to set up the payment links. So I've added this here. So when a user signs up to a plan or gets to 0 credits, gets to insufficient credits, get them to purchase through this payment link, and I've linked the Stripe link. It's the $20 a month plan and should give them 100 credits in the database. The backend should all be linked up so we know which user is paying and when it's paid. So let's see what it comes back with here. It might ask us to set up something on the Stripe side, as I believe we have to connect our Stripe account to the Lovable app here. There's a link missing. We need a user to pay, but then in our database, we need to link that user base back from Stripe based on their transaction to the user in our database. So I've followed up with how does this connect to my Stripe account and know which customers created a purchase. And it's given me a few extra steps to consider. We need to have a webhook handler to process Stripe events. So when Stripe sends the data that suggests a purchase has been made on a certain product, it should be received back by our SaaS so that it knows to update the database and it knows which user is associated with that transaction. And then along with that is the customer linking that I just mentioned. So to implement this properly, we would need your Stripe secret key. Do not share your Stripe secret key with anyone, and a Stripe webhook endpoint setup, and then edge functions to handle the webhooks and update your database. Would you like me to implement these Stripe integration components? All we need to do is say yes. So it understands the steps we need to take, and we can just ask it to take those steps for us. And we're going to go and grab the Stripe secret key here. An alternate way it may ask you to do things is to use the product ID, which if you click into the product, you can just grab from these areas and say, okay, this is associated with the AI SaaS 100 credits product as well, instead of using a payment link. And it might ask us to do that. So we've come back here and it says we need to create all of this stuff for you. First, I'll need your Stripe secret key. Again, I reiterate, do not share this with anybody, but it links to the Stripe API key page here. So once we've done that, it's told us to add the API key. So I've gone to that page, got my secret key, come back and just pasted it in here. We can submit that and now it's going to save it in the backend securely for us. Let's move on to the next step it asks us to do. So while that processes, just to be clear, this is the stage that we're at now. So we've built a front end and we've got the automations working on the back end. It's now deducting credits based on our usage. However, when we run out of credits, it's going to force us to sign up and pay. And right now we are connecting Stripe so that Stripe can interact with our database, which can interact with our front end, and everything is synced up so that our customers are getting a good experience, and that also you can sell these SaaS automations or the process of running them in the back end to other people. Great. So it's taken our Stripe secret key and it said it's created a complete Stripe integration with the following features. It creates Stripe checkout sessions for subscriptions and one-time payments. It handles Stripe events. So whenever Stripe receives an event like a customer's paid, it will effectively handle that by receiving them back. It verifies a user's subscription status with Stripe. So everything we need it to do with Stripe, it's going to do for us. And it also is integrated with our existing Stripe customer ID field in our profiles table, if you remember in the Superbase table, and adds credits to users' accounts when they make payments. The UI updates its connected the pricing page to the checkout flow and updated a billing page to use real product IDs. So they need a couple of things. They need us to set up a Stripe webhook in the Stripe dashboard to point to our Superbase webhook endpoint. So basically, we need to connect our database, so it updates, with Stripe, where we detect that a user has made a payment. And we need to get the webhook signing secret from Stripe and add it in as a secret in the Superbase with the name Stripe webhook secret. We'll go through all of this and replace the placeholder Stripe IDs with your actual product price IDs from your Stripe dashboard. And it's actually linked us to all of the relevant resources. Let's first set up a Stripe webhook in our Stripe dashboard that points to our Superbase webhook endpoint. So we'll click on the Stripe webhook setup here. We're going to create an event destination, and then we need to find the endpoint URL. And then endpoint is effectively a URL that this is going to connect to, and it's going to hear our Stripe events. So every time a customer pays, Superbase is going to hear and receive data from Stripe, and that will update the database directly. So we'll open the edge functions on Superbase, and it gives us these different webhook endpoints. So we're going to connect it to this URL or this endpoint, and I'll just go back there. And there's a little copy tab there. So I'm going to copy that. I'm going to take it back here, and we're going to connect it to here. And we'll just give it a description here of Superbase Stripe. So we also need to select which events it's going to listen to. So Stripe has a load of different events for different things that we could take actions upon, but we're actually just looking for checkout session completed. So when a checkout session is completed, it has loads of sub events that we'd be monitoring and actually just detecting. So whenever a checkout session is completed, it's going to send that event, and we'll just go down there to add events, add endpoint, and that should now be set up. We'll go back to Lovable, and we need to get the webhook signing secret from Stripe and add it in as a secret in the Superbase with the name Stripe webhook secret. So we're going to go down here to Edge Function Secrets, and it's going to pop up with a page with all of our secrets here, and they're redacted at the end here. So we're going to need to put in, like it said, Stripe webhook secrets, and then we need to get the signing secret from Stripe and add it in to that value. So you're going to come back into your Stripe webhook page where you've created that here, and you're going to click reveal. You're going to take that back and copy that in just a second. So back in Superbase, you're going to put the Stripe webhook secret, and you've copied there. That is effectively connecting Superbase to Stripe. So we hear those events, and the secret is used to validate that it is receiving them in the correct places and somebody's not intercepting those events. And then finally, we need to replace the placeholder Stripe price IDs with the actual product price IDs from your Stripe dashboard. So let's go to our Stripe dashboard. Let's go to our payment links. Let's open this link here. And within the products, we will have an individual product ID. And I'm just going to copy that there. And I believe the price ID is the product ID here. And then it's saying, once set up, users can subscribe or purchase credits, and your system will automatically track these transactions and add credits to their accounts. So this should be all set up in a second, and we'll be able to go in and test that. Okay, so the product ID is not the same as the price ID. So we'll go back into Stripe, go to products, go to the pricing section, and it should start with price. And actually, if we're in the product here, in the price, you can click on here and copy the price ID. So we'll copy that back into Lovable, and everything should be set up ready to test. So what we're going to do is go in and use our sales lead qualifier twice, and hopefully that starts to push us towards the checkout flow once we run out of credits. And just to reiterate, this is all on a test data account, so it's going to let us purchase without putting any funds forward. When we switch this to a production environment, you need to set this up again with those different credentials or just update them in the relevant places we have here. Okay, great. It seems like it's ready to test. So let's start testing again. Let's insert the LinkedIn URL here, and we'll run it twice to effectively run out of credits. Oh, we run it once. Okay, so great. So it's shown us this insufficient credits. You need 8 credits to use this tool, but you only have 2 credits. That's really nice that it's set all of this up and also linked us to the purchase credits. So let's try and go through this purchase credit route. and it's sending us to the payment link page. Let's see if it works. So we'll say it's getting stuck on the payment link page from the purchase credits warning button. It's probably not linked it to the correct payment page. So let's just get that fixed. Great. So it says it's updated the purchase credits button. Let's give it another go. Redirecting to payment, error creating checkout session. You have to be very patient with a tool like Lovable, but don't forget that what you're doing is stuff that would take you, if you were a software developer, a considerably longer amount of time to actually do this. But each time you run one of these changes, it's going to take about 1-2 minutes to update. You test again, etc. But what you're replacing here is a very high development cost, and you can get a SaaS prototype up and running for very cheap. So it's definitely worth the time investment, and it's really cool, and I'm very impressed with the outputs here. There were always tools like Webflow, WordPress, Wix, etc., that could create good front ends, but tools that integrate that front end with the back end were very few and far between, and often had a big technical barrier. But using something like Lovable completely takes away that technical barrier. You need a little bit of understanding of architecture, but other than that, you can do it just by prompting like you would with ChatGPT. So very impressed with it. So lesson learned here, that the issue actually was that the embedded window here inside Lovable was not showing the Stripe page. But when we opened up the page here, we go to tools, we try the same process, we purchase credits, it actually takes us straight to the Stripe page. So just a little bit of a learning there. And what we'll do is we will just enter some test details and we will hit pay there. And you can see that this is in test mode anyway. And that's going to process, and hopefully that will update in all areas. It will update our database, which will receive a notification that a purchase has been made. So it's thrown us back to the login page here, which is not ideal, but let's go to the database and have a look to see if anything is updated. So we can see that the database is not updated. It's also thrown us back to the login page, and we've got 2 credits still up here. So let's go to our Stripe developer portal, and inside the logs, we can see everything that's happened. So I can see that the checkout session loaded correctly, and then the payment methods endpoint was contacted, suggesting that the payment had gone through. If we go to customers, we can see that there is a customer in here with my name, and it's saying that the payment had succeeded, and it gives us details around that. If we go back to our database, we should have a Stripe customer ID in here, and it's still showing as null. So what we should do is check in our edge functions in Supabase, and if we click into the Stripe webhook, we should be able to see that something has happened here, and it has shown that something has been received. So there is a connection there. Let's go to the logs, and it's showing that there were a few errors. So great. So it has actually received the information. And what I'm going to do is just copy that. I'm going to go back to Lovable, and we're going to attach the image of the error. So I'm going to say went through on the Stripe side. Supabase seems to have received it like we saw, but then shows this error. Let's see if it can help us resolve it. And it seems to think it's fixed the issue now. So let's go and try again. In the tools, run the tool, purchase the credits, enter the test details. And I probably didn't say before, but when you're using a test account, this is a well-known test card information. So 424242, etc. You can put in any dates, but it's a Visa test card that you can use. It might decline other cards, and we'll process that there. So it's thrown us back into the login page. Let's refresh the database. Same problems. So let's go back and check what's happened here. And this time it doesn't seem to have received it. 439. Okay, it has received it again. And in the logs, and if we go to the overview here, I can see that something has happened. It's got a 4xx error, which usually means it can't find something. So if we go to invocations over here, go to this, which is my most recent run, and I'm just going to copy all of this metadata down here, take it back to Lovable, refresh the page, tell it it's not working again, just refresh. So got a 400 error in Supabase, copy that error code in, and we'll see if it can tackle that. So we seem to be having the same issues here. So I've come into the Stripe dashboard, and all of the payments that we've tried have succeeded in Stripe. So it must be, as a result, a connection issue between the Stripe dashboard and our Supabase database. In the logs that we were looking at before, it seems to show that things were executed, but they're always not found. So with some persistence, I've gone back and I've just refreshed all of those things we did before. Not sure why it wasn't working. I think we might have got it working now. So there's 6 credits in the account we're about to top up. We're going to add, again, some credits. And sometimes you just need to refresh, And let's see if that updates and hopefully tops up our credits here. So it's thrown us back, but we can see now, hooray, 106 credits. So we'll go to the tools and we're now able to use it. And if we go back to the database, we can see that it's 106 and we can see it's put our Stripe customer ID in there as well. So that is a success. We know that it stops us purchasing when we've not got sufficient credits. And now it's also connected to our Stripe customer ID. So hopefully now you can see that it's actually extremely easy, albeit takes a bit of time with prompting and reiterating and testing, to set up a full AI SaaS marketplace. And hopefully you've got some idea of the products that you could host on this marketplace. So today we just set up a sales lead qualification flow, as well as an extract from PDF flow. But looking at a marketplace like Agent.ai, you can see they have thousands, 98 pages of different flows. We've got things like pulling recent LinkedIn posts, a meme maker, fit to purpose image generator, industry analysis. So all of these things could be replicated with an n8n backend in a similar interface to this. It works with n8n in the backend, and your users could pay and come to one platform to access all of these tools. So the possibilities really are endless. If you're considering implementing this for yourself, obviously you followed the video through, but we've got all of the different prompts, implementation plans, the setup guide for Stripe payments, the credit management system. So we just did some basic stuff with credits that wouldn't stand up in practice. So we've got a full guide here on the different things that you might need to implement with Lovable and test to make sure that you could actually run this in production. So that is it in terms of the 4 different phases that we're going to run through. So we've run through now phase number 1, which was the 20% of n8n that will give you 80% of the value. We've then turned those foundations into robust systems. So we built out that invoice parser and various other automations in phase 2. We then did a deep dive we then did a deep dive in phase 3 into agentic and AI architecture, what use cases look like for that. And we've built out several different automations, including the calendar agent, a RAG flow, a CAG flow, and various other flows along the way. And then finally, we've talked about setting your goals and systematizing and selling AI automations. So if you followed that all the way through, a massive congratulations, because you made it so far and you're now ahead of 90% of others in this space. If you're still looking for more content, in particular around mastering AI and automation, then I've mentioned my community before, school.com/scrapes. We have a load more resources that are exclusive and on top of these courses inside the AI automation masterclass, all stuff that we haven't touched on around actually how do you very quickly pull together systems and confidence with your workflows and also set up your clients or your business for success. We then have an agency launchpad module, which takes you all the way through understanding what you should actually offer to clients, how to pitch yourself and how to do that well. And we've got a win rate formula to do that. We then help you search out the right jobs for you and actually scrape those jobs, as well as then make personalized intros to those jobs. Really easy, and it's all really automated for you. And finally, we actually set you up with an agency landing page. So if you're part of the community, you get a Go High Level account for free, which would normally cost you $100 a month, where you can manage all of your marketing, your landing page, your email comms, you can connect it to your own domain, all set up and made really easily for you. So I hope you enjoyed the content and thank you so much.